Hello guys, we are going to continue discussion with respect to Python, and in this video we are going to talk about loops. Already in our previous video we have seen a lot of examples with respect to conditional statements like if, elif, else, and we have seen multiple examples out there, right? Now in loops we will be discussing about what are the different types of loop we usually use in Python programming language, like for loop, while loop, loop control statements like break, continue, and pass. Then we'll be discussing about nested loops, and then we'll be seeing like all these things we will be seeing much more in with the help of practical examples and what are the common errors we usually face and how to avoid those errors. So all these things we'll be discussing in this particular video. So first of all, let's go ahead and work with for loop with a simple syntax. So in order to write a for loop, right, you need to understand what a for loop is. A for loop is a loop, right? It is used to iterate over a sequence of numbers. Okay, so let's say I will give one example like for I. Okay, I is just a temporary variable right now. In, let's say I want to create a sequence of numbers. Now in order to create a sequence of numbers, I will show you with the help of range. Okay, so what exactly is range? Okay, so let's say in this particular range I give 5 elements. I basically want 5 elements over here. So this is turn actually help us to generate numbers between 0 to 5, right? So here you can see that hey, I'm getting a range between 0 to 5 over here. And let's say I want to just display all these numbers inside this, right? Range is just giving us a sequence of numbers between 0 to 5. But if I want to iterate through this all the numbers, I can basically use for loop. So if I write for I in range 5, right? And here if I go ahead and print I, right? Now you'll be seeing that after every iteration, first of all, when we are looping inside this sequence of numbers between 0 to 5, first it will go ahead and display 0, then it will go ahead and display 1. That basically means after every iteration, this number is basically getting incremented and it is traversing through all this range of numbers. One important thing that you should understand that since I've used range between 0 to 5, the last number is not going to get included. So that is the reason you can see 0 is here, 1 is here, 2 is here, 3 is here, and 4 is here, right? But the total number of elements is 5 over here. And here, in short, I've spoken about for loop and range as a function. Okay, so range as a function is also given. Let's say I want to probably use for loop with different range of numbers, right? Let's say if I go ahead and write 1, 6, that basically means I want the number between 1 to 6. 6 is the last number, so we are not going to include it because at the end of the day, with respect to Python, whenever we are seeing indexing, right, it always starts with 0, right? So I'll talk more about it as I go ahead. Now, if I go ahead and execute this, here you'll be able to see 1 is getting displayed, 2 is getting displayed, 3 is getting displayed, 4 is getting displayed, 5 is getting displayed. So I can also call all my range of numbers with respect to by giving the numbers between one number to the other number itself, right? Now let me just give you more examples over here by using range. So if I go ahead and write range of 1, 10, and let me just go ahead and give some third parameter, right? So third parameter over here, you'll be able to see that it is something called a step. Now see the syntax. It shows start as the first parameter inside range function. Then you have the stop parameter. Then you have the step parameter. Okay. By default, step parameter is usually given as 1. Now start, I'm saying hey, start from 1 end till 10, right? End before 10. I'll not say till 10, but before 10, and use the step size as 1. That basically means only increment one number at a time. So if I go ahead and execute it, this will basically give me a range of value between 1 to 10, and the step size will be 1, right? Now let me just go ahead and make it 2. Okay. So here you can see that I'm starting from 1. Before 10 it will stop, and here the range is 2. That basically means the two numbers will get incremented. Now let me do one thing. Okay. Let me just write 1 over here, and let me use a for loop again for I in range of this, and let me go ahead and print I. Okay. Now when I'm printing I, you'll be able to see that what I'm actually getting 1, 2, 3, 4, 5, 6, 7, 8, 9. Now let me make this change from step size 1 to 2. Now what will happen? See, after 1, directly 3 will get displayed because we are going to skip one number. So it is just going to jump 2 steps ahead, right? Now see this. So now I can see 1, 3, 5, 7, 9, right? So I am not probably traversing through each and every number, but instead I've given a step size of 2, so it is jumping 2 numbers ahead. And that is how it is basically getting printed. Let me just show you one more example. Let's say that I want all the numbers between 10 to 1, but now this time I will use a step size of -1. Now what it is going to do? It is going to display a number between 10 to 1, and step size will be -1. That basically means after 10 it will become 9, then 8, then 7. See this? So here you can see 9, 10, 9, 8, 7, 6, 5, 4, 3, 2. 1 is not getting displayed as we know that last number will be skipped. Before this, all the numbers will be displayed. One more example that if I really want to show it to you. So here you can see -2. If I'm using -2, so 10, 8, 6, 5, 4, 2, 6, 4, 2, right? So I hope you have got an idea with respect to for loops and with the help of range how we can actually move. Okay. Now let me show you with respect to strings. I hope everybody has learned strings, right? So strings, how to probably create string. Let's say that this is my string. Okay. This is my string, and here I'm going to write Krish Nayak. Okay. Now if I want to traverse through this particular string, now see one amazing thing about this data structure called a string is that we can traverse to each and every character over here. So if I go ahead and write for I in str, okay, and for I in str, and if I just go ahead and print I. Okay, so string is basically a data structure. It is just nothing but it is a collection of characters, right? Now if I'm going to print over here, you can see KRISH, then again space NEIK, right? Let's say that I'm traversing through this particular string, and I also want to do something like I may have a sentence, I may have a paragraph. So based on that, also I can print it over here, right? Just to give you an idea what exactly this is, because string is a collection of characters, right? It is a collection of characters, and we can also traverse it. So the for loop main functionality is that whenever you have any collection items, like any collection data structure, you can traverse through it very much easily by just using a for loop, right? So I've just given you an idea about it, but as we go ahead, we'll be seeing more complicated example as we go ahead, right? But just to understand the basic example, this is what a for loop is all about. Now let's go ahead and discuss about something called as while loop. Okay, so while loop. So now let's see something about while. So now I have while loop. Okay. Now with respect to while loop, right? If I really want to give a small definition, this while loop is nothing but it continues to execute as long as the condition is true. Okay. That basically means unless and until this while loop, whatever condition I'm writing in while loop, it is true. It is just going to execute it. Okay. Now let me do one thing. Let me create a temporary variable called as count. Okay. Count. Okay. Now with respect to this particular count, let me just go ahead and write while count is less than 5. Okay. And now I've gone inside my while loop, while block or while loop over here. So I'm putting this particular condition. Unless until this count is less than 5, just go ahead and print it. Okay. Let's say I'm going to print the count. Okay. And after this, if I'm executing, see, I also need to increment the count over here. So I will go ahead and write count plus 1. Okay. So what I'm doing, unless and until this count is less than 5, I'm going to print the count, and for every iteration, because we have initially initialized count is equal to 0. For every iteration, I'm writing count is equal to count plus 1. Okay. Now see what will happen. If I execute this, you'll be seeing that 0 is getting displayed. Initially, I will be having 0. So when I write while count is less than 5, this is true. It is just going to print the count. So I'm going to get 0 over here, and then it is going to increment the count. Now my temporary variable count will have one value, right? I'll not say temporary, but my count value from this 0 has got incremented to 1. Then again, this while loop will run. Why it will run? Because this condition is still true, right? So now here you can see when 1 is less than 5. So 1 is obviously less than 5 in the second loop. So again, this will get executed. Then again, this will get incremented. Then again, it will go to the next loop. Then this will become 2, 3, 4. Then, but once it becomes 5, right? While 5 is less than 5, now this becomes false. It is just going to come outside the loop, right? So that is how you are getting displayed with 0, 1, 2, 3, 4, right? So this is a simple way of probably displaying or understanding about the while loop. Okay. I may also write something like this. While, okay, let's go ahead and write count is equal to 0. Count is equal to 0. While count percentile 2 is double equal to 0. Okay. So now see this condition. What I'm saying, while count percentile 2 is double equal to 0. If this is true, right, I will probably go ahead and print the count over here, right? Right, and let's say that I will go ahead and, or let me do one thing, okay? If I'm starting from count is equal to 0, and this condition is basically to check whether a number is even number or not, right? So if I just go ahead and execute it, how many times this will get displayed? See, 0 is getting displayed over here, right? And it's continually getting displayed. I'll stop this, see, because I've not written any condition over here. So let me just go ahead and write count is equal to count plus 1, okay? Now, how many times it will get displayed? You just see this, okay? Only one time, because the next time it became 1, this count became 1, the 1 percentile 2 is not equal to 0, so it is just going to come outside of the loop, right, of this particular loop. This is just to show you an example over here, but we will be seeing with more amazing examples. First of all, let's go ahead and just see the basic syntax of for, while, and now we're going to go ahead with respect to loop control statements, okay? Loop control statements. You'll be seeing that, Krish. Please give more examples. Don't worry. After I probably make you understand all these things, then we will be seeing more examples as we go ahead. Okay. Now, with respect to the loop control statement, first of all, we'll discuss about something called as break. Okay. Now, if you really want to understand break, I'll just go ahead and write this definition. The break statement exits the loop permanent. Exits the loop prematurely. Okay. What does this basically mean? I will just make you understand. Okay. Let's say I want to write a break statement. Now, how do I write a break statement? So first of all, let's say I'm going to run for I in range. Okay. Please make sure that you understand the syntax for I in range of the collection. This is nothing but this is collection. It can be a list, it can be a dictionary, it can be range, it can be string, anything it can be. And let's say I'm writing 10. So 10 basically means it is just going to iterate from 0 to 1. Okay. For one of the conditions, I'll say if I is double equal to 5. Okay. If this I is equal to 5, I don't want to probably, or I want to come outside this particular loop. Okay. I want to come outside this entire for loop. So I will go ahead and just write break. Okay. And once we probably write break, okay, it is probably going to come outside of this particular for loop itself, right? Now, one more thing. If I is not equal to 5, at that time we just need to print I. Okay. So now see, what is this entire code that I have actually written? For I in range of 10, if I is double equal to 5, I'm saying only when I is equal to 5, do the break statement comes outside of this particular for loop. When I is not equal to 5, you just need to keep on printing the numbers. Okay. So now if I go ahead and execute it here, you'll be able to see 0, 1, 2, 3, 4. Then when 5 came, automatically we came outside of this particular for loop. Okay. And then after that, nothing is getting printed. So we are exiting this particular loop permanently. Okay. Permanently with the help of break over here. But this break will only get applied on any statement, on any condition as such, right? So that is why we are specifically using this break statement. Okay. This is one of the good examples. Again, now with respect to the another loop control statement, we also have something called as continue. Okay. So now we will go ahead and write continue. Now what exactly continue is? Okay. And you also need to know this. If I really want to define continue, okay, continue statement skips the current iteration and continues with the next. Okay. So that basically means, let's say I'm going to write for I in range. Okay. For I in range. For I in range. And let's say I write some elements over here 10. Okay. And now if I go ahead and write if I modulus 2, right, is double equal to 0. Okay. And this condition is basically just to check whether the number is even or not. If the number is even, let's say that I will go ahead and write continue. Okay. I will just go ahead and write continue. And then I will just go over here and print I. Okay. Now, in short, if I really want me to understand, this is just like displaying all the odd numbers between 0 to 10, right? Do you agree with me or not? See, what I'm doing over here, for I in range of 10, if I modulus 2 is equal to 0, that basically means this is an even number, we're just going to continue. Otherwise, if it is not, which is an odd number, we're just going to print it. So if I go ahead and execute this, you'll be able to see that I will only get an odd number, 1, 3, 5, 7, 9, between 0 to 10, right? And that is what is a continue example. With respect to continue, we are just skipping the current iteration. This will just skip. It will even not go to the print statement. It will just go ahead and continue the loop, right? So this is what is the power with respect to the continue statement. There is also one more amazing flow control that we use that is basically called as pass, okay? And you should know all these things because some of the other way we will be using all these things, right? Further when we'll be seeing multiple examples. The pass statement is a null operation and it does nothing, okay? It does nothing. Nothing means nothing, right? It'll just say, hey, I don't want to do anything on a specific condition, okay? So now if we go ahead and write for I in range of 5, let's say, okay, for I in range of 5, let's say I'm giving this particular condition, okay? I'm saying, hey, if I is equal to 3, if I is double equal to 3, okay, then I'm saying, hey, just pass, okay, do nothing, okay? I don't want you to do anything over here, okay? And then we're going to print I, okay? Now see what will happen. In this particular case, whenever I say, hey, whenever the number is even, just skip this for loop. But here it is saying, do nothing, just go ahead, right? Just go ahead and skip it, right? Now if I go ahead and execute it, now see what is happening. 0 is getting displayed, 1 is getting displayed, 2 is getting displayed. When I is 3, again, I'm just saying, hey, skip it. So just skip this if loop, right? Or the best way will be to print something like this, okay? The number is, okay, I'll write number is over here as I. Okay, now you'll be able to understand this. Now this pass, as soon as we do the pass, right? At that time, what will happen? First of all, when I is equal to 3, only this will get printed, and we're just going to skip this, okay? Or do nothing as such. So here you can see 0, 1, 2, 3. The number is 3, 3, 4, right? Pass in, it's just like a null statement. Suppose I don't have anything to give over here. I'll just remove this, and I'll just write pass. Do nothing as such, okay? So this can also be useful, and again, we'll talk about it. What exactly will be the use case over here, right? But most of them, if I probably consider pass, continue, or let's say if I'm probably defining an empty function, and if I define an empty function, and if I internally write just pass, that basically means that the function does nothing, okay? So this is some of the amazing things that have been brought by Python. If I talk about break, this will be very handy because on a certain condition, we're just going to break this or come out of this particular loop. We can use break. Then we have continue, then we have pass, right? Now let's talk about nested loops. Okay, so let's talk about nested loops. Nested loop is nothing but a loop inside a loop, right? Let's say I will run a loop for I in range 3, okay? And let's say for j in range 2, okay? Now what I'm doing, and let's say I go ahead and print, and here with respect to the print statement, let me show you how you can use f string also. So f string is nothing but here I'm basically writing it out, and here I'll write I is equal to will be equal to I and j equal to, it will be equal to j. Okay, so whenever we use this f string formatted statement to display the variables, we have to use this curly braces. And in short, this is just a formatting option of displaying the string. I can use this particular string together along with flower braces so that I can display that particular variable. Now, what is exactly happening over here? See, it is very simple. over here you'll be able to see for I in range of 3, right? I'm iterating through another range over here, another iterables over here. Then I'm also running another iteration over here, right? So there are 3 elements over here. So first it will run this, then it will go inside this, and it will complete the inner loop, right? Inner for loop. Then it will go to the outside for loop. So first time when it gets displayed, this is going to get executed for the 2 times. Then it will going to go and increment the I to 2. Then again it is going to run it for 2 times for this particular J loop. If you don't understand, see over here. I'll show you with respect to the output. So here initially you can see when I is 0, J is 0. Because initially when we are running this particular loop, right? And then when we go inside this particular loop, J will run for 2 times. So J is running for J is equal to 0, J is equal to 1. Then you have I is equal to 1, then again J is equal to 0, J is equal to 1. Then when I is incremented to 2, J is equal to 0 and J is equal to 1. So it is basically going to run with respect to all the inner loops, right? And here this for loop every time it will be executed based on the number of ranges that I've actually given over here, right? Whenever we enter the upper for loop itself, right? So this is just an example of for loops over here, nested loops over here, right? Now let us go ahead and see some examples, okay? And this is where we will practice multiple things. The first examples that we are going to do is that let's say I'm going to write over here, calculate the sum of first n natural numbers using a while loop, using a while and for loop. Okay, so let me just go ahead and first of all show you with the help of while loop. Okay, so first we'll see with respect to the while loop, and then we will go ahead and see with respect to the for loop. Okay, what we need to do, calculate the sum of first n natural numbers. Okay, first n natural numbers, very simple. So now I will just go ahead and say, let's say that the number of n number, the natural number is 10. Then initially I will define my sum variable to 0. This will be my temporary variable because the addition that I'm going to do with respect to all the natural numbers, I'm going to save it in this particular variable called as sum. Then I will keep this temporary variable called as count is equal to 1. Okay, now let's go ahead. Okay, so here I'm going to write while. Okay, count is less than or equal to n, right? Unless until the count is less than or equal to n, I'm going to just go ahead and I'm going to use this sum is equal to sum plus count, right? So what we are doing over here, we keep on adding the count, right? Unless and until this is not equal to less than or equal to n. And after this, we will go ahead and write count is equal to count plus 1. We are incrementing the count variable also. And finally, when this for loop is while loop is getting completed, I will write sum of first 10 natural numbers. Okay, natural numbers will be equal to nothing but whatever sum we are probably getting over here, right? Just go through the statements. Here we have initialized how many number of natural numbers we are going to consider. Initially the sum is equal to 0, count is equal to 1. Now I'm saying well count is less than or equal to n. I'm going to increment this count continuously unless and until this gets satisfied. Then automatically internally we are doing the sum also. Okay, so here you can actually see the sum of first n 10 natural number is nothing but 55. Perfect. So there's just like 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10, right? It'll not go, yeah, it'll go till 10 because we have written less than or equal to n. Okay, perfect. So this was one of the example. Let's do it the same thing with the help of for loop. So I'll write so let me just go ahead and define this 3 variables again. Okay, so let's say for I in range, and here also I can just go ahead and write till 11 because I want to probably do from 0 to 10. Okay, and here I'll just go ahead and write sum is equal to sum plus I. That's it, right? And here I don't even have to write this count is equal to 1. Okay, because automatically this will get incremented. So here let me just go ahead and print the sum, and if I go ahead and execute, I'm also able to get it 55. Okay, so here I've shown you with the help of both while and for loop how you can calculate the first 10 natural number sum, and here you're able to see it. Okay, now let me do one thing. Let me show you one more example. Okay, now this time the examples will be talk about the prime numbers or display the prime numbers between 1 and 100. Now what is prime number? Prime number is something which is divisible by 1 or the number itself, right? Now here I'll just go ahead and write it down, and again for this I will use a for loop. So I'll write for num in range of 1, 101, right? Because we need the numbers between 1 and 100, right? If the first condition will be that I will go ahead and write if num is greater than 1, right? Obviously the number has to be greater than 1. So one condition is over here. We're going to use if, nested for loops and all, right? Please pause the video, try it by yourself, and then probably see the solution. Okay. Now if this is true, then what I'll do for I in range 2, num. Okay. For I in range 2, num, that basically means from this number, from 2 to this particular number, whichever number we are specifically discussing, or from this for loop, which number I'm able to increment, I'll just go ahead and write this particular condition. If num percentile I, right, I is the same number over there, right, is equal to 0, then we are just going to break it, okay, and then we are just going to break and come outside this for loop, and I'm going to say else print number, okay. We just need to print this because if this gets satisfied, right, this is basically indicating that hey, I've got a prime number, right, and then it is just going to display the prime number. So again, I'm repeating. First of all, I'm going to check a condition if number is greater than 1. Then we are going to write for I in range of 2, num. Okay, 2, num. So we are incrementing the so we are running through this particular 2, num. Whatever num is there, let's say the num is 3. So 2, 3. For range in 2, 3, then we can go ahead and write 3 percentile 2 is double equal to 0. The answer is no, right? If it is no, we're just going to go ahead and display this number, right? And if it breaks, it is just going to go outside this particular for loop. Okay, so that basically means if this condition is becoming true, right, that basically means it is not a prime number. Otherwise, we are just going to display the number in the else block. Okay, and one more thing about for loop is that along with the for loop also you can write else block, right? Else block. If something you don't want to execute it, but you want to execute it compulsory at the end of the for loop, so you can also use this else block. Okay, so once I execute this, here you'll be able to see 2, 3. So 2 is a prime number, 3 is a prime number, 5, 7 is a prime number, 11, 13, 17, 19, 23, 29. All these are prime numbers. You can probably go ahead and check it out. Okay, these are like numbers which are only divisible by 1 or the number itself, right? So here you can actually see the example. Okay, now some more examples that you will be seeing as we go ahead, where we'll be using when we'll learn more about different data structures like list and dictionary. But at the end, conclusion that I really want to give after every lesson, right? And let me make a markdown cell over here. Okay, so conclusion is that loops are really powerful. Okay, loops are definitely very, very powerful. Okay, in Python that allows you to execute block of code multiple times by understanding using for and while loops along with the loop control statement like break, continue, pause. You can handle a wide range of programming tasks efficiently, and you'll be seeing that when we'll be discussing about more examples. But I really want to keep the video between 20 to 25 minutes where I show you multiple examples where I write each line of code in front of you so that you'll also be able to understand. So yes, this was it from my side. I'll see you on the next video. Thank you. Hello guys, so we are going to continue our discussion with respect to Python, and now we are going to start data structures in Python. Some of the most common data structures that are used in Python programming language are like list, tuples, sets, and dictionaries. So in the series of videos, we are probably going to discuss about all these topics. In this video, we are going to focus more on list. So let me just go ahead and show you what is the video outline. So first of all, we will go ahead and show you how to. I will go ahead and show you how to create a list. Then I will also show you accessing list items, modifying list items, some of the amazing list methods that we use. Then we have operations like slicing list. How do we iterate over list? By using for loop and all. And then along with that, we'll also be seeing list comprehension, and then we will be seeing about nested list. All these things will be covered with a lot of practical examples, and I'll also be talking about what are the common errors that we will be getting. So before I go ahead, first of all, let us go ahead and just see the definition of list. So here you can see list are ordered mutable collection of items, right? Ordered mutable collection of items. What does mutable collection of items basically means? Like all items that are present in list, we can actually change it, okay? And they can contain items of different data types also, right? So these are the two main properties with respect to list. First of all, they are ordered mutable collection of items, and they can contain items of different data types. So let me just go ahead and let me show you that how do you define a list. Let's say I create a variable called as LST, and if I use this two brackets, and before that, don't forget to select the kernel. So right now I've selected the kernel based on the environment that I've actually created. So here you can see over here when I write list with some this empty square braces, and if I go ahead and print the type of this variable, this will give us an empty list, right? So this is a class type of list. So in order to create a list, it is very much simple. You can just use this empty brackets, right? Now, if I want to add elements in the list, let's say that I want to go ahead and create it. Like I may have multiple names over here. Let's say I have Krish, I have Jack, I have Jacob, right? So this is basically a list of names, okay? I may also have other elements, like I may have 1, 2, 3, 4, 5, any number of elements. I may also have different data types of elements over here. So here, if I go ahead and print names, so it is giving me a name error because I did not write names. So here you can see that I'm able to get a list of elements, right? So this is how a list is. Let's say that I go ahead and create a mixed list, mixed underscore list list. And here, let's say my first is a number, second is a string, third is a floating point, right? And fourth is a Boolean variable, right? So I may define any type of data type, and I may also print this. So let me just go ahead and print mixed underscore list. So I hope you got an idea about how to probably create a list of items, right? So one is directly you're using this particular empty brackets, or you can also go ahead and add elements over here with respect to any kind of elements, any different data types of elements you can basically add. Okay. Now let's talk about accessing list items. How do we access the list elements, right? So let's say that I create a fruits, right? Let's say that I'm going to create a fruits element, like a list of fruits. Let's say like apple, it can be banana, it can be cherry, it can be kiwi, it can be pomegranate, okay? Or let me just write a simple, okay, let's go ahead and see. Cherry is already written. Apple, banana, cherry, kiwi. Okay, I'm not able to remember more fruits names, right? So let's just keep it till here, okay? Okay, fine. I got one. Guava, right? So I'm just going to go ahead and create this list of elements. So here is my list of elements over here. Now, let's say that I want to go ahead and display apple, right? So in order to display it, all I have to do is that just go ahead and write fruits. And here you can probably see that I can actually use indexing, right? So whenever we create the elements inside a list, okay, so here this first fruit is basically present in the 0th index, then this is present in the first index, second index, third index, fourth index. So similarly, all the indexes, when I probably say all the indexes in Python starts with 0. If you know about our programming language, all the indexes over there starts with number 1, right? But here we are specifically going to use 0 is the index over here, right? But if I really want to just display apple, right? So I will just go ahead and write fruit of 0, right? If I'm actually trying to print this, so let me just go ahead and write print fruits of 0. It is nothing but apple. Let's say I want to probably get fruit of in middle cherry, right? So this will become 0, 1, 2. So if I go ahead and write fruits of 2, so I will be able to get apple and cherry. And there's some amazing techniques with respect to indexing also. So let's say that I want to pick up guava, right? So I can also go ahead and write print. One way is that I can go ahead and take 0, 1, 2, 3, 4. So I can probably go ahead and write fruits of 4th index. I will be able to get guava. Now this guava can also be taken through a different way. So let me just go ahead and write. So let's say that I'm going to write print of fruits. Let me just say and show it to you over here. So let me just go ahead and write fruits of okay. And now in this particular case, let me just go ahead and write -1. Let's see what will happen. See, -1 is nothing but it's basically talking about the last element itself, right? So I think I should be able to get both power, right? So this is the amazing thing with respect to fruits, right? Sorry, this list, right? You're able to probably retrieve any fruit or any items inside this list just by using simple indexing. Okay. Now let me just show you one more way of printing some set of fruits elements. So if I go ahead and write fruits, okay, and if I just use the index 1, okay, I'll be able to get banana. So I'm getting banana 0, 1, I'm getting banana over here. But what if I have a requirement? I need to get all the elements from banana till guava, right? So if I go ahead and just make one simple change over here, right? What I'll do, I'll just write fruits 1 colon, right? 1 colon basically means from first index till the end index, because I'm not giving anything after the colon. So if I just go ahead and execute this, here you can see banana, cherry, kiwi, guava, right? So this is one way, right? Now let me do one thing. Let me just go ahead and print fruits 1 colon, and let's say I want to get all the elements till this kiwi index 1. So here you have 0, 1. So right, 2, 3, right? So now if I go ahead and write 1 colon 3, that basically means it is just going to pick up this first index, second index. It is not going to pick up the kiwi index, right? And now if I go ahead and display it, so here you can see banana and cherries there. That basically means the third index is not getting picked up. Till the third index, everything will get picked up, right? So if I don't write any element over here, so it is just going to take it completely till the end, right? And here also what I can actually do, let me just go ahead and show you one more thing. So if I go ahead and write print of fruits -1 colon, right? Now if I go ahead and execute this, you can see -1 colon basically means from -1 element till colon, right? Till colon is till the end, and this is just my last element over there, okay? But if I just go ahead and write -1 to, let's say, second index, so here I can see that you have to please observe here. -1 is nothing but this specific element, right? 2 is this, right? But I'm not talking about all these elements. Now, if I go ahead and write -1 to -3 or -3, right? Now, here also you'll be able to see this indexing is obviously a little bit confusion. Okay, there's a little bit of confusion over here because when I'm picking up the -1 element, this is what it is giving us. But I'm saying from -1 to -3, right? So there is no such element, and we'll talk more about this kind of examples and how to do this kind of indexing also when we are further discussing about many things as such, right? Right now, don't worry about this, otherwise you'll get more confused over here. I'll just keep it like this. I'll remove this particular code for some time, and then later on, when you'll be seeing in the series of videos, we'll also be talking about those kind of indexing. Okay. Now, perfect till here, I think we have learned many things over here. Now, what I will be showing is that how you can modify the list elements. Okay. So let me just go ahead here and show you modifying the list elements. Okay. Now, modifying the list elements is very simple. Let's say that I want, this is my fruits, right? So this is my fruits. I want to make sure that I replace banana with something else, right? Now, banana, it is in first index, right? So if I go ahead and write this, it is in first index. Let's say from this, I want to probably change this into watermelon. Okay. And now I will just go ahead and print my fruits, right? So in that specific index, I'm writing watermelon over here, and I'm actually displaying it. Now you can see my fruits has changed banana to watermelon, right? So this way, in the indexing also, you can directly go ahead and probably replace this particular values, right? So this is how you modify any elements that is present over here. Not only that, let's say I want to go ahead and write like this: fruits, okay, fruits, 1:, okay. So 1: is basically giving you this answer. Now if I go ahead and just write, hey, please replace everything with watermelon. Now if I go ahead and see fruits, so here you can see I'm getting this error. Let's see what is the problem. Watermelon. Okay. Now what it has done is that from this particular index, it has replaced with this particular word, right? But here it is not considered as a word. Instead, it's taking this as character by character. We will also be seeing how we can add word to word, right? So in list, you have some amazing methods like append and all. We'll be talking about it as we go ahead right now. Okay, just after this section itself, right? So this is one of the problems that we see, right? Now let me do one thing. Let me again use that same fruits over here that I've actually defined. Okay, but you understood the problem. What has happened over here? As soon as I said 1:, right? So from first index, it has just added WATER. So it's not just considered this as a single word. Instead, it's considered character by character and it is adding it. Okay. So let me just go ahead and define my fruits again. Okay. Now let me just go ahead and discuss more about amazing thing that is called as list methods. Okay. Now this list methods is quite beautiful. We'll see to it and we'll be learning more about it. Okay. Now let's say I want to, as I said, right, I want to append an element inside this. Okay. I want to add one element at the end. Let's say. So for this, I will go ahead and write fruits.append. And here, let's say I want to append orange. Okay. Now once I write that, basically means this will add an item. Okay. To the end. Okay. It'll basically add an item to the end. Okay. And if I just go ahead and print my fruits, you'll be able to see this, right? So now here you'll be able to see apple, banana, cherry, kiwi, guava, and oranges over here, right? Now let's say that I have a requirement that I want to probably append any element at a specific index. Okay, so let's say I want to add, watermelon in this first index. Okay, and right now in the first index, banana is there. So what I will do, I'll say fruits dot insert. Okay, insert, and I will give the index number. The first element will be the index number, and the second element will be whatever item I want to put. Let's say banana. Okay, and then I'm just going to print fruits. So here you can see apple, banana, banana. Okay, banana was already there, I guess. Yeah, banana was there. Let me do one thing. Let me add watermelon also. Okay, so in the first index, I'm just going to add watermelon. So here you can see apple, watermelon, banana, banana, banana because I've added one time, right? Let's say that hey, 2 bananas are there. I want to remove this, so I will go ahead and write fruits dot remove. So remove is another inbuilt function that is present inside this. So here I'm going to basically write banana. Okay, and now if I go ahead and print fruits, okay, so here you can see banana has gone right now, but we don't have one more additional banana. Okay, let's say I want to also remove and let's say see whenever we are using this remove, right, it is basically removing the first occurrence of an item, right? Now, let's say I want to remove and return the last item. Return the last item. Okay. Let's say I want to do this. What do I mean by this? Let's say I go ahead and use one amazing inbuilt function which is called as pop. Okay. Now, pop basically means it's just going to pop the last element that is present in that particular fruit, and it is going to return us, right? So here I'm going to write popped underscore fruit. Okay, is equal to, and let me just go ahead and print it. So I'm going to print it over here, and let me just go ahead and write pop fruits. Okay, and let me just print it. Okay, let's because at the end of the day, once I probably print this, and I'll also print the remaining items that are there in the fruits. Okay, so here you can see orange has been popped. Why? Because the last element in this list of fruits was orange. When orange was popped, from this particular orange got removed. Okay, remove and return the last element. That is how you can specifically do it, and for that we use an inbuilt function called as pop. Okay, now let's say that I want to get an index of any fruit, right, based on the name of the fruit. So if I go ahead and write fruits.index, and here let's say that I want to use cherry. I want to get the index of the fruit called as cherry. Okay, cherry, and this will basically be my index. And let me just go ahead and print the index. Now if I go ahead and execute, you can see that cherry is basically present in 0, 1, 2, 3, third index. So I'm able to get the output. Okay. Again, one more thing is that let me just go ahead and do one thing. Fruit dot append, or I will try to insert in the second index banana. Okay, banana is already there. And now let me do one more inbuilt function. I'll just go ahead and write fruit dot count, and here I will just go ahead and write. So it should be count. I will just go ahead and write banana. Okay, and let me just print this. Okay. Now what is going to happen is that you'll be able to see it just count the number of elements, and obviously after inserting this banana, right now if you see inside my fruits, there are 2 bananas, right? 2 banana and banana. So it is just counting that how many number of items in this specific in this particular list it is there, right? So here I'm just showing you different inbuilt functions just by using a list of items, and here you can see I've shown you a lot of coding with respect to this. Okay, now I may also do something like this. I may sort this entire list of items. So if I go ahead and write fruits.sort, so here you'll be able to see now if I go ahead and print this fruits, you'll be seeing apple, banana, banana, cherry, guava, kiwi, watermelon. So automatically based on, so in short, this will sort the list in ascending order. Okay, it is just going to sort all the list in ascending order. And finally, here you have fruits.reverse. Reverse is another function which will reverse all the elements over here. Now, if I go ahead and do this, right, now you can see all the list of the elements will basically get reversed, right? So this is nothing but it reverse says the list. Okay, and just I'm showing you what all different inbuilt functions are basically present over here. Okay, and then finally, if I want to clear the entire list, I can go ahead and write fruits.clear, right? And now if I use this inbuilt function, so this will remove all items from the list. Okay, now if I go ahead and print fruits, so here you can see I'm getting an empty list. So till now we have discussed about mainly if I go ahead and show you with respect to the video outline, we have understood about creating list, accessing list items, modifying list elements. Then we discussed about list methods. Now we are going to discuss about slicing list. So let's go ahead and discuss more about slicing list. So guys, now let's go ahead and talk more about slicing list. So before that, I will go ahead and make some cells. So there is a shortcut. Just press escape and A. You'll be able to create as many number of cells as you want. Okay. Now what I'm actually going to do is that I am just going to take this numbers. Okay, so I'm defining these numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I will just go ahead and write some print elements. Let's say print numbers 2:5. Okay. Now let's talk about more numbers. Oops. :5. Okay. I didn't close this bracket, so that is the reason it was giving me an error. No worries. I'll go ahead and write print numbers 5:, and along with this, we will also go ahead and see print numbers : 2. Okay. double colon. So here we're also learning about double colon. Single colon, I'm just giving you an idea about it, but we'll also see with respect to double colon, and then we'll also go ahead and print numbers double colon -1. Okay. Now just pause for a second and just try to imagine in your mind like what will be the specific outputs. Okay, and then we will discuss further. Okay. So here you can see 2 colon 5 is very simple. 0 1 2 from 2 to 5 elements. So 2 3 4 5 is basically getting displayed. 0 1 2 3 4 5. So this 3 elements will get displayed. Colon 5 1 2 3 4 5 will get displayed. So it is basically coming over here till 5. Then you have 6 7 8 9 from 5 colon to till the end. Now this is very much important. Double colon 2. What does this basically mean? And double colon 2 basically means from all the elements from first. And this 2 will be taken as a step size, right? So we will jump 2 steps ahead. Like from here we'll jump 1 2, then 3 will get displayed again. Jump 2 steps, 5 will get displayed from again from this jump 2 steps, 7 will get displayed again. Jump over here, 9 will be getting displayed. So double colon. See, if I really want to make you understand about double colon, so I will go ahead and write double colon. Double colon basically means all the elements, right? Now if I'm writing, okay, fine, let's give the step size as 1. Then also I'll be getting the same output. If I give the step size to 2, so double jumps will be happening, right? This is basically the step size. Then if I write 3, then again 3 steps, like from here 1, 2 jump, and third, whichever will be the element that will get displayed. So 4, 7, 10, right? So I hope you got an idea about it. Now double colon 1 basically means what? Okay, so double colon is nothing but it is all the elements -1. Okay, from previous, take all the elements 1 by 1 and display it. If I go ahead and again write something like this, let's say I go ahead and write numbers, okay, double colon -2, right? So from back every 2 numbers, right? It'll skip every 1 number and display the other number over here, right? So this is basically called as a slicing, and some of the operations will be involving slicing whenever we want to retrieve some results, we want to modify them, do something, right? So we can actually use it, right? Now coming to the next thing is iterating over list. Okay, now I've already shown you how to iterate over strings. Similarly, you can also iterate over list, right? So for that also again I will be going and using for loop. Let's say I will go ahead and write for fruit in fruits, right? And I'll just go ahead inside and print all the fruit items that I have, right? So here 1 by 1 right now no fruit items is present or what? Okay, I've cleared that fruits, right? So let me do one thing. Let me just take numbers over here so that I'll be able to see through it, right? For number in numbers, right? So numbers is also a collection over here, list of elements. So 1 2 3 4 5 6 7 8 9 10. Okay, so this is also there. Let's say I want to iterate all this list with indexes also. So I want to iterating with index. So for this, I can use for index comma fruit index, sorry, for index comma number in numbers. Now once I use these numbers, right? Obviously, see, if I'm directly using this number, I know this is a list. But if I want index information also, I have an inbuilt function in Python which is called as enumerate. Okay, and if we specifically use this enumerate, that basically means we are also going to get the index number. So if I go ahead and print index comma number, now you'll be able to see all the indexes. So this is my 0th index. The first element is present in the 0th index. Then I have 2, which is present in the first index. Then 3 in the second index, 4 in the third index, 5 in the fourth index, 6 in the fifth index, 7 in the sixth index, 8 in the seventh index, 9 in the eighth index, and 10 in the ninth index. So I have all these things, and just by using this inbuilt function, you get an access of the index number also, along with the list of elements that are present in that particular list. Okay. So this is one amazing thing about you can also iterate over the list. You can also iterate along with the index, right? Now let's go ahead and talk about one more amazing thing, which is basically called as list comprehension. Okay. Now list comprehension. Now guys, let's consider that. I want to do something, right? I want to probably let's say I'll write a for loop for x in range. For x in range, let's say I'm going to write 10. And here, what I'm actually going to do is that I'm going to probably create a list element. Let's say I'm going to create a list empty elements, and then I will go ahead and write list dot append. And let me just go ahead and do this. Okay. So just imagine what I've actually done. Here inside this for loop, I'm squaring every number and I'm appending in this particular list, right? And finally, I can go ahead and print this particular list. Okay. So in short, this is a code that I've actually written to square every number inside this particular range of numbers, right? So I'm getting 0, 1, 2, 4, 9, 16, 25, 36, 49, 64, 81. Now see, imagine in this line of code, right? I've written 3 to 4 lines, right? Over here, I first of all initialized an empty list, then I'm putting a for loop, then I'm performing the specific operation. What if I can perform this entire list operation, because everything is happening inside a list itself, and we are creating a new list also over here, right? Obviously, if you're creating more list, again new list over here, again playing with different elements, more memory will be required. So Python actually helps us to play with list comprehension. Now in list comprehension, it tells you that you can perform all this operation, right, within a list itself, right? So now see this, observe over here. Now I will go ahead and write for x in range 10, right? So here, if I go ahead and execute this, okay, right now it is giving me an error because it is invalid syntax. I get it. Okay. Now let's do this. Okay. So first I've written for x in range of 10. So this is basically iterating through this. Now the next thing is that what kind of operation I'm performing. So I want to perform x square. So here, if I go ahead and write x square. So list comprehension basically has 2 important things. What we want as an output and what is the kind of operation that we are doing, right? So see, this is doing some kind of operation, so that needs to be displayed, and this is basically my iteration. So both of them are combined. If I go ahead and execute this, you'll be able to see that in a single list, I'm able to get the specific answer. So here, what did I do? I did not have to create other list item or list elements as such, right? All I did is that I probably executed my code within a line of code, and what I really want is x square. I've written it in forward, right? Now let's go ahead and see more examples with respect to list comprehension. So guys, we have just seen one example, and I know that you may be having some kind of confusion. So it is a better way that if I really want to make you understand about list comprehension, first of all, let's talk about a specific syntax, like what kind of syntax we specifically use. Okay. Now basic syntax. Okay, let me just make this as a markdown. Okay, markdown over here. Okay, list comprehension. Okay, and this is important, so that is the reason I'm also going to show you the syntax over here. Okay, first of all, the basic syntax. Okay, now basic syntax is nothing but it looks something like this: expression for item in iterable, right? So that is what we have done for item in iterable, which is traversing everything, and this expression is going to perform on all the single items. Okay, this is the basic syntax. Okay, now I may also have other option like with conditional logic. Okay, if I want to apply some logic over here, so with conditional logic, the expression looks a little bit different. Okay, and let me just show you this particular expression also. Okay, so here you can see expression for item in iterable. If condition also I can put. So I'm putting if condition over here. So any kind of conditional logic is there, you have to probably put it at the last. Whatever iteration you really want to do, you want to put it in the center, and any kind of expression that you want to perform, you can put it in the starting. Okay. Now, based on this, we will try to see some kind of example. Okay. So, but remember this is super important. Okay, and you have to use with respect to this itself, right? So let's consider one example. So let me go ahead and write basic list comprehension. Okay. Let's say I want to do a square of all the number. Okay. Square of all the number. Okay. Square of a set of numbers. So I will write for x or for num in range of 10, right? And for every of this number, I just need to do num square, right? Square. Done. Now, if I go ahead and print this, in short, what I'm actually going to get, I'm going to basically get the square of this number. Now, what condition I've applied over here? Basic syntax for item in iterable, and then I have expression. Okay. Now, coming to the next one. Okay. Let's consider with list comprehension with condition. Okay, a specific condition over here. Okay, and let's say I will try to find out from a list of elements which are basically even numbers. Okay, which are even numbers. Now, let's say if I go ahead and write in for loop for I in range 10. Okay, if I go ahead and write if I colon 2 is double equal to 0, right? Then what I have to do? Print, or I will probably create a list and I'll append all the even elements, right? So let's say I have created a list, an empty list over here, and now what I'm actually going to do? I'm going to basically write list dot append, and here I'm going to basically write my I, right? So finally, if I go ahead and print my list, you'll be able to see that all the even elements will come, right? Till this particular 10 number, right? But here, you need to see, how do I convert this into list comprehension? And I showed you one expression with conditional logic. Expression is over here for item is here, and if condition is over here. Now, the same thing, I will try to convert this into list comprehension. So I will write for I, or for num in range 20, okay, or 10, okay. I have to display the number itself, so I will write number. I don't need to even apply any expression. But here, I will go ahead and write one if condition. I will say, hey, if num percentile 2 or modulus 2 is double equal to 0. Now, this basically becomes my even underscore numbers, right? Now here I do not have to even create a new list, right? All I'm doing it in one single line of code. So this way my execution will happen quicker, right? It'll be faster. So I hope you are getting this as an idea. Okay. Now one more thing is there. Okay, one more very important thing is there, which is again a type of list comprehension you can basically say, which is called as nested list comprehension. So let me just go ahead and write it down. So here you have something called as nested list comprehension. Okay, and it is good to know all these things, guys. I'm trying my level best so that you'll be able to understand multiple things. Okay, so here you can see, and here you can see. Now, what is so different when compared to this? Okay, now here we are iterating through two different iterables. So for item in iterable 1, for item 2 in iterable 2, then we are writing an expression. So that basically means if I have two lists, and then on top of that two lists, I want to perform any kind of list comprehension, then I can use this nested list comprehension. So let me show you one perfect example. Okay, let me just go ahead and write it over here, and let me write it as nested list comprehension. Okay, comprehension. So let me go ahead and create my list 1, and this will be 1, 2, 3. Okay, or I'll take one more element 4. Let me say this is my list 2, which will be nothing but A, B, C, D. Okay, so these are my 4 elements. Now let me do one very simple thing. Okay, I will try to make a pairs of list 1 and list 2 elements. Okay, so first of all, I will iterate through list 1. So let me just go ahead and write for I in list 1. Okay, then I will iterate through list 2 for J in list 2. Okay, and then I have to pair it, right? Now for pairing, I'll be using a tuple. I've not discussed yet about a tuple, but I'm just going to take this I and J and pair it together. Okay, just write it in this way. Okay, now you can see, or if you don't want to write like this, you can also use list over here. Okay, let's see whether this will work or not. And now I'm just going to print pair. Okay, appear have written pair. Okay, so here you can see 1, 1, B, 1, C, 1, D, 2, A, 2, B, 2, C, 2, D. So it is just doing all the pairing: 1A, 1B, 1C, 1D, 2A, 2B, 2C, 2D. So this is what is happening. First of all, this will iterate, right, with respect to one element, then it will iterate all the elements, right? We can also write this in this particular way also, right? But again, a lot of lines of code we really need to write. But this is really, really powerful, and here you can actually see with the help of nested list comprehension, we are able to do it, right? Now, in Python also you have a lot of inbuilt functions, right? So we can actually use list comprehension with function calls. You can create your own custom function and all, but right now I'm going to show you some inbuilt functions. Okay, so inbuilt function we'll try to see. So list comprehension with this. Let's say, and I'll show you the code over here. So here I have words like hello world Python list comprehension. Now see, everybody focus. So I'm writing for words in words, and I'm just saying length of word, right? So it's just going to give us the length of word over here, right? And how easily we are able to see this particular output, right? And this looks amazing, right? And most of the things are basically very much simple over here, right? Now there is also one more list comprehension technique where you can use else block also. So I will give you that as an assignment. Please make sure that you do it. But don't worry, as we go ahead and learn more about the tuples and all, there also we'll be covering more about it. But I hope you got an idea with respect to list comprehension, and this was all about the discussion with respect to list. And I think I tried my level best to cover almost each and everything. Okay, and at the end of the day, you really need to try more and more to understand more examples. Unless you don't practice, I don't think so you'll be able to do any perfection in this, right? So more examples, more things. But at the end of the day, I would like to give the conclusion of this lesson and probably talk about it, because list is something really important. So the list. So here you can see I have given some conclusion with respect to the list comprehension. Powerful and concise to create list in Python. They are syntactically compact and can replace more verbose looping construct. Understand the syntax of list comprehension will help you write cleaner and more efficient Python code, right? So yes, this was it. I will see you on the next video where we'll be talking about the next data structure. Thank you. Hello guys, so we're going to continue discussion with respect to Python, and in this video, we're going to see some amazing real-world examples using list in Python. Now guys, you may be using a lot of applications, you may be using a lot of apps, some or the other way, there are many smaller modules where specifically list can be used. So over here, I'll be showing you some of the examples. Yes, we are not going to develop a complete end-to-end project like kind of thing, but it's more about understanding what applications, specifically this kind of data structures list is used. Okay, so the first example that I'm actually going to do is something called as manage a to-do list, right? So we will try to create a list which will keep the track of all the tasks that you're planning to do. Okay, so let's say I will just go ahead and create a variable to-do list. Okay, and inside this, let's say today my task is I've opened my app and I've probably selected, okay, today I need to buy groceries. Let's say I need to buy groceries. The second task that I really want to do is that clean the house, okay, which is necessary, clean the house. And let's say the third task that I have is something called as pay bills, right? Now, let's say after some time, I had to get some kind of task. I got some more task, and now I want to add that particular task to my to-do list. So right now in the to-do list is already a list, so we know some of the inbuilt methods that we have already discussed, like how we can make sure that how we can add more tasks in our plate, right? So what I will do, I will just go ahead and use this to-do list dot append, right? And inside this append, I can probably go ahead and say, okay, schedule meeting is one of my tasks. I need to schedule a specific meeting with someone. Okay, so this can be one of our tasks. And after finishing my work, let's say I want to go to a run, so I will go ahead and append another task over here, something like go for a run. Okay, go for a run. Okay, so this is my another task that I really want to do. Let's say that I have done out of all these tasks, I have started my day, and the first task that I've actually done is clean my house. Okay, so what I will do is that after I probably in my app, after I complete this particular task, I will make sure to remove that particular task. And once I removed, right, a completed task in the backend, what kind of code will be written? So from my to-do list, right, which will be in the session. We'll talk more about session and all. I will just go ahead and remove clean the house task over here. So I will just go ahead and copy this entire thing, and I will just go ahead and say, hey, this is completed, so please remove this particular task from my list. And then let's go ahead and check, okay, whether this particular task after removing it is present or not. So here I'll say checking if a task is in the list, okay, and here I'll say, hey, if let's say pay bills is there, okay, pay bills is there in the task, okay, in to_do list, then I will say print. I'll send a reminder for me, hey, don't forget to pay the utility bills. Let's say this is my utility bill, okay, utility bills, okay. So this is just like a reminder that I'm actually getting. And let's say after finishing all the work, how many tasks I really want to probably, how many tasks are remaining if I want to print it, right? So I'll just go ahead and write print. This is my to-do list that are remaining, to-do list remaining, and I will just go ahead and print for task in my to-do list. Print. Let's go ahead and print with the help of f string. F is basically a formatting string, and this will just go ahead and display my task, right? Now, obviously, I'll be able to see that from my task, this clean the house should not be there, and I should have this both the tasks that should be appended in my to-do list. So let me just go ahead and execute it. So here you can see, hey, don't forget to pay the utility bills, because I got a reminder saying that over there, because pay bills is still there in my to-do list. Then the remaining to-do list that are remaining, that are like buy groceries, pay bills, schedule meeting, go for a run, right? So all these specific things are there, and I will be able to keep a track of it. So extensively, I know in a bigger application, you'll be seeing that a to-do list specifically uses list, because with the help of list, you can actually remove it, you can add it, you can append a new task over there, and everything can be created through it, right? So whichever programming languages you specifically go ahead with, list will be a common data structure that will be used extensively. Okay. Now let's go ahead and see another example. So here you have something called as organizing student grades. Okay, and now I will just go ahead and copy and paste it over here, code for you. So here you can see organizing student grades. So I have some grades over here, 85, 92, 78, 90, 88. So I'm adding a new grade. Let's say a new grade has actually come. So I'll go ahead and append a grade inside this. Then we'll go ahead and calculate the average grade. So this is my average grade. Find the highest and the lowest grade. Let's say by using inbuilt function like max of grades, I'll be able to get the highest grade. And another inbuilt function by min, I'll be able to get the lowest grade. So this is how I will be able to see my highest and lowest grade, right? So such a simple example, but here you can also see that extensively list is basically used. And just by using this inbuilt function like sum, right, which will basically get applied in a collection, specifically in a list, right over here, you'll be able to see that I'm able to calculate sum of grades, length of grades, and then I'm able to calculate the average one, right? So this is another one example with respect to organizing student grades, and here you can see average grade is so much, highest grade is so much, lowest grade is so much. So that is what I'm actually doing to calculate the average of the students. Okay. Now one more example that I've actually taken is managing an inventory. Okay. So managing an inventory basically means I'm trying to just manage an inventory whenever we do an e-commerce site. Inventory is the major thing that will be managed by the entire company itself, right? So here you can see. Let's say in my inventory I have apples, bananas, orange, grapes. Okay, so these are all items that is present in my inventory, and then I'm adding a new item which is called as append strawberries. Okay, now with respect to this particular strawberries, this is a new item that has come, and I'm appending it. Whenever there is one item that has been ordered by someone, so once we deliver it, we have to remove that particular item. So we have removed that particular item called as bananas. Let's say bananas was ordered by someone, so I've just removed this. Okay, after the delivery done, checking if an item is in stock. So if I'll say item is called oranges, if this item is present in inventory, I'll go ahead and say, hey, they are in stock, otherwise they are out of stock. Then we can go ahead and print the inventory. So here you are able to see that we are able to manage everything in the form of list. Yes, the scale of data will be quite huge, but internally these all data structures will be specifically used. So this is another one amazing example. So if I go ahead and execute it, here you can see oranges are in stocks since oranges are already present over here, and then inventory list you can actually find apple, oranges, grapes, and strawberries. Okay. Now this was one more example, a good one. Now I hope you are able to understand what all beautiful use cases are definitely there. Now this one I'll just give you the task. Please go ahead and explore it. Okay, and just try to see whether you're able to understand it or not. Okay. So this is the code collecting user feedbacks. Use a list to collect and analyze user feedback. So here is my user feedback. Great service, very satisfied, could be better, excellent service. Let's say another feedback is added, not happy with the service. Okay. So we are just counting the specific feedback. So I'll say one for comment in feedback if great in comment.lower. Okay. Now see here we have also used something amazing, right? So I'm saying for comment in feedbacks, we're exploring it. Okay. If a great word is present in that comment. Okay. If in all these comments great is present, so we are just going to do the summation with respect to one. Like if anytime great is present, I'm going to take one, right? Or excellent in comment order, right? So we are just going to do how many number of times great or excellent is present. We're just going to keep on adding it. Okay. So here you can see positive feedback count we are able to get. So this is the variable, and then finally you can see print user in feedback, comments in feedback, and we are printing it. I hope you are able to understand. So over here with respect to the output, positive feedback count is 2. That basically means if great and excellent is present over here, we're just going to count it down. Okay. So 2 times we have actually found out. So user feedback like great service, very satisfied, could be better, excellent experience, and the last feedback was not happy with the service, so that is also appended over here. So these are some of the beautiful examples, and again, list is something I think the most common data structures that may be used everywhere. Probably whenever we are working with large applications. So I hope you understood the video. I hope you got an idea with respect to the real world example, and this was it from my side. I will see you in the next video. Thank you. Hello guys, so we are going to continue the discussion with respect to Python, and in this video we're going to discuss about a new data structure which is called as sets. Now, first of all, we'll see the definition of sets, and we'll see a lot of example along with methods and what is the importance of sets altogether. But one of the most common data structures we specifically use sets after probably list and dictionaries and tuples, right? So that is the reason why I'm covering this data structure. So we'll be seeing a lot of examples in short. So first of all, let's go ahead with the definition. So here you can actually see sets are built-in data types in Python used to store collection of unique items. They are unordered, meaning that the elements do not follow a specific order, and they do not allow duplicate elements. So they are some of the very important points. So please make sure that before you start any of the lessons, see the definition. Sets are useful for membership test, eliminating duplicate entries, performing mathematical set operations like union, intersection differences, and semantic differences. Now all these things what we have actually learned, we'll see with the help type of practical example. So first of all, I'll go ahead and make a lot of cells over here. Okay, so let's start. So first of all, the first thing that we're going to discuss is how to create a set. Okay, and creating a set is specifically using curly braces, like how we actually did in the dictionary. But only one difference that is present between sets and dictionaries is that in dictionary we usually give key value pairs, right? So let's say if I'm going to define my underscore set over here. Okay, so I will just go ahead and use curly braces, and I'll just go ahead and write 1, 2, 3, 4, 5 elements. Okay, and if I go ahead and print my set over here, and also see the type of my set, then here you'll be able to see that, hey, I'm able to get it over here, something like this. See? So all the elements is basically getting displayed, and over here you can actually see that it is a class set. Okay. Now, if I also want to go ahead and create my empty set, so here I can go ahead and write my empty underscore set. Okay. I can directly use the class, okay, something like this. So if I go ahead and create like this, then I'm going to get my empty set itself, right? So I'll just go ahead and print it. So here you can see the type is nothing but it is a class set, but since I've not put up any elements, so over here you'll be able to see that it'll be an empty set. Now along with this, what I will do, I will just go ahead and copy this, and let's say that inside this set I can give tuples, I can give list, and also if I go ahead and give 1, 2, 3, 4, 5, 6, I will probably execute this also. Okay, so let's go ahead and print this right now over here. Okay, and let's see the sets, right? So this is one of the most easy way, probably take a list or tuple and just typecast with the help of set class, right? And here you'll be able to see that I'll be able to get the set. Now one of the functionality that I've actually told you over here, right? Sets are nothing but it is built-in data type used to store collection of unique items. Okay, so what does this basically mean? So if I go ahead and copy this and execute it, so let's say this is my set itself. I'll not say my empty set because now we have elements. Okay, and here also I'll just go ahead and remove this. So let's say that this is my set, right? Now let me just go ahead and write some duplicate elements. Let's say over here I'll go ahead and write 6, 5, 4, 5 to 6, right? Now even though I have duplicate elements, what it is going to do is that it is just going to ignore the duplicate elements and take only one element of the similar type, right? So here you can see 6 and 5 are duplicate elements. So what it will do, it will just display 1 time 5 and 6. So if I go ahead and execute it, here you can see that I'm getting 1, 2, 3, 4, 5, 6, right? And as said over here, you can see they are unordered, meaning that the elements do not follow a specific order and they do not allow duplicate elements. Okay, sets are useful for membership test and all. We will have a look onto that. Okay, so now let's go ahead with some of the basic set operations. Okay, basic set operations. Okay, now with respect to basic set operation, the first thing that I'm going to show you is adding and removing elements. Okay, adding and removing elements. Now in order to add and remove the elements, I can probably, let's say this is my underscore set over here. Let's say I want to add more elements over here, right? And then I'll try to print it. So for that, what I have to do is that go ahead and use my add method. And let's say here I'm going to add a specific element over here. Let's say 7. I'm going to go ahead and add it, and I will just go ahead and print my underscore set. Okay, so if I go ahead and execute it, here you'll be able to see 1, 2, 3, 4, 5, 6. Okay. Similarly, if I go ahead and add the same element, okay, then you know what it will happen. Then it is just going to ignore the repeated elements because I have already added that in the set. So here also you'll be able to see that I'm going to get 1, 2, 3, 4, 5, 6. Okay. Now coming to the removing the elements. So in order to remove the elements from a set, okay, from a set. So what I'm actually going to do, I'll just go ahead and write my underscore set dot remove. Okay, my underscore set dot remove. And here I'm going to specifically use one element, let's say 3, and I'll just go ahead and print my underscore set. And now here you can see that the third element is already not present. Okay. Let's say what happens if I try to remove an element which is not present at all? Okay, so for that, let's say I'll go ahead and write my underscore set dot remove. Okay, remove of element 10. Okay, so if I go ahead and execute it, it shows that hey, there's a key error because I don't have that specific element. Okay, now there may be scenario that I need to have a scenario that if an element is not present in the set, it should not give us an error. Okay, it should just continue. If there's an element, it should remove. Otherwise, it should not give us an error. So for that, what I will do, I'll just go ahead and run my underscore set dot discard, and let's say inside this I'm going to remove an element called as 10 or 11, whatever. And if I go ahead and execute it, here you'll be able to see that I'm not getting any error, right? Even though I go ahead and print it, right? So print my underscore set over here, and here you can see 1, 2, 3, 5, 6, 7. So that basically means if I'm using this discard method, right? It'll just go ahead and see remove an element from a set if it is a member, right? If that particular element is there, it will remove. Otherwise, it'll just make sure that it will not give us an error. Okay. Now removing a random element, right? Using pop. So here we also have something called as pop method. Let's see what is exactly this pop method, right? So for pop method, I will just go ahead and write this is my removed element. Okay, and then I'll just go ahead and write my underscore set dot remove. Oh, sorry, dot pop. My underscore set dot pop. Okay, and what I'm actually going to do, I'm just go ahead and display my print removed element first of all. Print removed element, and then I'm also going to print my underscore set. Okay, so here if I probably go ahead and display it, right? So over here you can see with respect to set, it is just like first in first out, right? So whatever element is first inserted, that element only will get removed. So that is the reason why I'm getting is something like 2, 4, 5, 6, 7. Okay, so here you can see that whenever I have an element, I should be able to remove it just by using pop, and I'll also be able to get the element itself. Okay, and finally, if you really want to clear all the elements, okay, all the elements, you can just go ahead and write my underscore set dot clear. Perfect. And here you can go ahead and just print the set. Okay, so this will basically be my print my underscore set. Perfect. So if you see this, if I execute it, here you can see that I'm actually getting an empty set altogether. Okay, now let's go ahead and see some more examples. So first of all, I'm going to show you set membership test. Okay, membership test. Okay, now with respect to membership test, it's just like whether an element is present in the test or not, whether an element is a member of a set or not. That is what we will basically check. So I'm going to write for my underscore set nothing but 1, 2, 3, 4, 5, and here I will just go ahead and write print, let's say, and here we'll use an in operation, right? Let's say I'll take an element 3 in my underscore set, right? So here if I go ahead and print it, or if I go ahead and print 10 in my underscore set, right? So if the element is basically present in set, it is just going to give us true, otherwise it's going to give us false. So that is the reason here you can see when I'm checking whether 10 is present in my set or not, I'm actually getting false. But when I'm checking 3 is in my set or not, so here I'm actually getting true, right? So that is the reason it's just checking whether this particular element belongs to that particular member or not. Now let's go ahead and see some more mathematical operations. Okay, now in this particular case, let's say I go ahead and create my set 1. Let's say it'll be 1, 2, 3, 4, 4. Okay, I'll have 4 elements. Okay, just to give you an idea over here, and or let me just go ahead and write something like this: 4, 5, 6. Let me add more element, and this will be set 2. Okay, and inside the set 2, let me just go ahead and write from 4. Let's say 4, 5, 6, 7, 8, 9. Okay, so these are my basically all the elements. So first operation that we're basically going to discuss is nothing but union. Union basically means when I have two sets, I'll just combine all the elements, right? So in order to get the entire union set, so here in set also you will be able to see that I will be having a lot of inbuilt methods. Okay, so there is something like difference update, and is law is this is there, and let's say symmetric difference is there, symmetric difference update is there, union is there. So I'm just going to write say set 1 dot union, and here I'm going to specifically use set 2. Right now, if I go ahead and print my union underscore set, you'll be able to see that I will be able to get the output. So I'm getting an error because of syntax. So here you can see all the elements has been combined. Union basically means you're combining everything. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so this is one of the operations, most common operation that we do in sets. The next operation that we are basically going to do is something called as intersection. Now intersection is nothing but it will basically give us a common set, common elements from both the sets, right? So here I'm going to probably create the intersection underscore set. Let's say I'll just go ahead and write. So here you can see set 1 dot intersection of whatever y will not be there. Here I'll just go ahead and write set 2. Okay, set 2. Okay, set 2. Okay, now if I go ahead and print my intersection set, so here let's go ahead and see this intersection set. Here we'll be able to see only the common elements it will be able to give. So 4, 5, 6 are common, available in both the sets. So that is the reason it is basically getting displayed. Let's see one more operation. I don't know whether it is present or not. It is called as union. Okay, so only union is present over there. No worries. Okay, let's do one more thing. Let me just go ahead and write something like this. Set 1. Okay, set 1 dot intersection update. Okay, so we'll try to see this. Okay, what is this function called as intersection update? Okay, and here I'm basically going to give set 2. Okay, so here the kind of operations that we are actually doing, and if I go ahead and print my set 1, okay, if I'm going ahead and printing my set 1, please focus on this. Okay, let's see this. What will be the third print? Right, first print, you know, it will be the union. Second print will be the intersection, and third print whenever we use intersection underscore update of set 2. Now if I just go ahead and print it, here you'll be able to see now when we did this intersection underscore update. So whatever are the common elements from set 1 and set 2, that we got it, and that all elements got updated in set 1. That is most important that you really need to understand over here. Intersection underscore update basically means whatever operation, specifically intersection we are doing over here, it will just find out the common elements and it will update in the set 1. So that is the reason I'm actually able to get 4, 5, 6 when I'm printing set 1. Okay, so please make sure that you keep this in mind, and whenever we do intersection or difference, there will also be a difference underscore update, intersection underscore update altogether, right? So this is why I have actually showed you one example. Okay, so please make sure that any operation underscore update basically means we'll perform that operation and we'll update in one of the sets itself, right? So I will go ahead and create my another set 1 and set 2. Now this time let me go ahead and create difference, right? Difference operation, let's discuss. So if I go ahead and write set 1 dot difference of, again I don't know why this is giving us x and y, I think by default it's taking us, and then we go ahead and write set 1 dot difference of set 2. Now if I go ahead and print the element of this. Okay, so here we'll be able to see set 1 minus difference of set 2. Set 1 dot difference of set 2. That basically means from set 1 we will remove the common elements that are present in set 2. So here you can see 4, 5, 6 has been removed, and here I'm actually able to get the output as 1, 2, 3. Okay, there's also one method, as I said, difference underscore update. Difference underscore update basically means it will perform that operation difference and it will update in the set 1. So in set 1 I'll be able to see right now it is if I probably see right now it is set 1 is nothing but it is having all these elements 1, 2, 3, 4, 5, 6. But when I do difference underscore update, there's a method over here. It is going to make sure that it updates this difference operation whatever output is coming in set 1. Okay, this is the basic difference. Now let's do one more thing, and again see if I want to remove all the common elements from set 2, I can also go ahead and write something like this, set 2 dot difference, set 2 dot difference over here, and here I will just go ahead and write my set 1. So whatever is my element that is available in whatever is my unique elements or remaining elements in set 2, and set 1 elements has been removed because 4, 5, 6 is the common element over here, right? And that is the reason I'm actually getting it over here, right? So I hope you are able to understand till here and all. One more operation that we are going to discuss is nothing but symmetric difference. Okay, and let's see whether you will be able to understand what exactly this is. So if I go ahead and write set 1 dot symmetric difference, okay, of set 2. Okay, let's see. Now, if I go ahead and execute it, here I'm able to get 1, 2, 3, 7, 8, 9. That basically means both the unique elements from both the sets are combined. Common elements are just removed. Okay. So this was some of the mathematical operations that we probably perform. Again, I'll repeat it. Symmetrical difference is nothing but from set 1 and set 2, which are the common elements, only that will be removed, and remaining all the unique elements from both the set will be combined. Okay. So that is when the intersection elements is just removed over there. Okay. So that is what symmetric difference basically means. And you can also do the vice versa. Set 2 dot symmetric underscore difference of set 1. You'll be able to get the same answer. Okay. Now let's do one thing. Let me go ahead and make some more cell. Okay. I'll go ahead and make some more cell, and let's discuss about some of the sets methods. Okay, again important one. You may be using some of the other thing over here, right? So first of all, I will just go ahead and create my set 1. Let's say I'm going to write 1, 2, 3. Okay, 3 elements are there. In set 2, I'm just going to write 3, 4, 5. Right? Now, first of all, we will go ahead and see what is subset. Okay, is subset. Now with respect to is subset, I will just go ahead and print set 1 dot is subset. Okay, set 1 dot is subset of set 2. Okay. Now once I do this, you'll be able to see we are just checking whether set 1 is a subset of set 2 or not. Is subset basically means all the elements that is present in set 1, is it also available in set 2? Is this the parent I can say is it the parent set which has all the elements of set 1? So right now here you can see that I don't have it, right? Because set 1 is not available. One of the elements is also not available in set 2, right? So if I just go ahead and execute it, here you can see it's false. Okay. The next one is just to check whether set 1 is a superset of set 2. Okay. So if I go ahead and write set 1 is superset of set 2. Is it a superset of set 2? I'll just go ahead and print it, and here you'll be able to see that I will be able to get the answer. So here right now it is false. Again, set 1 is not a superset of set 2. It checks if set 1 is a superset. Superset basically whether it has all the elements of set 2 or not. Okay, so this is also false because it is not. Let's say if I go ahead and write like this 3, 4, 5. Now if I execute it, here you can see set 1 is not subset of set 2 because here there are more elements. But if I go ahead and write set 1 is superset of set 2 because this 3, 4, 5 is also available over here, you can actually see, right? If I just remove 5 also, then also you'll be able to see both are false, right? It should at least have all the elements from either one of the set. Okay, so this is what is an example with respect to some of the methods that we use. Is set, it's superset, and again, guys, there are a lot of methods that are available in sets which you should definitely keep on practicing and keep on seeing. Okay, now let's do one kind of task. Okay, so here let's say I have some numbers. Okay, or I have a list. Okay, list, and with respect to this list, I will just go ahead and 1, 2, 2, let's say 3, 4, 4, 5. Okay, so these are my elements. Okay, now if I just want to quickly remove the duplicates from this list, okay, from this list, what I can do, I just have to convert this into a set. So if I go ahead and write set of listy, here you'll be able to see, hey, I am going to get all my unique elements 1, 2, 3, 4, 5. Right? So simple it is. If question is basically asked whether you really need to find out a list of elements, you can basically do that. Okay, now let's do one practical example here. What I'm actually going to do is that I'll just go ahead and write counting unique words in text. Let's say if I have a sentence text. In this tutorial, we are discussing about sets. Okay. So here it is. So I will just go ahead and I need to basically count unique words in text. How many unique words are basically there? And then we can basically do that. Very much simple. So here, first of all, what I will do, I will just go ahead and create a variable words. I will take this text and I will do the entire split. Okay. I will get all the elements over here with respect to the split, and then you will be able to see convert list of words to set. Okay. To get unique words. Okay. Unique underscore words. Okay, unique underscore words, how do we get it? We just need to use set of all these words. Okay, whatever words we are specifically given. Okay, So once I get the unique words, I will just go ahead and print it, print unique words, and then after that, I'm also going to print the length of the unique words. Length function is there, and let's just go ahead and write length of the unique words. Okay, if I go ahead and execute, so tutorial we discussing this in about sets R, right? So 8 unique words are specifically there, and here you can actually see that how I actually printed it, right? Simple. So I hope you liked this particular video with respect to sets. We have almost discussed each and everything like common key methods, errors, what kind of errors you feel, and what are the common functionalities, methods with respect to the sets. So I hope you were able to understand this particular session. I will see you on the next video. Thank you. Take care. Hello guys, so we are going to continue the discussion with respect to Python, and in this video we are going to discuss about our next data structure which is called as tuples. Already in our previous video we have seen about list, and we had written a lot of code. If you probably go ahead and show you, we had written somewhere around 54 lines of code. We understood about list comprehension, we saw different methods, operations, and many more things. Now in this session, what all things we are going to discuss, so I have actually given you the brief outline of the video. First of all, you're going to understand about tuples, how to create tuples, accessing tuple elements, tuple operation, what is this immutable nature of tuples, and what are some of the tuples, common tuple methods that are used, how to pack and unpack tuples, nested tuples, and all these things we are going to see with a lot of practical example. Now before I go ahead, first of all, let me just give you a small definition about tuples, right? So tuples are ordered collection of items that are immutable, right? So we'll understand about this particular meaning, which is called as immutable. If I talk about list, it is an ordered collection of items, and the items can be of any type, and they are mutable, right? But here it is something like immutable. They're similar to list, but their immutability makes them different. Now, first of all, we'll try to understand how to go ahead and create a tuple. So for creating a tuple, right, we have to just use this two empty brackets. So let me just go ahead and write it over here. So this is my empty tuple, okay? And just by using these two brackets, right, I will be able to create it, right? And if I go ahead and display the print, let me first of all print this empty tuple, and then we will also go ahead and display our type of this particular empty tuple, okay? So here you have this. If I execute this, you can see this is an empty tuple that is getting created. In list, we use two square brackets. In this, we are just using this rounded brackets, right? And then over here, you can see that I'm getting an empty tuple, which is completely empty. And if I go ahead and see the type of empty tuple, it is nothing but tuple itself, right? Now, if I probably consider list, right? So list, if I also use like this, right? And if I go ahead and create an empty list, so I can also use this class directly and create an empty list, okay? So this I missed in my previous video, so I'm just going to show it over here. And similarly, if I want to probably create a tuple, let's say this is my tuple, I can actually go ahead and use the same type of class and create an empty tuple. So both the ways I'm actually trying to show you so that you understand both these ways, right? So here you can see when I'm seeing the type of this will be an list and this will be tuple, right? So you can also use this method in order to create an empty list or tuples, okay? Inside this also I can put up elements. It is up to us, right? Now let me go ahead and add some elements into this particular tuple, okay? Now how do I add this particular elements inside this particular tuple, and how to do that we'll be seeing a lot of methods, but here what I'm actually going to do, let me just go ahead and directly create a tuple, and if I go ahead and write tuple, okay, and here I can actually give a list like 1 2 3 4 5 6, okay, and now this list will basically get converted into a tuple. So if I go ahead and display these numbers here, you can see that I'm actually getting a tuple, right? So that basically means a list can be converted into a tuple, and even a tuple can be converted into a list, right? So if I go ahead and basically write like this 1 2 3 4 5 6, right? So this is my tuple itself. Now if I go ahead and write list and I close this particular bracket, so here you'll be able to see that I'm able to get a list, right? List of elements. So both of the ways you can basically do the type conversion, okay? Now as I said, in tuples also you can, let's say I'm going to probably go ahead and create my mixed tuple. Here also you can use different data type elements. Let's say I want to use numerical, I want to probably use string, I want to go ahead and use a floating point number, I can also go ahead and use my boolean variable, right? So now if I go ahead and print this, then also this will get created. The tuple will basically get created, okay? Now this is a basic information about tuple, how you can actually create and how you can proceed, okay? Now let me do one thing quickly. Let me go ahead and explain you about the next thing that we are going to discuss. It is nothing but accessing tuple elements, okay? Now for accessing tuple elements, what all things we really need to do, that we will be discussing, okay? Like I want to pick up any elements as such. So right now let me just go ahead and see this is my numbers. Now here you can see that this is in the form of tuples. I have 6 elements. Let's say I go ahead and write numbers of 0, okay? Or let me just go ahead and write it in the len line. Next slide. So if I go ahead and write numbers of 0, so here I'll be able to see first element over here. This is my first 0 thing. I'm able to see it over here. Then I have 2 over here. Also you can see I'm able to pick up these elements, right? Similarly, if I go ahead and say that I'm just going to print this, okay, I want to pick up the last element, okay, last element. Either you can directly write the index, or what I'm actually going to do, I'm just going to use -1, right? So I'll be able to get the last elements. Again, the indexing will be almost similar like a list. Even the slicing operation will be also similar like a list, okay? So let's say I go ahead and write numbers, and here I'll cite 0:4. That basically means I'll be able to get the element between 0 index till the third index. So same slicing operation, whatever things we have actually discussed. Similarly, if I go ahead and write numbers with double colon, right, I'll be able to see it. If I go ahead and write double colon -1, I'll be able to get the reverse of all the tuple values, right? But the return type will be always tuple, okay? So all the indexing and the slicing operation that we have actually done with the help of list, similarly you can actually do it with the help of tuples, okay? Then let's go ahead and see tuples operation. Tuple operations, okay? Now tuple supports various operations like concatenation, repetition, and slicing, okay? So we'll be discussing about that. Let's say I have numbers 1 tuple, okay? And I'd also created another tuple which is called as mixed tuple, right? So this were the elements, right? Now what if I just go ahead and write something like this, numbers plus mixed tuple, okay? So here in short, this is an arithmetic operation, but since we have 2 tuples over here, I will definitely say this as a concatenation, right? Concatenation basically means combining 2 things, right? So here you'll be able to see, I will just go ahead and write concatenation underscore tuple, and I will just go ahead and concatenate this. Now if I go ahead and print this concatenation, right? Concatenation tuple, you'll be able to see that I will be getting something like this. Now all this tuple, both the elements of this particular tuple has been combined. So I have 1 2 3 4 5 6, then 1 hello world 3.14 and 2, okay? Now let's say that I want to perform some operations, right? Let's say I want to go ahead and write something like this, okay? Repeated, or let me do one thing. Let me just go ahead and create this. So I will just go ahead and do, okay, or I'll take this mixed tuple, okay, and I will just try to multiply with an operation 3. Now see what will happen. So here you can see mixed tuple had 1 hello world 3.14 and 2. Now this has got entirely repeated 3 times, right? So in this kind of multiplication operation, what is basically happening is that the entire tuple is basically getting appended 3 times, right? So that is the reason we are basically doing an operation over here. So this is what is something different with respect to the calculation that we do. Now you may be thinking, Krish, what about if I try to do this with numbers, right? Numbers multiplied by 3. So here also the same thing will happen. So 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. You may be thinking, Krish, wasn't it like you have to probably multiply all these numbers? That also we can do it, but we have to iterate it inside this particular tuple, get each element, and then perform the numerical operation. Okay, but right now with respect to generic concatenation and this kind of operation, here you can see that 3 times, n number of times based on this multiplication that we are doing, that means number of times this tuple will get appended with respect to the element. Okay, so these are some of the basic operations. Now let's go ahead and discuss about immutable nature of tuples. Okay, this is important, of tuples. Now, in the immutable nature of tuples, you need to understand one thing, and that is the first point that you have already learned, right? Tuples are immutable, okay? Meaning the elements cannot be changed once assigned, okay? Let's say that I go ahead and create my list, and I go ahead and write 1, 2, 3, 4, 5, right? Now, let me do one thing, list of 0, or if I go ahead and print this specific list, I will be, okay, there is an error, don't worry. Okay, so here you can see I'll be getting the specific element. Now, let's see this, okay? Now, what I'll do, I will go ahead and take the first index and replace with it Krish, okay? Now I'll go ahead and print the list. Now see what will happen. So here we are changing the element, and this second index or this first index element has got replaced with Krish. So this basically means lists are mutable. That basically means the element can be changed once assigned. Now similar operation, if I try to do with the same numbers that we had, right, in the form of tuple, if I go ahead and say, hey, number of 1, what is number of 1, 2? If I try to assign some value, let's say I try to assign a value called as Krish. Here it says that, hey, tuple object does not support item assignment. And this is what immutability comes into picture. Tuples are immutable. The elements cannot be changed once assigned. Okay, so here you can actually see what I exactly mean to say, right? And this is very much important. That basically means once you have defined a tuple, you cannot change the element inside that, okay, once it is assigned. There are ways how you can do it. First of all, you can take the tuple, convert into a list, and then change the element, and then finally convert back again to the tuple if you want. Okay, that is how you can actually do. Okay, but by default, you'll be seeing that tuples are immutable. Perfect. So till here we have understood. Now let's go ahead and discuss about tuple methods. Okay, and now in this tuple methods, we will be seeing two important methods in tuple. So let's go ahead and see this. So let's say this is my tuple number. So one of the example that I would like to show you, or one of the method that is commonly used with tuple, and there are only two methods that we specifically use. Okay, numbers dot count. Okay, let's say I want to count how many number of times 1 is present. Okay, so let me just go ahead and see this, and it is only present one time. Let me just go ahead and make a code over here, and let me just display the numbers. I have 1, 2, 3, 4, 5, 6. Okay, so this count function is like it will just try to count how many number of times the element that I've given over here is present in the specific tuple. And the next thing is that I will go ahead and print numbers dot. Let me just go ahead and do one function which is called as index. Now let's say I want to understand what is the element present in the index third, right? And if I go ahead and execute here, you can see that in the third index 0, 1, 2, 3, right? Or sorry, what is the element like? Where is this third element present? Like in which index this third element is present, right? Or this 3 is present. Again, let me repeat it. Numbers.index. Index is a function over here, and with respect to index, what it does is that it returns the first index of the value. Okay, whatever value I'm actually giving you, it is just going to return the index of that value. So here you can see 0, 1, 2. So 3 is basically present in the second index. Okay, so I hope you got this two methods easily and you have understood it. One is count and one is index, and these are the two common methods that I specifically use with tuples. Okay, now let me talk about one amazing thing. Okay, and that is basically called as packing and unpacking tuple. Okay, packing and unpacking tuple. Again, this will be really handy whenever you are developing projects and whenever you are writing the code, right? So let me just go ahead and write packed underscore tuple is equal to, and I will define the elements like this 1, comma, and let's say this is my string. So this will be like hello. Then I have 3.14. Okay, and I'll just go ahead and print my packed underscore tuple. Now once I do this, here you'll be able to see that I'm able to get it. Now whenever I define the numbers in this way, like comma separated, right? By default, what it is going to do is that whatever number of elements that I've given, it's going to pack them in a tuple itself, right? So that is the reason we say it as we are packing a tuple whenever we give this. Now, how do we unpack a tuple? So this is with respect to packing, okay? Packing. But how do we unpack it? So unpacking a tuple, and how do we do it? So here we know that there are 3 elements inside this tuple. Let's say I have 4 elements or 5 elements. Let's say in this case there are 3 elements. So I'm just going to create 3 variables. Let's say ABC is equal to, and here what I'm actually going to do, I'm going to use the same packed tuple. Okay. Now what will happen if I go ahead and print A? Okay, and let me just go ahead and print B. And similarly, let me just go ahead and print C. So here you can see 1, hello, and 3.14, right? So you're able to see this, and this is nothing but it is called as unpacking a tuple, right? Now, there is also some very important things that you really need to understand, okay? With respect to unpacking, we can also use star, okay? So let's say unpacking with star. Again, this is something new that you'll be able to see as new Python version will be coming. Some of the amazing features. So let's say I have a numbers, and in these numbers, I define a tuple, 1, 2, 3, 4, 5, okay, and 6, okay? Now, let me do one thing. I will create one variable like this, and I use star. Let's say star will be middle, and my third variable will be last, okay? Now, why I'm creating this, you'll be able to understand. Now, see, if I go ahead and display the number, I'll just go to assign this particular numbers over here. Now, let me just go ahead and print first. Then I will go ahead and print middle. Okay, sorry, I'll remove the star over here. I'll not require star. And then finally, I will print the last element. Okay, now see what will happen. Over here, I know 6 elements are there, but I'm just using 3 variables just to unpack, and I'm unpacking with 1 star. I'm using in the middle variable 1 star. Okay, now see what will be the output. Okay, so the first one has given me 1. This is fine. Now the middle star, what it is done, right? The star middle, it is taken all the remaining elements till the last element. See 2, 3, 4, 5, and the last number is basically giving you the 6th, right? So what the star does is that from wherever you're probably starting, right, till the last element, right, before that last element, all the elements will be picked up. Okay, so this was about unpacking 3 variants I've actually shown you: packing, unpacking a tuple, and unpacking with a star. Okay, let me just go ahead and create more cells so that you'll be able to we'll be able to execute more code. Okay, now let's go ahead and see some example for nested tuples. Okay. Tuples inside a tuple is basically called as nested tuples. List inside a list is also called as nested list. So let's say if I go ahead and write like this, I can go ahead and create any number of lists inside a list. Okay. Let's say I have elements like 1, 2, 3, 4. Here I have 6, 7, 8, 9, and let's say I have 1, 1, hello, hello, 3.14, C. Okay. Now this is what? This is list inside a list, right? So here is an example of nested list. Okay. Because see, I did not take in the previous session of list. The reason is only that whenever is the right opportunity, right, we should include this topic over there, right? And that is how you'll be able to understand all the other topics itself, right? Because whatever operation we specifically do in list, similarly only we also do it in tuple also with respect to accessing elements. And the difference is immutability and mutability, right? Now let me just go ahead and write list of 0. Now list of 0 basically means what? This is my 0th index. This is my first index. This is my second index. Okay. So if I'm writing list of 0, you will be able to see that I'm able to get 1, 2, 3, 4. But let's say that I want to pick up third element. Now, to pick up third element, what I really need to do, I have to use another index. And this time, this will be nothing but 0, 1, 2. So this will basically belong to my second index, right? So here you can probably see that I'm able to get the third element, right? So this is some common example, right? Let's say I want to also use slicing operation. I want to get the elements between 1 till 4. Okay, so I can also go ahead and write like this: 0 colon 3. Okay, if I go ahead and write it, so see, I'm able to get 1, 2, 3. So slicing operation can also be applied in nested list. Okay, list within a list. Okay, and it is not like only you need to have a list. You can also have tuples. You can also have multiple things, right? So let's say I am going to probably go ahead and define this as tuple. Okay, tuple. Okay, or let me just show you another example so that this code remains, and I'll paste it over here. Okay, and let me do one thing. And here you have this, and here you have this. Okay, now if I'm executing this, let's say I want to probably get from my second index 0, 1, 2. Okay, second index, and let's say I want all the elements between 0 to third index. So here I'll be able to get 1 hello world and 3.14. So inside a list also you can have tuples. Okay, it is up to you, however you want to create. But whenever we talk about nested tuples, let me just give you one basic example. Here we are just going to create tuples inside a tuple. So I have 1, 2, 3, ABC, true, false. Okay, so these are my tuples over here. Now we will try to access the elements, access the elements inside a tuple. Okay, now let me just go ahead and write print nested underscore tuple of 0. So if I go ahead and execute it, I'm able to get 1, 2, 3. Okay, if I want to just pick up C, let's consider that I want to just go ahead and pick up C. Then how do I write? I'll go ahead and write print nested underscore tuple. And here I'm going to specifically write first index, right? First index will basically get me all the elements over here, and this will be my second index, right? So here, if I go ahead and execute it, I'm able to get C, right? I can also iterate through this nested tuples, right? By using a for loop. So iterating over nested tuples, okay? And here you'll be able to see for sub underscore tuple in nested underscore tuple. Okay, I'll first of all go to the nested tuple, and then I'll take the item in the sub tuple, and let me just go ahead and print it. Let's print the item one by one, right? So print item, and here I'm just going to write end is equal to with a blank statement, so that whenever it is printing, it should print along with this blank a new line also. So now if I go ahead and execute, see, first tuple is basically getting printed 1, 2, 3, ABC, and then true and false. So that is what I have, right? So this was example with respect to tuples. We have seen different operations. We have seen about packing, unpacking. We have seen the inbuilt methods. We have seen why do we get an error, what is immutability, everything we have actually seen, and we have also seen some of the examples with respect to list, right? But overall, if you probably see, right, tuples are a kind of data structure. Again, it will be specifically used when you do some kind of data analysis and all. Some or the other way, whenever you're writing the code and all, you will be using this tuple extensively. Now let me do one thing. Let me go ahead and finally write the conclusion so that you have this conclusion in mind where all tuples are. Tuples are versatile and very useful in various in many real world scenarios where an immutable and ordered collection of items is required. They commonly used in data structure, function arguments, and return values as dictionary keys. Understanding how to leverage tuples effectively can improve the efficiency and readability of your Python codes. So I hope you like this particular video. This was it for my side. I will see you in the next video where we will be learning about the next data structure that is called as sets. Thank you. Take care. Bye bye. Hello guys, so we are going to continue the discussion with respect to Python, and now we are going to discuss about our new data structure which is called as dictionaries. So in this video, this is the entire video outline where we will be discussing about the introduction to dictionaries. We will be creating dictionaries with the help of Python, how to access the dictionary elements, modifying dictionary elements. Then we'll be seeing some of the amazing dictionary methods that we usually use while we are developing projects. Along with that, we'll also be iterating over dictionaries. Then we will be discussing about nested dictionaries, then dictionary comprehension, and finally, we will be seeing some of the common errors that we usually face. Now, in this, it is very much important that we probably do a lot of practicals. So that is the reason I will be showing you each and everything with the help of coding. Now, let me go ahead and first of all, let's see the definition of dictionaries. So dictionaries are nothing but it is an unordered collection of items. They store data in key value pairs. Okay, so there all the data is basically stored in key value pairs. Key must be unique and immutable. So once you specifically define a key, it cannot be changed. Values can be changed, and a key must always be unique. Okay, and it can include strings, numbers, or tuples, which while values can be of any type. Okay, so let me just go ahead, and I hope you have just understood the definition. But again, to make you understand much more in a better way, first of all, we will go ahead and discussing about creating dictionaries. Okay, now with respect to creating dictionaries, first of all, what we are really going to do over here is that create an empty dictionary. Now already you know if I use square braces. Okay, and before that, make sure you select the kernel. So if you are basically using this square brackets, then you basically create an empty list. If you are using tuples, you create an empty tuple. Now in case of dictionary, we use flower braces. Okay, now let's go ahead and define and create our empty dictionary. So here you can see if I go ahead and print type of empty dictionary, you will be able to see that I will be getting a class which is called as dictionary. So in order to create an empty dictionary, all we have to do is that we have to specifically use this flower braces. Okay, another way how we can actually create our empty dictionary is that by using this dict class. Okay, and here we will initialize it as a method. So once we initialize it, here you'll be able to see now again I will be getting a complete empty dictionary. Okay, so right now it is a complete empty dictionary. So these are the two ways of specifically creating an empty dictionary. Now as I've already said that dictionary is all about key value pairs, right? Now whenever we talk about key value pairs, let me just give you an example. So initially you start writing in the flower brackets. So first of all, what we are going to do is that we are going to give my key name. Let's say one of the key name with respect to student information is name, and let me just go ahead and write the name called as Krish. Okay, so Krish is the name. So this basically becomes the key. This basically becomes the value. Okay, now the next thing is that I will go ahead and use my another key which is called as age. Okay, and here we are specifically going to use a value. Let's say 32. Okay, third I'm just going to use another key which is called as grade. Now if I go ahead and write this, you'll be able to see if I go ahead and print the student. This is a complete dictionary where I have three keys, that is name, age, and grade, and the values are Krish, 32, and 24. Now if I go ahead and print the student, so this basically becomes my entire dictionary, right? Which has this key value pairs. If you want to also check out the print of type of student, you will also be able to see that I'm able to get a dictionary over here. Okay, so this is how you specifically create a dictionary with the help of key value pairs. Okay, now let me just show you one more thing here. When do you get an error? Because as I said you, that key should be unique. Okay, so let's say if I go ahead and copy this and paste it over here, and again I use the same name. Now what is going to happen? Okay, and I'll just go ahead and print student. Let's see. What is going to happen, because you really need to understand whether we'll get an error or whether it will just print out. So here you can see only two keys are basically getting their name and age, right? Name is having the value of 24, age is 32. Now what has exactly happened over here? Now when I'm writing name is equal to Krish, this was one of the keys that I have already defined. Now if I'm again defining this particular key, you know, in the upcoming like in the key value pairs, then what it is going to do, the value is going to get replaced. Okay, but it is going to consider as one key itself. So which is the recent value that you have replaced over here, the value that is what is basically displayed. So always please make sure that here you don't have to always create the key with the same name. I'll not say this as an error, but here you can see that I can just write single key is always used. Okay, instead of multiple keys. So this is one super example, and this will be very much important because see, if you know about databases, NoSQL databases like MongoDB, like Cassandra, over there, all key value pairs will be specifically used, right? All your data will be stored in key value pairs. So it is important that we always need to have this key unique, right? Now let me just go ahead and let me talk about accessing dictionary elements. Okay, now with respect to accessing dictionary elements, now what I'm actually going to do, let me just go ahead and make this as I'll just copy this. Okay, and let me copy this over here. Oops, not here, sorry, here, and let me just make this grade as A. Okay, now this is my entire dictionary, right? Now if I want to access any value, let's say I want to access the value of grade. Okay, now how do I do it? We definitely have to use this key. So what I will be doing is that I will just say student of, I want the grade of this particular student, so I will just give the key name over here, and let me just go ahead and print it. Okay, so here once I do the print over here, right, I should be able to see the grade. Similarly, let's say I want to go ahead and get the age, so I will go ahead and write student of age, right? And if I go ahead and print it, it is 32, right? So this is one of the method of accessing. I'll write it down over here, accessing dictionary elements. Okay, this is one of the easiest way to probably do it. There is also one way where we'll be able to access the values using the default get method that is provided by the dictionary. Okay, get method that is provided by dictionary. Now how to do this, I will just show you. Okay, so first of all I will just go ahead and write print. Let's say I want to get the grade, right? What is the grade of this particular student? So I will just go ahead and use dot get, and here I'm just going to give my key name, that is dot grade. Okay, similarly, let's say if I want to go ahead and print student dot, and let's say I want to probably let's say that there is no, like over here the key that are available are name, age, grade, right? Let's say I will go ahead and search for last name. Okay, I know the key is not present over there. So let's see what is the value that I will be getting. Okay, and by using get, we will be able to get the value anyhow. But if I execute it here, you'll be able to see first student grade, I got A, student age, I got 32. Again, when I'm writing student.get of grade, I can get A. But when I'm searching for last name, I'm not getting anything, right? I'm getting it as none. Now let's say that if I don't find any key, I want to probably give a default value. So for that, I will go ahead and write print student.get. Okay. And here I'm going to specifically write last underscore name. I know last number underscore name key is not available, but I will give a default value if it is not available. So I'll write not available. Now let's see the value that we're going to get. So see over here last name was not present in this particular key, so I'm getting the default value which I have provided it over here as not available. So before it was giving us none, now it is probably giving us not available, right? So this is how with the help of key you will be able to access it. And two ways I've actually shown you how to access dictionary elements. Either you're directly calling the key or you're using the get method, right? Now let me just go ahead and let me talk about the next method that's called as modifying dictionary elements. Okay. Now with respect to modifying dictionary elements, one very important key that I really want to write, right? Dictionary are mutable, right? So you can add, update, or delete elements. Okay, so this is the most important thing about dictionary. But you cannot like always all time your key needs to be unique, right? At any point of time. So let me just go ahead and show you some of the examples over here. So let us go ahead and discuss about modifying dictionary elements. So here already let us go ahead and print this students, right? And here you can see the name is the key name. Is basically having the value Krish, age is 32, grade is A. Now, let me do one thing. Let me just go ahead and add a new key. I'll also be showing to add a new key and also updating, let's say, age. So here, now, if I go ahead and write student of age, and let's say the age is now 33, okay, and I'm just going to print the student. Now, along with that, what I'm actually going to do is that I'm going to add a new key, and the new key will be something like address, okay. And let me just go ahead and write the address as India, okay. So this is the new key that I'm specifically adding. Now I will go ahead and print the student. Now here you can actually see that the first key age has got updated to 33. Now once it got updated, I again added a new key over here, which is called as address. So now I will be able to see the address India that has been added to the same student dictionary. Okay. Along with this, we can also go ahead and delete any key, right? So what I'm actually going to do is that I'm going to delete the key over here. Okay, let's consider that I'm going to delete the grade key. So let's go ahead and see that. So here, what we have actually done, we have updated the value for the key, right? Here we have added a new key and value, added a new key and value. And in the next statement, what I'm actually going to do is that I'm going to delete the key. So in order to delete the key, I just need to use this del keyword, okay, that is available in Python. And I will be using the student, and let me just give the key name. So if I go ahead and write like this will basically delete the key and value pair. Okay. Now if I go ahead and print the student, you will be able to see that I will now have the entire key, right, grade has got deleted along with the value, and I just have the remaining key, that is key value pairs like name, Krish, age 33, address India. Okay, so this is how you delete the key value pair. So these are some of the operations and how you can modify dictionary elements. Okay, now let me just go ahead and show you some of the common dictionary methods that we use. Okay. Now, you'll be also seeing more examples because after this, I will be also showing some use cases examples. Okay, so there again, we'll be discussing more about dictionaries. Okay, now some of the important dictionary methods. Okay, so first of all, let me just go ahead. Let's say you just want to get all the keys of that particular dictionary. Okay, so I will go ahead and write keys is equal to student, which is my dictionary, student dot keys. Okay, and let me just go ahead and print all the keys over here. Okay, then let me just go ahead and write values is equal to student dot values. Okay, if I want to get the values, right, of all the dictionary that I have, basically in the dictionary, all the values that if I want all the values, how can I get it? So this first code that I've actually written, this will actually help you to get all the keys, okay, and this will actually help you to get all the values, okay. And if I go ahead and print the values, I will be able to see the values over here. One more, let's say I want to get all the key value pairs, let's say in the form of dictionary items, okay. How do I get the key value pairs, right? In that case, so let me just go ahead and write, and I'll define a variable called as items. And if I go ahead and write student dot items, right, and this will actually help me to get all key value pairs, okay. Now let me just go ahead and print this specific items, okay. So here you can see that, let's see the first one, okay. Student.keys, I'm getting all the keys, so name, age, and address are the key. When I wrote student.values, I got all the values, I'm printing it, so Krish, 33 and India. And when I want all the key value pairs, so like this, I'm able to get it, right? So this will be a new type, is called as dictionary items, which will be in the form of list of tuples. So these are nothing but tuples, right? Tuples, right? I will be able to access this particular tuples also, and it is a list of tuples, okay. So here you can see name, Krish, age 33, address India, right? Now one more thing I really want to do is do a shallow copy, okay. Now let us discuss about shallow copy over here. So guys, now let me just go ahead and show you the working of shallow copy. And this is something really, really important, and trust me, you should never do this mistake whenever you're implementing in any kind of project. You have to make sure that whenever, and you need to remember this concept because this can be a very small mistake whenever you're developing projects, okay. Now I have student dictionary over here, right? Now let me do one thing. Let me create another variable. Let's say I will go ahead and write student underscore copy, and I will assign the student value over here. And as you all know, what is present in the student? The key value pairs, right? Now if I go ahead and print student, and if I go ahead and print student underscore copy, okay, student underscore copy, what am I getting? I'm getting the same value. This is perfectly fine, and obviously since I'm copying this particular value to another variable, so this will also be a dictionary that will be having the same value over here, okay. But now what I will do, I will just go ahead and take student name value, right? Student name value, and I will assign some other value itself, right? Let's say Krish1. Okay. Now let me just go ahead and print student, and let me print the same student underscore copy. What do you think should be the name in student underscore copy? Should it be Krish1 or Krish2? Okay, I'll make it to Krish2. Okay. Let's say I'm changing the name of this particular student, right, over here to Krish2. Now since I'm making the change to this student dictionary, since I made a copy of this in student underscore copy, then you may be thinking, okay, student underscore copy should still have Krish1, but it does not happen in that way. If I go ahead and see the output, you'll be seeing that since student also got the name as Krish2, since we had assigned the value to student underscore copy, so here also we are getting Krish2, and this is a big problem, right? So how do I make a separate copy? You know, whenever I probably want to make a copy for this particular dictionary to another variable in such a way that after that, if I update this, the same update should not happen in your copy variable. So for that, I will be showing you about shallow copy. Now in shallow copy, what we do is that, let's say I go ahead and create my student copy one variable, I will go ahead and write student dot copy function. Okay. Now this copy function is responsible for doing the shallow copy over here. In short, if you really want to understand, this will basically allocate a different memory. It will take this variable and it will give the reference of this variable to another memory, which will have that entire value that we really want to store. Okay. Now if I go ahead and print student underscore copy one, okay, and if I want to go ahead and print student, right, and if I execute it, now here you can see, okay, I'm having the same value, but now let me just update the student name. Okay, if I go ahead and update the student name, let's say if I go ahead and write Krish3, okay, now if I go ahead and print both of them, will I get the same value of the name? The answer is no. See, I'll execute this. Now in my student underscore copy 1, I still have Krish2. In student, I have Krish3, right? And why this was possible? Because of the shallow copy itself, right? So just get an idea about shallow copy. Shallow copy in turns, provides a different memory location so that whenever we change one of the variable, it should not impact the other one. Okay. So just a smaller thing to understand over here because this will be important when you're doing the coding. Now let's go ahead and discuss about iterating over dictionaries. Okay. First thing, you can use loops to iterate. Like how did we do in the case of list or in the case of tuples? So here also we are specifically, okay, I'll write you can use, okay, loops to iterate, and we can iterate over dictionaries. And in dictionaries, if I probably talk about, we have keys, we have values, or we have items. Items basically means the combination of key and value pair, right? So let me just go ahead and show you the same example. Let's say that this is my student variable, okay? And for this particular student, I will go ahead and iterate through each and everything. So first of all, I will try to show you iterating over keys, okay? Now iterating over keys for keys in, again we'll use a for loop, and I will just go ahead and write student.keys. When I write student.keys, obviously you'll be able to see that I'll be getting the keys itself. If I go ahead and print the key, you'll be able to see, keys, sorry. You'll be able to see name, age, and address. These are the keys that I've actually defined. Similarly, you can iterate over values. For that, what you need to do, again, copy the same thing, right? Paste it over here. Instead of student.keys, now you go ahead and write student.values. Okay? And once I go ahead and write it over here, I can print it over here itself. And this is what you will be able to get a value. Krish 3, you'll be able to get 33 India. Okay? Now, if I want to iterate over key value pairs, then what we really need to do, I will be using two variables in my for loop. One is key comma value and student.items. And now I will just go ahead and print by using an F string. Okay, so this is one way of formatting, print formatting. I can go ahead and write my key. Along with this, I can go ahead and write my value. If I go ahead and see this is my age, Krish 3, name Krish 3, age 33, address India. So you can also iterate over the key value pairs, and just by writing student.items, you get that value in tuples, right? In list of tuples. So all these things you can basically work, and you can basically iterate over the dictionaries. Now talking about the next one, here we are going to go ahead with, let me make some cells. Okay, so we are going to talk about nested dictionaries. Okay, now nested dictionaries, a dictionary inside another dictionary. Okay, and usually if I talk about databases, MongoDB, right? NoSQL database. Over there, everything is stored in key value. Whenever we say key value pair, later on we can read that, convert that into a dictionary, and I may have any number of records in the MongoDB database, right? So let me just go ahead and do one thing. Let me go ahead and write students, and let me just show you how you can create key value pairs. Okay. So let's say this is my first key, that is nothing but student1, and I will just go ahead and write my key value pair. Here, the first thing I will go ahead and see name. Name is, let's say, Krish. Age is, let's say, colon 32, okay, and age 32, and here I am specifically creating this, right? Sorry, it should be colon, not equal to colon 32, okay. This is my first record, yeah. Now let me go ahead and create my second record. Let's say I may have student2 data, and now with respect to this particular student2 data, I may have name. Name is nothing but, let's say, Krish, or I'll just say Spider-Man, or Peter Parker, or anyone, right? So Peter, right? Age is nothing but, let's say, 35, right? So here you can see key value pairs, right? And this is nothing but, this is basically a nested dictionary, right? Now if I go ahead and print students, you'll be able to see that, hey, it looks like a dictionary. Key value pairs, again, we can have nested key value pairs, right? But these are just like a kind of records, like how we upload it in MongoDB or in any other non-SQL database, NoSQL databases, right? Now, how do we access this nested dictionaries? Access nested dictionaries elements, okay? So I will just go ahead and print, right, students. And here I'm going to use, let's say I'm going to read the age of Peter Parker. Then how do I write? So I will just go ahead and write student2, okay? And the next bracket will be specifically name, okay? Or name or age. I can also get name. If I want to print, I can print name. Let's say if I go ahead and print this entire information along with age, here I will be getting age or name of Peter Parker, and here I'll be getting the age, right? So if I go ahead and see Peter and 35, right? So here, with respect to the nested dictionaries also, like how we read in a nested list, similarly we can go ahead and do that. Here the main thing is that we only have to call the key names, and automatically you'll be able to get the value names, right? So this is one amazing way of playing with nested dictionaries, okay? Now, again, you can try multiple examples. You can create your own nested dictionaries, any level of nested dictionaries. There's no limit as such. Inside name also, you can again go ahead and create another nested dictionary if you want, okay? Now, let me just go ahead and show you one more thing. Iterating over nested dictionaries, okay? Now for, let's say I will go ahead and write for student underscore ID, okay? Since I require ID and information, so let's say I will go ahead and write like this. Just see this, okay? Student underscore info, okay? I will consider this as ID and this as entire info, okay? And if I go ahead and write students, okay, dot items. So what will student.item give me if I go ahead and execute a code over here? What will students.items give me? It will give me dictionary in the key value pairs, right? Like student1 will be one key and this will be entire value, right? Inside this can be a key and this can be a value, but it will be giving you in this particular format. Now, if I iterate over this nested dictionary, this I will consider as my ID and this I will consider as my value, right? So that is the reason I've written from student underscore ID, student underscore info, right? So this can be a temporary variable, right? Now I will just go ahead and print, okay? So one print, I'll just use an F string, and inside this F string, let me first of all go ahead and display my student underscore ID, okay? And this will basically be my student underscore info, right? Now, I may want a scenario wherein I traverse through or I iterate over all the elements that are inside this, right? So let me do that. So I will go ahead and write for key, comma value, okay, in student underscore info, right? I need to iterate through this, and this all information are present inside student underscore info. Now, inside this also, I will be able to find out keys and values. So I will go ahead and print F, again my key, and this will be nothing but, it will be colon, again my value, right? Now let's go ahead and see. So there is an error for key comma value in student underscore info dot items. I missed out dot items because I am not getting too many information out of it. So see, how it is printing this first information. This is my student. All the information is over here. Then I took this info and I iterated to every key and values, right? So name is equal to Krish, age is equal to 32. Then again it went to the for loop. It found out the another student ID, that is student2 with this name, and now it is printing name is equal to Peter and age is equal to 5. So this is how you iterate over nested dictionaries, and you can play with different elements as you want. Okay. So again, any level of nesting, let it be, right? You can iterate through each and everything, and just by using dot items, you can get the key value pairs. Okay. Now let me just go ahead and talk about dictionary comprehension, like how we discussed about nested list comprehension. Similarly, we'll discuss about dictionary comprehension. Okay. Now, dictionary comprehension, how does it work? Let's say that I want to just print what is the square of a specific number between 1 to 10. Okay. So let me just go ahead and create a variable. Squares is equal to, and again, what is the mechanism? See, list comprehension, we basically write like this, right? In dictionary comprehension, we use angular braces, right? So first thing first, always remember we need to write. You can write a for loop. You can write any condition over here. So let me go ahead and write for x in range of 5. Okay. So I'm iterating between 0 to 5, and what I want to display something like this. X is equal to x square. Okay. I'm basically squaring each and every number, and that is what is my x value. And this way, it will probably display me. And this is the way how key and value pairs displays, right? So this is my key. This will be the value. This will be my key. This will be the value as we keep on iterating. So if I just go ahead and execute this print squares. Again, you can, one assignment I definitely like to give you, just go ahead and write this entire thing with a simple for loop, okay? And then you try to convert this into a dictionary, right? Dictionary comprehension. So here you can see now I'm able to get a key value pair. So this is my 0 is my key, 0 is the value, 1 is the key, 1 is the value, 2 is the key, 4 is the value, and we're doing squaring of it, right? Squaring of each and every number. Now let's say I want to probably go ahead and just find out the squares of only even number. So here I will also show you by writing conditions. So let me just go ahead and write conditional dictionary comprehension, okay? Comprehension. Now, the best way over here is that I'll go ahead and create even variable. Now, first of all, for x in range of 10, let me just go ahead and take 10 variables, okay? I know what I need to display, x square, okay? But I will write one more condition. If x modulus 2 is double equal to 0, I will go ahead and print my events, okay? Now, let me just go ahead and execute it. So this is 0 colon 0, 2 colon 4, 4 colon 16, 6 colon 36, 8 colon 64, right? So this is in short giving me the square of only even numbers, right? Now, these are some of the examples. Again, dictionary comprehension, you can, like, how do you execute with respect to lists? Similarly, you can also do it with respect to dictionaries. Only the thing is that you need to have the output over here in the form of key values, okay? So this was one of the most amazing thing, okay? Let me just show you some of the practical examples that may be beneficial for understanding. Some more practical examples. And in the next video, I will also talk about some of the amazing use cases where all these list dictionaries will be used, okay? So practical examples, okay? Now, with respect to this practical example, I'll give you a task. Use a dictionary, okay? Use a dictionary to count the frequency of elements in list, okay? Now I'll go ahead and see this. Let's say I have numbers. Numbers is nothing but it is in the list format. 1, 2, 2, 3, 3, 3, 4, 4, 4, 4. Okay, so these are my numbers. Now you need to write a code using dictionary to count the frequency of every element in the list. Like 1 is present 1 time, 2 is present 2 times, something like this. So I will go ahead and create. First of all, you try it out. Okay, just pause for 5 minutes and just try to write whatever is possible by you, and then go ahead and see the solution. Okay. Now let me just go ahead and create a frequency empty variable. Then I will go ahead and write for number in numbers. Okay. First of all, I will iterate for each and every number. Then I will go ahead and write if number in frequency. Okay, the number is basically present in the frequency. Then it is fine. Then what we do? We basically take the frequency of number and we keep on incrementing it. Right? Plus is equal to 1. Now what exactly this is basically doing? This is with respect to the key. And with respect to that particular key, I need to just keep on incrementing the value, saying that hey, it's present 1 time, 2 times, 3 times. Like when 2 times basically comes, right? So first time it will be 0, and then it will go to 1, 2, 3 like that. Okay. Else, if it is coming for the first time, then we should basically assign that value to 1, right? Otherwise it will keep on incrementing. So number is equal to 1. Now let me just go ahead and print the frequency. So here you'll be able to understand how many number of times 1 is present, 2 is present, and 3 is present. Just see this code, observe this code. Okay. If I go ahead and execute it, now here you can see numbers, it is iterating. If number is in the frequency, initially it is not present. So what it will do? It will go over here, take this number, and it will assign the value 1. Then it will go again back to the next number. 2 is present. Number is not present in the frequency. It will again go back to the else loop, and again it will update 1. Then again it will go back. Okay. Then the next number is 2. This time it is present in the frequency. So it will go inside this. Frequency of 2 is equal to plus is equal to 1, right? Plus equal to 1. So that means we are just going to increment 1 with 1. So it will become 2. So how many number of times 2 is present? Only that much will be remaining. 3 it will increment till 3, 4 it will increment till 4 because there are 4 number of 4s. Okay. So this is how you specifically get one amazing thing. Okay. Now let me just show you another one example, and this is probably we have not discussed also. Let's go ahead and merge 2 dictionaries into one. Okay. There may be a scenario that I may have 2 dictionaries and I really want to merge them in one. Okay. This is one kind of hack that I really want to show it to you. So dictionary 1, and this is what we'll understand when we understand about functions, because there is one very key important parameter which is called as positional argument and keyword argument. Okay. Why we use asterisk, mask, and all. I'll just discuss when we discuss about the function. So now let me say that okay, there is my dictionary elements over here. A is equal to 1, and this B is nothing but equal to 2. Okay. Similarly, I may have a different dictionary, the second dictionary here, B colon 3, and C is colon 4. Okay. Now if I go ahead and write merge dictionary. Okay. Now see, if I go ahead and try to merge this dictionary, I will use 2 amazing things over here. One is asterisk asterisk dictionary 1, okay, comma asterisk asterisk dictionary 2. Now the best thing about this asterisk is that any number of key value pairs, right? If I'm giving 2 double asterisks, any number of key value pairs that is probably going to consider come, it is just going to take that as a key value pair and it is just going to append it inside this particular dictionary. Okay. This is basically called as a keyword argument. Okay. And over here you can see in dictionary 1 and dictionary 2, both are keywords argument. Okay. So keywords argument basically means any value that is present in the form of key value pairs. Okay. Now if I go ahead and print this merge dictionary, and we'll discuss more about that in functions. Okay. So here you can see that it has merged very much easily. Okay. So I hope you got an idea about dictionaries. We've discussed so many different lines of code I've written over here in front of you, and almost each and every topics with some examples and all I've actually explained in a way that you should be able to understand in a very lame language. So I hope you like this particular video. This was it from my side. I will see you in the next video. Thank you. Take care. Hello guys, so we are going to continue the discussion with respect to Python, and in this video we are going to discuss about the most important module that is called as functions. So what is the entire video outline in this video? We will be discussing about what exactly is functions, why do we require functions. Along with that we'll also be seeing about calling a function, defining a function, how do we define it, what is the syntax of it. Then along with that we'll be discussing about functions parameter, default parameters, then what is variable length arguments, so there are some very important arguments like positional argument and keyword argument. We'll be discussing about that. Then we will also be discussing about the return statement. So we will be covering each and everything with the help of again code, with the help of Python. Yeah, each and everything we'll try to write it down with multiple examples, and I'll be making sure that you understand this, because this is one of the most important thing, because whenever we are writing any data science projects or Python projects, we will be definitely using a lot of functions. So first of all, let's go ahead and define the function. A function is a block of code. Okay, again I'm repeating it. A function is a block of code that performs a specific task. A functions help in organizing code, reusing code, and improving readability. Okay, so it is a block of code that performs a specific task. It helps in organizing code, reusing code, and improving readability. One of the best syntax, if you really want to check it out, right? So this is a syntax. So here I'm just going to give you the syntax. This function is an empty function. I just written it for just to make you understand. So first of all, a function starts with a definition keyword. Then you have the function name, and if any parameters that you're defining, so we have to define the parameters. This is docstring. Docstring is just to use to write some kind of comments what the specific function does. so that any developer will be able to understand it. Along with that, we will go ahead and write our function body. Function body is more about all the code that we are going to use inside the function, and then finally we return some kind of value. Okay, it's not necessary that return should be there. Some of the functions may not have return value, but some of the functions will definitely have a lot of return value. Okay, so this is the basic syntax. Now let me just go ahead and tell or talk about why do we require function. Okay, why functions? This is important for everybody to understand. Let's say I am creating a number variable and I go ahead and write a code which will be able to check whether the number is even or odd. So suppose if I go ahead and write if num modulus 2 or percentile 2 is double equal to 0, then obviously I'll say, hey, print the number is even, right? So I'm just going to write the number is even. Else what I usually do is that in this I will go ahead and print and write the number is odd, right? So here what exactly is basically happening, we're just going to check whether the number is even or not. And obviously if I go ahead and execute, this condition will be true because the number is even, and I'm going to get the answer, the number is even. Okay. Now let's say in my project I want to write this piece of code and I need to reuse this piece of code in multiple places, because in multiple places I'm going to check whether the number is odd or even, right? Now in this case what I have to do, I have to copy the same code, use it in multiple files. Instead of this, a better way of reusing the entire code will be with the help of functions. Now what I will do, this entire code I will write inside a function. Now the best way to write is that, let's say I will go ahead and create my definition keyword. I will say, hey, my function name is even or odd, okay? And this will specifically take a parameter which is called as number. And now I will go ahead and write my condition inside this, right? So as soon as I go ahead and press enter, that basically means I'm inside my function, right? So automatically the indentation goes inside this function block, right? Now the first thing is that I can go ahead and write my docstring. The docstring will be like, hey, this function performs finds even or odd. Okay, even or odd. So this is what I'm specifically writing over here. So this becomes my docstring. It is not compulsory that you really need to write a docstring. You can leave it completely empty, and you may also not even write any of these things. But it is a good practice that we should definitely write some information about the function itself. Now I will go ahead and write my code inside this. Now I will go ahead and write if num is nothing but the same parameter that I'm actually getting, and this is basically my parameter. If num percentile 2 is double equal to 0, I will go ahead and print the number is even, or I will go ahead and write else print the number is odd, right? So here you can see I've defined this entire function. I will just go ahead and press it and execute it, right? So as soon as I execute it, I have actually created my first function, right? And this is amazing. And if you have also created it, always make sure the indentation is managed. If the indentation is right, then everything is going to work fine. Okay. Let's say if I miss out the indentation, I execute it, I will be getting an error. It will be saying, hey, expected an indented block after the if statement. And this is what we have actually done. Okay. So I'll just take Control Z. Yeah. Now we are fine. I'll go ahead and create my function even or odd. Now in order to call this function, so let's call this function. Now wherever I want to use this code to find even or odd, I will just call this function. Okay. In order to call this function, just go ahead and call the function name. And here you just need to provide your parameter, right? So let's say the number parameter that I'm giving, I want to give it as 24. Now if I go ahead and execute it, here you can see that automatically it is printing the number is even. Because as soon as I give the parameter, it went over here, it went and checked all this condition, whichever is true, it printed it, right? A very simple way of creating a function and calling a function. And why do we require a function? Because everywhere we cannot write the code. We need to reuse this kind of code. So whenever you think, okay, I have some set of code block which I really need to reuse it, I will try to create that entire thing inside a function itself and I'll reuse it, right? So through this, the most important thing will be that it helps in organizing code, reusing code, and improving readability. Improving readability, why? Because you're also writing some amazing docstring over here so that we'll be able to understand. Because in a company, many people will work, many people will write different code over there, multiple modules will be built. Okay. So this was a basic example with respect to function. I've also spoken about a parameter, like what exactly is a parameter, how do you give a parameter in this. Now, there may be scenario that I may also have multiple parameters. So let's work with multiple parameters. So here I will go ahead and write function with multiple parameters. Okay. And parameters you can give integers, string, whatever things you require. So I'll go ahead and write definition add. Let's say I want to go ahead and create a add function to add two numbers. So I will go ahead and write definition add a comma b. And let's say I go ahead and write my docstring. Again, not compulsory. I can also leave it like this, okay, just to show it to you. That is the reason I'm writing. Okay. So I will go back over here, press enter. So I'm inside this particular code block. Now I know that I have to add two variables, right? So I will create one way is that I will create a variable c, a plus b. Okay. And then I can return the c output from that particular function. Okay. Return c plus c, which is nothing but a plus b. Whatever sum is there, we are just going to return it. A better way of writing the code, instead of writing c, I can directly write return a plus b. Right. So here what we are doing, we're just returning the sum of a and b. Now all I have to do is that create a variable and call this add function. Here I'm going to give 2, 4. Now what is going to get, what value result is going to get? As soon as we call this function 2, 4, it will just return 2 plus 4. Whatever will be the result, like 6, it will be stored over here. Now if I go ahead and print the result, here you'll be able to see that I'm able to get the 6 value. So here you can have any number of parameters and code whatever things you're writing. You can basically use this parameter and write any code that you want. Okay. So it is up to you what kind of function that you are building. And as we go ahead with multiple examples, if we see in the future, and in upcoming videos, we'll be writing very complex functions. There's something called as decorators, lambda function, many things will be probably coming. One by one we'll be learning. First we'll start with basics, then slowly we'll be building the blocks with respect to the learning, and then we'll be continuing on. Okay. Now let me just go ahead and show you and talk about one very important thing which is called as default parameters. We can also provide default parameters within our function. Okay. Now what exactly is default parameters? Let's say I create a function. Okay. I create a function saying as definition greet. Okay. Definition greet. This function is responsible. Let's say I give a name over here, right? Let's say one parameter is name. Okay. And here I'm just going to write print. Okay. I'll use f string and say that, okay, I want to probably write some information. Let's say I want to say hello, whatever the person name is. Okay. So I'm going to just go ahead and print this. Okay. And this is what is my definition greet. Greet is just more like you're welcoming someone. Okay. Welcoming someone. Now what I will do is that I will just go ahead and call this function. So I will go ahead and write greet, and let me say that Krish has entered somewhere. So I will just give the Krish parameter. Like let's say you're entering a restaurant, and as soon as you write Krish over there in one of the applications, and suddenly I will get a message saying that hello Krish. Okay. Or welcome, something like this. Welcome to the paradise. Let's say this is my message. Hello Krish, welcome to the paradise. So as soon as I give this parameter, automatically this will get replaced over here. Okay. Now I may also give one parameter. I may also give some parameters with a default value. Okay. With a default value. Now what does that particular mean? Okay. Let's say I just go over here, and this time I don't give Krish. Okay, I'll just try to execute this without giving any parameter. So here you can see I will be getting an error. Hey, greet, missing one requirement positional argument. Okay, we'll talk about what exactly is positional argument more about it. But here you can see that I've given this particular name parameter over here, but I'm not given any parameter when I'm calling it, and that is the reason I'm getting this one missing one required positional argument. Okay, now in order to solve this problem, what I can do, I will say since I'm not giving the name, I'm going to give a default value to the name. Let's say if I'm not giving it over here, then what will happen? It'll first of all go and see whether the greet name is equal to guest is given or not. Now, if I go ahead and execute this, see, I'm not giving any parameter, but the default parameter, it will take it as guest. Okay, so if I go ahead and execute it, here you can see, hello guest, welcome to the paradise. Let's say if I go ahead and give the name, okay, over here, let's say the guest is not interested to give the name, but by default, it will take it as guest. But if I'm giving my name, it will just replace the guest will get replaced with Krish. Okay, so this is some good example with respect to the default parameters, and this is how you can also assign default parameters. Now, we are going to discuss about the main topic, which you will be seeing in function. That is nothing but variable length arguments. Okay. Now, in the variable length arguments, here we are going to discuss about two things. One is positional and keyword argument. Okay, positional and keyword argument. Okay, keywords arguments. Okay. Now, let me tell you one very important thing. Let's say that I have in a function many parameters as such. Okay, and let me just define one simple function that is called as definition print underscore numbers. Okay, and here inside this, let's say I have like this. Okay, number 1, number 2, number 3, number 4, number 5, like this. I have many parameters in short. Okay, it's just not one single parameter. I'm basically having many parameters. Okay, so what I will do, instead of just writing all the parameter names, right, I will use one very simple positional argument, which we denote it as star args. Okay, now it is not necessary you need to write star args. I can go ahead and write star Krish also. Okay, but it is always a good practice. What is followed throughout the entire word, the same practice we should also do. Now in this particular case, I'll just show you with star Krish. Then we will go ahead and write with the documentation, like what is the best practices argument we specifically use. Like positional argument is basically given by star args. As I said, it need not be args. I can also write Krish. Okay, now I will go ahead and inside this particular function. Now here, what I will do, as you know, the star Krish will be having multiple parameters. So what I will do, I'll just go ahead and write for numbers in KRSH, okay, which is my argument. I will go ahead and print numbers. Okay, I'll go ahead and print number. Okay, now see this. Okay, so this becomes my function. Please observe very carefully. Okay, now my print underscore numbers function when I'm calling, let's say I have 1, 2, 3, 4, 5, 6, Krish. It can be anything. Okay, so these are all the parameters that I have. You can see it is a set of parameters, and these parameters are basically called as positional arguments. Okay, positional arguments, one after the other. Now if I go ahead and execute, now see the magic. This all the parameters will be referenced by star Krish. Okay, so Krish will be a variable which will be referring all these particular positional arguments. Now if I go ahead and execute it, now clearly here you can see for all the numbers it has been able to iterate through this, right? 1, 2, 3, 4, and it is displaying it something like this. Okay, because here I just use one. So this star Krish is basically referring to all the positional arguments, right? Positional arguments basically means all the arguments that is given over here. Okay, now as I always said, the best practice would be I will go ahead and write this, and I will say args. Okay, so args is the kind of positional argument that we basically use. Okay, so here I'm going to write positional arguments. Okay, why it is important? Because I may have many number of arguments over there. Okay, so I may directly use this specific thing. Okay, now the other thing will be that, okay, this is fine. If I go ahead and execute it, and if I execute the same thing, okay, I will be able to get the same answer. Fine, perfect. 1, 2, 3, 4, 5, 6, Krish. Now there is also one more important function which is called as keywords argument. Okay, now what exactly is keyword argument? Okay, let me just go ahead and create one more function. Okay, let's say I'll go ahead and write definition print underscore detail. Now how it is different from positional argument, you'll be able to understand. Keyword argument is given by double star, and you can write any parameter that you have. So usually the best practice that is basically used is KWARGS. KW basically means keyword argument, right? ARGS is a simple positional argument. Now inside this, let me do one thing. One thing that you really need to remember, in keywords argument, all the keys or all the parameters will be in the form of key value pair. Okay, again I'm repeating it. In keyword arguments, all the parameters will be in the form of key value arguments, right? Key value pairs. Now you know if it is in the form of key value pairs, that basically means you'll be able to access this like how we access dictionaries. So I may go ahead and write for key comma value in KWARGS dot items, right? Dot items, right? If I go ahead and execute this, what will happen? If I go ahead and print it, so it will be nothing but f key colon value, right? So I'll just go ahead and execute this. Now, how do we provide a keyword argument? It's very simple. Let's say I want to just go ahead and print these details. Let's say my first parameter is nothing but name. Okay, I've not defined it anywhere, but during runtime I'm just giving name, Krish, age 32, and let's say city or country. I'll go ahead and write country is nothing but India. Okay, now if I go ahead and print all these details, so directly see if all my values is in the form of key value pair, where I'm using a key name, I'm using a value name, key value. So all these parameters will be referenced by star KWARGS. Okay, star KWARGS. If all the parameters are just written like this, where it does not have any key name, then this basically becomes a positional argument. Okay, now let's combine both of them and let's see how things work right now. Okay, so I will just go ahead and write definition. Okay, and how do I specify my positional key argument? Nothing but star ARGS. So this will be my first parameter, this will be my second parameter. Now in my first parameter, I will go ahead and write, and let me just go ahead and display this. And for ARGS, I'm just going to display this values. Okay, let's say I'll not take numbers because I can display anything, right? For val in ARGS, print val. Okay, and here also what I'm going to do, just to make it much more better, I'm going to use this f string, and here I'm just going to use this indication. And I'm going to write over here, right? So what I've done over here for val in ARGS, print val. Okay, for key comma value in KWARGS.items, we're just going to print this. Now the best way is that I will go ahead and write over here something like positional argument. Okay, this will be my value. Now see, now I'm using both of them, right? Now how this function is able to identify, right? Let's say I'm giving print underscore detail. Let's say I give my positional arguments like 1, 2, 3, 5. Okay, and here I'll go ahead and write Krish. Okay, so this basically becomes my positional, all the positional arguments. And between them, I'll just go ahead and give this keyword argument. Let's say go ahead and give it anywhere that you want to give. Okay, now out of all these parameters, it will be able to identify. Okay, let's see what is the error that's probably coming over here. Positional argument cannot appear after keyword argument. See, this is the error. Now the main problem over here when we write like this, right? First of all, always remember we need to specify all my positional key arguments. Now I'll go ahead and write my keyword argument. Now if I go ahead and execute the details, see, initially first argument is positional argument, second, third, fourth, till here, and this all that you'll be able to see is my keyword argument. So this is very much important to understand the differences between positional and keyword argument. In keyword argument, you have all the parameters in key value pairs, like how we have specified over here. In positional, you just have something like 1, 2, 3, 4, 5 with respect to only the names that will be there. Will not be assigning any key names, right? So this is the most important thing with respect to keyword and positional arguments. I hope you were able to understand. I hope you are able to understand the difference between them. And it is very much important if you know this because next in the upcoming session you'll be seeing I'll be defining functions where I'll be having multiple parameters over there, and then we will also be seeing that. Okay. Now let's talk about the last topic for this video, that is called as return statement. And I hope I've already spoken about it. In return statement, our function returns something, right, after the entire statement is executed, right? So let me just go ahead and do it. So here I'm going to create my multiply function. This will be a comma b, and here I'll just go ahead and return a multiplied by b, right? So here we are returning some value after the function is getting executed. Now in order to execute it, so I'll go ahead and find my multiply function. Let's go ahead and write 2, 3, and finally I get my output. So functions can return multiple values also. Let's see whether this function will be able to return multiple value or not, right? So let's say I'll write c is equal to or let me just define this function once again, okay, and let me execute it over here. So here I'll say, hey, return a comma b comma a. Okay, let's see whether we'll be able to return this. So in Python, a function can also return multiple values. So here we are returning a comma b comma a. A comma b is nothing but let's say we 2 comma 3 are given, so 2 comma 3 is 6, multiply when we are doing it is 6, and a value is 2. So we can also return multiple statements, multiple parameters, multiple parameters from a function. Okay, and that is what we basically use. We need to use this return variable. So I hope you are able to understand this. This was it from my side. This was all about functions. In the upcoming session, we are going to learn many amazing things about function. There are many things like lambda function, nested function, high order function. We'll be discussing about them. So yes, this was it. I will see you all in the next video. Thank you. Hello guys, so we are going to continue the discussion with respect to Python, and now we are going to see some of the examples. Already in our previous video, we saw many topics regarding functions, and there are a lot of advanced topics that are going to come. But before that, I thought why not create some examples and show you how we can probably solve those, right? So first example over here is that we need to create a function for temperature conversion. So temperature conversion basically means we need to convert Celsius to Fahrenheit or Fahrenheit to Celsius. So how do we define a function? We'll go ahead and see. So let's go ahead and see this example. So first of all, I will go ahead and create my function. Let's say I'll write convert underscore temperature. So this is my function over here, and here I'll give two parameters. One is temperature, and one is the unit that I really want to convert it. Let's say if I give the unit over here as C. That basically means I need to convert this entire temperature from Celsius to Fahrenheit, right? And if I give the unit as F, right? So I need to convert the temperature from Fahrenheit to Celsius, right? So let me just go ahead and give a docstring. So this function converts temperature between Celsius and Fahrenheit. Okay. So this is what is my definition of this particular function over here, and we will go ahead and write our code, right? So here, let's say I will go ahead and write if unit is double equal to capital C, right? If I'm giving this particular unit, that basically means I need to convert my temperature from Celsius to Fahrenheit. So I'm going to return temperature multiplied by, and I'll do the operation 9 by 5, okay? And here, let me just give the bracket 9 by 5. I need to first of all multiply it. Then I will go ahead and do the addition plus 32. So this is the formula of converting a Celsius to Fahrenheit with respect to the temperature, okay? So this is the simple formula that we specifically use, and this in turn will be converting Celsius to Fahrenheit, okay? Fahrenheit, right? Then let me go ahead and write elif. Okay, so here we're going to use everything, whatever thing I've learned. Let's say there's some examples that I'm going to use dictionaries, some examples that I'm going to use list and all. In this particular case, you can probably see that I'm also using if elif, right? So if elif the unit is double equal to Fahrenheit, okay, then I'm going to basically return, okay, and for this particular temperature, I need to minus first of all 32 and then multiply by 5 by 9. Okay, and this will basically give us our Fahrenheit to Celsius, right? So this is the formula. If you go ahead and do the Google search also to convert Celsius to Fahrenheit, so this is the formula that you usually get. Okay, so that's it. This is what it is, right? And if I don't give any information for our third parameter, we need to also handle that. That is, if I'm not giving any unit, so I'll just go ahead and return none. Okay, none. So here I'm going to basically use this function. Now let me go ahead and call this function as convert temperature. And if I go ahead and write like a value, let's say temperature, I'm going to give 25, right? And this is in Celsius, right? Then I'm going to go ahead and print it, right? And I'll be basically getting converted. We are converting this from 29 degrees Celsius to Fahrenheit. The next one that I'm actually going to do is print. Okay. Again, I will go ahead and call my convert temperature. And here I'm actually going to give 77 comma F, right? And this I will be able to get the answer. Let's see whether it works. Yes, 25 is nothing but 77 degree Fahrenheit, and 77 degree Fahrenheit is nothing but 25 degrees Celsius. So this is how the conversion is done, and I feel that formula is absolutely right, what we have written. And here you can just see based on units, we are able to do it. So this is our first example. Now what I'm actually going to do is that I'm going to show you one more amazing example, which is called as password strength checker. Okay. Now what exactly is this? Let's say that we are creating our user ID or login, and over there we specifically give passwords, right? And most of the people just write password as 1, 2, 3, 4, 5. So we need to have a strong password check. Okay. So I'll be giving some of the check over here to just making you understand whether it is a weak password or a true or just a very strong password, right? So first of all, I'll go ahead and write my definition is strong password. So this function will be responsible in checking whether password is strong or not. Okay. So here you can see I'll just go ahead and write my docstring. This function checks if the password is strong or not. Okay. Now let me go ahead and write. Let's say the first condition, that first criteria I want to put with respect to the password. My password should be minimum of 8 characters, right? So I will go ahead and write if length of password is less than 8. So that basically means I'm going to just say, hey, this is a very bad password in short. So I'll just go ahead and say false, because this function that I'm actually creating is basically checking whether the password is strong or not. So right now the password is not strong, so I'm returning false. Then let me just go ahead and write another condition. If not, okay. So if not is one condition, if not any, okay. So here we are just going to see whether this character is having any digit or not, right? Whatever character, whatever password we are specifically giving, whether it is having any digit or not, right? So what I'm actually going to do, if not, is basically like comparing whether there is not present or not, right? Something like that. So I will go ahead and use the for loop for character in password. So we will go ahead and see each and every character, and here I will just go ahead and see whether this character is having any digit or not. Okay. So each digit is a function that is present in every character or string, right? So I'm just going to compare for every character in the specific password whether it is having a digit or not, right? If there is not any digits, right? So what I will do, I will again return false. Okay. Please see carefully what kind of condition I'm using, right? So this is just like any function or an inbuilt function that is present in Python, and we are iterating through each and every characters in that password, and we're seeing whether it is a digit or not, right? And this is digit is a kind of function that is available in strings. Okay, so this is one of the check that I really want to do, right? Then I will also be checking with respect to the password is lower. If all the characters is lower, then also we should return it false, saying that hey, it is not exactly a good password, right? So I will go ahead and write if not any. Again, I will go ahead and write my next condition, and here this time I will say hey for char in password, and here I'm going to check, right? And what I have to check over here, whether my character is lower. So is lower is one of the function that is again present in Python. Sorry, for character in password, I have to write. Okay, I'm just checking whether the character is lower or not for all the characters that are present over there. And if it is present, I'm just going to return the false. Okay. So guys, now we have written the condition still here. We have also checked like all the characters should not be lowercase. Okay. Now similarly, all the characters should also not be uppercase. And we'll also check for that, right? So here I'm going to write if not any, and this time I'll be using cat dot is upper, right? So there are a lot of functions with respect to strings which I can specifically use over here. And let me just go ahead and write for char in password. Okay. And this we'll go ahead and check it out, and we'll again write return false. Okay. Now this is there. Now let's think of more things. Let's see for any special characters. So for special character, I would like to add many special characters that are probably present, right? If not any, let's say in our character, if there is no special character like this, then also I can say that hey, this is basically a weak password, right? At least it should have one upper, at least it should have one digits, so this kind of condition. So here I've used all special characters over here for character in password, and then if it is not present, we are just going to return false. If everything satisfies, then we will go ahead and return true. Okay. So here all return false are there, and then here return true is there, right? So if all this condition is false, then if all this condition does not get satisfied, then we are just going to return true, saying that hey, this is super amazing password and it is a strong password. Now let me just go ahead and call the function. So calling the function over here, okay, and let me just give some of the things over here, right? So I'll go ahead and write print is underscore strong password, and let me just give one example. Let's say I have a capital letter, and I will write a small letter, again a capital letter, and this is weak password, okay? But here you can see that I'm not having any special character. Other than that, I think everything is getting satisfied, right? And digit is also not there. So I should definitely be getting false for this. One more way is that I can go ahead and print, okay, is strong password, and let me just go ahead and use some special characters. So I will go ahead and write str, and let me just go ahead and use 0 over here, okay, and I will be using ng capital P WD, and let me use one special character like exclamation. Okay, now let's see whether both of them, I think this should basically be giving me false and this should be giving me true. Okay, so now if I execute this, here you can see since I do not have a digit or a special character, I'm actually getting false. Here I have both a digit and a special character, so and that is the reason I'm also having a capital letter over here, so that is the reason I'm getting true. So this is one amazing example with respect to password strength checker. Just with the help of one function, we are able to do this kind of validation, and we are able to execute it. Okay, now let's go with the third example. Now this specific example I've actually selected just to make sure to show you like how in the real world application this can be used. So calculate the total cost of items in a shopping cart. So here we are going to define a function. So I'll go ahead and write def calculate underscore total underscore cost, and here I'm going to give my cart. Okay, now this cart will basically be having a lot of items over there, and we can also give in the form of dictionary. So right now I'm just going to do pass because first of all I'll see what kind of data I have. Okay, so let's just go ahead and show you some of the example with respect to cart data. And since we have already learned about dictionary, so we will go ahead and write cart is equal to, and we'll create a list, and this will be a list of dictionaries. Okay, so let's say my first item is something like with key value pairs, like name is equal to let's say I have apple. Okay, then I have price which is equal to 0.5, then I have specifically quantity. Okay, and this quantity will be equal to 4. Okay, now I'll go ahead and create my next example, and let's say this $0.5 I've written like that, right? Obviously, so here let me just go ahead and name should be banana. Okay, price will be $0.3. Let's say quantity, I'll say six bananas. This is the price, and let me just go ahead and again add one more item over here, right? Now let me just go ahead and write one more like orange. Okay, the price will be 0.7, and quantity I can write as 3. Okay, so this is my cart. Okay, with respect to all the items that I have. Then I will just go ahead and write my function over here. So let me just go ahead and create a temporary variable. Total cost is equal to 0. Now all I have to do is that I have to explore. I have to probably go through this each and every cart, take the price. Okay, and see this price is basically for one quantity. Okay, so we will go ahead and multiply with this many number of quantities. Okay, and again we have to retrieve the data from this particular dictionary, and then we will be doing the total sum. Okay, so now let me just go ahead and write from item in cart. So I will go ahead and explore this. Okay, so I will just go ahead and write total cost is equal to or plus equal to. Okay, so just like an increment operation where we are adding something. Then here I'm going to write item of price. Okay, item of price. So this for every item of price we are just going to multiply with the item of quantity. Okay, so let me just go ahead and write it down. Then I'll be getting my total cost. Then I can go ahead and return the total cost. So this function is just going to multiply the price with respect to all the quantity for each and every item. Now quickly let me just go ahead and call the function. So here I'm going to write calling the function. Okay, and here I will write total underscore cost is equal to calculate total cost, and here I'm going to give my data as cart. Now let's go ahead and execute it. I'll press shift enter, and here okay, let me just go ahead and print this total cost because we have not displayed anything. Now here you can see 5.889. So this is my total cost, right, with respect to all the items that I've actually bought. Okay, and this is amazing. I'm able to see the total cost of my entire cart. So here we have just created a function which is taking the cart item, and cart can be given as a dictionary list, whatever things you really want. Then we'll iterate through each and everything and we'll calculate the cost. Perfect. Let's go ahead and see one more example. This time what we are basically going to do over here is that we are going to check, we are going to create a function which will be checking if a string is palindrome. Now what does palindrome basically mean? So if you just want to understand about palindrome, right, some of the examples, let's say if I use the string ABA, if you read it from the front direction, it is ABA. If you read it from the backward direction, it is again ABA only, right? So from front and back, both are same. Okay, so we are going to basically write a function which will be able to do the check for any string from whether from the front it is equal and from the back it is equal with respect to the characters that we have. It should be same. Okay, so here let us go ahead and define a function. So I'm going to write is underscore palindrome. So I'll just go ahead and write the function is underscore palindrome, and here I'm going to give my string. Okay, now the best way to do is that whatever string I write, right, between all the spaces, first of all, I should remove it. So I'll take the string, I'll write s.lower because I have to also do the lowering of all the characters. And let me just replace all the empty string, okay, with a string, right? With like I should just remove that empty spaces. Now, the best way to do this is that I hope everybody knows in string we have discussed about slicing operations and all. So I will just go ahead and write colon colon -1. Okay. Now, if this string is if I'm see this is what I'm getting the reverse of a string, right? If I'm writing this particular code, I just need to compare this with my s, right? So if I go ahead and write s double equal to, this will either give true or false. This is basically the reverse of this specific string itself, right? So if both of them are equal, then we can definitely say that it is a palindrome. Now let us go ahead and see here. I will go ahead and call is palindrome. Now in Google also you can search for different text, right? So I will use a sentence which is called as a man, a plan, canal, Panama. Okay. Now, if you read from here, right, and if you read from the reverse, it is almost same. See, a man, right? So if it is starting from a man, so here also from backwards, if I read a man is over here, right? Then again a plan, so a is over here and plan is still here, right? So if you read this particular sentence, it's reverse. Again, it is almost same, right? So let's go ahead and print this. And next one, I will just go ahead and take one sentence which is not palindrome. So let me just go ahead and write hello. So in hello case, I don't have the same sentence from forward or backward, right? It is not equal. So first one should be giving me true, and second one should be giving me false. So here you can see it is true, and the second one is basically false. So this is one amazing example with respect to palindrome, and just by using the string operation, slicing operation, how easily you are able to do it. Okay. Now the next example that we are basically going to see is something called as factorial of a number using recursion. Now, what is recursion? Recursion is nothing but if I create a function, that function inside the body of the function will be called again and again. Okay. And if I talk about factorials, let's say I would calculate 5 factorial. So it is nothing but 5 into 4 into 3 into 2 into 1, right? So this basically is the operation of any factorials, right? So I have to write a function which will be factorial. And let's say I want a factorial for 5, right? So first condition will be that if n is equal to 0, right? Then what I need to do, I just need to return 1, right? Because 5 into 4 into 3 into 1, right? So 3 into 2 into 1, it should be like that. If I'm starting from 5, it should end till 1. So if n becomes 0, I need to just return 1, okay? Else, I'll go ahead and just use one simple return n multiplied by factorial n minus 1, right? So here I am calling this particular function, right? So initially if I give 5, right? So what will happen? This condition will become false. So it will just go ahead and write 5 multiplied by factorial of 4. Then again, factorial of 4 when it is called, it will be 4 into factorial of 3. Then 3 into factorial of 2. Then 2 into factorial of 1. Then 1 into factorial of 0. When 0 comes, return 1. So it will be multiplied by 1, right? So now if I just go ahead and call the function, it will be nothing but I can just go ahead and write factorial with respect to 5. And here you can see this is my output. If I want factorial for 6, this is the output. Here you can see, and I'm able to get it, right? And this is what is called as recursion. In recursion, inside a function, you're calling the same function unless and until based on this condition, it will keep on executing. Okay. So there are two more examples of function to read a file and count the frequency of the word. Okay, I know I have not discussed much about file operation yet. Okay, but I really want to show you, like, let's say that I have one file over here, sample text. I have written 2 lines of code. Hello world, how are you? My name is Krish. Okay, as we go ahead, we'll be discussing more about reading file and doing file operation. But here, I just want to give you an example, like how we can create a function to do this task. Okay, so first of all, what I'll do, so my task is very simple over here. I will try to read a file and count the frequency of each word. Right, so how many times each word is present. Okay, so quickly we'll go ahead and write definition count underscore word underscore frequency. Okay, and now I'm just going to give my file path. The best way to read file path is by using with open function. Open function is there in Python where you can specifically use and open any kind of file. So I will go ahead and write word underscore count, and I know that since I need to count the frequency of each word, so I need a dictionary over here. So this will be an empty dictionary. Now I'll go ahead and write with open my file underscore path, and this will open in my read mode. Okay. So for read mode, I will give it in string. Okay, and there is also like write mode and all, which we'll be discussing as we go ahead in the upcoming sessions. And then we will go ahead and write as file. Then we will go ahead and write for line in file. Okay, and we are just going to write words is equal to line dot split. Okay. Line dot split. So we are splitting it based on new line characters. We are going through this particular file, right, with respect to that. Okay. Now once I get the words, right, by using this particular line of code, we will be getting words because every space it will try to calculate, it will split it, and it will retrieve all these words. Okay. Now once we get the words, what I will do is that I will go ahead and write for words in word. Okay. And here I'm going to basically write word is equal to word dot lower. Okay. So I'm going to do the lower operation. First of all, I really need to make small for all the words. Okay. Then let's say I want to probably do dot strip operation. Okay, and if you don't know about dot strip, you'll be able to understand whenever I give any specific words, it should be able to split based on any kind of character because I need each and every word. So I'll be using some special characters like colon, slash, exclamation, everything. I'll be using this even like it should also split HE also separately, right? So that is the reason I've given this also. And if there is exclamation, everything, I'll try to strip it and I'll try to get the word. Okay, then I'll just go ahead and write word of count, and I'll take that specific word. Okay, please focus on the logic. Okay, logic is super important. And logic you become better when you keep on practicing. Then I'm going to write word underscore count dot get, and here I'm going to write word comma 0. Okay, word comma 0, and then we are going to add it with 1. Okay, so I'm using this get function which is available in the dictionary as I have already shown you, and I'll go and search for this specific word. Okay, if it is not present, then the value will be assigned to 0. Otherwise, we're just going to increment with 1. And we have already seen dot get in our previous videos when we discussed about dictionaries. And finally, once it does it, I'm just going to return my word count, and it needs to be with respect to this particular width, right, in the same line. Now let me just go ahead and call the function. Here, first of all, I need to give my file path. Okay, file path is very simple. In the same working location, I have sample.txt file. So this is the same file. It is present in my same folder location, that is functions. So I'm just going to go ahead and call this. Then I'm going to use word underscore frequency is equal to count underscore word underscore frequency, and then I'm just going to give the file path. Okay, so this will basically be my file path. Now after this, I will just go ahead and print the word frequency. Now see, each and everything is done. Let me execute, and always make sure, guys, indentation is the main key thing. Many people may face problem if your indentation is not correct. Okay, so now if I go ahead and execute it, cannot access local variable word where it is not associated with a value. So let's see where is the error. So word frequency of word, frequency of file path. If I'm going inside this particular function, inside this it is going to for words in word. Okay, okay, it should be opposite. Okay, so I'll just go ahead and write this because I have to access words. So here you can see hello is present, 1 word is present, everything is present 1. Okay, so let me just go ahead and save it, and let me write again Krish Okay, so Krish is present 2 times. So if I go ahead and execute, I should be getting Krish 2 times. So here is Krish. Okay, a simple example of a function to read a file and count the frequency of each word. So here we have taken a sample file and we have read it in the read mode and we have counted each and every word. Amazing function again, and I hope you're learning many things out of it. Okay, more about the file operations we'll be discussing. There's a separate section that will be coming up as we go ahead. Now, final task. This is for you. Anyhow, I'll be giving you the code. Okay. So here the question is very simple. You need to validate the email address. Okay. So let's say that you there's a subscription emails that you really want to get from a company. Let's say there's a page and people will go ahead and write any email and just click on start subscription, right? If they want the free materials or anything as such. Now the problem is that someone may not put a valid email address. So we also need to do the valid email check. So for this, I will already give you this particular code. Okay. And you can go ahead and write out and just try to understand it. Here I've used every special characters. Okay. It should be matching this pattern, right? Like let's say one of my email address is some username at the rate. It can be gmail.com, right? So similarly, this is my first regular expression, right? It can be between A to Z, capital A to Z, 0 to 9 plus. Then again, at the rate will be there again. You can have Gmail, you can have Hotmail, you can have Yahoo, anything as such, and then finally .com. Right, so this will be the entire matching for the regular expression. I will talk more about the regular expression as I go ahead. Now, if I go ahead and check this, you'll be able to see it. Here you can see this is my true email. This is a valid email. This is not a valid email. So just go through this and check it out. The reason why I'm including some new things so that you get excited by just seeing all this kind of application. So I hope you like this particular video. This was it from my side. I will see you on the next video. Thank you. Hello guys, so we are going to continue the discussion with respect to Python, and in this video we are going to discuss about lambda functions in Python. Now, what exactly is lambda function? Lambda function is a small anonymous function defined using the lambda keyword. Now whenever we talk about anonymous function, it can be basically said a function without a name, right? So they can have any number of arguments but only one expression. Okay, and they are commonly used for short operation or as arguments to higher order function. Now here let me discuss about 2 to 3 keywords. First of all, anonymous function. Anonymous function is basically a function without a name, and in order to create lambda function we specifically require lambda keyword, and they can have any number of argument but only one expression. One expression basically means one logic, right? So here is one of the syntax I've given it over here, like lambda arguments colon expression. Now let me just show you with some of the good practical examples so that you'll be able to understand how does lambda function basically work. Okay, now let me do one thing. Okay, let me just go ahead and create a function just called as definition a comma b. Okay, now what I'm actually going to do over here is that I'll return a plus b. Now here obviously I've created a function which is taking 2 numbers, and here clearly you can just write 2 comma 3, and here you'll be able to get an answer. Let's say the addition of 2 numbers 2 comma 3 is 5. Now over here this is just a basic function, right? And inside this you just have one expression, one logic that you have written, or one operation that you have written over here, right? And for this you have created entirely one entire function. You have written the definition keyword a comma b, all these things you have specifically written. Now what it says is that if you have just one expression, and let's say you have multiple parameters over here, then instead of just creating a wholesome function over here, you can create an anonymous function which is also called as lambda function, a function without a name. Now if I really want to convert this function into a lambda function, see the syntax. Okay, so first of all I will go ahead and write lambda, and then the second parameter that over here it is asking is argument. So what are arguments I'm giving for this particular function? It is very simple. It is a comma b. Okay, now with respect to a comma b, I need to go ahead and write my expression. Expression is what task or what operation I'm actually doing. Okay, so once I execute this, so you can see that this becomes an anonymous function or lambda function also. So here I will just go ahead and create a variable, and this addition variable will be my lambda function. Okay, if you don't believe me, let's go ahead and see the type of addition. Okay, and we'll try to print it. So here you can see it is a function. Okay, lambda function is not saying, but here you can see that it is a kind of lambda function itself. A function without any specific name, like we did not use any definition. We have just created a variable. Now in order to call this, okay, all I have to do is that just call this variable, give the parameters that I want. Let's say I want to give 5 comma 6, and let me just go ahead and execute it. So here you can see automatically with the help of this lambda expression, entirely the operation is basically happening. Here these are my arguments and this is the expression that we have specifically given, right? So I hope you are able to understand, and how beautifully just by understanding the syntax we have just given the values over here and you're able to see the answer. Okay, let me do one more thing. Okay, let me just go ahead and create one function. Let's say I'll create a function which is called as even. Okay, and here I give a number. Okay, now with respect to this number, I'll just go ahead and put a condition. If num modulus 2 is double equal to 0. So in short, I'm just checking whether the number is even or odd. Then I'm just going to return the value as true. Okay, perfect. Now let me just go ahead and give the value. So here I'm going to call a function write even 24. So here I'm actually going to get true. Okay. Now similar, if I want to convert this into a lambda function, let me just go ahead and create a variable even 1. I'll be using lambda. I'll give my parameters. What is my parameters? Arguments that I need to give only num. Then I'll write my colon, and all I have to basically do is write my expression. And the expression is over here, simple num modulus 2 is double equal to 0. Right. Now this even 1 becomes my variable. So now if I go ahead and just go ahead and write 12, now it is going to give me true because 12 is basically an even number. Right. And here you can write any variable. It is not necessary that you only need to write number. Okay. You can write A, you can write B, you can write C, whatever things you specifically want to write. Okay, based on that, you can actually do that. Now, let's try with some more examples. And here, this time I'm going to take multiple parameters. Okay, so let me just go ahead and create one function which is called as addition. Let's say, and here I'm actually going to give my x comma y comma z. So these are my parameters. I'm just going to return x plus y plus z. Okay. Now, when I'm actually doing this, if I'm calling my addition function, so here you'll be able to see that I'll give my values. So let's say 12, 13, 14. If I execute it, the sum is basically 39. Now let me show you how you can actually convert this into a lambda function. I'll create addition one variable, and now I'll be using a lambda function. And with respect to the specific lambda function, what I'm actually going to do, I'm going to give my arguments, which all is required. Let's say x, y, z. Then I'll be giving the colon, and I only have to write expression, and I've already shown you how to write it down, x plus y plus z, right? So this is it, and if I go ahead and call my addition 1, so here you'll be able to see that if I give my values 12, 13, and 14, I should be able to get 39, right? So through this way, I am not wasting much time to probably create a function. Instead, just by using a lambda function or anonymous function, I'm able to do all this kind of expression operations, right? Again, to repeat, guys, lambda function, where only a single expression is there, we can actually convert that entire function into a lambda function itself. Lambda function has more amazing features, but for that we really need to understand about map, and there are 2 functions which called as map and filter. So in the upcoming videos, we'll be discussing about this map function and filter function, and I'll just give you one example right now, just to make you understand what exactly map and filter basically does. Okay, so yes, in the next video we'll be discussing more, but I just want to give you the expression of power of lambda function with map. Okay, so let's say I want to probably go ahead and create a list, right? And with respect to the list, I have values like 1, 2, 3, 4, 5, 6. Okay, now let's say that I want to find the square of each and every number, right? If I want to find the square of each and every number, or let's say I want to just go ahead and see that, hey, let's say I'll just go ahead and create a variable. Let's say square underscore numbers. Okay, now in order to find out square for every number, right? What is the kind of function we'll define? Let's say I'm going to define definition square. Okay, square. And here I am going to give my numbers, or let me just give single number. Then what this is going to do? Return number double star square, right? So here we are just giving a square. And if I give two number, I'm going to get the square of that particular number. This is fine. And this is only for one number, right? Now, if I'm giving for a list of number, then what I have to do? I'll give this number as a parameter over here. I'll write a for loop, iterate through each and every number, and do this particular operation and return it, right? But is there a better way instead of iterating it thoroughly? Probably writing more couple of lines of code for this, right? Is there a better way? So we can specifically use this map function. Map function, what it does is that it applies a function to all items in a list, okay, right, or any collection also. Okay, so what does this basically mean? And I will show you along with the map function. Okay, so now, sorry, along with the lambda function. Now let me just go ahead and create this lambda function. So first of all, I will go ahead and write lambda. I know what is my operation. My operation is basically squaring, right? So I will create a argument. So argument I will be requiring a number x, and the expression will be x squared. Okay, so this basically becomes lambda, right? Now, map basically requires the first parameter in map is basically a function. The second parameter is iterables. So this actually is my lambda function, or you can also call this particular function, but right now I'm giving my lambda function over here. And the second parameter that I'm actually going to give is nothing but my numbers, right? So here is basically my map, right? Now, at the end of the day, if I execute this, this basically creates a map object at this particular memory location. And map usually uses a lazy loading technique. That basically means still it is not completely initialized. So to make it initialized, I will convert this into a list. Now see the magic, okay? For every number in this particular list, automatically you're able to get the square, right? Isn't it beautiful? So I will just try to show you like how we can use map, lambda, and there's also one more function which is called as filter, right? And I'll explain all these things in my upcoming video. So yes, this was it from my side. I will see you all in the next video. Thank you. Okay, so we are going to continue discussion with respect to Python, and in this video we're going to discuss about the map function. Okay, so what exactly is the map function? It applies a given function to all the items in an input list or any other iterable and returns a map object, an iterator. This is particularly useful for transforming data in list comprehensively. Now, the best example to show you that why do we exactly use map? Let me just go ahead and write a code for you. Okay, so let's say I will just go ahead and define one method which is called a square. Okay, so what the square does is that it takes an input and it just multiplies, or it does a square of that specific input, or it multiplies it with itself and it gives us the result. Okay, so if I go ahead and try to put any number over here, let's say square of 4 is nothing but 16. If I go ahead and ask square of 10, then I should be getting 100, right? Now this is fine, right? Here it's very simple. I'm just giving an input and I'm doing the square of it. Okay, now let's say if I have a list of numbers, or let's say I have a numbers in the form of list, or it can be in the form of tuple. Let's say in this particular case I have all these numbers 1 2 3 4 5 6 7 8. Okay, now I want to apply the same operation for each and every number. One way is that I may probably give the list directly over here, then I may put a for loop, right? Iterate for each and every element, and then probably do the multiplication and append in a separate list, right? So for doing this specific operation, I need to do so many things, right? I need to create an empty list and again do the append operation inside that, iterate through all these particular elements. Now, instead of doing all those things, we can directly use map, right? Now let me show you what does map usually take. Okay, now I want to perform these operations on all these elements. So map usually takes two input parameters. Okay, one is the function name and one is the iterable. Iterable basically means the collection, right? So in this particular case, if I'm calling map, so first parameter that I'm going to give is square. So square is my function. I don't even have to use brackets over here. And the second thing that I have to give is my iterable, that is my numbers. Okay, so if I go ahead and execute this, here you can see that it has created a map object at this specific memory location. Now since I want, let's say, all the values in the form of list, so I will just go ahead and convert this into a list. Okay, so if I convert this into a list, so here you'll be able to see the output, right? Now what this is going to do is that it is going to take each and every number. The map is going to take each and every number, call this particular function, and basically just for each and every number, it is just going to do the square, right? Now if I go ahead and see the answer, so this basically becomes my list over here. So I have to use this brackets since, okay, now let's go ahead and see this. So here you can see for every number 1, 4, 9, 16, 25, 36, 49, 60. It's just squared up each and every number. So this is one basic example of using map, right? So it applies a given function to all the items in an input list, like in this particular case it is list, or it can be any other iterable. Okay, now this is amazing. Let me just show you more functionalities, and this time I will be using lambda function with map. Okay, lambda function with map. And obviously lambda function, you know that if there is a single expression, you can just go ahead and apply lambda. Okay, so I will take the same operation. So let's say this is my numbers. Okay, now how do I apply? Instead of this particular function, I'll apply lambda function and I'll give the same number. So again, I will go ahead and write list, and here I'm going to use the map function. The first parameter will be my lambda function. Lambda function is nothing but it is an anonymous function. So I'll just go ahead and write lambda. Now what is the kind of operation that I really want to do? So input argument will be one x parameter, let's say any x parameter, and here I'm just going to multiply x into x, right? And this is my entire lambda function itself, right? Now the second parameter is nothing but my numbers, which is my list. Now if I go ahead and execute it, here you'll be able to see with the help of lambda function also we're able to execute this. Okay. Now this is also very much simple, very much easy. Here you can write any kind of operation. Let's say I want to just add 10, I want to add 100, I want to do the multiplication, division, anything that I really want to do, I'll be able to do it. Okay. Now let's say that, okay, fine, this is fine. Okay. Can we map multiple iterables? Now the question is, can we map multiple iterables? Okay. And that is what we are going to discuss over here. So let me go ahead and write numbers 1. Okay, numbers 1. And here I'm just going to create 1 2 3, and then I'm just going to write numbers 2, which is equal to 4, 5, 6. Okay. Now, since I have two iterables over here, and what I really want to do is that take each and every element from this iterable and keep on adding both of them. Let's say my final output should be a list of elements where I'll be adding the first element, second element, and third element. So my final answer should be 5, 7, 9. Okay. So can I do that with the help of map and lambda function? So here I'm just going to go ahead and create added underscore numbers. Okay, and here I'm going to just go ahead and use map. Along with that, I'm going to use my lambda function. Let's say I'm going to take two parameters, right? This will be one parameter, this will be the other parameter. So I will just go ahead and use x, y. And now my expression will be very simple, right? I'm just going to add both these numbers. So it should be x plus y, right? Now the second parameter that I'm going to give is my numbers 1, right? So it should be my numbers 1. Now second parameter also I can actually give, right? So second parameter will be my next list, right? So here I'm just going to go ahead and paste number 2. And this all needs to be converted in list. Okay. And now if I go ahead and print my added numbers, so here you can see that I'm able to get 5, 7, 9, right? So this is one amazing example directly what I'm actually doing. Now there are multiple things that we can do with map. Let's show you one more operation. So here now I try to use map to convert a list of string to integers. Okay, I'm going to do this. Okay, now let's say that I have this entire code. Okay, I'll just show you this code. Very simple. So here in my string numbers, what I'm actually doing, I'm just applying map. The function will be int. So typecasting is basically done on all the string underscore numbers, which is in the form of list. And here you can actually see I'll be able to get the output. So there are a lot of options that you can specifically do with the help of map. Again, you can use inbuilt function like int, like string.upper, anything that you really want to do. And one thing you have to make sure, whenever you are using function, I don't have to use any brackets, right? So like lambda function I've called, square I've called, square is already defined over here. I don't have to use any brackets. Okay. Now let me just show you one more good example that how I can apply inbuilt function with the help of map. So let's say these are my words. Okay, the first word is apple, and let's say that these all are in smaller character. Then I have banana. Then I have cherry. Okay. Now what I'm actually going to do, I'm just going to create my upper words, and here I'm going to use list of map. Okay. And now I know that in string there is a method is called as dot upper, and I need to apply this str.upper on each and every words, right? So I'll just go ahead and write words. So once I do this and once I print my upper underscore words or word, I'll be able to see this. See, apple, banana, and cherry is there. Okay. Let me just do one more thing, one more best thing over here. Let's apply to a list of dictionary. Let's apply a map function to a list of dictionary. So I will go ahead and create a function which will be saying get underscore name. Okay. So here I will be giving my dictionary. Okay. This person will be a dictionary, and I will return person of name. Okay. Now this is fine for one dictionary item, right? But what if I have a list of dictionary item? Let's say that I have a list of dictionary item which I will define over here. So let's say I will go ahead and write people, and let me quickly go ahead and define over here, and let me go ahead and write name colon. Okay. And name will basically be Krish, comma age. Age will be nothing but colon 32. Okay. So this will be my first name item or people item, and then let me just go ahead and say name colon is equal to Jack. Okay, and then I have the age as 33. Okay, so this will be my second item. Okay, now I want to perform this not only to one item, instead all items, right? So let's say I've just taken two over here. Now how do I do it? First of all, I will use list, then I will use map. The map first function will be get underscore name. Okay, then I'll be applying this to my entire item, and here I have list of dictionary items, right? So if I go ahead and see the output, here you can see from these two records I've explored Krish and Jack, and it has been given me in the form of list, right? This is one amazing things that you'll be able to see over here. And at the end of the day, you can apply even multiple functions if you want. You can create multiple functions and apply to the same list of elements. So in conclusion, if I really want to talk about map, so here one thing is that map is used. It is used in various places. So I'll just give some kind of conclusion over here. So map function is a powerful tool for applying transformation to iterable data structures. It can be used with regular functions, lambda function, even multiple tables, providing a versatile approach to data processing in Python. So by understanding utilizing map, you can write more efficient and readable code. So it is quite efficient, you know, in just single line things without iterating. You're using these particular efficient data structures, and at the end of the day, you just need to make sure your code is much more readable, the efficiency is there, performance is there with respect to this. So I hope you like this particular video. This was about map function. I'll see you on the next video. Thank you. Hello guys, so we are going to continue discussion with respect to Python, and in this video we are going to discuss about filter function. Now what exactly is filter function? So filter function constructs an iterator from elements of an iterable for which a function returns true. It is used to filter out items from a list based on a condition. So finally, just to understand what does filter function do, it is used to filter out items from a list or any iterable based on a condition. Okay. So in order to make you understand, let me just go ahead and quickly write a code for you. So here I'm going to create a definition. Let's say this is my function which will tell whether a number is even or odd, right? Or let's say this particular number is this function is just going to check whether the number is even, and it is just going to return true or false. So here if I'm giving num, okay, and let's say that I'm going to write my condition if num percentile 2 is double equal to 0, then what we are going to do, we're just going to return true, right? So perfect, this works absolutely fine. We have seen this kind of function a lot. So now if I just go ahead and give my 24, so it is just going to give me true because this is obviously a true number. But let's say that now I have a list of elements, and here I have like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, something like this, 11, 12. Okay. Now I want to apply the same operation on top of this particular element, and I want to just filter out which satisfies only the specific condition, right? So now focus on the last statement. It is used to filter out items from a list based on a condition, right? So this is my condition, and I want to filter out from this specific list, right? So how do I do it? Yes, I can actually do it. I can just iterate through all these particular elements inside this even function, and then I should be able to do it, right? I should be able to get true, you know, probably append it in another list and get the values. But let's do this with the help of filter. Okay, now in filter, if you know about filter, right? Filter usually takes first parameter as again function. So in this case, even is my function, and the second parameter will be my list. Okay. Now what this filter does is that whatever condition I've written inside this particular function, only that will get applied into this, and the elements will be taken from the list only which satisfies this condition, right? Which is returning true. Only that elements will be taken up. Okay. So here when I say filter even of list, and let me just go ahead and probably convert this into a list, you will be able to see that I'll be getting all the elements that are only even, right? So this is a basic example to understand about filter function, right? So it applies a kind of filter on the list that we specifically have. Okay. Very easy with respect to this. Now let's go ahead and see more examples, and this time I'm going to take filter with a lambda function. Okay. So lambda function, and I'll try to use the same thing, or let me just use some other things. Like let's say this is my number variable. I have like 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And then I will say, hey, do a filter and try to just take out greater than 5. Okay. Greater than 5. Okay. Try to create a filter something like that from this particular list. I should only get numbers that are greater than 5. So now I will just go ahead and write list. I will go ahead and use filter function. Now let me just go ahead and define my lambda function, right? Lambda function will be very simple. If I go ahead and write this lambda expression, this will be my argument. Argument, and I'll be writing my expression that is x is greater than 5, and on which list I'll basically apply this entire thing in my numbers, right? So this entire function is going to get applied on this particular list. Now once I go ahead and print it, you'll be able to see that I will only be getting the elements greater than 5, right? So this is one amazing thing with respect to list, and here with a simple just logic how you're able to use filter. Even in the previous video we saw about lambda also. Now I will show you filter operation with multiple conditions. Okay, so here I'm going to say filter with a lambda function and multiple conditions. So just to make you understand what all things are possible. Okay, so multiple conditions. Now as usual I'll take these numbers. Okay, right, and let's say I will write a variable even and it should be even. I'm writing to check, okay, even and greater than 5. Okay, so this is my variable that I'm actually going to create. Two things I'm actually doing over here. First of all, I will check whether the number is even or not. We'll filter out based on the number is even or not, and it should be greater than 5. So in this, I will again use list. I will again use filter. Okay, and along with that, I will use my lambda x colon greater than 5. Okay, so this is my one condition, and I will go ahead and use one logical and. So and operation over here I will use, and this will be x percentile 2 or modulus 2 is double equal to 0. So these are my two conditions. If it is getting satisfied, and this will get applied to all my numbers, list of numbers that is available over here. So inside this lambda function, what we are doing, we are applying two expression. One is x is greater than 5, and the other one is x modulus 2 is double equal to 0. Right now, if I go ahead and print, so what it is going to do, first of all, it is going to check whether it is even or not, and then whether it is greater than 5. So out of this elements, you'll be able to see that I'm able to get only 6 and 8. Remaining all elements are odd or less than 5. Perfect. Let's go ahead and see one more way of doing this. Okay. Now let's say that I want to apply a filter operation not only on list, let's say on dictionaries. Okay. So here I will just go ahead and do this. Okay. I will say, hey, apply filter to check if the age is greater than 25 in dictionary. Okay. So here you can basically see I will just create some data, and again I've already created this kind of data. So let me see from my which functions. Map function, I think I've actually used this kind of data. Yeah. So this is my people data. Okay. So here I have specifically people data. I will use this same thing. Okay. Just trying to save time. Okay. Now from this, I will create a function where I'll say age greater than 25. Okay. And let's say I'll just make some more data over here. I will copy. I'll put over here. I'll say Jack. Then along with this, I'll say John. Age will be 25. Okay. And then what we're going to basically do, we're going to create a function here. We're going to give the person information, one item person information, and then we're just going to return the person of age, right? And this age should be greater than 25. And based on this, either it will return true or false, right? Now we are just going to apply this with the help of filter, and we will use this particular function. So I'll say filter, and this will be my age greater than 25 along with my people, because I need to apply this on my entire collection that is iterable, and then I'll try to convert this into a list. So if I go ahead and print it, so here you'll be able to see name, age, age 32 and 33, because this particular condition checks only and returns only the age. Based on the age condition greater than 25, it will return those specific records. And yes, from this particular filter operation, you'll be able to see that I'm able to do this, right? So these are some of the amazing operations that you can do with filter. So I definitely like to put some kind of conclusions, and I'm doing that particular thing with respect to every video that I record in this. So here, these are some of the conclusions. So here you can see the filter function is a powerful tool for creating iterators that filter items out of an iterable based on a function. It is commonly used for data cleaning, filter objects, and removing unwanted elements. By mastering filter, you can write more concise and efficient code for processing and manipulating collections in Python. So yes, this was about filter. Now as we go ahead, we'll be discussing about, and again we'll be reusing all these things. But I think you got a clear idea about functions, different types of functions, anonymous function, lambda function, maps function, filter function. So yes, this was it from my side. I will see you all in the next video. Thank you. Take care. Hello guys, so we are going to continue our discussion with respect to Python, and in this video we are going to discuss about modules and packages. Now in Python, already it is an open source programming language, and as you all know that it has a lot of packages, through which you can actually use those packages. There will be a lot of different inbuilt functions that will be available in those packages, so that you don't even have to write the code completely from scratch, right? So just by using these modules and packages, you can actually use the functions that are available over there and quickly write down the code, right? So here, modules and packages helps organize and reuse the code. So let me just show you, and let me talk about some of the important modules that we specifically use. And there are a lot of modules over there, and as you will be seeing, as I will be probably going ahead with more tutorials, you'll be seeing different packages that I'll be using. So first of all, I would like to show you how do we import a package, right? So this math, right? So let's say I'm importing math. This math is just like a package or a module, and inside this, I'll just say that this is a package, and inside this you have a lot of inbuilt functions, specifically mathematical operations that you really want to do. It will be available over here. So in order to import any package, we just need to go ahead and write import and that the package name. Okay. And let's say if this package is not installed, then we have to probably install this particular package. Okay. I'll show you one of the example. Let's say that I want to use NumPy. NumPy is an amazing package which works with array. I'll show you how to install it and probably go ahead. So here I have imported math. Now math has a lot of inbuilt function. Let's say I'll go ahead and write math sqrt. So this is basically a function which will do the square root of a number. So if I give the number over here and if I execute it, here you'll be able to see that I'm able to get the square root of 16. Okay. Similarly, you'll be seeing I will have different functions inside math, right? Let's say I want to use square root also, right? So how do I import square root function from this particular package? So I can just go ahead and write from the package name, right? So let's say from math import import sqrt, and let's say I want to use one more function that is available inside math, so it will be pi. Okay, so there are two functions that are available inside math. Okay, and if you want to probably go ahead and check it out, you can just go ahead and write math dot, and these are all the inbuilt functions that are available with respect to this particular package, right? Math dot, and here you'll be able to see it. Okay, so let's say I want to use the square root of pi, so I've imported both these functionalities over here. Now I can directly call this functionality or call this function. So I will just go ahead and write sqrt. Let's say I want the square root of 16, and then I want the square root of 25. Let's say, or I want also to probably print, what is the pi value? Okay, so pi, everybody knows how much is the value, right? 3.142. So if I go ahead and execute over here, you'll be able to see square root of 16 is 4, square root of 25 is 5, and pi is definitely 3.141. So similarly, in every packages, you may be having multiple functions which you can directly use it. And in order to import it, you just need to remember this particular keyword from the package name. Import any function that you want that is available in that particular package. Okay. Now let's say that you don't have a package right now. Let's say there's one more package which is called as NumPy. So I will go ahead and use NumPy. I will talk more about NumPy as we go ahead in the upcoming sessions. So there will be a detailed video on NumPy and pandas. NumPy is specifically a library that will be used whenever you want to create arrays, you want to apply different operations with respect to arrays. So that where this particular package will be used. So if I am using NumPy, let's say I'll go ahead and write import NumPy as np. Now what this np is nothing but it is an alias. Okay, alias. I don't even have to write every NumPy dot. I can directly use np dot. So like my code, I don't have to completely write the entire package name. So that is where we specifically use the alias. Now let's say that I'm importing this, and if I import this, I'm getting an error, no module name NumPy, because obviously I've not installed NumPy. When you create an environment by default in Python, virtual environment, some of the packages, some of the modules will get installed, but not every module will get installed, right? So let's say that I want to probably go ahead and import NumPy, and for that I need to install. So what I will do in the requirement.txt, I'll go ahead and write NumPy, okay, and I'll save this, okay. Now I'll go to my terminal, okay. Now let me just go ahead and show you in my terminal. So my terminal will be over here, and I am in my command prompt. I'm inside my Python basics, so I will go cd dot. I'll go back because this is entirely this requirement.txt is present in this Python folder, right? Now I'll go ahead and write pip install -r requirement.txt. This is one way that I can directly write, or I can also go ahead and write pip install NumPy. Okay, So if I go ahead and pip install numpy, you'll be able to see that, hey, my installation will start taking place, and this will basically get installed in my VENV environment. Okay, so this is how things you basically do, and now you can see my numpy has got installed. Okay, now I'll close this. Okay, and what I will do, I'll go again back to my statement. Now let's go ahead and import this. Okay, now here you'll be able to see that my import is successful. Okay, now let me just show you one simple operation where I will be trying to create an array, and here I will give 1, 2, 3, 4. So if I go ahead and execute, I will basically get an array. We'll discuss more about the numpy, but since we are just discussing about basic Python modules and packages, we're discussing over here, right? Now this is like there'll be a lot of inbuilt modules. Okay, let's say from math I want to import every module, right? So what I can do is that I will go ahead and write from math import star. Star basically means it is importing all the functions that are available in math, right? I don't have to specify, right? Now I can directly go ahead and call sqrt. Okay, let's say I will go and call sqrt. So sqrt is an inbuilt function that is available in math, and since we have done import star, automatically I'll be able to see the output. So here you can see I'm getting the answer as 4, right? And similarly I can go ahead and probably print my pi. Okay, and up also I will just go ahead and use a print statement. Okay, print statement, and then we are uploading this, and here you can just see by import star that basically means we are able to access all the functions that are available inside this particular package or module, which is called as math. Perfect. I hope you're able to understand till here. There are different libraries that we'll be seeing when we'll be doing the coding, but just get an idea in this particular video. What I'm actually trying to show you is that how do you import a package or a module, an inbuilt module that is already available, inbuilt packages that are already available like math, numpy. If there is no library as such, you can probably install it. Okay. Now the most important thing, how do I probably create my own custom package? Okay. Now let me show you one thing over here. Okay. Let me just go ahead and create one folder, and this will basically be my package. Now let's say that this is my source code that I'm going to write. Okay, I want to define my own custom, you can basically say custom module or custom package, which I should be able to call in any other files. Okay, because here you can see that I'm importing math, right? And this math may be available somewhere, right? It is available in our VNV environment. All the packages are available, and we are importing from there, right? Now similarly, I can also go ahead and create my own custom things, right? So let's first of all start. So let's say this is my package folder, and here I'm going to create some modules. So first file that you actually require in this is init_init.py. Okay, so this .py file, why this init_init.py is that it is a special file. Okay, so here I'll just go ahead and write a comment for you so that you'll be able to understand. Okay, so this is a special file. Okay, init_py, or let me just use a multi-line. Okay, and I will go ahead and use this. See this. Okay, I will close it over here. Now this init_init.py is a special file used in Python to define packages and initialize the namespace. Okay, so let's say that I've actually created this. Now let me just go ahead and create any file that I want. Let's say I will just go ahead and write one operation, or let's say that I am creating a calculator, and so here my maths.py file is there. Okay, now inside this maths.py file, what I will do, I'll just go ahead and define a function. Let's say I'm going to write definition addition a comma b. Okay, so what this function basically does is that we are just going to return a plus b. Okay, we know that in math also, right, some operation is also there, inbuilt some operation is there, but I'm just trying to show you. So inside this package you will be able to see that math.py file is there, and inside that there is a function which is called as addition. Now very important thing that you really need to understand. Over here, this package folder .math, right? It becomes our module, right? Since we are using this _init.py, and always remember, inside a folder, if you want to initialize this entire folder and define packages, right, or define modules, you have to probably use _init.py. Even though it is empty, just keep it empty, but you need to have this file. Now I'll show you how I will call this particular function by importing this, right, from this particular package. Okay. Now this is my entire package. Now I'll go back to my import.ipynb. Now here I will go ahead and write from packages, right? So see, from package I'm getting dot. What is my file name? Math, right? Import, right? From package.math. See, from package.math. And remember, this needs to be in the same folder location. Then only you'll be able to call it, right? So from package.math, right? .math is basically this folder. I'm going to import addition. So let me just go ahead and copy this. And here you'll be able to see, I will just go ahead and copy this, right? Now after calling this, I can just go ahead and call this function, right? And here I can give 2, 3. And if I execute it, you'll be able to see that I'm actually able to get the output. So I hope you're getting an idea, right? How do you probably create your own custom module, right? And from package.math, how I'm importing addition, right? And if you don't want to write like this, okay, let's write it in another way. From package import math. I can also write like this, okay? I import maths. Now, in order to call this, I can go ahead and write maths.addition, okay? And here I can call 2, 3, right? So this how you can probably create any number of files inside this particular package folder, right? Since I have _init.py. When I create only this file, then only this becomes a package or a module, right? And then I can actually call this anywhere that I want. I can build my own custom function. I can build any number of custom functions. Let's say I'll go ahead and write definition subtraction, and here I'll give a comma b, and let me just go ahead and write return a minus b. So once I've updated subtraction, so what I will do, let me just show you how to call. See, in IPynb, obviously you know how to call it, right? By just importing addition, maths, whatever things you specifically require. But mainly when we are developing projects, we have to call all these files in some py files. So let me just go ahead and create one more py file, and here I will just go ahead and write test.py. Okay, test.py already exists. Let me just check. Okay, here we'll create test.py. So test.py is over here. Now in this test.py, I will try to call from this particular package. So how do I call it? So here I will write from package.maths. Okay, import start. Okay, now what I can do, I can basically call my addition. So I'll go ahead and write print addition, and here I'm going to say 2, 3, and let me just go ahead and write print subtraction with 3, 4. Okay, or 4, 3. Okay, now I will just go ahead and show you how to execute this. So I can directly execute .py file. Always make sure you have to be inside this folder itself, right? This 5 modules. If you want to execute any test.py file, like any py file, you have to make sure that you have to go to that folder location and run it. So here I will just go to cd 5 modules. Okay, now in order to execute it, I will write python test.py. Now see, here I'm able to get an answer. For addition I'm getting 2, 3, for subtraction I'm getting 1. Okay, so this was just an idea where I've actually created the packages, my own custom packages, math.py file, any number of function that I want to, and I've shown you how to call it in IPynb file. Along with that, I will also have shown you how to call it in test.py file. So this in short talks about the most important thing, that how an import is basically done, right? We'll also talk about one important thing which is called as sub package imports. Okay, and with respect to sub package imports, the thing is that let's say that, okay, I have this packages. Okay, now let me just show you one more thing. Okay, I have this packages. Now I will click this. I'll create one more folder. Okay, and this, sorry, inside my packages. Okay, so this is my package folder. I'll create one more folder, sub packages. Okay, now if I also want to make this as a package and probably call it somewhere, here also I have to use _init_.py file. Okay, now I can go ahead and create any operation that I want. Let's say I want to probably go ahead and write math.py. Okay, now math.py is nothing but we'll specifically be using this. Let's say instead of math, I'll just use some other file name so that we'll be able to distinguish it. Let's say multiply.py. So this package is responsible in performing any multiplication operation. So let's say I'll go ahead and define a function, and I'll say, hey, this is my multiply. Here I'm going to give a comma b, and this is basically going to return a star b. I know the functions are very simple, but the core idea is to understand how to call all these packages. Now, perfect, this multi.py is present inside this subpackage. Now, what I will do in my test.py, I will try to call this particular package. Okay, now it will be interesting. So here you'll be able to see from package, okay, dot maths dot subpackage. Okay, sorry, from package dot subpackage dot mult. Okay, I'm going to import my multiply function. See how step by step we went. So packages, first there were packages, then we went to subpackages, then we called this mult.py. And remember, we are only able to identify it unless and until this underscore init.py file is present or not. If this particular file is present, then this makes this particular folder as a package, okay, by default. So now let me just go ahead and call this over here, and let me go ahead and print my multiplication. So here I will be calling my multiply function with 4,5. Now if I just want to execute it, how do I execute it? I'll just go ahead and write python test.py. Okay, so here you can see initially I got 5, 1, and 20, right? So addition, 3 plus 2 is 5, 4 minus 3 is 1, and 4 multiplied by 5 is 20. So I hope you got this specific idea. I hope you're able to understand about packages and all. This was it from my side, and here I've shown you both the things, how to call default packages that are open source packages that are already available, right? So I've actually used this NumPy, math, and all. And the second thing that I've actually shown you how to call any other packages that are available in any other folders or functions that you're probably defining. So yes, this was it from my side. I will see you all in the next video. Thank you. Hello guys, so we're going to continue discussion with respect to Python, and in this video we're going to discuss about standard library overview. Now Python has a lot of libraries and packages which is completely open source, and you can definitely use them while you're coding your projects or developing something, right? So in this video I'll be showing you some set of libraries. Obviously it is not possible to cover all the libraries because there are more than 300k plus libraries, I guess. So it is very much difficult to cover each and everything, but just to give you an idea how to use some of the libraries, I'll be talking about them. So first of all, I'm going to show you about array. So array is one important library which will actually help you to create array itself, right? So here if I go ahead and define my array variable, and if I just go ahead and write array.array, right? And here in this particular array.array we have to give two parameters, okay? One is a temporary variable. Let's say I'm giving I, and then if I give 1, 2, 3, 4, so here you'll be able to see type code. Sorry, I basically means integer, type code, and your initializer, right? So with respect to it, returns a new array whose items are restricted by type code. Okay, so here it is basically going to print an array with these integers. Okay, so you can see over here that I'm able to get this particular answer, right? So this is one. I've already spoken about math, so let me just go ahead and again show you with respect to math. So here I'm going to use math.sqrt, one common function that you have over here. So if I go ahead and want to find out the square root of any number, I'll be able to find it out. Then let me just go ahead and print, okay, math.py. And here you'll be able to see that I'll be able to get an answer. Okay, perfect. Now let me just talk about one more inbuilt library that we have, which is called as random. And this is most commonly we use it. Okay, so all we have to do is that go ahead and just do import random. Okay, and then we will go ahead and print. Over here, random, we specifically use two important inbuilt functions. So let's see which all inbuilt function is there, which is called as randint. Okay, randint basically means it provides any random integer based on the value that we give over here. Like, let's say if I give 1, 10, so it is going to give a random integer between 1 to 10. Only one single number it is going to give you, right? It will be between 1 to 10. It will just pick up randomly and it will be giving you a number, right? And in one more function that we specifically use in random, which is called as random.choice. Let's say if I have multiple choice over here, and from that I want to select any choice in the case of string or anything as such. In the case of collection, sorry, then I will be able to use this. So let's say apple is there, banana is there, and over here you'll be able to see that cherry is there. Okay, so if I go ahead and execute it, so here you'll be able to see that, okay, randint, I'm able to get one value, and the value will be between 1 to 10. Okay, random.choice is nothing but from the collection what choice it is basically picking up. Okay, so if I again execute it, this may change. Okay, if I again execute it, this may change, right? It may not be all the time same, so it is randomly picking up these particular values. Now we're going to talk about one very common library that we use, that is called as OS, right? So that is used for file and directory access. Okay, directory access. We'll be talking about file handling and more operation. There also we'll be using this. So let me just go ahead and import it. So this is called as import OS, and let's say I want to go ahead and print in which current working directory I'm working in my project. So I can use os.getcwd, get current working directory. Okay, and if I can execute it, here you can see that I am in this particular folder location. That is my Udemy final Python, and this is my 5th module, right? So I'm inside my 5th module, and automatically I'll be able to see that which working location I'm there. Let's say in this particular working location, I want to probably go ahead and create a folder. So I will go ahead and write os.make directory, right? So they are make directories, different functions there. Let's say I want to go ahead and write test dir. So this will be the directory name. As soon as I execute it, now you'll be able to see that I'll be having a folder which will be of text directory. Okay, one assignment that I really want to give: go ahead and find out the function that is used to create any file. Okay, so that you can actually go ahead and do it. Okay, now let's say I want to do some high level operations on files, right? High level operations on files and collection of files. Okay, let's say for that I will be using this import shut util, okay, il, and this function, let's say that I want to create util over here, and let's say that I have one source.txt file. Okay, so here let's say I have one source.txt file, and let's say here I go ahead and write hello, how are you? I'm good, I am fine, welcome to the course. Okay, something like this. Now inside this standard library, by using this, let's say I will go ahead and do an operation which is called as copy file. Okay, I will copy this file that is nothing but source.txt. Please make sure that you are in the same working location, and then let's say I will go ahead and create my another file which is called as destination.txt. Now let's see whether we'll get an error saying that whether there is a file or not. So here you can see destination.txt is there. Did I get it? Yes. This is my destination.txt. This is my source.txt. Automatically the copy from source.txt happened in the destination.txt. Okay. So this is another important operation that we specifically use in this. Okay. So let me just close this. I think many files got open. Okay. But I hope you are able to understand it, what we are trying to talk about. Okay. Now the next thing is that let's talk about one very important or common thing that we will be doing. It is nothing but data realization, like converting a dictionary into a JSON, right, or converting any data frame. What it is, we'll discuss more about it. Let's say we want to convert that into a JSON. JSON is very much important because whenever we create an APIs, let's say whenever we are retrieving any data from the database, specifically NoSQL database, the return type of the data or the response, or we are interacting with any API, the response will be in the form of API itself, right? The response will be in the form of JSON, right? So in order to work with JSON, so we usually import this JSON library, and let's say that I am creating one data. Okay, let's say the name colon is fresh. Okay, and here what we're going to do is that we're going to basically write the age will be colon equal to 25, right? So right now this is just my dictionary. Now if I want to convert this dictionary into JSON, so I will use the JSON.dumps. Okay, and when I write JSON.dump on this particular data, I will be getting JSON in the form of string. Okay, which is basically required. Okay, now let me just go ahead and print this. Okay, so I will go ahead and print JSON_str. Okay, now once we print it, and let me just go ahead and print the type of this also, so that you will not get any confusion. So type of JSON_str. Okay, now let's say I want to convert this back into this kind of dictionary again, right? So for that, one operation that I use is JSON dump. One operation will be JSON.load, right? So whatever JSON, let's say when I'm interacting with an API, I get some kind of JSON response. That would be always in the string format, which I've actually converted. Now if I want to convert this back into a dictionary and probably do any kind of operation over here, so I can actually go ahead and use JSON.load operation, and here I will give my JSON string. And now this will basically be my parsed data is equal to this one, right? And now what I'm actually going to do after this is that I will go ahead and print my parsed data, and I will also go ahead and see the type of it. So I'm going to see print type of parsed_data. So if I go ahead and execute it, here you can see initially this was my see, it got converted into a string, so the class is string. Then again we converted back into a dictionary, right? So JSON, whenever we get in the form of API from an API, it will be in this particular string format. We can just load that particular information, convert that into a dictionary, and perform data serialization. Okay, so this is one very good example of probably writing each and everything over here, and this is what is all about data serialization, and we'll be using this a lot as we go ahead. Okay, now let me just go ahead and talk about one more standard library, which is called as CSV. Okay, whenever you need to work with a CSV file, right? And there are a lot of files which we'll be learning, and we'll be using pandas and all. There we'll be learning more different kind of operations and all. Okay, so I'll go ahead and just import CSV, and now with open, right? With open, and here I'm going to specifically use, let's say I will create an example.csv file. Okay, and then let me just go ahead and write the mode, right? So open has, first of all, you need to give the file name, then what mode you really want to open it. Let's say I want to open this in write mode, so I will go ahead and write w. There is also something called as w plus mode. So w plus is nothing but write append. Okay, and here I will go ahead and say, hey, use the new line as this. Okay, so it should be as this, and I will open this as a file object. Okay, now by using the CSV dot, I will go ahead and write inside this particular file. So there is a writer function, right? We will write inside this file, and this will basically be my writer. Now I can go ahead and take any data and write each and every row. So here what I'm going to do, I'm going to basically write writer dot write row. Okay, and let me just go ahead and give the row. So first row will be my column names, name, comma, age. I have to give this in the form of list or collection. Then I will go ahead and write writer dot write row, and I will start writing my second row. And now I will start with my data. So let's say Krish, and here I'll be able to put 32, or I'll go ahead and put integer, right? Now this in short, what it is going to do is that it is going to create an example.csv file. Okay, and there it is going to insert two records. One is with the column name, comma, age, and the next one is with respect to the data. Okay, now what I'm actually going to do, I'm going to write with open. Okay, and here I'm going to specifically write example.csv, because once I create this particular CSV file, it is in the write mode, right? I'll create the CSV file. Now we'll try to read it. Okay, now I'll change the mode to R. Okay, and now what I will do, I will basically read the entire file, the CSV file. So I'll create a reader is equal to csv.reader function is there, and I will give the file name. Okay, whatever file is over here. Then since I will be having multiple rows, so I will go ahead and write for row in row reader, and we will just go ahead and print the rows. So what we have actually done, we have created a CSV file, we have printed two records, and then now we are opening the same CSV file and we are reading the data, right? So let's go ahead and execute it. So here you can see, let's see first of all whether the CSV file is created or not. See, example.csv is created, and here is my two records. So you can also open this with Excel file. Okay, and now I'm reading this, and I'm also displaying it over here. So perfect. This is one very important function that we can actually use. Okay, so you can actually go ahead with seeing this. Okay, now one more function that one more standard library that we specifically use is datetime. Okay, now with respect to datetime, you can go ahead and import something like this from datetime import. So datetime is again a module, so I'll be importing from datetime import datetime. Along with that, I can also import one more function which is called as time delta. Okay, time delta. Now if I want the current time, so I can go ahead and write datetime.now. Okay, so datetime.now will specifically give you the current time or current date. Okay, then let's go ahead and print now. Okay, let's go ahead and print now, and then let's say I want to probably currently what is the time, and yesterday, one day back, right? So I can actually use time delta. So let's say yesterday, I will go ahead and write is equal to now minus time delta. Let's say that I'm going to go ahead and calculate difference, and here I'm going to use one parameter days is equal to 1. I'm saying that hey, go one day back, and with respect to that, just try to calculate the entire delta itself, right? So like one day back, what will be the time, right? So here I'm going to just go ahead and print yesterday. So if I go ahead and execute right now, the time is 11:37. I can see the watch, it is perfectly fine. And yesterday, one day back, it was 11:37. I'm just doing currently divided by minus time delta of day is equal to 1. And yesterday time will be something like this, right? So this is also one very good thing with respect to this. Okay. Now one more standard library that we can specifically use and which is common is nothing but time. Okay. Let's say I'm writing a code. I want to make the program sleep for some couple of seconds, right? So for that I can use time. So import time, and let's say if I go ahead and print time.time. Okay. And let me just go ahead and say, hey, after this you just sleep for 2 seconds, sleep for 2 seconds, and then again let's go ahead and print time.time. If I go ahead and execute it, here you can see it sleeping for 2 seconds, and then I got this specific thing, right? This is what it is more about, and you'll be able to see that, wow, we're able to do some amazing thing with respect to this. We're able to make the program sleep for some seconds also, okay? Now, one more common libraries that we will be using is something called as regular expression. So for regular expression, there is a library, again, which is called as import RE, okay? Now, regular expression basically helps you to match a specific expression in the top of a sentence. You can do it on an entire data set and do many things. Let's say that I define a pattern, okay? Now, with respect to this particular pattern, I'm saying, hey, use this pattern, something like this, okay? I'll say, hey, go ahead and use this. It'll be /d plus, okay? Let's say this is the pattern that I select, and I'm having a text, okay? There are 123 apples, okay? Then I will say, let's go ahead and match whether this pattern is there or not, okay? Digit plus, okay? Whether this pattern is there or not. So in order to do that, I will just go ahead and write re.search, and here we're going to use pattern, comma, text, okay? So let's go ahead and print match dot group, okay? So if I go ahead and use dot group, so here you'll be able to see the answer where this specific D plus pattern is getting matched. So here you can see that 1, 2, 3 is present, and D is basically digits, right? We're just going to see that where digits are specifically there, right? And we are going to get over here. If I go ahead and write over here another 1, 4, 5, 6, so here you'll be able to see that after getting this continuous digit match, then it will stop over there because the match is successfully done over here, right? So match is successfully done, so we don't have to check the forward one. So this is some of the things that we specifically use in regular expression. Now this can be a lot more complicated. It is not you always have to probably use this, right? It is other things also you can probably check. Okay. So I hope you were able to understand this. These were some of the standard libraries. Again, there are a lot libraries as I always said. Okay, there is no limit as such. It is up to you how much you can try. You can practice, keep on practicing, and based on different scenarios, you can use this. So I hope you like this particular video, and this was it from my side. I'll see you in the next video. Thank you. Hello guys, so we are going to continue the discussion with respect to Python, and in this video we are going to talk about file operations. We will be performing various file operations with the help of Python programming language. We will be playing with both text and binary files, and we'll also be understanding how to probably create files, how to write inside that, how to read the file content, and many more things. So let's go ahead, and first of all, let me just go ahead and do the first task, that is read a whole file, right? So for reading a whole file, again, we will be using with open method, right? And here I'm going to give my file name. Let's say that I'm going to give example.txt, and the first second parameter inside is open. We will specifically use this R parameter. R basically means read, okay? And there are also other parameters which we will discuss, like write, write append, read append, right? Sorry, not read append, it is append separately. Then we have W plus operation where we can both read and write a specific file. So we'll be seeing one by one. So let us first of all start with read. So this will be my read operation, and I'll create a object of file, and then from line in line, okay? So from line in file. So inside this particular file, how many lines are there? Like in example.txt, we'll keep on reading it. And now let me do one thing. Instead of just going line to line, initially we'll just go ahead and create a variable called as content, and we'll take this file, and then there's an operation which is called as dot read. So what dot read is basically going to do is that it is just going to read the entire content of the file. Okay. So right now I've not created the file, that is example.txt. So we will go ahead and execute it. So here you can see that I'm getting an error saying that hey, no such file or directory in example.txt, right? So this is the first error we usually get whenever we are directly trying to read. I'll be showing you other ways also, but there what will happen is that if I'm trying to read it, right, first of all it will create a file and then we will be able to read it. Okay. Now here what I'm going to do. So this is the file handling part. I'll go ahead and create one example.txt file. Okay. And with respect to this example.txt file, I'll just go ahead and write hello, how are you? Okay. And I'm good. Okay. Something like this. Krish is my name. Okay. And welcome to the course. Okay. Something like this. So now I'm going to perform all these things. I'll be reading specifically from this example.txt, and now let me just go ahead and execute it. Okay, you'll be able to see that now I'm reading the entire content, right? So with example.txt, this is basically opening this particular file in the read mode. Okay, we'll not be able to write if you are opening with the help of read mode, right? And then we are just reading the entire file content. Now I may also have a scenario that I want to read a file line by line. Okay, I just want to read it line by line. Now how do I read it line by line? So here we're going to specifically use with open operator, right? Here I'm going to use my again example.txt file, and this will specifically open in read mode. And now I'm going to use this particular object as file. Now since I have to read all these things line by line, so now I can go ahead and use my for loops, so that file will be over here as an iterable because I have so much of content over here, right? So for line in file, right, I'm just going to go ahead and print my line, okay? And what I'm actually also going to do is that if I go ahead and execute this, so here you can see example, okay, example spelling is not right, so I'll just make it right. Now here you can see that when I'm reading line by line, it is also taking the new line characters, right? So here, because when I see this, right, if I go to the next line, so here a new line is basically getting added. So that is the reason you'll be able to see this space. Now let's say I want to go ahead and remove this particular new line character. So for that, I'll be using an operation which is called as dot strip, okay? So this dot strip operation removes the new line character. Perfect. So this is what we are able to do it out of it. Okay, so this is what is there, right? And we are able to get the output. Now let's do some more operation. Now what I'm actually going to do over here is that let's say that I want to probably open a file for writing something inside it, right? So here let me go ahead and write writing a file. Okay, and here I will also make sure that I will show you overwriting clauses. Okay, over here, right? Now let me do the same thing with open function, and I'm going to basically open this, and here I'm going to use example.txt, right? And this will basically be my write mode, and as file, okay, and then I will go ahead and write file.write. And let me quickly go ahead and write hello world. Okay, I'm writing this hello world with a new line character. Okay, so file.write. Write is a method which will specifically help me to write anything inside this file. And here you can see that I'm using W mode over here. W mode is nothing but write mode. Okay, now this is the first line that I'm going to add over there with a new line, and then I'm going to add file.write. This is again a new line. So let's say I'll just go ahead and write this is a new line. Okay, and let me just go ahead and execute this. So let's see what will basically happen. Now as soon as I execute this, already you know in example.txt I have this content. So if I go ahead and execute it, here you'll be able to see that the entire content got overwritten, right? So overwritten basically because I have just opened this particular file for the write mode, and it will just consider okay, the file is completely empty. And when we write file.write, it is just going to overwrite completely from this particular content. And again, this is a problem out there. We should never be doing like this. Instead, if I want to write a file, write a file without overwriting, okay, without overwriting, then I'll be using a different approach. So let me just go ahead and do it. So I'll say from open, okay, and here I'm going to specifically use example.txt, and let me just open this in another mode which is called as append mode. Okay, now in this append mode, what will happen is that if I go ahead and write anything, so if I go ahead and write file.write, append operation taking place. Okay, and if I go ahead and execute it now, so here you'll be able to see this operation is taking place. Now, if I go ahead and see in the example.txt, this is the new thing that is getting appended, right? I may also want to write it in the next line, so you can just use /n over here and do it, right? And now here clearly you can see that I'm able to append any text, okay? Let's say I'll go ahead and write /n again. I'll try to append this. Okay, so here you'll be able to see again it is getting appended. Now, along with that, what I'm actually going to do is that again, let's go ahead and append this. So here you can see it'll go to the new line because I had used /n before, right? So the file operation is basically taking place, and here you're able to append it. Okay. Now there may be also scenarios that I want to write multiple lines. Okay, multiple lines specifically. So writing a list of lines to a file. So let's do this. Okay. Again, let's say this is lines. Okay, these are my list of lines. So here I'm just going to write. Okay, this is my first line /n. Then the second line /n. Okay. And let's go to the third line /n. Okay, so these are my 3 lines that I really want to add. Okay, Let me make some cells and let me copy this thing entirely. Okay, and let me do this operation over here. Okay, now what I'm actually going to do, I will just go ahead and open my file. Okay, and I will try to open this same example.txt file in my append mode, okay, in my append mode, and I'll create an object as file. Now, in order to write all the lines, right, inside this particular list, there's again a function which I can actually use, which is called as file.writeLines, and all I have to give my list over here, right? So once I execute it, you'll be able to see that now first line, second line, and third line has got appended. Okay. So apologies for this particular spelling kind of error. So you can actually make the changes as best on your grammatical things that you have, right? So I'm just making sure that I try to show you more amazing features with respect to this. Okay. Now this was with respect to text file. Now let's go ahead and discuss with respect to binary files. Okay. How to work with binary file. Binary files are usually, if I probably see the extension, it is basically a bin file, right? So if I go ahead and create a file over here, you'll be able to see if I go and write example.bin. Okay, so this is what we basically say it as binary files. Okay, let me just go ahead and append something over here, hello world, something. Okay, some information over here, and this will be in the form of binary files. Now I'll go ahead and show you how you can read or write binary files. In binary files, we usually update bytes. Okay, bytes is very much important. So I'll just keep this as empty right now with respect to binary files. So let me just go ahead and write. So here I'm just going to write to a binary file. I'll be using this kind of bytes. Okay, with open example.bin in write byte mode. Okay, so now my this operation will become, it will not be read or write. It'll be read byte or write byte. Okay, since I'm going to write, so I'm going to basically use it as write byte. Now if I go ahead and execute it, so here you'll be able to see in the bin, this is what I'm actually able to get. Okay, in the form of bytes. Okay, so this is one of the operations that you can see over here. Right. Similarly, if you want to probably read it, again we can use, instead of writing R, we can also use RB. Okay, so RB as file.read, and we are just going to print the content. And this is what I'm able to display. Right now in bin file, it should looking like this. And this is what I think hexacharacters for the same thing what we have actually written. Okay, so this was one of the most beautiful thing with respect to file operation. Now, as I said, let's do some of the things, right? Some practical examples and all, how to probably solve it. Okay, let's say I want to read the content from a source text file and write it to a destination text file. Okay, if I want to do this, I can go ahead and write it. Again, for this, it is very much simple. I will first of all read from a file. So let's say I'm reading from example.txt and I'm writing it to a destination.txt. So I'm not created destination.txt. Let's see whether we'll get an error or not. So here is the content that I'm getting, source underscore file.read, and when I write destination underscore file.write content. Okay, so if I execute it here, automatically you'll be able to see that I'll be creating this destination.txt, and this was my example.txt. Okay, this is one of the operation. One more assignment that you can probably take. Okay, please make sure that you do this. It'll be important. Okay, and read a text file. Okay, and I have already done this, I think, for you all, but I'll give you this as an assignment. Read a text file and count the number of lines, words, and characters. And this is the code. So first of all, you try it from your site. Anyhow, I'll be giving you the code. Okay, you can give the file part example.txt and just go ahead and do this. Right. So this is a function that is got created. We are reading the lines. We are doing the summing up of all the lines itself. Okay, so this is one assignment you can probably take it. Okay, so I think we have discussed so many things about it, but let us go ahead and discuss about one more operation. Okay, that is nothing but writing and then reading a file. Okay, this kind of operation. Okay, so what I'm actually going to do, I'm going to basically use with open again, and let me just go ahead and write example.txt. Okay, and this time I'm going to open this file in W plus mode. W plus mode is nothing but, if you don't know about W plus mode, I'll just give a statement over here so that you'll be having this as a markdown. The W plus mode in Python is used to open a file for both reading and writing. If the file does not exist, it will be created. If the file exists, its content is truncated. That is, the file is overwritten. Okay, so here you'll be able to see that I'm using W plus mode as file. Okay, and here I'm just going to go ahead and probably write the data to the file. So let me just go ahead and write file.write, and here I'm just going to say, hey, hello world. Okay, it's just going to overwrite it. Okay, and then I will go ahead and write file.write. Okay, this is a new line. Okay, this is done. Okay, perfect. Now after we write, we will make sure that we move the file cursor. Okay, what right now the file cursor will be pointing to the second line. Okay, it will be pointing to the second line that is over here. But we need to move the cursor to the first one so that we'll be able to read it. Okay, so move the file cursor to the beginning. And how do we do this? We just use one very important method which is called as file.seek. Okay, now this seek, if you probably go ahead and see this, if I give it to 0, so it is just going to move the file cursor to the beginning. That is just like a 0th character or 0th index, right? Then we can go ahead and read the content of the file. Right, and then I'll go ahead and print the content. Okay, first of all, I'll show you what will happen if I commented this out. Okay, will it display anything? Okay, so let's go ahead and run this. So here you can see I'm getting hello world. This is a new text line. Okay, let's see what is getting printed. So print content is basically happening over here. Let me see whether my example.txt has got loaded. So example.txt, this overloaded. This is basically giving me a new sentence, hello world and all. And here you'll be able to see that I'm printing the content. Okay, just a second. Okay, so the thing is that I did not read the file. So previous variable only was showing me. Now let me do one thing. Okay, file.read. Okay, now I did not read the file, right? So what I'm actually going to do, see, I'm just commenting this. Okay, and we are writing these two lines in my example.txt and we are reading it. If we do not write this line of code, what will happen? It will not display us anything. Okay, and here you can see in example.txt, this two line has got appended because the cursor will be pointing here. We have to make sure that we have to take the cursor over here, right, to the first one. So that is the reason you'll be able to see once I probably remove this, and if I execute it, now you'll be able to see that I'm actually able to get both the line. Okay, so this is what you'll be able to see with respect to this and how amazing this is, right? Again, let's say that you want to do multiple times read and write. Always make sure that you try to use this file.seek and make it to the beginning one, right? Yes, this was it. I think I had probably taken a lot many things with respect to file handling. But yes, as we go ahead and see multiple use cases, as we go ahead in the upcoming sessions, we'll be seeing more different kind of operations. So yes, this was it from my side. I'll see you all in the next video. Thank you. Take care. Now, the next task that I'm actually going to do over here is that let's go ahead and create a new directory. Okay, so create a new directory. I'll be doing this. Let's say I will again Unity import OS. So let's say my new directory is something like this. Okay, let's say this is my new directory called as package. Okay, I want to create a package folder over here in the same working location that I'm actually writing a package folder over here in the file handling folder itself inside this. So all I have to do is that I'll just go ahead and write os dot make dir, and I'm just going to give my new directory information. And let me just go ahead and print this. I'll use an f string and say that directory, and here I'm going to specifically use this new directory name is created. Okay. So this will be my message. So here you can see directory package created. Okay. And here you can probably see I will be able to get this package folder. Okay. And this is how you can create a new directory with the help of OS. Okay. Let's say that I want to list all the files from a directory itself, right? So next task will be that listing files and directories. I want to list all the files and I want to list all the folders that I have inside a folder itself where I'm actually working. So I will just go ahead and write items is equal to os dot list dir, and here I'm just going to use this dot. Okay, dot basically means we are specifically looking at the current working location, whichever folder it is inside, okay? And it'll just list and it'll give you the entire information. Okay, so let us go ahead and display this entire item. So if I go ahead and print items over here, so here you'll be able to see I have this particular file, a destination txt, example.bin, package. So all the folders inside this particular folder, it is able to give me. Okay, pretty much amazing, and definitely we use this kind of file a lot because I may have a scenario that in my project I need to probably read all the files and folders and I need to probably do some kind of operations, and I can actually do that. Okay. Now talking about one more very important concept, that is nothing but joining paths. Okay. And this is the most important feature of using this OS package, because this path will be different when terms of coding in Windows, separately coding, you can just hard code it, right? Till Linux or in Mac. So by using os.path, we can specifically use this. Okay. Let's say that I want to probably create, I have a directory name which is called as folder. Okay. And then let's say I have my file underscore name. Okay. And this will be my file.txt. Now, how do I create this particular path? That basically means inside my folder there is a file.txt. Right? If I want to probably get the full path or relative path, also I can say I can just write os.path, okay, dot join. Then I can actually use this directory name. Okay, oops, just a second. I can directly use this directory underscore name, comma. I will go ahead and use file underscore name. Okay, so this basically becomes my full path. So now if I go ahead and print my full path, you'll be able to see, hey, this is my path that I'm actually getting. Right? Let's say I want to completely get it along with my folder location. Then I can copy this entire thing again. Okay, I can paste it over here, and here I can also do os.getcwd. Current working directory along with my directory name. Okay, so if I go ahead and write this, now here you can see this is my entire path, right? I can also do this. If I want to just have the relative path, I can just use these two variables. Okay, and this is how things are amazing over here, and you'll be able to see it. Now, in our previous tutorials, we have seen, right, whenever we are trying to open a file, first of all, we need to create that file, right? But here, we will try to manipulate, or let me just show you an example. Okay, so here, what I'm actually going to do, I'm going to create an example file. So let's say this is my example1.txt. I will say, hey, if os.path.exist, okay, if this particular path exists or this particular folder exists, then I will just go ahead and write print f. Okay, print f. Here you can actually see the path, this specific path exists. Okay, that basically means that folder also exists. Else, I'll just go ahead and print f, the path does not exist. Okay, so here if I go ahead and execute it, here you can see that the path example1.txt file does not exist because I don't have that specific file. Now let's say if this file is not there, what I can do, if it is not there, or if this file does not exist, I'll go ahead and create that particular file with with open command or with any kind of command. I can go ahead and do it, right? So this is very much important, and this kind of condition needs to be used in our coding environment whenever we are making some assumptions of a specific path itself. Okay. Now this is fine. There's also one more way to check whether the file is present or not. Okay. So here I will show you. So I'll just go ahead and write this command, checking if the path is a file or directory. So there is one more method over here. So here you can see import OS. I'm using path is equal to example.txt. Now this file, right? os.path.is file of path. So is file, it is going to check whether this path is a file. If it is a file, then it is going to say it is a file. If this path is a directory, so for that I have is directory function. Then it will go and say that hey, this path is a directory. Else this path is neither a file or a directory. So if I go ahead and execute it, I will go ahead and see this, right? So here it shows the path example.txt is a file. Okay. So this is how things are basically working over here, and you'll be able to see that, hey, yeah, this particular file is the file because example.txt is a file. Okay. As I already told you, okay, relative path is something different. Relative path basically means this file inside this particular folder file.txt. If I'm saying this becomes a relative path. Okay. And the absolute path is a complete path. Okay. Let's say for any folder location I want to get the absolute path. Okay, getting the absolute path, because I may be requiring some of the other thing over here. Okay. So here what I will do, let's say that this is my relative path. So this file is basically present inside this folder, which is called example.txt. Now I will go ahead and create my absolute path. Okay. And for this I will go ahead and write os.path.appspath. So appspath is one method over here, and then we can use this relative path. Okay. Now if I go ahead and just print my absolute path, here you'll be able to see the complete path. I'll be able to get it, right? Again, if you do not want to go ahead and do it this way, you can specifically go ahead and join all these particular things along with the directory name. But I feel this is again better when compared to that one. So I hope guys you were able to understand all this file path operations specifically with the help of OS. Again, there will be multiple examples which we'll be seeing, but most of the common operations that we usually do in the code is probably discussed over here. This will be the most useful operation or most useful library when you're working in end-to-end projects, working with different files, working with different directories over there. So there we are going to extensively use it, right? So please make sure that you practice this more, see different examples with respect to this, and yeah, this was it from my side. I will see you all in the next video. Thank you. Take care. Hello guys, so we are going to continue discussion with respect to Python, and in this video we are going to discuss about exception handling, right? And I hope you have heard about this particular term and what exactly is an exception handling. Exception handling in Python allows you to handle errors gracefully and take corrective actions without stopping the execution of the program, right? And here in this specific lesson we are going to cover and we'll be seeing some of the keywords like try, except, else, and finally blocks. And we will be seeing how we can handle the exception that rise in our program, and we have to handle in such a way that we do not break the entire execution of the program, right? Now there may be scenarios. Let's say that I'm using an application over there, a user is filling some kind of form and it does not give the right kind of input. So in that particular case, I will not just stop the execution of the program. Instead, I will say, hey, I will raise an exception. I'll tell the user, hey, try to put some proper information over there, right? And make sure that you always try to put this kind of information to make that entire form get submitted. Okay, so we are handling it gracefully, right? We're not stopping the execution of the program. Now let's go ahead and understand what are exceptions. And you really need to understand the differences between errors and exception. Exceptions are events that disrupt the normal flow of a program. They occur when an error is encountered during program execution. Common exception include zero division error. So here we have something like divide by zero, file not found error, value error, type error. These are some of the examples. Okay, now let me just show you I'll just show you some amazing examples and how do I handle it with the help of exception handling. I will try to talk about it. Okay. Now let me do one thing. Okay. Let me just go ahead and write a is equal to 10. Okay. So this code, I think it will work perfectly because we have assigned the variable. But if I go ahead and write a is equal to b and if I just execute it, so what is the error that I'm getting over here? Right? Error is very simple. It is saying, hey, name b is not defined. So what has happened over here? This is a kind of error that has actually happened. And as I've already told, they occur when an error is encountered during a program execution. Here, obviously, I know the error is that name b is not defined. So an exception is basically getting raised over here. And this name error is one kind of exception, right? It is one kind of exception. Like how I've written over here, zero division error, file not found error, value error, type error. So name error is also one kind of exception that is probably getting raised over here because we have not defined b. Okay. So how do I handle this? Let's say that I'm not defined b over here. And obviously, this kind of error that I probably see, it is suitable for a coder, right? A coder will be able to understand. Okay, if I'm in this particular line of code, I'm getting this kind of exception, right? But if an end user is using some kind of application, if he or she sees this, right, they'll not be able to understand. So it is always better that we handle it gracefully by providing a good message, right? So how do I handle this? So what I will do in order to handle exception handling, right? Let me just go ahead and write. I'll be using over here try, except blocks. Okay, it is just like try catch block in other programming language. So first of all, I will go ahead and write try. Okay, now what does try mean? Try basically means inside this block, I will go ahead and write my block of code where exception may rise. Okay, so let's say right now the exception was rising in this particular right, a is equal to b. Right now, what I will do is that when I write a is equal to b, right, obviously we know that an error will come over here. Now, in order to handle this error, what I will do, I will just go ahead and write except. Okay, and I will just go ahead and write my print statement. I'll say, hey, the variable has not been assigned, right? The variable has not been assigned. Okay, so this is my custom message that I'm saying, hey, if this particular error, see, when this code gets run here, exception got raised, right? And this exception will be caught by this except block. And when it will get caught, here is the print statement. This is the print statement that will get displayed, right? So if I go ahead and execute it once here, so here you'll be able to see, hey, see, the variable has not been assigned. Now this is a very good message when compared to the previous message where we had red statements and all for the end user, right? And obviously we know that what is the kind of error that we have got over here, a is equal to b. See, this is the error that we are getting. Name b is not defined. It's not like that I cannot display this. I can also display this. Let me show you how we can display this. So what I will do, I'll just copy the same thing. I will paste it over here. I know what kind of error or what kind of exception it is throwing. It is a name error exception. So I will go ahead and call this same exception. Okay, this is one type of exception over here, right? And let me just go ahead and make my alias, right? And I will just go ahead and say, hey, print ex. Okay, so what I'm actually doing when this kind of error is falling, right? When this kind of error is getting raised, a name error is getting raised, I'm handling those kind of exceptions with the same exception handler over here, right? And this name error is a class which handles this kind of exception, right? I hope you're able to understand it. So now if I go ahead and execute it, see the same message is getting displayed. Name b is not defined, and here also we are getting name b is not defined. Why? Because I have used the same class, right? That is name error, which is responsible in catching this specific exception, right? So this is one amazing example which you can easily understand, right? Now similarly, I may have other kind of exception, right? So let's go ahead and do this. I will go ahead and write, hey, let's do this. Okay, I will go ahead and write result is equal to 1 divided by 0. If I execute this, you see what kind of error is coming, right? This is called a zero division error, right? Zero division error. Now, zero division error is again a kind of error that we are getting it, and this is also kind of exception, right? And we can also handle this exception. How do we handle it? I will go ahead and write my try block, okay? And here my code will be there. Now I know if this exception gets raised, I'm going to basically call except, and my exception handler will be, or my class name that I have to use, which will catch this kind of exception is zero division error as ex, okay? Ex is just an alias, and we'll go ahead and print ex, okay? Now you can see division by zero, right? And apart from this, I can also go ahead and write another message saying that, hey, please enter number, please enter the denominator greater than 0, right? So I can go ahead and write this. So this way I'm able to get more beautiful messages and I'm handling it gracefully, you know. What do I mean by gracefully? I'm not stopping the execution of the program. I'm not giving that entire red section that you always are having a fear, right, of that. I'm giving a proper message over here saying that, hey, this is the exception that got raised, you need to fix this. Please enter the denominator greater than 0. So again, the person will go ahead and make sure that he'll understand, and then they'll go and write this particular denominator greater than 0, right? Now all these exceptions, one more thing, right? So here you can see that all these exceptions that are there, like zero division error, file not found error, value error, type error, these are derived from a main exception class. Okay, so let's say that I don't know, there may be some kind of exception that may be happening. Okay, let's say that over here again, if I go ahead and write a is equal to b, right, and let's say I am going to just write it 1 by 2. Now here you will be seeing that. Okay, or let me just go ahead and write like this. I'll copy this. Let's say I go ahead and copy this, and I'll go ahead and write 1 by 2. So obviously zero division error is not going to get caught, right? So now if I go ahead and write a is equal to b, now I know a is equal to b is going to give me a name error, but will this exception get caught right now? The answer is no, because I have just written zero division error over here, and I'm catching it in the except block. Other than that, I'm not used name error, right? This exception is never handled it with the help of name error, right? So I'm not written it in the except block, right? So that is the reason I'm getting this particular error saying that the name b is not defined, right? So how do I handle it? So see, one more thing is that, and sometimes it happens in such a way that there may be different exceptions that may be occurring, right? And all these exceptions that we learn, like zero division error or name error, value error, this is derived from one single parent class, right? We'll talk about more classes and all. That is nothing but exception. This is the base class of exception. It can handle any kind of exception, right? So if I go ahead and write as ex1, okay, and now let me just go ahead and print ex1. Now you'll see, since I'm getting an error over here, obviously you'll be seeing that this exception is not getting handled over here because this is a zero division error. But this exception will probably handle because this is the main parent class of exception, and every exception will be derived from this particular exception class, right? Like zero division error will also be derived from this, name value error will also be derived from this. So at the end of the day, you'll be seeing that this exception will be handled over here, right? So if I go ahead and execute it once again, so here you can see name b is not defined. From where it is basically coming, right? So here it is basically coming from, right? Main exception class, main exception got caught here, right? If I execute it, see, it is getting caught over here. So you can write any number of exceptions, but always make sure that the last exception class that we are using should be in the last section, right? We should not write this before zero division error or any other kind of exception, because this is the parent class from which all the exceptions are basically getting derived. Okay, and this is how we handle different kind of exceptions, right? So I hope you've got this particular idea. But here what we have actually done is that we handled multiple exceptions, right? So let me just go ahead and show you one more example. Let's say I go ahead and try over here. I'll create a number, okay, and this will be my int. Okay, I'll just go ahead and write input, and here I will go ahead and write enter a number. Okay. Now once I enter a number over here, let's say that I go ahead and divide this. Result is equal to 10 divided by num. Okay, 10 divided by num. Now I will go ahead and catch or write this except block. Remember, except block is basically to handle all the exception that rises inside this try block, right? So I will just go ahead and write except. Okay, now inside this except, let's say that I will go ahead and use one value error. Okay, value error, and here I will just go ahead and print. Let's say value error is specifically if I do not write a proper number over here, right? So this is not a valid number, not a valid number. Okay, similarly I will go ahead and write except, another except block, and let's say here I'm just going to use 0 division error. Okay, and this will basically say, hey, print, you can't enter number, enter denominator greater than 0. Okay, now see how I'm handling, right? This is the block of code where the exception will be handled, exception will be raised, right? And this exception, like error, will be coming over here, and we will catch this particular exception either over here or either over here, right? So let's see this. So if I go ahead and execute it, let's go ahead and say that I've given the number as 0. Now what will happen if I press enter? Just imagine, obviously 0 division error will get caught. So here you can see enter denominator greater than 0, right? Let's say that if I go ahead and execute it, and this time I give a string, I give a value called a string, Krish. So now what will happen? The value error will get caught, and this is not a valid number, right? So here clearly you can see that I'm able to handle it. Now there may be different kind of errors. So what I will do finally, I'll just go ahead and write except with exception as ex, and I'll just go ahead and print ex, okay, over here, just to manage all the other errors. So let's say if I'm giving 34, this will get executed perfectly because I'm dividing the result by 10 by that specific number. Okay. So here was an example to make you understand about try catch block, or we also say try except block. Okay. Now I just want to also show you one more example, and here along with try except, I'm also going to show you else block. Okay. Now let's go ahead and see this. So here is my try. Okay. I will go ahead and create my number, and this will be input. And here let me just go ahead and write enter a number. Okay. Enter a number. Then I will just go ahead and say result is equal to 10 divided by number. Okay. Let's say this is there. Okay. Now one exception that I'll try to handle is value error and 0 division error. Okay, so I've written it over here. Let's say if both these errors are not coming, that basically means this has got executed successfully, right? In the worst case, I will also go ahead and write my exception. Okay, so that basically means if this is also not getting caught over here, then that basically means the code has got successfully executed. Okay, without any exception. Okay, but finally, let's say that I want to display this particular result value. Okay, now the result value can be displayed over here, and I will try to use one amazing try catch functionality right over here, which is called as else. Now let's say after this particular code has got executed, if exception is not happening, I want to close this entire try except with making sure that some lines of code needs to be executed anyhow. Okay, so there will be an option of writing else block, and this else block is nothing but it is you can just say that okay, at the end of the day, after this gets executed successfully, it has to execute this. Okay, so if I go ahead and write in the else, so let's say in the else I go ahead and say, hey, the result is this specific result. Okay, so I'm just displaying the result over here, right? So if I go ahead and execute it, now see what will happen. Okay, now what will happen? I will give the input, let's say 23. If I press enter, okay, you'll be able to see 23, no exception will be raised. Now when no exception is getting raised, so obviously this will get skipped. But at the end of the day, this has to get executed, right? So else is something like it has to probably get executed. Let's say if there is an exception over here, then one of the exception block will get executed, and it will come outside of this try except block. But if this gets successfully executed, anyhow it is going to execute this else block. So if I go ahead and press enter, so here you can see the result is 0.434. Okay, let's go ahead and execute this once again, and let me just go ahead and write 0. Now in case of 0, what will happen? 0 division error is there, so you can't divide the number by 0. So I'll press enter, that is the error. But here you can see else block is not getting executed. So that basically means whenever an error happens or exception happens, it will get handled in the except block. At that point of time, else block will not get executed. But if none of the exception gets raised over here, then what will happen? Else has to execute anyhow. Okay, so this was an amazing example with respect to else, right? So where you'll be able to see that okay, if I'm not getting an exception, then it'll execute. Okay, otherwise if I'm getting an error, this is just going to stop and it is not going to execute this else block. Okay, this is how you will be able to understand. Now this is fine. Let's try something more. Okay, now this time what I'm actually going to do, I'm going to use try except else. And I'm also going to use one more amazing functionality or one more block, which is basically called as finally. Okay, now let's see one example with respect to this. Now what exactly is finally? We'll discuss about this. Okay, I will just write a code, and the same kind of code I will just copy and paste it over here. So see this. Okay, so here is my number, right? And here I'm probably dividing it. If exception does not happen over here, then directly else has to get executed. Okay, else will get executed only when error is not there. Okay, again, let me repeat it. This is going to get executed only when there is no error over here, right? If there's an error, it will be handled by this kind of exception. I'll also go ahead and write this exception over here so that I will bring up multiple condition of exceptions. Okay. Now finally is something. Finally is a kind of block. Whether error may be coming or not in this particular block of code, it has to execute anyhow. Okay. So let me repeat it again. We have already discussed just a while back about else, right? Else is something like this. If no error is probably coming over here, then we will go ahead and execute this. If error is probably coming up, then else part will not get executed since it is getting handled in the exception block. In case of finally block, whether the error may be coming here or not, it has to execute. Okay. Now let me just show you. So let's say if I go ahead and write 12. In case of 12, obviously it is a good number. It is a proper input. So no error is getting handled. So else block will get executed. The print result, something will come. And after this, finally block will also get executed. So if I go ahead and press enter, so here you can see the result is 0.833 and execution complete. Okay. Finally is also getting executed. Now in case of let's say in case of error, let's say if I go ahead and write over here 0. Now in case of 0, what will happen? 0 division error is coming up, right? So else block will not get executed, but finally block will definitely get executed. So if I go ahead and press enter, you can see you can't divide by 0, that is 0 division error, and finally it basically gets executed, which is called as execution complete. Now you may be thinking, Krish, where in the real world scenario this will come, right? Where do we specifically use finally block and all? Let me just give you one example, guys. Let's say that in try block, I am connecting to a database, okay? Now in this particular database, let's say I got some connection issues, user password issues and all, right? Or let's say that I've connected to the database and I did some kind of operation, there I got an exception. I handled that particular exception, right? But at the end of the day, I need to close the connection of that particular database. So I can write the code over here in the finally block, right? Because at the end of the day, if I'm getting an exception, so that exception is basically getting handled. But if I come out of that particular block, I need to make sure that that entire connection gets closed. And that is how we can specifically use this try, except, else, and finally block. Okay. Now this was some of the ways of handling exceptions. And again, any kind of errors that you'll be seeing, there'll be different exceptions which you can probably check it out. Okay. Again, guys, the thing is that unless and until you don't practice, you won't be able to become perfect. Please make sure that you have this all indentation techniques that is basically getting aligned. You can have multiple exception blocks. You can have multiple, but you can also use this else and finally block also to handle more diversified code errors. Okay. Now let's see some kind of practical examples. So first of all, I will just go ahead and show you file handling and exception handling. Okay. This is most commonly used. Okay. So let me just go ahead and use a try block. I will go ahead and open my file. So let's say file is equal to open. Now you remember, right, in previous videos when we were discussing about file operation, we tried to open a file which is called example.txt, but that file was not present over there, and it gave us an error. It gave us an exception saying that, hey, those file does not exist. Okay, so we'll try to do the same thing over here. So here I'll just go ahead and open my example1.txt file, okay, and here I'll open this in read mode. Let's say, and right now if I go ahead and show you in exception handling, there is no file called as example1.txt. Okay, then I will just go ahead and write content is equal to file.read. We'll read the file inside that, and we'll go ahead and print the content. Okay, so this is my try block where the exception may rise. Right now, I will go ahead and handle this exception. So I know that this is a kind of file not found error. Okay, and because if the file does not exist, so this kind of exception I'll be able to see. So here you can see the file does not exist. Okay. Now anyhow, in the finally block, let's go ahead and write this in the finally block. In the finally block, I'm going to make sure that at the end of the day, I need to close this particular file. Right. So I'll write if file in locals. Okay. Now what exactly is locals? Return the dictionary containing the current scope local variables. Okay, if it is not present in the local, okay, and the file is not closed, okay, I may get an exception over here also in the read also, right? So that is the reason I'm writing this particular condition. If these two are, if that file is present in the local variable and it is not closed, I will go ahead and close this file because I cannot make this file open. There may be some kind of issue. Similarly with respect to database connection, so I will go ahead and print file closed. Okay, at the end of the day, whatever may happen in the exception, right? In the finally block, I'm going to close this particular file. Now, if I go ahead and execute this, you'll be able to see the file does not exist is coming, right? So here, automatically, the exception is basically getting handled, right? And let me do one thing. Let me just write is equal to b over here, and let's say that okay, fine. I have some kind of file. Okay, I have some kind of file. Let's say here, example1.txt. Okay, I have this file. Okay, I have this file. It is an empty file. Now, what will happen when I write is equal to b? I know it is not a file found error, so I will just go ahead and handle it with the parent class exception as ex. Okay, and I will just go ahead and print ex. Okay. But at the end of the day, I know the code will be giving me an error over here. But what I'm doing, because here I will be reading the file, right? So the file is in the open state yet. So when this error comes, I know this will not get handled by this, but instead it will get handled by this. In the finally block, I'm making sure that I'll close the file. Okay, so that is how we will specifically do. So here you can see that I'm actually getting an error over here. Now instead of this and, I will just go ahead and use or. So once I've used or, here you can see name b is not defined and file close. Okay, so we are at the end of the day, we're just closing all the specific files. Okay, some kind of errors will definitely be coming up. So we should always make sure that whenever we are opening the file, at the end of the day, we need to close this file. So I hope you are able to understand this entire thing and you're able to understand with multiple examples. I've shown you each and everything. Step by step, we have executed each and everything. So yes, this was it from my side. I will see you on the next video. Thank you. Hello guys, so we are going to continue the discussion with respect to Python, and in this video we are going to talk about the most important model that is called as OOPS, where we'll be discussing about classes and objects. Now, object-oriented programming is a programming paradigm that uses objects to design application and computer programs, right? OOPS allows us for modeling real-world scenarios using classes and objects. Now, any end-to-end projects that you're specifically going to create, we really need to use classes, we need to use objects. This increases the reusability of the code, and if I talk about developing real-world use cases, we will be able to use it efficiently, like we'll be able to develop that application efficiently with the help of classes and objects. Now, to give you a basic example of class, let's see the definition of class. So class is nothing but it is a blueprint for creating objects. Okay, it will be having separate attributes and separate methods. Okay, let's say that I go ahead and create a class. Okay, so let's give a basic example over here how to create a class. We'll see this. So here we use a keyword which is called as class, and here we will give it the class name. Let's say that I'm going to create a class name which is called as car. Okay, now car is nothing but it is a class. Okay, and it is a blueprint of creating objects. Now I'll show you how to create an object. Okay, so let's say that this is I'm just writing or I'm creating an empty car. Right now, when I say creating an object, right, car may be of different type, it may be of different brand. Right, so I may go ahead and create. Hey, first of all, I'll go ahead and create an Audi object. Right, so Audi object, it is a type of car, so I will go ahead and use the same blueprint and create this particular object. Right, similarly, I may go ahead and take a different variety of car. Let's say this is BMW, and here I may again use this as an or instantiate from this particular class, right, to create this particular object. So this is nothing but if I go ahead and print what is the type of Audi, right? So you'll be able to see that if I execute this, it is nothing but it is also class, but this is exactly an object over here, right? The reason why I'm saying it as an object because we have instantiated from this specific class which is called as car. Okay, and similarly, you can just imagine, right, what class is. It is a real world entity. Okay, and it is also called as a blueprint. And that using the specific car, I can create different objects which may be using the features of the specific car, right? Like we have Audi, BMW, and all. Okay, now let me just go ahead and probably explain more about it because I've not still discussed about attributes and methods, which we also called it as instance variable or instance methods. Okay, so if I probably also go ahead and print this Audi, so if I go ahead and print Audi, what will I get? It will be showing that hey, this is a car object at this specific memory location. Okay, and similarly, if I go ahead and print BMW, right? So here also you'll be able to see yes, it is showing that yes, it is a car object at this specific memory location, right? Now let me just go ahead and include two more important things. Let's say I will go ahead and write instance variable and methods. Okay, methods. Now let me just take another class. Okay, let's say that I'm going to create a class called as dog. Right now, dog is a blueprint, right? And in order to define the attributes over here, right? See, one way if I probably take this Audi and all, right? If I just go ahead and write Audi dot, let's say I'm going to go ahead and define one instance variable that's present inside the class. Let's say Audi has some windows, right? I'll just go ahead and write 4, right? This windows is basically 4, right? And if I go ahead and print Audi dot windows, then I will be able to see that I'm able to get the answer as 4. So Windows is a kind of attribute that is present inside the car. And for Audi, it may be that I may have 4 windows. For some other car, I may just have 2 windows. Like let's say that I'm taking a very smaller car over there, which is just like a Tata Nano. Okay, it may be having 4 windows, but let's say that there is a new variety of car that may have 2 windows. So I can change that particular attribute values. And this is how we specifically define, right? This is nothing but this is the kind of attributes. But initializing attributes like this is not a proper way. The reason is very much simple. Why this is not a proper way? Because see, whenever I create another object, let's say that I'm going to create another object. Let's say this will be a Tata car, and now I'll go ahead and initialize with car object, right? I'll go ahead and create this particular object. Now I'm going to go ahead and write Tata dot doors, right? So this will be my another attribute, and let's say there are around 4 doors over here, right? But if you see with respect to Audi, I did not create an attribute called as doors, whereas over here I created something called as windows. In Tata, I did not create an attribute called as windows, right? So if I go ahead and print Tata.windows, will I get anything? Let's see. So here you can see that I'll be getting an error saying that the car object has no attribute windows, right? So defining the attributes in this way is not a proper way. So I will just show you another way how we can clearly define all the attributes and methods in the first hand while we are initializing or while we are creating the object itself, right? So I'm going to take an example with respect to dog, okay? And here there is one very important function. See, if I go ahead and write dir directory of this specific class that is called as starter, okay? Here you'll be seeing there will be a lot of different inbuilt methods, right? And each and every inbuilt methods will be doing something else, right? Now, since you can see that I have created an attribute called as doors, you'll be also able to see that this doors will be available over here, right? Inside this particular directory. I will be talking about different over here methods, right? What functionalities it usually does. But here I'm going to talk about one method which is called as underscore init underscore underscore. Now, what this method is all about? This method is called as constructor, okay? Constructor. Now, what does this specific method do? So if I go ahead and write definition underscore underscore init underscore underscore, if initially I'm going to define any attributes, I can make sure that with the help of this particular constructor, at the first hand, I'll be able to define all the attributes that will be available inside this particular class, right? Now, in order to define it, let's say in dog, right? Let's say I have two attributes over here. One is name and the other one is age, right? So while I'm initializing or while I'm creating the object from a dog class, I have to make sure that I have to give these two attributes, okay? During the runtime, I have to give these two values during the runtime when I create the object, okay? Now, the best thing over here is that this is basically my parameter, right? And internally, I will go ahead and create some instance variable. Now, this instance variable are like some kind of properties that are available inside the dog class. Okay? And you know that I have to basically take this particular name and assign this name itself, because during the runtime I'm going to put this particular value. Now, obviously, I've written the same name, so the variable name is almost same. So let me just go ahead and write one more parameter which is called as self. Okay, it's not compulsory. You always need to write self. Okay, you can write anything over here. You can write Krish, you can write your name also. But self is a keyword which we specifically use, worldwide in terms of good practices. We use self keyword, right? Now, this self keyword will be responsible, in probably accessing the instance variable inside the class itself whenever we create an object. So here, what I'm going to write, I'm just going to say self.name. Now, this name that you'll be seeing, which is along with self.name, this name is nothing but it is my instance variable that is available inside the dog class. Okay, and this name is what is the parameter that I'm passing while creating the object. Okay, so here are the two parameters. One is self.name, and the second one that I'm actually going to go ahead and write, it is nothing but self.age is equal to age. So this way, I am initializing my entire class with a constructor. Now, if I go ahead and create the object, okay, now let's go ahead and create the objects, right? You'll be able to see that as soon as I go ahead and write, hey, let's go ahead and create my object dog1, this will get initialized from dog, okay? And here I'm going to give two parameters. If I execute like this, it will tell me, hey, you're missing two required positional argument, name and age, because name and age is not given. As soon as I call this, what is internally going to happen is that it is going to call this constructor first, okay? Because of this constructor, it is going to take all these values that is required for the instance variable. So here I need to provide two parameters. Let's say here I will go ahead and write buddy, and the age is 3, okay? Now, if I go ahead and execute this, print dog1, okay? You'll be able to see that I will be able to create a dog object at this specific memory location. Now, this instance variable is there, right? Name and age. Now, let's go ahead and retrieve this dog1.name, and the next one is print dog1.age, right? So now if I go ahead and access these values, you'll be able to see that I'm able to get that value which is called as buddy and 3, right? Similarly, I can go ahead and create any number of dogs objects, right? So I'll go ahead and write dog2, and again I will be using dog, and I'll go ahead and give my parameters over here. Let's say I will give something like Lucy, and the age is 4, and I will be able to print the same thing over here. That is nothing but dog2.name, and similarly print dog2.age, right? So here you'll be able to see that I will be able to access this instance variable over here. Now, the best thing is that we have defined the instance variable initially in the constructor, so that we cannot create any more. Whatever things is defined in the constructor, only those number of instance variable itself we can create. If tomorrow I require any more instance variable, I can just go ahead and write self dot that particular instance variable, and I'll assign the value based on the parameter that I pass over here, right? So this is the best practice that we specifically use with respect to creating instance variables, right? Now let's talk about instance method, right? Now, instance variable, whenever we talk about it, is some kind of properties that talks about dog, right? So over here, name and age are just like my properties for this particular dog, right? These are nothing but these are some kind of attributes, right? Similarly, there may be methods which we also call it as instance methods. Like a dog may be barking, right? It may be doing some kind of functionalities, right? It may be running at a specific speed, something, right? So those are nothing but those are basically instance methods. Now let me show you how you can actually go ahead and create the instance methods, right? So now I'm going to define a class with an instance method. So let's go ahead and define a class with instance methods, okay? Now, in order to define a class with instance method, again, I will go ahead and write class dog, okay? Now, as you know that I will be using my init constructor, so I will go ahead and write definition underscore init underscore. Here I will use a self keyword. Let's say that there are two parameters or two features that I'm going to use, that is name and age. These are my two instance variable. I can also say it as properties, attributes, anything you can specifically talk about, but all these parameters are basically talking about this dog class itself, right? These are the properties of them, right? And this is what I'm going to pass in the runtime. Now I'll go ahead and create my properties. So I'll go ahead and write self.name is equal to name, then I'm going to write self.age is equal to age, okay? Now this is fine, right? Now, once I create my constructor, now I'm going to create some instance method that is related to dog. Let's say the dog will be barking, right? So, and different dog can bark in a different way. So here also I'll be using the self keyword. The reason is very simple. So that inside this method also I'll be able to use this instance variable. Okay, that is the reason we provide this self keyword over here. Now I will go ahead and write print. Okay, some functionality or some print statement I will write over here, and I'll go ahead and write self.name. Right, self.name basically means the same attribute I'm calling it over here. Says woof. Right, so this is the sound a specific dog makes in generic. Okay, so here you can actually see over here. Right, and if I probably just consider this. This is one of the instance method. Okay. Now what I'm going to do, I'll go ahead and create my object. Let's say that this is my dog1, and here I'm just going to call dog. And let me just give the values. Here I'll be giving buddy, comma 3 is the age. Now I can use this object and call this particular function, right? Method, right? This method is nothing but it is basically called as bark. Okay. Now if I go ahead and just execute this, you'll be able to see that I will be getting that print says buddy says hoof, right? Now tomorrow I'm going to go ahead and create my another dog2. Okay. And let's say this dog2 is basically having the name as Lucy. Okay, and the age is 4, right? If I go ahead and just go ahead and call this dog2.bark, so here you'll be able to see that I'll be able to see it, get Lucy says hoof, right? So buddy says hoof, Lucy says hoof. Now this is the function, and based on different dog types, you can just consider that the object is nothing but different dog types, right? They're using the same properties and they're using the same methods, and this will be relative to that specific object. So that is the reason over here in the definition we have clearly written as a class is a blueprint for creating objects, and it has its own attribute and methods which can be used by this objects, right? So I hope you got an idea with respect to this, and I hope you're able to understand this. Okay. Now let's design a better example for you. Okay. So here we're going to take this example, which is called as modeling a bank account. Okay, so now let's go ahead and do this. Okay, so here you'll be able to see I will define a class for bank account. Okay, first of all. Now, in a bank account, you'll be able to withdraw money, you'll be able to deposit money, and you'll be also able to see the balance in the money, right? So here, first of all, how do we design this entire application with the help of classes? So I'm just going to use class with respect to bank account. Okay, it is always a good practice that you use capital letter whenever you are defining a class. Then I'm going to use my constructor, that is underscore underscore init underscore underscore. Let's say that what all parameters I'm going to probably give over here. One is owner information, and the next is balance. By default, whenever we create an account, the balance will be 0. Okay, so by default, I'm giving some values over here. Then I will go ahead and write self.owner is equal to owner. So, and again, guys, you may be thinking, should this particular attribute be same to this particular parameter name? Answer is no, right? You can write as your own, but I'm just following the good practices that many other developers usually follows. Then I'll go ahead and write self.balance is equal to balance. Okay. Now here you can see that I've created my bank account. Perfect. These are my attributes, right? Owner and balance. We also call this as instance variable. Now the next thing is that I will go ahead and define my instance method. So first of all, we'll go and create one method which is called as deposit. And here I'm going to give self, and one parameter that I will give is amount. Okay. Amount is like how much we really need to deposit as the parameter I'm giving. Okay. Now whenever I try to add money in my account to deposit, I have to probably increase my balance. Now, in order to get the excess of the balance, again, I have to use self.balance keyword plus is equal to this specific amount, right? And this is what we are basically doing with respect to the deposit function. And I will just go ahead and print and go ahead and write, hey, amount is deposited, new balances. I'm just going to write some print statement, new balances, self.balance, okay? Self.balance. I cannot directly use balance because this is nothing but it is an instance variable that is available over here, okay? Now, the next function that I'm actually going to create is nothing but withdraw. So I'm going to write withdraw, definition withdraw, and here I'm going to use self amount, okay? And with respect to this, if amount is greater than self.balance, okay? I'm just saying that, hey, if I'm withdrawing, first of all, I need to check whether the amount is greater than self.balance. If the amount is greater than self.balance, and if I'm trying to withdraw, then obviously this should not be allowed. And I'll just go ahead and print, hey, insufficient funds, okay? And finally, I'll close this, right? Now, if this is not satisfied, then what I will do, I'll just go ahead and write my else condition, and this time I have to subtract it from my balance account. So I will go ahead and write minus equal to the specific amount, okay? So I hope you're able to understand this. Now, if the amount is greater than self.balance, I'll say, hey, it is insufficient funds. But if this is not true, if the amount is less than self.balance, I should be able to withdraw it. So here you'll be able to say that I'm writing self.balance minus is equal to that specific amount. And here I will go ahead and print and say that by using an f string, say that, hey, this amount is withdrawn, okay? New balance is self.balance, right? So this is perfect. So I've created two instance methods along with that two instance variable. And finally, one more method I will go ahead and create, and you can create any number of methods. I will say, hey, get balance, okay? And here I will again use the self keyword, and all we have to do over here is that I will just go ahead and write return self.balance. I just need to return the balance in my account, okay? Done. Now you'll be able to see the balance amount and all, everything is there. Now let's go ahead and create an object. So I will go ahead and create an object. Now you can perform any kind of operation that you really want. While creating an object, I have to make sure that I create an account. So first of all, I will go ahead and write bank account, okay, which is my class. And when I call this particular bank account, I have to give two attributes, that is owner and balance, right? Owner over here is nothing but, I'll go ahead and say Krish. And initially, let's say my balance is, I am depositing around 500 rupees, okay? Or let's say 5,000 rupees, okay? Now let me just go ahead and print the account dot balance. So this is Krish account, right? So here you'll be able to see that I'm getting 5,000 rupees. Now let's say that I want to call this instance method, okay, when I want to withdraw some money, okay? So first of all, let's go ahead and do some deposit. Let's say that I got my salary, and my salary is 100 rupees, and I've deposited it, okay? So if I go ahead and print, or if I just go ahead and execute this, you'll be able to see that I'm getting a message saying that, hey, 100 is deposited, new balance is 5,100, right? Now let me just go ahead and withdraw some money. Let's say that I want to withdraw, account.withdraw is nothing but I want to withdraw 300 rupees. So I'll just go ahead and execute it. Now here you can see, hey, 300 is withdrawn, new balance is 4,800, right? Now finally, if I want to get the complete account balance, I should be able to just call print account.getBalance, and that is what I'm actually going to execute it. And here you can see I'm getting 4,800. So here in just front of you, I have designed the entire bank account with respect to all the operations with the help of class, instance variable, and instance method. So I hope you are able to understand this completely with respect to this particular example of bank account and all. As we go ahead, we'll be talking more about different examples, right? This is just to give you an idea of how powerful these classes are. But please always make sure you keep a note of all the indentation, how to probably create it. You need to understand very much clearly that this init is nothing but it is a constructor. These are my instance variable, these are my instance methods, and I can probably go ahead and write any number of instance methods that I want. And the importance of self keyword is to use this kind of instance variable wherever we want inside this particular instance method, right? Out of this class, I cannot use self keyword. That is very much clear, right? So I hope you are able to understand this entire video. So finally, I will just write some conclusions saying that what all things is important with respect to why these classes are important. So here, object-oriented programming is very, very much important. It allows you to model real-world scenarios using class and object. In this lesson, you learn how to create a class and object, define instance variable method, and use them to perform this operation, right? So yes, this was it from my side. I hope you like this particular video. I will see you all in the next video. Thank you. Hello guys, so we are going to continue our discussion with respect to Python, and in this video we are going to discuss about inheritance in Python. Now this inheritance is a fundamental concept in object-oriented programming that allows a class to inherit attributes and methods from another class, right? So in this specific video, I will be talking about how you can implement inheritance with the help of Python. We'll be discussing about single inheritance and multiple inheritance, and I'll be showing you multiple examples. So let's go ahead and let's see. Now inheritance is basically derived from the real-world scenario, guys. I hope, like let's say you will be inheriting your parents' property, it may be house, it may be land, but the vice versa will not be possible. Your parent will basically not be inheriting your property, but instead it will be going to your children, right? So this kind of scenario. So this is based on the real-world scenario, and similarly, the inheritance property in Python also works in the same way, okay? So let me just go ahead and show you one specific example of inheritance, and then I will show you how you can probably create a child class and probably inherit the parent class altogether, right? So I will first of all start defining my parent class. Okay. Now here, let me just go ahead and define one class which is called as car. Okay. Now car is my class. Okay. So I can also go ahead and write like this. Okay. Class car. Now, first of all, as you all know, whenever we define a class, we need to probably create a constructor. So let's go ahead and create this underscore init underscore. And here I'm going to use one parameter that is self, and the other parameters that we are going to provide while we are instantiating the object of the car class, like windows, doors, right, engine type. So let's consider that these are some of the attributes that we are going to pass, and let's go ahead and create some of the instance variables. So I will go ahead and write self dot, and first thing is that windows, right? I'll go ahead and create the first attribute that is windows, and I'll assign this value to the windows that I'm passing over here in this init method. Okay. Then we'll go ahead and write self dot doors, okay, where I will be passing the doors value, and finally I'll go ahead and write self dot engine type, okay, engine type. And again, I've already told you it need not be this name need not be same as this. You can write anything over here, but these are the attributes or instance variable, right? So is equal to, we'll go ahead and write engine type. Okay. Now this is my car class, and this is what I have in terms of attributes and all. Let me just go ahead and define one instance method also. Let's say with the help of car we usually derive. So here what I'm actually going to do is that I'll go ahead and use self keyword, okay, and let me just go ahead and print, okay, and let me say that the person will drive the car. The person will drive the which car? Okay, so let's say that the person will drive the petrol car or engine type car, right? So here I will just go ahead and write engine type, okay, and here I'm actually going to use this f string, okay, engine type. Now engine type I cannot directly use it over here because I have to use self dot, right? Because engine type is an attribute over here, right? So the person will drive the engine type car, okay, and I have to probably, if I want to use this attribute over here, I have to use self dot, okay. So inside this is my parent class, okay. I've defined a class with an init method. The attributes are windows, doors, and engine type, and one instance method which is called as drive. And here I'm saying that hey, the person will drive whether it can be a petrol car or diesel car based on the values that we provide, right? Now once I probably go ahead and create this class, let's consider this is my parent class. Now I can go ahead and write car one is equal to, I will go ahead and find my car, okay, and here I'm going to give the values. Let's say the number of windows are 4, number of doors are 5, and let's consider the engine type is petrol, okay, petrol car, okay. And now I'll go ahead and print car one dot the method that is drive, right? Now if I go ahead and execute it, here you'll be able to see that hey, the person will drive the petrol car, and obviously drive does not return anything over here, so that is the reason it is giving you none, okay. But in short, over here you can see that I'm just writing car one dot drive, so it is just going to display this, the person will drive the car, okay, perfect. If I just remove the print method, then you'll be able to see that I'll be able to get only one message, okay, that is print the person will drive the petrol car, because this drive method is not returning anything. But this is fine, right? This is very much easy, and here you can actually see that what all things we have basically done, right? We have given a car class, and probably we have defined an init method, we have defined a method over here, right? And we are able to create the objects, right? This is perfect. Now let me do one thing. Now see, there are different types of cars, right? I can just consider this car class is a blueprint of a car object, right? This is the blueprint where it has this many number of attributes, this many number of methods. Now let me just go ahead and create one class which is called as Tesla. Okay. Now this Tesla car that you're probably seeing over here, obviously it needs to inherit from the car blueprint itself, right? Because in this Tesla also, I'll be having windows, I'll be having doors, I will be having engine type, right? And there may be some additional feature that may be available in Tesla. So I don't have to again go ahead and define this entire thing. Instead, what I can do, I can just inherit this car class, and I can inherit these properties along with I can inherit these functions or methods, right? Because I don't have to recreate the entire class completely from scratch. If it is inheriting this particular car class, which is a blueprint, it will be able to inherit all these attributes and methods, right? So let's go ahead and do this. So in order to make Tesla inherit car, so I will just go ahead and write over here as car. So this is how you basically write. First of all, you really need to write your child class like class Tesla, and then whatever things you basically write in the bracket, this is basically inheriting that particular class. Okay. Now we'll again go ahead with defining our init function, because here also we'll be having an init function, right? So definition underscore init underscore. So this is my constructor inside the Tesla, and here also we require attributes like windows, doors. Okay. So we'll pass it during the runtime. Then you have engine type, and finally these all attributes are already available over here, right? So there may be additional attributes that may be available in Tesla. So I will just go ahead and say is self-driving, okay, and this will be a boolean value. Let's consider this, okay, is self-driving. So Tesla, that it has the self-driving functionalities, okay. Now fine. Now the main thing is that I need to create the attributes for windows, doors, and engine type, and I know that car already has this kind of attributes, right? So I don't need to go ahead and write self dot, right? What I can do is that I can just use the super keyword, right? If I use the super keyword, that basically means I'm saying, hey, I'm trying to call super basically means I'm just trying to call the parent class over here, and from the parent class I will just go ahead and call my init method, okay. So here what does super underscore init basically mean? That basically means that you're just calling this init method from the car class, right? Parent class, right? And that is the reason we're just writing super dot underscore init. Now over here the next step will be that what all attributes I'll be getting from the parent class. One is windows, okay, so let me just go ahead and write windows, doors, and then you have this engine type, right? Then you have this engine type. So this three values or attributes I should be getting from this car class, right? So I don't have to again define it. But what about my is self-driving? So I will just go ahead and write self dot is self-driving, okay. So let me just go ahead and create this variable self dot is self-driving, self dot is self-driving, and I will assign it to is dot self-driving. So this is the attribute, and this only attribute we'll try to create inside the Tesla class, okay. And remaining all we are in short inheriting from parent class, right? Now when we are inheriting this, obviously it is true that we'll also be able to inherit this too, right? So let's see this, okay. Now I will go ahead and probably I've created my init method over here, and now what I will do, I'll create another function which supports self-driving, right? Let's say self-driving. So here I'm just going to write self-driving, and here I'm going to say self, okay, perfect, right? So this is the method, or this is the instance method that we're going to create inside this Tesla class, which is the additional thing when compared to the class blueprint, car blueprint. Sorry. Now here I'm just going to print something and write over here Tesla supports, okay. I can just go ahead and write self dot is. So here I'm just going to use my f string. Always focus on using this f string, then only you'll be able to use this particular. You'll be able to basically write in this way. So self dot is drive. Okay. So here you have this entire thing. Okay. Now Tesla supports self-driving. True or not? Tesla supports self-driving. So here I'll say self-driving. So this will basically give me a value like true or false. Okay. Now this is my entire Tesla car, right? And this is my child class, which is inheriting the car class, right? Now once I execute this, now let's go ahead and call this. Okay. So first of all, I will just go ahead and write Tesla 1 variant, and I will go ahead and initialize it. And now what are parameters I need to give? Windows, doors, and engine type. So I'll say, hey, windows are 4, doors are 5, engine type is electric. Let's say electric. Okay. And whether it supports self-driving or not, I'll just go ahead and write true. Okay. Now after giving all these parameters, you'll be able to see that if I go ahead and print Tesla 1 dot self-driving, Okay, and I'll call this function. Let's see what it says. So here you'll be able to see that it is printing Tesla supports self-driving is equal to true, and this is what we have given. So what happened once we call this particular child class with Tesla and all these values? What it is going to do is just go ahead and call super init, and it will pass all these parameters over here. And this init will make sure that all the attributes it will go ahead and initialize with those values, like self.windows, doors, and engine type. Now once that is done, then we'll go ahead and initialize the attribute is underscore self-driving, which will be assigned to true, and then I can probably call this particular function. Not only this, now in the parent class I have this drive function, right? So I can also call that. See, I will go ahead and write Tesla 1 dot drive function. Okay, if I go ahead and call this, here you can see the person will drive the electric car, right? And this is how you can probably see that a single inheritance works like, right? And you understood the main mechanism. If you really want to inherit any parent class, how you have to probably use this init method, how you have to call this super init method, how to define the new attributes, how to initialize those new attributes over here, during the runtime. And along with that, you can actually go ahead and create any more methods that you want. Okay, and this is what is an example with respect to inheritance. And this inheritance, I will just say it as single inheritance because only one child class is inheriting the parent class. Okay, now let me just show you an example with respect to multiple inheritance, but I hope you are able to understand. Okay, so here will be multiple inheritance. Okay, now multiple inheritance means what? When a class inherits from more than one base class. Okay, when a class inherits more than one base class. Okay, now what does this basically mean? Let's go ahead and create one base class. Okay, let's say I will go ahead and create animal. Okay, so animal is one class. Okay, and here I'm just going to use my init method. And here let me just go ahead and write self comma name. Name is what I'm going to pass as an attribute, and I'll go ahead and create my attribute self.name is equal to name, right? So this becomes my animal class. Okay, an animal class. Let me just go ahead and create one function which will be like speak. Okay, and here I'm going to use self, and let me just go ahead and probably print something. So here I'll just go ahead and print. Okay, subclasses must implement this method. Let's say I'm just going to write this. Okay, now this is done with respect to my class, right? Now what I will do is that I will go ahead and create another base class. So this is one of my base class. So here I'll write base class 1. Okay, base class 1, because see what, when a class inherits from more than one base class. So this is my base class 1. Now let me just go ahead and create my base class 2. So base class 2. Okay, and here I'm just going to copy this, and here you can see I have this pet class, and I'm creating this init method with self owner, and I'm saying hey self.owner is equal to owner. Okay, now let's go ahead and create my derived class. Now derived class will be something like inheriting both these classes. Now in order to for a child class to inherit both this class, I will go ahead and create class dog. Okay, and this time in order to inherit both the classes, I will go ahead and write animal comma pet. Okay, so this is how you basically give in comma separated inside these brackets. Then what I will do, from animal I will be taking this name attribute. I will be accessing this speak. Along with this, from pet I will be getting owner, right? So here if I want to use this owner attribute and name, all I have to basically go ahead and write, I'll go ahead and create my init method. Okay, and here I'm going to give self comma name comma owner, right? And here let me just go ahead and write animal dot underscore init. Okay, so this is also another way of probably calling it, right? Let's say I want to get the attribute of name from animal, right? So this name is basically present in animal. So instead of just writing super dot, I can just write the class name dot init, and here I can actually give self comma name. Okay, so this is one way. The other way is that again I will go ahead and do it for the other class pet underscore init underscore, and here also I'll go ahead and write self comma owner. Okay, self comma owner. See, what is the difference between before the methods that I've discussed? Here I have used super because I just had one parent class. But since here I have two parent class, like base class 1 and base class 2, right? I need to use one attribute from this particular attribute itself, from this particular class animal, and one more from this another base class. So what I'm doing, I'm just writing animal dot underscore init. I'm calling the animal init method, and there I'm passing this particular parameter, and then I'm calling pet underscore init, and then I'm passing the parameter over there. And when it goes to this init method, then this attribute gets the value of this, right? This is how the entire flow goes. Now finally, let me just go ahead and create a speak method. So I'll just go ahead and write a definition speak, and here I'll go ahead and say it is a self. Now let me just go ahead and return. So return will be an f string, and let's say here I'm going to basically write self.name says hoof. Okay, self.name says hoof. Okay, and this is what is basically getting printed. So let me just go ahead and write a return over here. Okay, now it should be working fine. Now let's see this, how this will work. Now we'll go ahead and create an object. Okay, create an object just to see that whether it is working fine or not. So here first of all I'll go ahead and call dog is equal to, I will initialize from dog. Here I'm just going to write the name will be buddy and the owner belongs to Krish. Okay, let's say. Then I will go ahead and print dog.speak, and if I go ahead and execute this, you'll be able to see that I'll be getting buddy says hoof. See, there is also a speak method over here, but since we are directly calling it from the dog class, so this speak method will be given more priority when compared to the parent class, right? So that's the reason it is saying buddy says hoof. Okay, then I will just go ahead and print my f owner. Owner will be nothing but it will be self dot dog dot owner, right? Dog dot owner. Okay, so let me just go ahead and execute it. So here you'll be able to see that owner is nothing but Krish and buddy says hoof. So here what we are doing, here we are creating two parent class, two separate base class, okay, and we are inheriting them from a derived class, and this is basically called as multiple inheritance, okay, or we can also say it as multiple inheritance. Yes. Now let's do one thing. Let's create an amazing use case, and this use case will be about modeling a complete library system. That we'll discuss in our next video, where we'll be modeling a complete library system. Here there will be using single and multiple inheritance. So yes, this was it from my side. I hope you like this particular video. I will see you on the next video. Thank you. Take care. Hello guys, so we are going to continue the discussion with respect to Python, and we are going to continue the object-oriented programming series, and in this video we're going to discuss about polymorphism. Now polymorphism is a core concept in object-oriented programming that allows objects of different class to be treated as objects of a common superclass. I know there will be a lot of confusion when you read this sentence, but just go ahead and read the next line, and if you are not even understanding over here, don't worry, I will show you a lot of practical examples which will actually help you to understand each and everything. So it provides you a way to perform a single action in different forms, okay? Polymorphism basically means multiple form, okay? If you split this word, it is basically called as multiple form, okay? And here it is written, polymorphism is typically achieved through method overriding and interfaces. So let me just go ahead and talk about this, and let me just give you a good example to make you understand, okay? But it is my duty to probably write this kind of definition so that you also know the definition with respect to this. Okay. Now, what does method overriding allows a child class? So here I'm just going to give you this comment. See, or let me make this or remove this completely, and let me make add a markdown over here. So here you can see Let me just go ahead and execute this. Method overriding allows the child class to provide a specific implementation of a method that is already defined in the parent class. Okay, that basically means, let's say if I'm defining a parent class, okay, over there I have defined a method, right? Let's say the method will be like, if I probably create a dog class, the method is speak. Okay, so one dog makes a sound, whoa, woof woof. Then let's say that I'm inheriting that particular dog with some child class. Now that particular dog makes a louder sound, woof 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 woof. So there, what we are doing, we are overriding the functionality of that particular method, right? So method overriding is nothing but it allows the child class to provide specific implementation of a method that is already defined in its parent class. So let me just go ahead and take one specific example, and here you'll be able to understand. So first of all, I will go ahead and create my base class. Okay, now this base class will be my animal class. Okay, so let's say that this is my animal class, and I'm just going to create a function that is called as speak. And here I have not written any constructor because I'm not defining any attributes. Okay, so let's say that I've used speak and with the self parameter, and it is just going to return something like the sound of the animal. Okay, something like this. Now this becomes my base class. Now let me just go ahead and derive my derive class. Okay, or write down my derive class 1. Now in this derive class, let's say I will go ahead and derive, I'll create a child class which is called as dog, and it is basically inheriting from animal. Okay, and then we go ahead and define the definition speak, and here we go ahead and define self, right? Now see, the method is same over here, right? If we are inheriting this particular class, you'll be able to see that, okay, fine, this is the method that I have right over here, and I can also go ahead and return my own definition. So let's say the dog makes a sound like woof. Okay, so this is the sound that the dog makes. So what I have actually done, the same method is there, but different implementation. So here method overriding allows the child class to provide a specific implementation of a method that is already defined in the parent class. So this method is already present over there, but the child class has provided its own specific definition or implementation, right? Now let me just go ahead and create another derived class. Okay, derived class, and this time I will go ahead and create a class that is called as cat, and let this get inherited with animal. Okay, animal. Now here I can again go ahead and override the functionality of this method, and here I can say, hey, it returns meow. Okay, it returns meow. Now let's go ahead and define our or create our object. So here what I'm actually going to do, I will just go ahead and write dog is equal to dog. Okay, now if I go ahead and print dog dot speak, which method it is going to just call? It is just going to make sure that it calls this specific method, right? And similarly, let's say that I go ahead and create my cat. Okay, and let's say that here I will just go ahead and print cat dot speak. Okay, now if I go ahead and execute this, here you'll be able to see that, hey, I'm getting, when I go ahead and execute dog dot speak, I'm actually getting hoof. When I'm executing cat dot speak, I'm getting meow. And this is what method overriding is all about. You know, the same method is getting overridden in the derived class with its own implementation, right? And I can also do one thing. Okay, after doing all these things, you know, I can also create one additional function. So function that demonstrates polymorphism. Here what I'll do, I'll go ahead and create a function, and this is a public function, not inside a class. Okay, not inside any class. So let's say that I'm going to create animal speak, and here we will provide an attribute of the class or an object of a class. Okay, and then we can just go ahead and write print animal dot speak method. Okay, now this animal that I'm actually providing, it's an object of this specific classes. Now after defining this method, I can just go ahead and write print. Okay, and I can go ahead and say dog dot speak, or let me just go ahead and sorry, it should be animal underscore speak, and here I will just be providing dog. So once I probably define this and execute it, here you can see that I'm getting poof, right? Because as soon as I call this function, here we are giving the object of this particular class, and inside the same dot speak method is basically getting called, right? So this way also you can probably show polymorphism. But here what we have done method overriding. We have just overridden all the functions over here from the base class till the child class. Okay, so this is one example over here. Now let me just show you another way where I will be showing you polymorphism with functions and methods. Okay, now polymorphism can be also implemented using function and methods to process objects of different types in the same way, right? So here let me just go ahead and show you one base class. Let me just go ahead and create one base class. Here the class name will be shape. Let's say that I'm going to define shape. Now let me just go ahead and write definition area. So I'm going to create a function which is called as area, and here I'm going to give my self keyword. Okay, self keyword. Now let's go ahead and return the area of the figure. Okay, I'm just going to probably give a print message, and this is basically present in the base class. Okay, now what I'll do, I'll go ahead and create my derived class. Now see this. Okay, again here I'll also be implementing function overriding. Okay, so this will be my derived class 1. Okay, let's say that I'm going to probably create a rectangle, and you know rectangle will inherit shape. Okay, and you know if for rectangle definitely what we require in order to calculate the area, it is nothing but width and height. So I'm just going to create my init method, and here I'm going to give self comma width comma height. This is what I'm going to pass in the runtime. I will go inside this. Now let me just go ahead and create my parameters or attributes. That is nothing but cell dot width, cell dot height, and then we'll go to the next sentence. Oh sorry, this should be assigned to width. Okay, then we will go ahead with cell dot height, which will be my another attribute, and this I will assign it to my height. Okay, now I will go ahead and call this area function. Right now, here what I'm doing, I'm overriding this area method because the functionality will be a little bit different over here. Right? How to calculate an area of a rectangle? It is nothing but it'll just return self dot width multiplied by cell dot height. Right? This is what we are specifically doing. Now let me just go ahead and call the derived class 2. Okay, so here we have completely redefined, or we have overridden the entire function. Right? So it's like all the functions are basically having multiple forms. As we keep on making sure that once our derived class inherits the parent class, we are basically redefining this entire function, or we are overriding the functionality. Okay, now let me just go ahead and create another derived class, and this time I'm going to create it as circle. Okay, this will again inherit shape. Okay, shape. So let me just go ahead and inherit shape. And now this time, you know, I'll be using an init function, and this will be a constructor. And here, what I require in order to calculate the area of a circle, I just require radius. Right. So here I'm basically going to write self comma radius. Okay. Now let me just go ahead and write self dot radius is equal to radius. Right. So here you'll be able to see that I'm able to just get this particular parameter. I'm able to create it. Now here also the area definition will be, the function will be different, right? So how do I calculate the area over here? I'll just say return, right? It is nothing but pi r square, right? Pi is nothing but 3.14 multiplied by radius into, sorry, self dot radius multiplied by self dot radius, pi r square, right? Done. And this will basically give me the area. Now what I will do along with this, I'll just go ahead and write a function that demonstrates polymorphism. And here is what I will be writing. So here let me just go ahead and write print underscore area. And here I'm actually going to give the shape, which will be an object, okay, of a specific class. And we'll just go ahead and print with my f string, the area is nothing but shape.area, right? Shape.area, which will be my function. Okay. Now this is what we are going to just print it, right? Now let me just go ahead and create the objects. So first of all, what I'm actually going to do, I'm going to create a rectangle object. Go ahead and use rectangle, right? Basically use 4,5. In case of circle, I just need to provide my radius. So let me just go ahead and define circle with radius. Radius is, let's say, 3. Now if I want to go ahead and just call the area function, I will just go ahead and write print underscore area, and I will give the object that is rectangle. Okay, rectangle. And similarly, I will go ahead and call print underscore area, where I will be giving circle, right? And this is how we execute it. And here you can see the area. Okay, the area is 20 and 28.25. So this is the area with respect to the area of the rectangle, which we basically write length into breadth. So nothing but 4 into 5. And if I go ahead and calculate pi r square, so I'm actually going to get 28.25. Right. So this is one amazing example. And here you can see that we have used functions. We have defined another function that demonstrates polymorphism over here. And this is one of the amazing examples with respect to this. Okay. And here also we are basically playing with the same method name, but with different definition. Okay. Now let me just introduce you to see. I've already written over here something like this, right? Polymorphism is typically achieved through method overriding and interfaces. Now let's talk about these interfaces. What is interfaces? In other programming languages, we basically say interfaces. In Python, we say it as abstract base class. Now what exactly it is? Let's discuss about it. So polymorphism with abstract base classes. Okay. Now abstract base class, if I really want to define it, okay, it's very simple. Let's go ahead and see the definition. I'll paste it over here and let me just go ahead and write this. Okay. Important topic altogether. Okay. Abstract base class are used to define common methods for a group of related objects. They can enforce that derived class implement a particular method, promoting consistency across the different implementation. Okay. So abstract base class, that is the reason we say it as ABC. Okay. Let's do one thing. Okay. Let's show you an example over here. I will be defining two important things. First, I will write from ABC. Okay. Now what is this ABC? We are basically using abstract base class. We are going to import ABC. Okay. Along with that, we will be importing abstract method. Okay. This abstract method is a kind of decorator. Okay, I'll be talking about what exactly is decorator as we go ahead, right? But just consider right now, this is what abstract class is all about. You know, it is just used to define a common methods. Okay, so I will just go ahead and define an abstract class. How do I define an abstract class? This is what I'm going to show you. Abstract class. Okay. Now, abstract class here, I'll say, hey, let's create a class called as vehicle. Okay, and this I'm going to inherit to the abstract class, which will be like an empty class itself, right? So, this abstract class, afterwards I define it, I will be defining an abstract method also. See, in order to just give you a simple definition of abstract class, it is like a complete empty class. You know, there if you're defining also method, it will be initially empty. Okay, so that is the reason why we have written that abstract base classes are used to define common methods for a group of related objects. Here, no definition will be there much. Okay, so with respect to this, now I created this particular class. I'm not putting any definition, but let me just go ahead and create an abstract method. Okay, abstract method is just like an empty method, but it is kind of common class that is probably going to happen in each and every class because we are going to inherit this kind of abstract class onto this, right? So here, what I'm going to write, I'll just go ahead and write define start engine. So this will basically be my function, and here I'm going to use my self keyword, and since it is abstract, it needs to be empty, so I'm going to just write pass. Okay, so this is how I've actually created my abstract class. Along with that, I'm also created my abstract method called as start engine. Now what I will do for my derived class 1, I will inherit this. Okay, so let me just take class car, and here I'm just going to use vehicle. Okay, now you know that I've defined my abstract method, which is completely empty. Now I can, since I'm inheriting vehicle, I'll also be inheriting this particular method, and I can define my own function. So that is the reason we'll go ahead and write definition start underscore engine. Okay, start underscore engine self, and we're just going to return over here car engine started. Okay, some information. Car engine started. Okay, and here you can define your own init method also inside this particular class also, right? Define any number of parameters that you want. Okay, now similarly, if I go ahead and create my derived class 2, you'll be seeing, hey, let's go ahead and create this particular class called as motor cycle. Okay, and here I'm actually going to give my vehicle. Okay, vehicle class, and let's go ahead and inherit it. And if I go ahead and write definition start underscore engine, here I'm just going to return motorcycle engine started. So here you can see this function is having a different definition inside motorcycle class, and it has a different definition inside the child class. Okay, then let me just go ahead and create the object of the class. So create objects of car and motorcycle. Now see, I will just go ahead and create it. Okay, and we can do the same implementation like this also, right? So I've inherited over here. Let me just go ahead and define one function that will demonstrate my entire polymorphism. And now I can just go ahead and start this vehicle and just let me define my car. If I go ahead and execute it, you can see that automatically it is being able to call this called as start engine, and here we are able to display it. So here I've actually shown you polymorphism with the help of method overriding. Along with that, we have also seen with the help of abstract class. So this two you definitely need to know. And again, ending this session, I will try to provide some conclusion, which is a good habit. Okay, so here with respect to the conclusion, you should know why polymorphism is important. It is a powerful feature of OOP that allows the flexibility and integration in code design. It enables a single function to handle objects or different class, each with its own implementation of a method. By understanding applying polymorphism, you can create extensible and maintainable object-oriented programs. Okay, but here we are just seeing that what all features it has with respect to polymorphism, right? So yes, this was it for my side. I hope you like this particular video. I'll see you in the next video. Thank you. Take care. Hello guys, so we are going to continue the discussion with respect to Python, and in this video we are going to talk about encapsulation and abstraction. Now this will be two videos. In this specific video we'll dedicatedly discuss about encapsulation, and then in the next video we'll talk about abstraction. Encapsulation and abstraction, they are very important concepts in object-oriented programming, and it will be helpful to design a very good maintainable and reusable code whenever we define all these things and use all these things in a project. Okay, so if I probably go ahead and read this, here you can see encapsulation involves bundling data and methods that operate on the data of the single unit, while abstraction involves hiding complex implementation details and exposing only the necessary feature. Okay, so abstraction involves hiding complex implementation detail and exposing only the necessary feature. So we will be discussing more about this in the next session, because there will be specifically discussing about abstraction. But if I I talk about encapsulation, it is nothing but it is a concept of wrapping data variables and methods together as a single unit. It restricts direct access to the same object, to some of the object components, which is a mean of preventing accidental inference and misuse of data. Now, what does this basically mean? Restrict direct access to some of the object components. And here we are basically saying, hey, it is a concept of wrapping data, that is variables and methods together as a single unit. So let me just go ahead and show you some of the example over here. And as I said, in this video, we're just going to talk about encapsulation, and in the next video, we'll talk about the next part, that is abstraction. Okay. So encapsulation we can do with something called as getter and setter method. Okay. Now, before I go ahead and make you understand about getter and setter method, let me just go ahead and talk about three important access variables. One is public. Okay. And I hope you may have seen this in other programming language, in C#, in C++. So public, protected, and private variables. Okay. We'll talk about this, what exactly it is. Okay. Now, let's go ahead and do one thing. If I'm going to create a class, let's say I'm going to create a class called as person. Okay. And let me just go ahead and write definition in it. Definition, this is my constructor. Here I'll take self, name, and age. Okay. Now, here you can see that if I go ahead and write self dot underscore name. Okay. Or just let me write self dot name is equal to name. Okay. This variable or this instance variable that we are actually creating, this is basically called as public variables. Okay, public variables. Okay, this instance variable, public variable. I'll talk about it, why we say it as public variable. And similarly, if I go ahead and define this, self.age is equal to age, this is also a public variable. This basically means I can call this, or I can use this particular variable from outside of this specific class. Okay, that basically means, okay, let's go ahead and see. I will go ahead and define person, and here I will just say, hey, the name is Krish, and here the name is age is 34. Okay. Now, when I say public variable, public access modifier, also I can say, see, I can also call this as public access modifiers. We'll also discuss about protected and private access modifiers. Okay, we can also talk like that, variables or access modifiers. Okay. Now, here you can see that there is one very important statement. It restricts a direct access to some of the object components. Here, if I go ahead and print, okay, person.name, okay, I will be able to print it. Okay. Here I'm able to get Krish. Now, let's see. If I go ahead and use this person, okay, and if I try to understand inside these objects, what are the different inbuilt methods or variables that are probably available over here. So if I go ahead and use this dir function, and if I just go ahead and execute it, here you'll be able to see, hey, and here this is what we use, right? Definition underscore underscore. This is a constructor. So here also you'll be able to find this method is there. Okay. And along with this, you'll also be seeing there'll be two more variables that are available. That is age and name, right? And these are nothing but these are my public variables, right? Or instance variables, which is specifically over here at public. The reason why I'm saying it as public, because here you can see that I'm able to see this particular variables directly over here. Okay. And I can use it from anywhere of the program just by using the object. I can use it in different functions anywhere I want specifically. Okay. Now, one thing that you can probably do, right? I can probably create a function. I can go ahead and write get underscore name, and I can give the object over here, let's say person, and I can go ahead and return something like this, return person.name. Okay, and I will go ahead and execute this. Okay, now let me just go ahead and print this. So here, if I go ahead and write get underscore name, and if I just call it with respect to this particular person, here you can see that I'm able to access this particular name from outside the function, outside the class itself. Right now, there may be a scenario where I may want to define some of the variables in such a way that outside this class, I should not be able to provide it as an access. Okay, because there may be some very important variables, right? And those variables I don't want to change it. Once we are initializing it, we don't really want to change it in the later stages. Okay, if you want to just change it, we should only be able to change it while we are creating the object, right? And I don't want this particular variable to be as an access over there, right? So that is the reason why what we do is that we use something called as protected and private variables. Now let me just show you one example of creating a private variable. Right now, if I just go ahead and see directory of person, I'll be able to see all these variables are publicly available. Now I will just go ahead and copy the same thing. Let's see this. Okay, I will just go ahead and copy this. I'll paste it over here. Okay. Now instead of just writing underscore, let's see, I'm creating a person class. I'm using name and comma age as a parameter while I'm giving it over here. Now instead of writing like this, I will use double underscore. Okay, double underscore name. And here also I will go ahead and use double underscore age. Now what is this double underscore name? This becomes a private variable. If you want to define a private variable, I have to write double underscore. And here also I will go ahead and write the private variable as double underscore. Okay. Now if I go ahead and execute this, okay. Now see focus over here. Okay, I'll remove all this particular code. Okay. And let me do one thing. Let me just go ahead and execute this particular code. Okay. And let me just create an object. So I will go ahead and create an object, and here I will write person, and let me just go ahead and give my values, Krish and 34. Okay. And let me just make this spelling correct. So it should be person. Okay. Now if I go ahead and check dir with respect to this particular person, now see here you can see that I'm not able to see this particular variable, right? You see this? Or let me do one thing. Let me just create one more public variable along with this. So here I will go ahead and write self dot name age. Let me just go ahead and say that gender. Okay. So gender is equal to, I will go ahead and assign this particular gender variable, which I'm actually providing over here. Okay. Let's say that this information. Now here you can see this is a public variable and this is a private variable. Why I'm saying it as a private variable? Because I'll just tell you in some time. Okay. Now let's go ahead and update it over here. Let's say that I'm writing this is male. Okay. If I go ahead and execute it, here you can see directory of person. Okay. It takes 3 positional argument, but 4 were given. 3, one is name, age, and self.gender is equal to gender. Let's see why this is an issue over here. Self.gender is equal to gender. Okay. I did not execute this. Maybe. Okay. Now it should work. Right. Now here you can actually see that I'm able to see this particular public variable. I'm not able to see all this underscore name and underscore age below this. Right. I'm not able to see. Why? Because that is a private variable. And wherever private variable will be displayed, it will be displayed over here in this format. Right. So here you can see when I write underscore person underscore age, the private variable basically becomes in this particular way. Right. It will get appended along with the person class. Right. So I'm not getting this direct variable underscore age is nowhere present. So this basically indicates that this is a private variable. Okay. Now let me do the same thing. Let me just go ahead and create a function and let me say, hey, get underscore name. And here I'm actually going to write, I'm going to give an object called as person. And I'm just going to say return person dot underscore name. Okay. I'm just going to return this. Now let me do the same thing over here. Okay. Let me just copy this entire thing. Let me call this person and let me just go ahead and call this particular function name. Get underscore name. Okay. And if I go ahead and see this, and if I just give this particular parameter, will the name get printed? The answer is no. Why? Because it's saying that, hey, it has no attribute underscore name. The reason is very simple. Because this is a private variable. And you will not be able to access this. You'll definitely not be able to access it because if I go ahead and see inside the directory, I'm able to see that, hey, my person, the underscore age has been in this particular name. Right? Yes, in this directory you're able to see. But as a developer, you're able to see. But as a common person will not know that, hey, my private variable has got converted in this particular name. Right? And that is the reason you're not able to access it. So here we are restricting, right? What happens with the help of access modifiers or encapsulation? We are restricting some of the variables because I don't want anyone to see this particular variable or directly access this variable because these are some very important attributes in a class which I should not be changing frequently. Yes, as a developer, I can definitely see it. What I can do, I can just go ahead and copy this and I can print it over here. Okay, I can do that as a developer, but this is not a good practice. The reason we create a private variable because it is saying to your fellow developers, hey, this is a private variable and it should always be remaining hidden. Now, if I go ahead and execute like this, I'll be able to get the answer, right? I'll be able to get 34, right? Or if I want to probably display the name, I'll be able to get this particular name, right? But if I directly call with underscore name, it will not be possible because I'll be getting that particular error, right? So what does private variable basically say? That a private variable cannot be accessed from outside the class. Very simple. It cannot be accessed from outside the class. Can we access it inside the class? Yes, we can do it. And for that only we'll be using getter and setter method, right? So private variable is something like which you cannot access outside the class. Even you have a derived class that can also not access it. Okay, so this is one of the very important property in encapsulation, and this is where we discuss about private and public variable. There's also one more variable which is called as protected. How do I define protected? So protected is nothing but I will use the same thing, and let's say instead of writing double underscore, I'll just write single underscore. So this is what a protected variable is like, right? A protected variable or access modifier is like. Okay, a protected variable basically says that hey, you cannot use it outside the class. Like outside the class basically means we cannot access this underscore name outside the class, okay, but we can access it from a derived class. So let me just go ahead and write, let's say if I go ahead and say employee is my another class, okay, employee is my another class, and if I say hey, this is inheriting person, so here I've created a class employee which is inheriting person. Now what I'm actually going to do, I'll just go ahead and write my init function, right? So here I'm again going to write my init function, and inside this particular init function I'm just going to pass all the parameters like let's say age, gender, okay, and what I'm actually going to do over here, I'll go inside this, and now I'm going to just write super dot, and since I'm inheriting all the attributes from the upper class, so I'll just go ahead and write this self comma name comma age comma gender, okay. Now here you'll be able to see that if I have this class employee, right, I should be able to access this particular values, okay? And that is what protected variable is all about, right? Whenever we create a protected variable in one of the classes, only its derived class will be able to access it. Other than that, you won't be able to access it outside that particular class, okay? So once I probably create this derived class, now from this derived class, I should be able to access all these variables. So what I will do, I'll just remove all these things, okay? I will not be requiring over here. Now let me just go ahead and create my employee, okay? And here I'm going to define my employee, okay? And let's say that I'm going to give some values like Krish, 34, and here I'm going to give the gender as male, okay? Now I will just go ahead and print employee dot underscore name, right? So once I execute it here, okay, 5 parameters is required. So let's see which all parameters. Name, age, gender. Over here, I'm given name, age, gender, and here you'll be able to see that underscore name, underscore age. It takes 4 positional arguments, but 5 were given. Let's see where it is. 4, 5 were given. So self is over here, employee person is over here, employee is over here, and this is nothing but employee dot underscore name. Okay, guys, one mistake that I've done over here, I've used self keyword, so I should not be using this. Now I think it should be displaying it. Okay, so employee dot underscore name. Here you'll be able to see that I'll be able to get this particular output. So in the case of whenever we define a protected variable, it is just like so it is not anything is compulsory in Python. You know, it is like a very it is a kind of programming language where there are no strict rules. But most of the concepts that we learn, right? Let's say that if I'm trying to create a private variable, if I'm trying to create a protected variable, in case of protected variable, I have to always make sure that this variable will only be accessible only from the derived class. In the case of private variable, nothing should be accessible outside the class. You know, and public variable is what you should be able to see that you'll be able to access it from anywhere, right? So here I have actually shown you the example of all these things with respect to private variable, with respect to public variable and all. And let's say that if I'm creating a private variable, if I'm not able to access it from outside the class, can we access it from methods that are present inside the class? Okay, and that is what we are basically going to do now. Okay, and we're going to learn encapsulation with the help of getter and setter method. So let's go ahead and write encapsulation with getter and setter. Okay. Now, what I'm actually going to do over here is that, first of all, I'm just going to create my class. So let me just go ahead and write class person, and this will be definition init underscore underscore. And here I'm going to basically write self name age. Okay. And here you can see self dot underscore underscore name. So this will basically be my private variable. I will go ahead and initialize it. Private access modifier or variable. Okay. Or variable or variable. Okay, and see, it is very simple. I need to probably not display this anywhere. It should be restricted within the class itself. That is what is my aim, right? Then I have self underscore age, which will be equal to age itself, and here I'm going to probably say that this is also my private variable. Okay, now in order to access this particular variable inside the class, I can definitely do it. And for this, we'll be using something called as getter method for name. Okay, so we'll go ahead and create one function which is called as get underscore name, and here we're going to use the self keyword, and with the help of the self keyword, wherever we use, we should be able to access the underscore name. So here I'm going to return self dot underscore name. Okay, so this is basically my getter method for name, right? So here you can see that I will just be exposing this particular method to the outside world because this is a public method, right? I will not be exposing underscore name. With the help of this particular method, I should be able to get this, right? Now, here is what I will talk about, one very important thing, right? Have you seen a washing machine? So if I'm probably working on a washing machine, in washing machine we'll be able to see buttons, we'll be able to see how to start, we'll be able to see that where we need to put the clothes, right? But internal working is completely hidden, right? And that is what over here, same thing we are doing. The internal things are probably hidden over here. Only the things that matter to us, you know, just like this function name is available for us or visible to us, right? So here you can see that just by calling this particular method get underscore name, I should be able to get the name itself from this particular function. This is called as a getter method. I may also have setter method for name, right? Now this setter method for name, what it does is that this will help us to change any values that I give to the name, which is basically a private variable, right, over here. So this is my private variable. I need to probably change that particular value, let's say. So I can just use self underscore name is equal to name, right? So with the help of getter, we are retrieving the data. With the help of setter, we are changing the name itself, okay? Similarly, let's say that I want it for the age, and I can also do that, you know, and probably use the getter method for that and setter method for that. So first I will create a getter method, okay? And here you can see I'm getting the age, just writing self dot underscore age. And now in the case of setter method, let's say that I want to probably put or change any age, right? So what I do, I first of all check the condition. If age is greater than 0, then only I will go ahead and change it. Otherwise, say age cannot be negative, right? So this is just one example with encapsulation with getter and setter, and we're completely hiding the main variables that we have, right? And we are only exposing this particular function, that is get underscore name and set underscore name. Now let me do one thing. Let me just go ahead and call all these functions, okay? And then you'll be able to understand. First of all, I'll go ahead and create an object. Let's say this will be person, and here I'm going to use Krish. Here I'm going to use 34. Okay. Now you will be able to see here what I'm actually going to do is that access and modify private variables using getter and setter. Okay. This is what we are going to do because obviously we cannot use directly the private variable outside the class, right? So here I'm going to just print person dot get underscore name. So if I want to go ahead and display get underscore name, I should be able to display it. Then if I go ahead and print person dot get underscore age. So I should be able to get that also. And then I will just go ahead and write person dot set underscore age. And here I'm going to basically write 35, right? And then I'm going to print person dot get age again, get underscore age. So I should be able to see the age now. Okay. Yeah. And then I will go ahead and set the age, let's say to -5, so that I get the other error that I have actually written. Now, initially, I'm creating an object, then I'm probably displaying the name, displaying the age. So Krish 34 will be the answer. Then when we set the age, then it will get replaced with 35, and then we can actually see this, right? So Krish 34, then we you can see over here that what we are doing. You are printing, you are setting this age, and then you're printing that particular age, and then when you're setting it to -5, you can see that it is showing age cannot be negative, right? So this is what is all about encapsulation. We have discussed about all the access modifiers like public, private, and public, private, protected. You understood that private variables cannot be accessed outside the class, So that is the reason we create get and set method. Public variables can be accessed much easily. Protected needs to be accessed only from the derived class. But again, in Python, nothing is compulsory. As I showed you when I checked the dir directory of that particular object, right? I should be able to see all the private and public variables, right? And with just with the help of those names, I can directly call it. But it is always a good practice that we should follow whenever we are implementing things. So yes, this was it. In the next video, we are going to discuss about abstraction. Thank you. Take care. Bye bye. Hello, so we are going to continue the discussion with respect to Python, and in this video, we are going to discuss about a new topic which is called as abstraction, which is one of the most important core pillar in OOPS concept. Now, what exactly is abstraction? Abstraction is the concept of hiding the complex implementation detail and showing only the necessary feature of an object. This helps in reducing programming complexity and effort. Let me talk about some good examples so that you'll be able to understand what does exactly abstraction mean. Okay, let's consider one thing, very simple thing. Okay, with respect to abstraction, if I just want to give you a real world example, I hope everybody uses a washing machine, right? And if you're using a washing machine, in washing machine, you will be having all the options to start the washing machine, how much for what timer you have to probably run the washing machine. You have an option to set the timer. Along with that, you'll be seeing that you'll be having a dryer part, where you'll be able to dry the clothes itself, right? And just with the help of a click of button, you will be able to do that specific operation. Now, that buttons that is visible on that washing machine is the thing or is the feature of that particular object that is visible to you. Remaining all the complex implementation, how the washing probably takes place, how that particular, as soon as you probably click start, what is the internal process that is going to happen, that all complex implementation is completely hidden, right? And this is what can be taken as a real world example with respect to abstraction. Not only that, you can also consider an example with respect to mobile phones, AC remote, your laptop, your desktop, you'll be able to see buttons are there. Okay, you'll be able to see, hey, if I go ahead and probably if I go ahead and click on shutdown, automatically how the system is getting shut down. If I open a specific application, how that particular application processor is basically allocated in the processor, in the RAM, how much memory is basically getting allocated. So everything is happening in the backend over there. And there are some kind of complex implementation that is happening in the backend, and that is completely hidden, right? Now, in order to make you understand about abstraction, so let me just go and talk with respect to code. So here I will go ahead and say, hey, from ABC, I'm going to import ABC. So this ABC is nothing but it is for the abstraction. It is just for abstract class, which we specifically use. And let's say if I want to define an abstract method, okay, I will go ahead and define an abstract method. I'll talk about why this method is very much important and all. Okay, so first of all, let us go ahead and define my abstract class. Now, what is this abstract class? Let's say that I go ahead and define my vehicle class over here. Okay, now when I'm defining my vehicle class here, I will be considering it as ABC. And always remember, the difference between a normal class and an abstract class is that here I will be inheriting this ABC class, right? And which is nothing but it is for the abstract class itself, right? Or you can also say abstract base class. Okay, this is nothing but abstract base class. Here you can actually see we are inheriting them. Okay, now let's say inside this particular class I have some definition, and the definition can be anything over here, right? Let's say that I will go ahead and write with respect to vehicle, I will say, hey, I have a function which is called as drive. Okay, and I will go ahead and print and write some information like the car, the vehicle is used for driving. Okay, something like this. I'm just writing some kind of examples over here. Now, this is a normal method. Now, let me go ahead and define an abstract method. Usually, when we go ahead and define an abstract method, this will be a complete empty function. Okay. And the best thing about abstract is that it is created in such a purpose that whenever a child class inherits this vehicle base class, it says that, hey, I am giving you functionality with respect to drive. Okay. And I am giving you one abstract method which you can do the implementation with your own way. Okay. That is what it is basically given. So this abstract method is just like giving you the necessary feature of an object, and it is just hiding the complex implementation detail. Right. So here we are just trying to provide you a way. So let me just go ahead and again repeat this. Okay. Now let's consider that I'm going to probably write an abstract method over here. Now, in order to define an abstract method, we'll go ahead and write definition start engine. Let's say this is my start engine. And I will go ahead and write self over here. And let's say that this is my empty class. Okay. Now in abstraction, what happens is that, as I said, this is my abstract base class, and this is how we create an abstract method, which will be completely empty. Now, if I probably go ahead and create my child class, and let's say the child class is inheriting the vehicle class. Now, before inheriting, always, let's say that if I'm inheriting this abstract base class, which is nothing but vehicle, which is also called as an abstract class, here it says that you can inherit, this car class can basically inherit the vehicle class, but there will be one condition. You will be able to use this particular method, but to use this method, we have to write our own definition, right? That the car will basically be writing its own specific definition over here, okay? So in order to show you over here what I will do, I will just go ahead and write definition, start underscore engine, okay? Start underscore engine. And here we will just go ahead and write the self keyword. And let's say here we go ahead and write car engine started, okay? So car engine started. So here you can actually see that I'm actually able to write the code, right? Now what I'm actually going to do, see, now I'll just go ahead and initialize something, you know, I'll create a function. Let me go ahead and create a function saying that operate vehicle, okay? So this will be my function, and this will basically demonstrate our entire process of abstraction. So I'll go ahead and just operate vehicle, and here I'm going to probably write vehicle, okay? Vehicle dot start underscore engine, so vehicle spelling should be correct. Start underscore engine. So here is my start underscore engine. Now let me define this. This function is created and it is outside the class. Okay. Now let me just go ahead and write car is equal to car. And now let me just go ahead and call this operate vehicle with respect to car. So here you'll be able to see that what has basically happened. Here this start engine is getting displayed. Now you need to understand where does abstraction come into mind, right? Here we are just saying that here there is one functionality. Okay, there is one functionality which is available for you, right? And this is basically defined in the form of an abstract method. And this abstract method, if it is present, if we really need to create an abstract class, we have to inherit this ABC, right? ABC library that we have imported over here. Now, if any child class wants to inherit this particular abstract base class, we have to make sure that we will be able to use this particular function. But along with that, you have to make sure that you have to go ahead and implement this particular function with your own way. And that is what we have actually done over here, right? If I go ahead and also write over here something like this vehicle, let's say if I go ahead and write vehicle dot along with this dot drive. So drive will also be able to access it, right? We'll be able to access it. Now if I go ahead and execute it, you can see the vehicle is used for driving. So the derived class is also able to use this, but with respect to this abstract method, which is where the abstraction is basically getting applied, where we are just showing the features of this particular objects, right? We are just showing this particular method, but the complex implementation can be overridden by all the derived class that is specifically using them, and that's what is basically done over here, right? So this actually gives an example, or it makes you understand about the abstraction method over here with respect to the Python, and how you can actually create an abstract class, how you can basically create an abstract method, and how abstraction is basically implemented over here. But in short, if I really want to discuss, abstraction is the concept of hiding the complex implementation and showing only the necessary features of an object, right? So yes, this was it from my side. I hope you like this particular video. I will see you all in the next video. Thank you. Hello guys, so we are going to continue discussion with respect to Python, and in this video we are going to discuss about magic methods. Now till now we have discussed so many different topics regarding classes, regarding hoops, you know, we have discussed about function overriding, method overriding, we have discussed about encapsulation, abstraction, so many things we have discussed. And where some or the other way you have definitely seen this magic methods. So what exactly it is, we'll go in depth, we'll try to understand it, and we'll see coding examples with respect to this. So magic methods in Python is also known as dunder methods, which is nothing but double underscore methods, right? They are special methods that start and end with double underscore. This methods enable you to define the behavior of the object for built-in operations such as arithmetic operation, comparison, and more. Some of the examples, if I probably go ahead and make you understand, some of the examples are something like this. See, I will just go ahead and write like this. I think you should be able to see it. It is not showing double underscore, but I don't know why. So let's see. Okay, I'll just make these changes and let's see whether we are able to see double underscore. No, it is not double underscore. So let me just go ahead and take this entirely over here. Okay, and I'll take a code. Okay, or use a triple quote. Okay, if I want. First of all, I will go ahead and select a kernel so that you will be able to understand what I'm actually talking about. Some of the examples with respect to this kind of operators are nothing but like this, right? So magic methods are nothing but like underscore underscore init underscore underscore. This basically means you initialize a new instance of a class, right? Basically the constructor. You also have some operators or some methods like underscore underscore str underscore. It returns the string representation of an object, right? And similarly, some of the examples are over here. And if you really want to see this, you will also be able to see this because once I probably create a class, let's say I'm going to create a class person, and inside this I'm just going to write pass. Okay, and now if I go ahead and create an object for this particular person, so here you'll be able to see this class. Okay, now if I go ahead and write directory of person, right, you'll be able to see all this, right? So these are nothing but these are called as magic methods, right? And we can use all these magic methods, and these magic methods are by default used to here it is very clearly written that why it is used to. It is used to define the behavior of an object for built-in operations such as arithmetic, comparison, and many more. Let's say I want to use underscore underscore str. This will just return a string representation of an object, right? So let's say that I want to just go ahead and print the person object. So by default, you'll be seeing that hey, I'm getting this message, and this message is basically getting displayed from this particular function that is nothing but underscore underscore str underscore underscore. And there are something like you can also override the specific method, and that is what I'm actually going to show you over here. Okay. Now let's go ahead and explore some of the basic magic methods, and then we will try to override them also. So let's say that I'm writing definition underscore underscore init underscore underscore, and here I'm going to write self comma name comma age. Okay. Now once I write this, I'm just going to write self dot name is equal to name. Okay. And along with this, I'm just going to say hey self dot age is equal to age. Okay. So we have defined this over here, and I think okay, I did not write the class or what? It got deleted, I guess. So class person. Okay. Person. And then let me just go ahead and press this def, and here I'm just going to press enter. Make sure that you have this indentation. If indentation is not there, then it will be a problem. Okay. Now I've defined this particular person class. Okay. Now let's say that I go ahead and define my person object, and let me just go ahead and write the name over here like Krish, comma age is 34, and I'll just go ahead and print person. Okay. Now when I'm printing person, by default I will be getting this information. Okay. This particular object is created at this particular memory location. Let's say that I want to override this kind of message, so I have to override this underscore underscore str method. So what I will do now, I will just copy the same thing over here. I'll paste it over here, and now I will just go ahead and define another function, another magic function over here, and this will be nothing but str underscore underscore. Here also we'll give self. Okay. And now along with this, what I'm actually going to do, I'm going to return some kind of message. Now I'm overriding the default functionality of this magic method. So here I'm going to basically write return f, and let me just go ahead and write this is nothing but my self dot name. I'll just try to display the self dot name, and along with this self dot name, I'll just go ahead and write comma self dot age years old. Okay, and I will just go ahead and display this years old, and let me just close these brackets over here. Okay, so here you can see that now I have changed the functionality of this magic method that is underscore underscore str, which is responsible in displaying the information regarding the object. Right now, if I go ahead and execute it, now you'll be able to see that this message is getting executed. Before the default message was something like this, right? And obviously, you know over here why underscore underscore str is used. It is used to return a string representation of an object. And now when I'm actually using this, and you can see that I've overridden the functionality and I've written my own way of printing the message, and that is what is basically getting displayed, right? Similarly, you can also use different functionalities. Let's say one more functionality is that is present is nothing but underscore underscore REPR, and this is basically for, I've written it over here. If you go up, right, why it is specifically used underscore underscore, it returns an official string representation of an object, right? So if I go ahead and take this, and now I want to return and write my own string, I can go ahead and write. I can say person. Let's say I will define something like this. Name is equal to self dot name. Okay, self dot name, and here I will go ahead and write age is equal to self dot age. Okay, something like this. I want to display in my own way. Okay, now if I want to call this function also, I can also call it. So I will go ahead and write print REPR. And with respect to that, I will just go ahead and call this particular person over here. If I execute it here, you can see person name is equal to Krish, age is equal to 24. So this is how in my own custom string representation I've displayed it. So matching methods, there are some very important functionalities which will be doing default implementation for objects. If you really want to override it, just write that particular magic method in this particular way and override it based on your comfort and your application. So I hope you like this particular video. This was about the magic methods, and I've also shown you that how you can override to change the behavior of the object. And I've just taken some of the examples. You can take any number of examples, and all the magic methods you'll be able to see over here. And further, you can do Google and probably find a lot of different options like GT, doc, and all. So in the next session also, I'll be discussing about operator overloading. I will be talking more about this magic method over there. Right. So yes, this was it. I will see you all in the next video. Thank you. Hello guys, so we are going to continue the discussion with respect to Python, and in this video we are going to talk about custom exception. Now in this custom exception, I'm probably going to raise and throw an exception. So that is what we will be seeing. So anybody who's probably developing any kind of project will probably develop their own custom exception handler, so that they'll be able to handle different types of custom exceptions that usually happen in your applications, right? So what I'm actually going to do in this particular video, please see to this step by step, right? So let's say that I have a specific form. Okay, now in that form, and let's say that is a kind of exam form, right? A competitive exam form or a government exam form. Now in that exam form, the requirement is that the person age should be between 20 to 30. Let's say if it is below 20, if somebody enters the age below 20 or greater than 30, we should probably raise a custom exception saying that hey, your age does not fall in that bracket for this particular exam, right? So that is what we are probably going to do. Now how to do it? And I was specifically waiting this video till I probably cover classes, and I hope everybody has seen about the exception class, right? Now how do I create my own custom exception class that we are going to see? So first of all, I'll just go ahead and create a class called as let's say I'll create a generic class which is called as error. Okay, and here we are just going to inherit exception. Okay, and let's say I want to probably right now I don't want to use any definition. I'll be using this exception class, whatever by default how it works. We are going to specifically use this, and this will be a generic error custom exception. Okay, that I'm going to use. Now I'll also go ahead and create one more class, and let's say this time I'm going to use a exception class which is called as DOB exception. So this is date of birth exception. Okay, and here specifically we will be inheriting this error class. Okay, and here also I'm just going to give pass because by default what is there in the exception will do that, but we will try to customize our own message with respect to the print statement so that we probably notify the user, hey, you're not giving the valid date of birth, right? So this is what is the classes that I've actually created. Understand I could have directly inherited from exception and done it, but I try to create a generic error. So any classes that I probably create with respect to custom exception should inherit this. Okay. Now what I'm actually going to basically do over here is that I'm going to probably go ahead and create that particular form and see how this exception works. So guys, now let's go ahead and create a variable called as year, right? Now here I will say year, and I'll just convert this into int, and I'll use an input function, and I'll say, hey user, please go ahead and probably enter the date of birth. Okay. So this will basically be my DOB. Okay. And I'm actually converting this into int because by default input will specifically give strings, right? Now what I'm actually going to do is that I'm just going to go ahead and find out the age. Now with respect to age, I'll just go ahead and write over here current age that I have, right? It is nothing but 2024. Current year that I have is 2024. I will just go ahead and subtract with this specific year. Okay. And then further, I will go ahead and give a condition. I'll say, hey, if age is less than or equal to 20, and if age is I should basically write less than or equal to 30, and if age is greater than or equal to 20, then what I should basically say, I should go ahead and write, hey, your print, the age is valid, the age is valid, so you can apply for the exams, right? So here is my default condition. Like this is the condition that should work with respect to the age that we give, right? But let's say if someone gives some other age where your age is greater than 30 or less than 20. So I'll go ahead and write my else condition. And with respect to this else condition, here you know that the age is not falling in this bracket. So what I will do, I will go ahead and raise my DOB exception. So this is how we specifically raise. Now, see, if you're just using this if else clause, right? Raising a DOB exception will be difficult. Why? Because we are not even used try catch block, right? Because when we are raising an exception, we should also catch that exception, and that exception needs to be handled. And that will not be possible right now because we have not used this try catch block. So what I will do, I will just go ahead and write try over here, and let me just take this entire code and press tab, right? So this will basically be there in my new line. Okay, so here you can see. Now, as soon as I raise this DOB exception, I should be catching this, right? So for that, I will go ahead and write except block. Okay, I will go ahead and write except block, and inside this except block, which exception I need to handle? DOB exception, right? And now I will go ahead and say, hey, print, sorry, your age does not follow, or your age is not within the, or I'll say, hey, your age should be greater than 20 or less than 30. Okay, so I'm just going to give this comment over here with respect to the code that I've actually written. Okay, now what I'm actually doing over here, we are raising this DOB exception, and we also need to catch this exception. In normal exception handling, what used to happen whenever an error is basically happening over there, automatically with the help of that default exception class, we were able to catch it. But here we are raising it and we are also catching it, right? Now let us go ahead and see whether it will work fine or not. So let's say that I'm going to write my date of birth as 1987. Okay, I'm just giving an example. I'll press enter. So here you can see, hey, your age should be greater than 20 or less than 30, right? Greater than 20 or less than 30 for your competitive exam. And this is how we specifically raise a custom exception, right? The main thing is that when we will be developing end-to-end application, there we'll be performing exception handling, we'll also performing logging and all. There also will develop our own custom exception, and we'll be seeing similar examples where we customize our message and display to everyone, specifically to the end user, so that they understand about the error. And we really need to see those exceptions that are basically happening. It is not because of our coder, like coding behavior that we are specifically coding, right? It is because of the mistakes that usually happens from the client end side who's specifically using that particular application. So I hope you were able to understand this particular video. I hope you liked it. This was it. I will see you in the next video. Thank you. Hello guys, so we are going to continue discussion with respect to Python, and in this video we are going to discuss about operator overloading. Now in our previous video when we were discussing about magic methods, right? So here you will be also able to see some of the function or methods or magic methods which is called as underscore underscore equal underscore underscore. This is nothing but this is a default, you can basically say this is a default method for any comparison or operation, right? It's like when we say, hey, if you really want to do any comparison operation, we usually use double equal to, right? So if I want to override that particular functionality, then I have to override this particular function. Let's say I also use a lot of different operations like 1 plus 1, 2, right? So 1 is an addition operation. Now how do I probably take this plus and override this particular operation? I will be showing you that. If I'm doing 1 minus 1, so this is a subtraction operation, how we can actually override this. So that is what we are basically going to do. And along with this, we know that, okay, I also have this kind of condition, 12 is greater than 6, right? So white is giving us true. So this is nothing but this is greater than or equal to. Can we override this particular operator also? That we will be seeing, and that is what we are going to see in this particular video, how we can perform operator overloading. Some of the best example over here is that you have this underscore underscore add underscore underscore. This nothing, it does, but it adds two objects using the plus operator. Similarly, you have for subtraction, you have for multiplication, you have for true div. This is for the division operation. Then you have equal sign, compare if two objects are equal using the double equal to operator. And similarly, you have less than. You also have greater than, which you can basically use underscore underscore gt underscore underscore, right? So that is what I'm actually going to show you each and everything over here. So underscore underscore, you can basically write it over here. So let's say if I go ahead and write underscore underscore gt, this is for the greater than. If you want to override that particular functionality. Now let me just show you over here, and we will try to overload some of the operations with respect to addition, subtraction, and all. Okay. So first of all, I'm going to define my class, which is called as vector. So this is my I will just go ahead and define my class, which is nothing but vector. Now inside this vector, I will be writing my init function. So here you basically have init function, and with respect to init function, let's say I'm going to create two variables x comma y. Now if I go ahead and write self.x is equal to x, and here I'm going to write self.y is equal to y. Okay. Now I'm going to just go ahead and add my add function over here. So let me just go ahead and use this definition add underscore underscore, and here I have to probably give two parameters, self comma other, right? So here what I'm doing, I'm just giving one more additional parameter. Now what I'm actually going to do over here is that in this addition operation, I will just change this entire operation itself. So I'll say, hey, go ahead and return, okay, vector class over here, and inside this vector class we'll give self.x, okay, plus other.x, okay. I'm just putting some kind of operation, okay. I'm doing some kind of operation over here. Self.x, okay, not z x plus other.x, and here what I'm actually going to do again, I'll go ahead and write self.y plus other.y. That basically means what I'm actually going to do. This other will be another vector itself, which will have x and y coordinate, and I'm just summing it up with the x that I'm actually giving, and along with the y coordinate that I'm actually giving, right? So I'm just going to sum it up with respect to this particular other, right? Similarly, what I will do the same thing for let's say subtraction, for multiplication, and all. So here I will go ahead and define my other function, and here you can see I'm doing subtracting over here, I'm doing subtracting over here, right? Other will be another vector, okay? We'll see to it once we probably initialize and call the function. Now along with this, what I'm actually going to do is that I'm also going to make sure to change my equal to functionality, okay? I'm going to overload this particular operator itself. So here with respect to equal to, I'm saying return self.x double equal to other.x and self.y double equal to other.y. It will be either true or false, okay, based on the comparison that is basically happening. And finally, to represent this entire string, we'll be using underscore underscore repr, and here I'm just displaying the vector with self.x and self.y, okay? Just a simple operation, and just to show you that how I'm overriding each and everything. So finally, we go ahead and create objects of the vector class, okay? And here we are just going to write v1 is equal to vector 2 comma 3, okay? And then I will be going to create my vector v2, and this will be nothing but 4 comma 5, okay? Now this is my v1 and v2 vector. Now let's see, okay, what kind of operation will basically happen. If I go ahead and write print v1 plus v2, we have already, you can see that I've already changed this plus underscore add operation, right? So if I go ahead and print it, so what is the output that I'm actually getting? See, v1 is nothing but, so here you can see that I'm adding both this, right? 2 plus 4, 6, 3 plus 5, right? So that is what I'm printing it with respect to the addition operation. So that is what is basically happening, self.x, other.x. So in short, I have modified this entire functionality for the addition of vectors. That is the main purpose over here, okay? Please make sure, that is the reason I had written initially all the code. This is nothing but, I'm doing mathematical operation for vectors, which is not available right now. So I have defined my own custom one. Here what we have done, here this is one coordinate x comma y, and this is the other coordinate x comma y, right? And when we do add operation, this is going to get considered, v2 is going to get considered as the other option, right? Then I'm going to take this as x and y coordinate, and this will be my other x and y coordinate. And this is what we are getting over here, and we'll be able to add those vectors, right? So next, I'll go ahead and write v1 minus v2. Similarly, print v1 multiplied by 3, okay? So if I go ahead and execute it, first of all, v1 minus v2, what it is going to do? Self.x multiplied by other, so sorry, this is multiplication. So self.x minus other.x, so we are just going to subtract it. 2 minus 4 is 2, and 3 minus 5 is minus 2. Sorry, 2 minus 4 is minus 2, and 3 minus 5 is minus 2. And here you'll be able to see that with respect to multiplication operation, I am just multiplying with this particular number, v1 multiplied by 3, so I have x and y coordinate, so x multiplied by other number over here 3, and y multiplied by 3, it is nothing but 6 comma 9, right? So this is how you can entirely overload all the operators based on your assumption. You can take up different operators and definitely make sure that you try to convert them based on your vectors or based on your requirements that you like. I'll also give you one more example which you can do it as your assignment. That is nothing but overloading operators for complex numbers. You can just go ahead and explore this particular code. Now it's time that you have to give some amount of time, and here we have also used TrueDiff and see what all things we are basically doing. If I talk about complex number, there will be an imaginary number, so there will be a real number, it will be an imaginary number, and based on that we have written this code. So just go ahead and explore this, and let me know whether you're able to understand or not. So finally, I would like to add some conclusion saying that magic methods and operator overloading are some amazing powerful feature in Python, allowing you to completely customize the operator functionalities itself based on your application development that you really want, right? So yes, this was it from my side. I hope you like this particular video. I will see you on the next video. Thank you. Take care. Hello guys, so we are going to continue the discussion with respect to Python, and now in this video we are going to discuss about a new concept which is called as iterators. Now what are iterators? Iterators are advanced Python concept that allows for efficient looping and memory management. Iterators provide a way to access elements of a collection sequentially without exposing the underlying structure. Now please understand this particular sentence. Again, obviously I'll be showing you multiple examples to probably give an idea like how does an iterator basically work. Now let me do one thing. Let me just go ahead and create my list. Okay, so let's say that I have a specific element over here, which is my list. I will just go ahead and write my underscore list, and let's say I have elements like 1, 2, 3, 4, 5, 6. Okay, now if I want to iterate through this particular list, right? If I want to probably go ahead see each and every element, what I can actually do, I will write for loop for I in my underscore list. Okay, and I will just go ahead and print I. Okay, so this is done. So here I'll be able to see 1, 2, 3, 4, 5, 6. Okay, and if I also go ahead and display the type of list, it is nothing but it just shows me that hey, this is nothing but this is my a list type. Okay, and if I go ahead and just print all the list over here, or if I just go ahead and print my underscore list, you'll be able to see I'm able to see all the elements inside this particular list. Okay, now let's talk about how we can create an iterator. Okay, so iterator, we will be using an iter keyword. Now when we use this iter keyword, and inside this, if I am giving my list, okay, so this actually becomes an iterator. Okay, and why I'm saying this, and let's go ahead and print the type of iterator. Here you'll be able to see that I will be able to see that if I go ahead and print the type of iterator, it is nothing but it is showing me it is a class of list underscore iterator. So this is like a list underscore iterator class. Okay, now I hope everybody's clear with this. Okay, now over here it says that iterators are advanced Python concepts that allow for efficient looping and memory management. Now when I displayed this list directly, which is a collection, I could see all the elements over here. But in this case, for the same my list, when I converted into an iterator, I'm not able to see all the elements. Why? Because I'll just go ahead and write over here iterator, and let's go ahead and see. It says that hey, it is a list underscore iterator at this particular memory location. So that basically means internally I'm not able to see the my underscore list elements, right? I hope everybody's clear with respect to this. Now here it uses lazy loading technique. That basically means right now my list underscore iterator is created in some memory location. It will not give us any elements unless and until we iterate through that particular element. Now in order to iterate through all the elements, we will use another function which is called as next. And here, if I go ahead and write iterator, as soon as I probably go ahead and hit next of iterator, then what is the first element in this underscore list that will get displayed, right? So if I go ahead and execute it, here you can see 1 it is coming, right? So now by lazy loading, just one value has got, basically we are accessing the one value over here, and it is being able to display it over here, right? So that is the reason it is showing 1. Now let me just go ahead and execute it again. Now it goes to the next element, see, 2 is getting displayed. Then if I go ahead and execute again, it shows 3, then 4, then 5, then 6. Now we have come to the last element over here, right, with respect to iterate. And we're just using this next function over here, right? Now if I go ahead and hit it, since this is the last element, you will be able to see that I will get an error saying that, hey, stop iteration, because there are no elements inside this particular list, okay? So this is how we iterate through an iterator with the help of next function, okay? And this next function, by lazy loading technique, it will generate the memory over there, and by this, you'll be able to see efficient looping and memory management will basically happen, okay? Now let me do one thing. Let me just go ahead and copy this, okay? I will just go ahead and copy this. Now, in order to handle this exception, I'll just go ahead and write try catch block. Now let me go ahead and write next of iterator, okay? And here, I will just go ahead and write except. And here, what kind of exception I'll handle? I'll handle this exception. Okay, now I'll go ahead and print saying that, hey, the elements, they are, or I'll just go ahead and write, there are no elements in the iterator, okay? Now here you can see how efficiently we'll be able to loop through. And this time, first time when we execute this, okay, or let me just execute this in my another cell so that we need to initialize once. Now see this, we will go ahead and execute this. So first time it will, okay, I did not do the print over here. So let's go ahead and do the print. Now just imagine which number will get displayed. I know 2 will get displayed because one time I've actually executed. So now let's go display 2, then 3, then 4, then 5, then 6. When it comes to the last element, now it is going to throw an exception. As that exception with the help of stop iteration, and here it is going to display this particular sentence, and this indicates that we have iterated through all the iterators, right? So I hope you have got or you have understood this particular example. Now similarly you can also do this same thing with the help of string, and here I'll just show you an example with respect to string iterator. This is my string. I'm using the iter function over here, and we are just displaying this particular string, right? So here you'll be able to see he is the first 2 characters inside this particular string, and we are able to display it, right? So why we are using this, it is very much simple. It is for efficient looping and memory management. So I hope you are able to understand this, because these are some of the amazing and advanced concepts in Python. Now in our next video we'll be discussing about generator. So thank you. I will see you all in the next video. Hello guys, so we are going to continue our discussion with respect to Python, and in this video we're going to talk about generators. Already we have discussed about iterator. One very important thing about generator is that it is a subclass of iterator itself, okay? And it is like generator are a simple way to create iterators. They use the yield keyword to produce a series of values lazily, which means they can generate value on the fly and do not store them in the memory. And that is how efficient memory management and looping basically happens, okay? Now, in order to show you one good example that how with the help of generator we are able to create iterator, we'll be discussing over here. And I'll just take a very simple example. Let me just go ahead and create a function. Let's say square. Okay, so square is the function over here. I'll give my n keyword, okay? Or let's say this n value will be there. And what I will do, let's say if I'm giving n is equal to 3, right? So I will go ahead and write for I in range of 3, okay? I in range of 3. And now what I will be doing is that I will just go ahead and say, hey, let's return I to the times 2. So we are basically squaring that particular number. But what is basically happening over here? Right now, we are iterating through a collection, and we are returning only one square, right? So if I go ahead and execute this, okay? Now just see this, okay? If I just go ahead and execute this, and if I just call square of 3, so what output I'm actually going to get? 0. Why? Because it iterates through all the elements over here, but the first element is 0, but it is returning 0 multiplied, like 0 to the times of 2, right? And obviously I'm just going to get the answer as 0. But what I want is that I want to iterate through all the elements as we iterate in the iterator itself. So in generator, when we are creating this kind of iterators, we use an yield keyword, okay? Now with the help of this yield keyword, what will happen? This yield keyword will create a local variable and will save the values also. Now if I go ahead and execute square of 3, right? Now see this, okay? If I just go ahead and execute this just by using this yield keyword, and I'm just going and executing the square of 3, it shows it is a generator object square at this specific memory location. Now this has actually got converted into a generator object, and generators are nothing but a simple way to create iterators, and here we are also using functions, okay? Now in order to iterate through this particular elements, what I can actually do, I can go ahead and write for I in square of 3. Let's say if I go ahead and write for I in square of 3, and here if I go ahead and print I, now see the magic, okay? Now what will happen if I run this iteration? Okay, so for let's say that here I will go ahead and write for I in square of 3. Now square of 3 it will go over here. Then over here for I in range of 3 it will become. Then it will yield. Yield basically means 0 to the power of 2. Now this yield it will save this first operation, and it will return the value over here, and it will print it. Okay. Then again it will go inside the square. It will go to the next value, that is 1. Again it will go ahead and do this particular operation. And whenever we say yield, it is going to save that particular value, and it is also going to return it. Okay. And as soon as it is getting returned over here, we are also going to print it. Okay. So now if I go ahead and execute this, see the magic. Over here I'm getting 0, 1, and 4. Right. So I hope you're able to understand the very importance of this yield keyword. This yield keyword is specifically it produces a series of values lazily. which means they can generate values on the fly and do not store them in the memory. They're just storing it over here and they're just displaying it and they're just passing it from the main function where it is called or from the main code where it is called, right? So this clearly shows that how you are able to access it. Okay, let's say that I will just go ahead and write like this. So this is one way of probably calling this all the iterator elements. The other way is that if I go ahead and create the square of 3 and let's say I go ahead and store this particular variable in a. If I go ahead and execute, this becomes a generator object over here, right? Now in order to iterate through this, I can again write next of a, right? If I go ahead and write next of a, the first element is 0. See, then again if I go ahead and hit next of a, the second element is 1, and then again if I hit, it is nothing but 4, and that is what I got over here, 0 1 4. And finally if I again hit, there are no elements, so I'm going to get the stop iteration error. So in short, what has happened is that we have used generator and we have also converted or we have created iterators with the help of this particular function. Here I've also shown you an importance of this particular yield keyword. Yield keywords, whatever operation I'm actually doing it over here, it is also returning the value where I'm actually calling it from. Okay, this is the main importance of the yield keyword. Okay, let me just go ahead and show you one more example. Let's say that I'm going to go ahead and create my another function. Let's say I'll go ahead and write my generator. Okay, and here we are going to write yield of 1. Okay, so let's say that I'm for the first time I'm returning yield of 1, then I will go ahead and write yield of 2, then I will have yield of 3. Now this is the most amazing thing about generators is that we can return multiple values also, like return multiple yield values also. Okay, now let me just go ahead and execute it. Okay, and if I go ahead and create or if I just call this particular my generator over here. Okay, so if I go ahead and just print this, what is this generator? It is nothing but it is a generator object at this specific memory location. Now in order to iterate through this, what I can do, I can go ahead and write next of gen. So next of gen, first of all, what is the first yield? Here you can see yield 1, right? Then the next yield is 2, then the next yield is 3. Then again if I go ahead and execute, again it is stop iteration. Now let me just go ahead and execute again this one. And now what I will do, I will just go ahead and show you with the help of for loop also. I'll go ahead and write for val in gen. Okay, gen. And now if I go ahead and print the value, now because of this yield, first time it is going to display 1, then 2, then 3. See, 1, 2, 3, right? So here you can see that this yield 1, this one will be getting saved over here. It will just return it from where I'm actually calling using the next gen. And during the fly, all the values are getting generated. But my entire object is basically created in this particular memory location. And one by one, we can iterate through all the elements through this particular yield keyword, right? So I hope you are able to understand this amazing thing. Okay. Now let me just show you one practical example of using generator. Okay. So generator, one very good example that I would like to give, one practical example, that is reading large files. Okay. So let me just go ahead and provide some definition over here. Okay, let me just go ahead and make some markdown so that you will also be able to understand it. Okay, so let me just quickly write it down over here. So here you can see some of the practical example, and we'll try to implement this. Generator are particularly useful for reading large file because they allow you to process one line at a time without loading the entire file into the memory. If you have a large file, you can specifically use generator and load chunks from that particular file itself, display it without loading into the entire memory, right? And this is the most amazing thing. So let me do and go ahead and create one function. So here I will write definition read underscore large underscore file. Okay, and here I'm actually going to give my file path. So let's say that this is my file path. Now I will go ahead and use with open. And let's say I'm going to use file underscore path in the read mode. Okay, whatever file path is there in the read mode. After opening this, I'll create a file object. Okay, and then let me just go ahead and say for every line in file, we are just going to yield. I'm writing yield line. So what it is going to do, it will just take a line, it will display it over here, or it will just return it from where I'm actually calling. Okay, so let me just go ahead and create one of the file over here. So let's say this is my large underscore file dot text. Okay, and what I will do is that I will just go ahead and probably take a big article and paste it over here. I'll just search for President of India. So I'm doing a Google search in my separate browser. Okay, and I'll just paste it over here. Some text I will try to paste it so that it becomes a large file. Okay, so just give me a second. Okay, so I'm just going to paste some information over here. Okay. So this is the information about the President of India, that is Srimati Draupadi Murmu. So I'm just going to save this, okay? And now I'm going to read this particular file. So let me just go ahead and execute this. So this basically becomes my iterator over here. This entire function is now my iterator, okay? Now let me just call this. So I'm going to go ahead and write file underscore path is equal to large underscore file dot txt, which I've actually created it over there. And then I'll go say for line in read large file, and here I'm going to give my file path, okay? I'm going to give my file path, and here I'll just go ahead and say print line dot strip. Now you know that over here I've used the yield, right? So as soon as it will read one line, it is going to probably display it over here. Now here you can see how quickly we are able to execute it. And understand this entire thing has been done with the help of a generator. And the best thing is that I have not even saved the entire file into the memory. And this is what is basically getting displayed, right? So I hope you are able to understand all these amazing things, right? And this is something, a really advanced concept in generators that we specifically use. Now, just to talk about the differences between iterator and generator. First of all, iterator, you have to use iter keyword. Generator, you have to use along with the function, you have to use yield keyword, right? Generator, in short, uses the yield keyword. It saves the local variable. So it saves the variable one by one and it just returns to wherever we are specifically calling. Generator in Python helps us to write fast and compact code. Python iterator is much more efficient when compared to the generators. Okay. So I hope you were able to understand about generators, guys. This was the basic difference between iterators and generators. And yes, this was it from my side. I will see you on the next video. Thank you. Take care. Hello guys, so we are going to continue the discussion with respect to Python, and in this video we are going to talk about an advanced concept in Python which is called as decorators. First of all, we'll go ahead and understand or see the definition of decorators, and then before understanding decorators, we also need to understand about two important topics that is called as function copy and closures. So once we probably understand this, then we will be able to understand very much easily with respect to the decorators that we are discussing in this topic. Now, before I go ahead, first of all, let us go ahead and check out the definition. So decorators are powerful and flexible feature in Python that allows you to modify the behavior of a function or class method. They are commonly used to add functionality to functions or methods without modifying the actual code. This lesson covers the basics of decorator and including how to create and use them. Okay, so this is a basic definition. You have to probably observe these keywords. They are commonly used to add functionalities to functions or methods without modifying their actual code. Okay, so first of all, we will go ahead and discuss about function copy, then we'll go ahead and discuss about closures, and then we'll get a complete understanding about decorators. Now, first, let's go ahead and discuss about function copy. Let's say that, hey, I am going to create a function which is called as welcome, and here I'm just going to say, hey, let's go ahead and return. Okay, let's say welcome to the advanced Python course. Okay, advanced Python course. I'm just going to define this. Okay, now if I go ahead and call this welcome class, welcome method, sorry, I will be able to get this message. Now, what does function copy basically mean? Let's say that I go ahead and create a variable, and I will go ahead and assign this particular welcome method over here. Now, if I go ahead and execute well, okay, so it shows that hey, it is a function, and here I have actually done a copy of this particular function over here. And can I run the same function over here with this? If I use the braces, you'll be able to see that I will be able to get my entire code. Welcome to the advanced Python course. So in short, function copy basically means I can copy one function to the other function. And here I will also show you something. I will just go ahead and delete the above welcome method. Okay, so let me just go ahead and delete this. Now, if you are deleting it, you'll be able to see that once I probably go ahead and delete it, this function will get deleted. Okay, I don't have to use even parentheses for this. And then, even though I delete it, will I be having this welcome or this well variable or well function that I've actually created by copying it? Will it work same or not? Okay, so if I go ahead and execute it, here you'll be able to see that I'm able to get the code that is welcome to the advanced Python course. So let me just go ahead and print this also. Okay, and let me just go ahead and print this also. And two times I should be able to print it, even though I delete it. Okay, so first of all, I'm just going to create the welcome class again, a welcome method again. Now let me do this where I have saved where I've done the copy of this particular function into this particular variable. Well, and now this becomes a function, so I'm printing it. Then I'm deleting the welcome method which I had actually created initially. Then I'm trying to print it. Whether it will be there or not, we'll try to see. So both the times you're able to see that hey, welcome to the advanced Python course is basically getting visible. So in the case of function copy, you can copy one function to the other function, and after that, with respect to the reference function or the function that you have over here, if you're deleting it also, then also you'll be able to see that that variable will have a new function altogether, right? Or whatever function I've actually created. So this is one example with respect to the function copy. Okay. Now let me just talk about one very important topic, which is basically called as closures. Okay. Now, what are exactly closures? Closures are nothing but if you have probably seen other programming languages like C#. I have also worked in C#. I've worked in Java. So there, closures basically means a function inside a function. Okay. So let's say that I will go ahead and create one function over here. Okay. So let's say I'll go ahead and write definition main underscore welcome, and here I'm going to give some kind of message. Okay. Let's say I'm giving some message. Okay. And let me do like this. I'll not give message over here. I'll just say message over here as and I'll assign it to welcome. Okay. Now, as I said, closures is not about it's like a function can have another function within them. Okay. So I will just go ahead and define a sub welcome method. Okay. So I'll just go ahead and define the sub welcome method, and this time let's go inside this particular method and print some message. So I will say, hey, welcome to the advanced Python course. Okay, advanced Python course, and here I will just use some quotes over here. Welcome to the advanced Python course. Okay, perfect. So till here we are very much good to go. So I've just written a print statement. Now let me just go ahead and again write another print statement over here, and I'll say, hey, please learn these concepts properly. Okay, so this is my message that I'm actually displaying. Okay, and then this will be my sub method. Now what I will do is that for the parent method over here, which I have like main welcome, I will just go ahead and write return nothing but sub welcome method. Okay, so I'm basically returning this particular method, the sub method that we have basically defined. Okay, now if I just go ahead and call this main underscore welcome, and if I execute it, so here you can see main underscore welcome is not defined. Why? Let's see, main underscore welcome, sub underscore welcome. So let me just go ahead and execute it. I've not executed that. Now if I go ahead and execute it, here you can see that once I execute this particular method, I will be able to get the sub welcome, because see, I'm returning the sub welcome method over here. So this in turn will get printed, right? So that is the reason you'll be able to see that welcome to the advanced Python course is getting displayed, and please learn this concept properly is also getting displayed. Now this is fine, right? Now here what I've done is that I've created a main method. Inside that there is a sub method, and the return type of this particular main method is nothing but this particular method. So when this method is called, you'll be able to see that this variable will be initialized, and when we are trying to return this, it will go inside this particular method and it will display all these results. So that is how in a closure function, this is how the process with respect to the execution actually happens. But let me add some more very important things over here. Now you can see that I have created this message variable, right? And you know that this is a local variable for the main underscore welcome. But now the question rises, can I access this particular variable inside the sub welcome method, right? So in closure functions, whenever I have a closure functions, I can actually use this message variable also, which is defined inside the main method itself, right? Main underscore welcome method itself. So if I just go ahead and write print message, you'll be able to see that. Now if I go ahead and execute it, I will be able to see that, okay, this welcome is probably getting displayed. So this means in a closure method, in a closure functions, anything that is defined outside the sub method, right? You can also access that within the sub method. Okay. Not only that, let's say that I will just go ahead and remove this. Okay. And here I will go ahead and write my message. Okay. During the runtime. And now what I will do is that here I will say, hey, welcome everyone. So this will basically be my method. And if I go ahead and call it, it takes 0. Okay, I did not execute it. So let me just go ahead and execute it. Now if I go ahead and execute it, here you can see welcome to the advanced Python course. Then welcome everyone. So this print message is basically happening, and you are able to see it over here, right? So I hope you're getting an idea with respect to closures. And this is what closures are all about. You know, so closure is nothing but a method within a method. And here you can also see that whatever local variable I'm creating inside the main method, I will also be able to access this. And remember, the return type is usually the sub method that we have actually created over here. Okay. Now this is fine. Till here everything is probably working. Now let me do one thing. Okay. Let me make some changes with respect to this closure function. So I will just copy this entire thing. I will paste it over here. Now instead of just giving function, I will try to give a function. Sorry, instead of just giving a message, I will just try to give a function, right? And this function, it will be an inbuilt function, let's say. Okay. And with respect to the function, what I will do is that I will just call, or I will just print whatever things are basically coming in this particular function. Let's say I will just go ahead and call this function over here. Okay. Now let's go ahead and execute this. Now this value that I'm actually giving is a function. Okay. Now if I go ahead and call main underscore welcome, and let's say I have an inbuilt function which is called as print. Okay. Let's say that I have an inbuilt function which is basically called as print. Okay. Now if I go ahead and execute this, here you'll be able to see welcome to the advanced Python course is getting printed. Please learn this concept is also getting printed. But here nothing is getting printed, right? But this print is an inbuilt function itself which will be printing anything, right? So here inside this function, I will pass some parameters. I'll say welcome everyone to this tutorial. Okay. Now see, if I go ahead and execute this, what will happen? So I will go ahead and execute over here, and here also I'll go ahead and execute. Now what is basically happening? This function is nothing but it is a print method, right? Now this print is basically getting replaced over here, and you know that if I'm using an inbuilt function called as print, I can basically get the print will get replaced over here. In short, we are writing this entire message over here that is nothing but welcome to everyone to this particular tutorial, right? Not only this, you can again use different functions that you want. Let's say that I want to use some inbuilt function called as length. Okay. Now I will just go ahead and print length. Okay. So let's say I will go ahead and write print this specific function over here. Okay. This specific function over here. Now I'll just go ahead and execute it, right? Now see the magic. Okay. See the magic with respect to this. And here I'm just going to go ahead and write main underscore welcome. And along with this, I will provide a function keyword that is length. And here let me just go ahead and define 1, 2, 3, 4, 5, 6. Okay. And let me just execute it. So here you will be able to see that I'm getting an error in this, right? Int object is not callable. So what I have actually given over here, we'll check to this. Okay. We will probably go ahead and see what kind of error is specifically coming over here. Okay. So length of 1, 2, 3, 4. Okay. 1, 2, 3, 4. So let's execute this particular code separately. Okay. And let's see whether this will get executed or not. So if I am executing this, did I not close the brackets over here? So this bracket is also closed. This is also there. Okay. So if I go ahead and execute this, here I'm able to get the value of 6. Now the same length function is probably going over here. Instead of just giving the values over here, let me do one thing. Okay. I understood the check what is basically happening. Here we will go ahead and initialize the list. Let's say the second parameter that I'm actually going to give is my list 1, 2, 3, 4, 5. Okay, and let me just go ahead and write this list of elements over here, LST. Okay, so let's say this is my second parameter. Now, if I go ahead and write LST over here, right, this is what I really want to do. I want to probably calculate the length of the specific list, right? Now see whether I'll be able to get the answer or not, right? So here you can say main welcome takes one positional argument or two are given. Okay, I did not execute this. Let's execute this particular method. Now if I go ahead and execute it, you can see welcome to the advanced Python course. 5 is getting printed. Why? Because this function of list is nothing but we're just trying to calculate the length of list, right? And this is how you're able to get the value over here, right? So this is the most important thing about closures. You can probably define methods. You can probably pass method inside a method. You can pass parameter as a method, and you can probably use multiple things, right? Now let's talk about decorators. If you have understood about closures and all, now it's time that we get an idea about decorators. Okay, and decorators will be something amazing which you will definitely be able to understand. Okay, so let's do one thing. Let's go ahead and probably start creating a decorator. Okay, first of all, I'll just try to create a decorator completely manual. Okay, so I'll go ahead and write, or let me just go ahead and do one thing. Let me copy this entire code. Okay, so instead of writing like this, I'll just call this function, right? Now in this case, you'll be able to see, and I hope you have heard about decorators in Flask, Django. There's also a lot of decorators is basically used. Okay, so this is what is my entire function. Let's say. Okay, now I will go ahead and create my another custom method. Okay, so let's say I will say course underscore introduction. Okay, and let's say I'm giving some kind of message over here. Print. This is an advanced Python course. Okay, advanced Python course. Now if I go ahead and probably call this method, then what will happen? I'll be able to get this message. Okay, if I call this particular method and I give the parameter inside this as course introduction, then what I'll be getting, so this function is going to just call whatever function I'm giving it over here, and this is going to get printed, and that is what we are actually getting it, right? Now my main scenario is that without calling this function, can I make sure that I display all these messages? And that is where decorators is used. Okay, now see the magic, everyone. This will be the most amazing thing. So in order to create a decorator, I will be using an @ symbol over here. I will call my course underscore introduction, but along with this @ I will just call this main underscore welcome class method. Now as soon as I do this, okay, as soon as I specifically do this, okay, and let me just go ahead and write my entire definition of my course introduction, which is my method. Now see what will happen. This main underscore welcome, you know what it is? It is nothing but it is a separate method, right? Which is taking a function as a parameter inside this, and inside this there may be some method which may be calling this particular function. Now as soon as I wrote this as a decorator keyword @ main underscore welcome, and I am defining this entire function, that basically means this function is going to get called inside this directly, and you will be able to see the output that I am displaying. Welcome to the advanced Python course. This is an advanced Python course. Please learn these concepts properly. What does this basically mean? Whenever we write this as a decorator, that basically means this particular method is going inside this as a parameter, and whatever operations are there inside, we are just doing it, right? I hope you are able to understand this. Now let's go back to the definition. It says that they're commonly used to add functionalities to function or method without modifying the actual code. So here we are not modifying any of the code of main underscore welcome. It is completely generic. It is taking a function over there and it is doing some kind of operation. I'm just adding this as a decorator on top of a function. That basically means this particular function will be gone as a parameter to that, and it will be displaying this wherever we are calling that specific function inside that particular main method itself, right? So I hope you are able to understand this, and I hope you are able to get a complete idea about decorators itself. Okay. Now similarly, you can do multiple things with respect to this. You can try multiple like you can create different types of decorators, but always understand the main thing is that you need to use this @ keyword, right, for creating that particular decorator. Okay. Let's see some more simple methods. I will show you multiple examples over here. Okay, and then we will go ahead and understand more about this particular decorator. Okay, so this will be my second example with respect to decorator. Okay, so let's consider that I have a closure over here. So I have a closure. So here you can see my decorator with some function. I've defined a wrapper class. I'm saying print something. Something is happening before the function is called. Then there is a function that is getting called. Then print something is happening after the function is called. And we are just returning the wrapper. We are returning this sub method, right? Now let me do one thing. Let me just go ahead and execute this code. Okay, so here we have just executed it. Okay, so my decorator is there. Now I will be using this @ my decorator. Now if I really want to give my method, okay, my @ decorator, okay, if I really want to use this, and let's say I go ahead and create a function which is called as say underscore hello, and I want to print something, right? So here we will go ahead and print hello, right? So here I'm printing hello. So once I probably just execute this, right, and now you'll be able to see that once I just say hey, or once I probably call this particular method that is say underscore hello, you'll be able to see that I'm able to get this, right? So here you can see that as soon as I call say hello, so automatically based on this particular decorator, for this decorator, this particular function is passed and it is getting printed everywhere, right? All the things are basically getting printed. Now let's try one more thing. Here I'm going to basically try something like decorators with arguments. Okay, so let's go ahead and try decorators with arguments, and let's take one more example. Okay, so first of all, please observe this particular code. Okay, so here I have definition repeat. I'm giving an n value. Here I have another function. Okay, and inside this I have another function. Okay, and here I'm giving star args and star kwrgs. This is nothing but positional and keyword arguments. Then I'm saying for underscore I in range, for underscore in range of n, and I'm just calling that particular function, whatever function I'm actually going to provide it over here with respect to this arguments and kwrgs. And for this particular function, right, I have to probably return this with wrapper. So whatever wrapper is over here, and for this particular function, you'll be able to see. Sorry, for this function that is decorator, I'm returning wrapper, which is my sub function, and for this function, we are just returning decorator, which is this particular function. Now, and here you can see that I'm giving arguments, right? Now I will go ahead and just call repeat, @ repeat, and let's say I'm giving 3 value over here, and let's say I go ahead and write definition say underscore hello, and this is my method that I'm actually going to call, and let me just go ahead and write print hello. Okay, so once I execute this over here, now let's go ahead and just call this say underscore hello. So once I call this, what is basically going to happen over here? Very simple. This repeat will take this 3 parameter. Along with that, it will take this function in the decorator itself, wherever we are calling the function, and then inside this wrapper, it is just going to display this arguments with respect to the keyword argument and positional argument. So if you probably see 3 times, it is just going to print hello, right? Because 3 is the repeated number with respect to n. So for I in range of 0, 3, first time it is going to call this particular function which is nothing but print hello, and print hello. So if I go ahead and execute it, here you'll be able to see that I'm able to see the output. Okay, so this is something really amazing with respect to decorators, right? Now if I probably say, right, decorator is something very advanced things. You can specifically use this for multiple purposes, and as we go ahead, we'll be seeing multiple examples when we discuss in different projects, right? So I hope you are able to understand this video. Finally, I would like to write some kind of conclusions over here. So decorators are powerful tool in Python for extending and modifying the behavior of functional methods, and you can read it over here just for your notes purpose, right? So I hope you are able to understand it. I hope I was able to probably discuss all the topics to make you understand about decorators. So yes, this was it from my side. I will see you on the next video. Thank you. Hello, guys. So we are going to continue the discussion with respect to Python, and in this video, we're going to discuss about a very important library which is called as NumPy. So till now, you can actually see we have covered till advanced Python concepts, where we discussed about iterator, generator, and decorators. Now we're moving to a new module which is called as data analysis with Python. So here we're going to focus on some of the libraries like NumPy, Pandas, some visualization libraries like Matplotlib, Seaborn, which are fundamentally used for data analysis. And out of all this particular library, NumPy is super important because even in deep learning modules also we will be using NumPy some or the other way. NumPy is like with the help of the library of NumPy, you will be able to see that we'll be able to create arrays, we'll be able to work with matrices, and all this operation that we specifically do, like mathematical operations. It'll be very, very fast. Okay. So in this video, we're going to discuss about NumPy, how to probably create arrays, how to work with arrays, how to work with matrices with the help of NumPy itself. So first of all, as usual, we will go ahead with the definition. So here you can see NumPy is a fundamental library for scientific computing in Python. It provides support for arrays, matrices, along with a collection of mathematical functions to operate on this data structures. In this lesson, we'll cover the basics of NumPy, focusing on arrays and vectorized operations. So first thing, whenever you create an environment, specific new environment, NumPy is not by default installed. So there are two ways how to probably install it. First of all, go to requirement.txt, go ahead and update NumPy, and just go ahead and in your terminal, you just need to go ahead and write pip install -r requirement.txt, which I've already shown you. One more way is that directly in the Jupyter Notebook file itself, you can just go ahead and write pip install. Okay, so let's say I will just go ahead and write pip install NumPy. And when I write this, you'll be able to see the installation will happen. And already, since I'm using the same virtual environment, so here it shows that requirement is already satisfied. So when we go ahead with the further sessions, so like wherever there is a library that is required, we will be installing either in this way or directly updating the requirement.txt. So this is the first step. Now, as I said, what exactly is NumPy used for? It provides support for arrays and matrices. So first of all, for using NumPy, we need to import it. So for importing it, I'll just go ahead and write for NumPy as np. So np is nothing but it is just an alias for NumPy itself, right? So we don't have to write NumPy dot at every place. We can directly use np dot. Okay. So this is the first thing that we really need to do. Now we will go ahead and I'll show you how to create arrays using NumPy. Okay. Now, first of all, we will go ahead and create a 1D array. Okay. So a simple 1D array, a one-dimensional array, how it is basically created. I will create a variable called as AR1, and here I will write np.array. So np.array is a function which will actually help us to create an array. And inside this, I can give list, I can give tuples. Let's say if I just give one list like this, 1, 2, 3, 4, 5. Okay. Now if I go ahead and execute or print this array, okay. So here you'll be able to see that as soon as I execute this, I'm able to see that I'm getting an array itself, right? Print AR1. And by default, you'll be thinking that this is a kind of a list format. No, it is not. So if I go ahead and see print the type of ARR1, okay, ARR1. So here you'll be able to see that it is a numpy.nd array, n-dimension array. Okay. If you also want to see the shape of the array, like what exactly is the shape of the array, so I can go ahead and write ARR1 dot shape. Okay. If I execute it here, you can see it says that hey, it has 5 comma blank. So it is a single dimension. Whenever there is a single dimension, only one number will be available. Okay, like comma dash like that. It'll be blank. So whenever we have blank on the other side, it is basically talking about single dimension. Here, no specific rows or columns are there. Okay. Let's say I want to convert this into rows and columns. Let's say I'm right now many people will be thinking, hey, these are like one row and 5 columns, nothing like that. Whenever we work with single dimension array, there we don't try to provide columns or rows, right? There it is just treated as a single dimension array with 5 elements. Okay. Let's say that I want to probably go ahead and do one thing. Let's say this is my array that I've actually created, array 2. Okay. So now I want to go ahead and reshape it to a 2-dimensional array. So what I can do, I can go ahead and write ARR2 dot shape. Okay. And here I will just go ahead and write 1 comma 5. Let's see whether this will get executed. So here it says tuple object is not callable. The reason is very much simple. Here we need to provide with this particular brackets. No worries. Tuple object is not callable. Let's see array dot. Sorry, I wrote reshape. I wrote shape. Okay, it should be reshape. My mistake. So it should be reshape 1 comma 5. Now you can see that very much simple, right? A single dimension array is basically having one braces entry and one braces closing, right? But here you can see there are 2 braces that is basically getting open and 2 braces that is basically getting closed. So this becomes a 2-dimensional array. In 3-dimensional array, you'll be able to see that there will be 3 braces that will be opening and 3 braces that will be closing. Okay, so this is how you can actually identify. Now, since I have told, hey, I need to reshape this 5 elements to 1 comma 5. 1 comma 5 basically means 1 row and 5 columns, right? Understand? This 1 comma 5 basically means 1 row and 5 columns. And anyhow, if I probably go ahead and see here, the total number of elements will be 5 only, right? So that is the reason we have reshape to 1 comma 5. If I go ahead and reshape to 1 comma 4, it will not work. Why? Because there are 5 elements. How can I reshape to 1 comma 4? Like 1 row and 4 columns. The total should be 5 elements. Right now, only 4 elements are basically there. So here I will just go ahead and write 1 comma 5. This basically means 1 row and 5 columns, right? So total how many elements it is becoming? 5 elements, right? I will not add 1 plus 5. Don't do that mistake. Okay. So once I'm reshaping it, I'm able to get this. Okay. 1, 2, 3, 4, 5. Now you may be thinking, can we go ahead and create like this directly? Yes, you can do it. So if I go ahead and write ARR2 dot, and if I use np.array, and here, let's say I go ahead and use my nested list, right? So I will go ahead and just use a list within a list. Okay. So here you can see that I'll be able to get an ARR2 dot shape. If I do dot shape, then again here you'll be able to see I'm getting 1 row and 5 elements. What did I do? I just used list inside a list. Now let me do one thing. Let me just go ahead and print like this, and let me add more elements. Now I'll go ahead and add one more list. Okay, like let's say 2, 3, 4, 5, right? And this also basically has 5 elements. 2, 3, 4, 5. Now if I go ahead and print ARR2, and I also go ahead and print my ARR2 dot shape. Okay. Now if I execute it, here you can see this time I'm getting the first row and the second row. All the elements 1, 2, 3, 4, 5 is present in the first row. 2, 3, 4, 5, 6 is present in the second row. That basically means how many columns? 1, 2, 3, 4, 5 columns, right? So the shape will be 2 comma 5. Why 2 comma 5? Because there are 2 rows and 5 columns. Now I hope you are able to understand. And this is also 2-dimensional array. Why? See, 2 times it is opening over here and 2 times it is closing over here, right? So it becomes a 2-dimension array, right? So I hope you got an idea. And this array what I've actually written is nothing but 2D array, 2-dimension array, right? So it is a 2D array, right? Single dimension array is nothing but this, right? So it is a 1D array. I'm just going to write down the comment so that you can refer this 1D array. Okay, perfect. So 2D array, 1D array, we have discussed about it. Now let's go ahead and create arrays with some of the inbuilt function. Okay, so for this, I will just go ahead and use np.arrange function. Now inside this arrange function, let's say I want elements between 0, 10. And the third parameter that you will probably be seeing is step. Okay, so if I go ahead and write 2, that basically I have to skip every one element and go to the second element and display it. So what is getting displayed between 0 to 10? 0, 2, 4, 6, 8. Now there are 5 elements. If I want to reshape this into a 2-dimension, I can basically do, since there are 5 elements, I can do 5 comma 1 or 1 comma 5. If I do 5 comma 1, what does this basically mean? That basically means I have 5 rows, 1, 2, 3, 4, 5, and 1 column, right? So this is how we can actually reshape or convert a single dimension array into a 2-dimension array, right? So this is how we can basically do. Now we're also going to check out some of the inbuilt functions that are present in NumPy array. So one is now np.once. So if I go ahead and use np.once with 3 comma 4, that basically means it is going to create a 2-dimension array with 3 rows and 4 columns, and all the elements is going to be 1. So see over here. So 3 rows, 1, 2, 3, and 4 columns. Now why you may be thinking why we have this function? See, when we see in deep learning, right? Some of the some of the inbuilt functions of NumPy, right, like np.1s or np.0s. Let's say I have to initialize the initial bits to 0. I can directly use this inbuilt function and create it over there, right? So quickly it helps us to create all these elements. Otherwise, I have to write multiple lists over here and then probably convert that into an NumPy array, right? Now this was one. There's also an option to create an identity matrix or an array, and here for that we use np.I. And if I just say, hey, what is identity matrix? It's like all the diagonal elements will be 1, remaining all will be 0. Let's say if I do 3 cross 2, then here you can see in diagonal elements I have 1, remaining all the elements are 0. So this is basically an identity matrix. Okay, so I hope you've got an idea with respect to np.array, how to reshape it, how to see the type, and what all things you really need to do while reshaping it. Okay, so all these things has been spoken about, right? Again, I will quickly write this kind of code over here so that you'll be able to see this. Array is array shape. You want to see number of dimension. You want to see 2 dimension or 1 dimension. You can use n type. Size, number of elements you want to see. You can go ahead and write array.size. If you want to see the data type of that particular array, you can just go ahead and write ar.d type. Output may vary based on the platform. You can come in 64 and 32. It depends on the platform. Item size in bytes, like how much bytes is specifically used. Okay, so all these things are there. So let's go ahead and execute it. So here you can see 1, 2, 3, 4, 5, 6, shape 2, 3. This is in 32. This is my system, so I will just go ahead and write in 32. In your system, it may vary to some of the value based on the operating system that you have. Right? So perfect. This is mostly about some of the amazing attributes. I'll write down a comment. Attributes of NumPy array. Okay, so perfect. So here you have this, right? Now let's do some kind of vectorized operation. Okay, vectorized operation. So NumPy vectorized operations. Okay, now what I'm actually going to do is that I'm going to perform some amazing operations over here, and here you can go ahead and create this quickly. Okay, NumPy vectorized operation. So first of all, I will go ahead and write array1. Let me just go ahead and create np.array, and here I'm going to probably give some elements like 1, 2, 3, 4, 5. Okay, again I will be using another array which will be np.array, and here I'm going to basically use 10, 20, 30, 40, and 50. Okay, I've just defined something over here, right? So first of all, I will go ahead with element-wise addition. Okay, element-wise addition, and here I'm just going to go ahead and print. This will be my addition, and here let's go ahead and let's say I will go ahead and write AR1 plus AR2, right? So if we really want to perform element-wise addition, that basically means what? This one will get added to this 10, 2 will get added to 20, which is present in the same index inside the particular NumPy array. That all elements will get added, and directly we can do that just by using this addition operation. Perfect. Now what I'll do, I will go ahead and also perform element-wise subtraction. Okay, so let's go ahead and do that. So here I'm actually going to write print subtraction colon, and here let's go ahead and do this. Comma AR1 minus AR2. So with respect to element-wise subtraction, we can basically do this. Similarly, if you want to do multiplication, again, all you have to do is that just do the same copy paste over here and just write AR multiplied by AR2. And similarly, you want to do division, you can also do that. Perform multiplication operation, whatever things you really want to do. So all this, the best thing about NumPy is that they are just going to do element-wise. Element-wise basically means the element that is present in the same index, automatically this will be considered. So if I go ahead and execute it, here you can see this is all my output that I'm able to get. Okay, and remember one thing, that all the return type will also be an array. Okay, so this is one very amazing thing. Let's talk about some of the universal functions. Universal functions basically means some functions that applies to the entire array, right? So let's say I will go ahead and write ARR np.array, and here I'm going to basically use an element 1, 2, 3, 4, 5, 6. Okay, it's like now what I'll do first, universal function that I'm going to apply, which is available in np.array. It is nothing but print, let's say I want to perform square root. So np.sqrt function is basically there, and here I'm going to just give the array, right? Automatically the square root is going to get performed. There's also a function which is called as exponential, right? We can also perform this. So for that we'll go ahead and write np.exp exponential, and here I'm going to basically use this array. Okay, next thing I will just go ahead and perform sign. Now the best thing is that whatever operation I'm applying, this will also get applied element wise, right? So here I can also go ahead and use np.sign. Okay, sign. And here also I can go and give my array. Okay, so this is also another inbuilt function. And similarly, you can go ahead and explore a lot. So I'll just go ahead and apply natural log also. And for that, I will just use print np.log. Okay, I'm going to do this, and here is all my function. Okay, sorry, np.log of array. Okay, so here you can see with respect to all the values, all these operations basically taken place. Okay, similarly, mathematical equations also can perform. It is up to you, whatever things you really want to perform. Now, coming to the universal function. So let's go ahead and write my universal functions. Now, inside this universal functions, funcs, I'm just going to basically go ahead and define. Now, see. Sorry, universal function is done, right? So let's go ahead and do the slicing operations, array slicing and indexing. Okay, array slicing and indexing. Okay, so we will go ahead and perform this entire operations with multiple examples. So guys, now let's go ahead and perform array slicing and indexing operations. And here, let me just go ahead and write ARR is equal to, let's go ahead and create a 2-dimensional array. Now this time when I'm creating a 2-dimensional array, I will take some of the elements like 1, 2, 3, 4, 5, 4. Then I will go ahead and create my another list where I will take 5, 6, 7, 8. And let me just go ahead and take 9, 10, 11, 12. Okay, so here in short, you have 3 rows and 4 columns, right? So let's go ahead and print this array. Okay, so here I'm just going to use array colon, let's say a new line, and here I'm going to just display this array itself. Okay, now let's go ahead and access the element. First of all, I'll just go ahead and print this. So here you can see array takes 1 or 2 position argument. Array. Okay, this was the problem. Let me just close this up. I have to use a 2-dimensional list over here. So this is specifically my array. Okay, now my question is that how do I pick up or access a single element from this particular array? Okay, now here what I'm actually going to do here specifically, let's say I'm going to go ahead and pick up one element. Okay, now one very important thing over here is that you should know the rows and columns, right? This is how your entire 2-dimensional array is basically built on. Rows and columns. Let's say I want to pick up this particular element, array of 1, right? This one element. So this is my array, right? Now what I will do, I will just go ahead and see which index. Let's say I have to probably go ahead and check out which row it is present on. So right now 0th row, right? So if I go ahead and write 0th row, I will be able to get 1, 2, 3, 4, right? Now out of this, which column I have to probably retrieve? I need to retrieve this one value. So obviously it is available in the 0th column. So always remember, indexing basically starts with 0 and 0, 1, 2, and you always need to probably look at whenever you're accessing any values, right? You have to access in such a way that you have to focus on the indexes. It can be the row index or it can be the column index. So once I go ahead and execute it, here you'll be able to see that I'm able to get the answer. Okay. Now let's say I want to probably go ahead and pick up elements like 7, 8, 11, 12. Now how do I do that? Now 7, 8, 11, 12. Okay. 7, 8, 11, 12. Understand it is available in which row? It is simple that it is available in second and third row, right? Now second and third row, how can I write? Okay. I can basically say start from second row, go till the end of the row, right? So it can be and any number of rows. So 7 and 11, I will be able to pick up this two columns, right? So sorry, these two rows. So if I go ahead and execute it, so 2 columns, 0, 1. Okay, I have to write 1 column. I'm extremely sorry. So here you can see I'm able to get 5, 6, 7, 8, and 9, 10, 11, 12. Now with respect to column, I have to focus on which column? 0, 1, 2, 2, and last, right? So here I will go ahead and write 2 colon, right? So once I do 2 colon, what will happen? I will just go ahead and pick up this particular columns. And out of all these results, what I'm actually going to focus on, I'll just be focusing on this column and this column, so that I get 7, 8, 11, 12. So once I go ahead and execute it, here you'll be able to see that I'm able to get the answer, right? Very much easy, very much amazing over here. Now let's do one more exercise, okay? So here, let me just go ahead and write print, and let me go ahead and write one more over here. Let's say I go ahead and write print ARR, and I'll say 1 colon, okay? Now when I say 1 colon over here, let's say that I want to pick up 3, 4, 7, 8, okay? Now 3, 4, 7, 8, let's say if I want to pick up 3, 4, 7, 8, you know that I have to focus on which all column? I have to focus on 0 and first column. So 0 and first column, how do I write it down? So I will go ahead and write 0 colon 2. That basically means it indicates I have to read from 0 and before the second column, that is first column, I have to read all the elements over there. So if I go ahead and execute it, here you'll be able to see 1, 2, 3, 4, 5, 6, 7, 8. I got it. Now I want 3, 4, 7, 8. So I have to focus again on the last two columns. So now my next specific value will be, or I can also write like this in separate brackets, or I can also go give a comma and just go ahead and write 1 colon, right? So once I do that, so I'm able to get 2, 3, 4, 1 colon. I have written 0, 1. So it should be 2 colon. Okay. So 2 colon, you'll be able to see that I will be having this 3, 4, 7, 8. So you can go ahead and pick up any kind of elements based on this index mechanism, etc. Right? And this is very much simple and this is very much clear, I hope. And you can still practice more ways. Like if I want to go ahead and pick up 6, 7, 10, 11. Let's do this. Okay. Let's do this. If I want to go ahead and pick up 6, 7, 10, 11. So here I'm going to write array of 6, 7, 10, 11 is present in which rows? First of all, I have to focus on the rows. That is on the first and the second row. So I'll just go ahead and write 1 column. So here I'm actually going to get 5, 6, 7, 8, 9, 10, 11, 12. Now my column needs to focus on this first index and second index. So what I can actually do, I will go ahead and write 1 colon 3, right? So till the third index, before the third index, I'll be able to get the element. So here is my 6, 7, 10, 11, right? So here you can actually see that how easily and how beautifully we are able to probably do the slicing operation and get all the values. Okay. Now if I want to also go ahead and modify the elements, modify array elements, right? Array elements. I can also do that. So for that, I'll just go ahead and say, let's say I want to go ahead and take this array and replace the 0, 0th element with 100, right? Right now it is 1. If I go ahead and execute it now, right? If we go ahead and print the array, you'll be able to see that I'm able to get this particular element over here, right? So these are some of the operations. You can again replace multiple things. You can replace multiple segments of numbers also. Let's say if I go ahead and write print colon, and here I'll go ahead and write, or let me just do one thing, array, and let's say that I want to go ahead and replace 1 colon, all the elements from first row till the last, and all these elements with 100. Now if I go ahead and print the array, I'll also be able to do this operation, and here you can see all the elements after the first row is basically having 100, right? Before that, I have basically changed this particular element. Perfect. So I hope you're able to understand this. Now let's do some of the practical applications with respect to array again. First one is a statistical concept. Okay, so I'll focus on statistical concept. This is basically called as normalization. Okay, so we will be learning about normalization as we go ahead with machine learning. So normalization, what exactly it is? I need to change my data to have a mean of 0 and a standard deviation of 1. Okay, so usually we do this, and for this there's a formula. Right now no need to focus more on that because anyhow I'll be discussing about that. So calculate the mean and standard deviation. Let's say this is my array. We will go ahead and calculate the mean and standard deviation. For that we can use nt.mean of data, nt.standard deviation of data. Then we have normalized data. It's nothing but data minus mu divided by standard deviation. This is also called a standard normal distribution. And here we can probably go ahead and display our output. So this is how my output looks like. After initially this was my data. After normalization, this is what my data is. Normalization is nothing but converting this data in such a way that your mean is 0 and your standard deviation is 1, right? And it is specifically used in statistical concepts, and we do a lot of things with respect to that. Okay? Let's take one more operation with respect to statistical operation, how to calculate mean, median, mode. So here I will be giving you one more example. So here you can see np.array, np.mean, np.median, np.standard deviation, np.variance, right? So these are some of the statistical concepts that we do. If you really want to find out mean, then we can go ahead and write np.mean, median, np.median, standard deviation is nothing but np.std, and variance you can specifically use np.variance. And these are some of the important concepts that we specifically use in statistics, right? So if I go ahead and execute it, you'll be able to see all these values. Perfect. Now let's do one thing. Let's quickly do one more operation that I'm really interested in this, and whenever you work with pandas later on, you will be using this. That is nothing but logical operation. Okay, logical operations. Let's say this is my data, and here I'm going to basically use np.array, and let me just go ahead and create the elements like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now I can go ahead and apply some logical operations. I can just say data greater than 5. Now what will happen when I write data greater than 5? It's just going to give me array which says whichever value is greater than 5, that will be true, right? And whichever value is less than 5 is basically false. Okay, so it is basically applying a condition on this particular data. Now let's say that I just want to retrieve all the elements that are greater than 5. So all I have to do, I will be using an indexing where I will say, hey, data of data greater than 5. And here you can see that I'm able to get the value that is nothing but 6, 7, 8, 9, 10, right? And this is super important because in pandas, when you do the data analysis, because we'll be having an Excel sheet, we'll be having a data frame there, we specifically apply this kind of logical operations within the arrays itself, right? So any condition you can go ahead and write. Let's say I will go ahead and write another condition where data is less than 8. So let's say all the elements within 5 to 8, right? Greater than or equal to 5 and less than or equal to 8. So here you can see an error is there. Okay, let's do one thing. I'll go ahead and write and there also it is not working. So let me do one thing. Let me do one thing as such. I'll just use some brackets so that it'll become simple for it. And here I will use another bracket. Okay. Data. Okay, here I'll close it. Now here you can see that I've used this particular bracket. So the reason was that why we are getting an error, because there were many things that we were probably putting as a condition, right? And it got confused. The compiler also got confused. So this and will not work. Instead, logical and will specifically work over here. So here you can see that I'm having the value 5, 6, 7, 8. So multiple types of condition you can put. You can use or, you can use and, whatever things you specifically want, right? Anything you can actually use it. It is up to you. So I hope you were able to understand this particular question, this particular topic. Sorry. And yes, this was it from my side. In the upcoming session, we'll be discussing about our next library, which is called pandas. So here, in short, we have discussed about NumPy, and as we go ahead, we'll be still discussing about NumPy. Even in machine learning, we'll be seeing a lot of multiple examples with respect to NumPy. So yes, this was it. I will see you on the next video. Thank you. Hello guys, so we are going to continue our Python series, and in this video we're going to discuss about a new library which is called as Pandas. Again, we are into the data analysis with Python series section, and in our previous video we have discussed about NumPy, which is an amazing library where you can actually perform a lot of operations with using this. Along with that, in this video we are completely going to focus on Pandas. The first topic will be Pandas, data frame, and series. So Pandas is also a very important library because it has a lot of data manipulation capabilities, right? So we will be discussing step by step. We'll be writing down the code in front of you, and again I will discuss in such a way that we take multiple examples and we try to find out its capabilities, right? So here you can see that Pandas is a powerful data manipulation library in Python, widely used for data analysis and cleaning. It provides two primary data structures: series and data frame. We'll understand the difference between series and data frame. A series is one-dimensional array-like object, while a data frame is a two-dimensional, size mutable, and potentially heterogeneous tabular data structure with labeled access. Okay, so the basic difference between series and data frame is that series is a one-dimensional like array object, like how we create a one-dimensional array in NumPy. We can also convert that particular NumPy array, which is one dimension, into a series, right? And data frame altogether, whenever we have a two-dimensional NumPy array, right, we can also convert that into data frames because data frame is also a two-dimensional, mutable, and potentially heterogeneous, means it can have different elements over there. So let's go ahead and start. Now, before we go ahead and start, the first thing that you really need to do is that go to your requirement.txt and go ahead and install Pandas. Okay, so we need to have this library. Again, I just showed you there are two ways. Either you can do it from here, or you can just try to install Pandas, right? So right now, I'll just try to show you from here. Let me just go ahead and open my terminal. Okay, now inside this terminal, I'll go ahead and open my command prompt. My VNV is in. Make sure that your VNV environment is activated. And I'll just go ahead and pip install -r requirement.txt. Okay, so here you can see that automatically my requirement.txt is going to install everything that is required, like Pandas, NumPy. So NumPy is already done. Now the Pandas installation is basically happening. So it's going to take time based on that. All other libraries that is already installed, I don't have to do any changes for that. So it is going to take some amount of time with respect to the installation. And remember, now you can see the installation is done. That basically means I can actually use this particular Pandas library from here. So just to check what I'm going to do, I'll just go ahead and write import Pandas as PD. Okay. So now if I go ahead and execute it, so let's see. So here you can see perfectly my Pandas library is basically working. Okay. As I said, the first topic that we are going to talk about is series. And what did we define a series? It is just like a Pandas series is a one-dimensional. So here I've written a definition of Pandas series is a one-dimensional array-like object that can hold any data type. It is similar to a column in a table, right? So let us go ahead and create this particular series, and then you'll be able to understand. So first of all, we will go ahead and import Pandas. And this time, whenever we are importing Pandas, I'm going to use the alias, which is called as PD. Okay. So that I don't have to write pandas.pandas. Let's say this is my data, and here I'm going to basically use 1, 2, 3, 4, 5. Okay. Let me quickly go ahead and create a series. So it is nothing but PD.series. Series is an inbuilt function, and here I can give my single dimension data over here, and automatically I'll be able to get the series itself. Now, if I go ahead and print this series, so here you'll be able to see series/n. Okay, and here is nothing but my series. So here you can see this is how a series look like. All the elements 1, 2, 3, 4, 5. These are the default indexes. Okay, so don't worry about this. 0, 1, 2, 3, 4, 5. This is the index with respect to the series. But you can just imagine like this is one column, one single column, and that is what series is all about. Okay, so this is one way of creating series just from a list. The other way that I'm actually going to show you is from dictionary. So let's go ahead and create a series from dictionary elements. Okay. So for this, what I'm actually going to do, and why I'm saying this is a series, if I go ahead and print type of series, okay, so type of this particular series variable, so here you can see that it is a pandas code.series data type. Okay, I created series from dictionary. So let's say this is my data, and here I'm just going to use some of the elements like A:1, next element will be B:2, the third element will be C:3, and these are my elements. Now, in order to use this particular data and convert this into series, I'll just go ahead and write PD.series, and here we are specifically going to use the data. Okay, now if I go ahead and check this out, series underscore dictionary. Okay, this is my variable. If I go ahead and just print it, okay, so let's go ahead and print, and here I'm going to basically go ahead and write series underscore dict. Here you can see this becomes my index. This key, what I've actually done, A, B, and C, this becomes my index. Before the default index was 0, 1, 2, 3, 4. But here you can see that these are my default indexes now, and that is what is important for creating series from a dictionary. Whatever will be the keys that will be considered as the index, and all the values will be considered as the series values. Okay. Now I can also make sure that I can give a different index over here based on my requirement. So for that, what I will do, let's say this is my data. So let's say I will go ahead and write 10, 20, 30. Now why Panda series and all this will be required? See, whenever we try to open an Excel file, right, there will be finding a lot of rows, columns, different data will be there. And to read that, do some manipulation, this pandas will be very much important. I will also show you how to read a particular data and show you amazing things over there, how you can explore it in the form of data frame and series itself. So let's take this particular data, and I will just go ahead and create my indexes. Let's say my indexes will be something like this: A, B, B. Okay, so these are my indexes that I want to do, and I have to always use based on the number of elements, that many number of indexes needs to be there, right? Now, in order to probably use this index over here, right, without using any key value pairs, right? How do I write it down? So here I will write PD.series. Okay. PD.series, and here specifically with respect to the series I will require data, and then the second parameter that I'm actually going to give is my index, and this is what index I'm actually going to give. Okay, so if I go ahead and execute this, so here you can see that this will basically be my index, and these are my elements. So this way also you can probably create your series and all, right? As said, what is a series? It is a one-dimensional array object that can hold any data type. It is similar to a column in a table. Okay, so here these were all the things. Now let's talk about data frame. Okay, so let's talk about data frame. So here, data frame, as I said, is a two-dimensional, mutable, and heterogeneous tabular data structured with label access, that is rows and columns. It is similar to a table in an database or in an Excel. Let's say that this is my Excel sheet. I'm going to use it for this particular example. So here you'll be able to see I'll be having some column names. I'll be having so many different rows. Right, this is a multi-dimensional array, right, or multi-dimensional data itself, right? I have so many things. I can directly read this, convert this into data frame, and with the help of data frame, what is data frame? Like it will be having multiple rows and columns. That's it. In series, it just has a single column. In data frame, it can have multiple rows and columns. Okay, so let's go ahead and create one by one. First, we'll try to see how to create a data frame completely from basics, and then we will also try to read a specific CSV file and see how a data frame is basically created. So here you'll be able to see create a data frame from a dictionary of list. Okay, so I will I'll create a list, dictionary with key value pairs, and in that key value pairs, values will be in the form of list, since I really need to have multiple data. So here I'll go ahead and create my data. So this is how we basically create a dictionary, and here we're going to use name value pairs, right? A key value pairs. Let's say my first column is name, okay, and in name I'm going to use multiple names, right? Considering multiple rows. First name will be Krish, second name will be John, okay, third name will be Jack, okay. So these all names are specifically there. Then let's go ahead and use this age. Inside this, let's go ahead and create some values, like let's say 25, 30, and 45. Okay, so these are my second column, right? Since I'm making sure that I have three records, so all the fields, all the column names that I'm specifically giving is also having three different values. Let's say city, I'm going to use over here. City will be, let's say over here, I go ahead and write Bangalore. Okay, let's say here I'm going to write New York. Okay, and the third one, let's say I'm going to basically write Chicago or Texas, anything. Okay, Texas. So this, okay, this is a city, this is a state, right? So let's say I'll go ahead and write Florida. Okay, so these are some of the elements that I've actually written. But in short, what is this? It has basically three columns and it has so many rows, right? This is my first row, this is my second row, right? Not first row, sorry. First row has the elements Krish, second row has the element John. Jack, Krish age is 25, he lives in the city of Bangalore. Similarly, John name is over here, his age is 30 and he lives in New York. Similarly, Jack is over here, his name age is 45 and he lives in Florida. Okay, so all those specific elements is basically present. Now what I'm actually going to do, I'm going to basically go ahead and write pd.dataframe and this will basically get created. How to create a data frame? I'll use this entire data and basically create it, right? So if I go ahead and print now, you'll be able to see that I will be having rows and columns, right? So this will be my df. Okay, now let me just go ahead and print type of df. Okay, so df and so this is my df, this is my zeroth index. You can see three columns, name, age, and city. I have Krish 25 Bangalore, John 30 New York, Jack 45 Florida. Like this is just like how we have the data in the Excel sheet, right? And clearly you can probably see with respect to this. Okay, and if I'm going to write type of df, I can actually see that all this information is there. Now see guys, it's not like I always have to keep it in the form of data frame. I can also use NumPy and I can convert this into np.array. Okay, so if I go ahead and write np.array with respect to df, I'll be able to get this array. Okay, then it'll just skip this index and it'll just skip this column names. Like this also you can basically do. Okay, so this was one example like how you can actually use a dictionary from a list of dictionary you can specifically create, or from a list of right? Nested list also is there. This list is basically inside a dictionary. You can also see that. Okay? Now what I'll do, I'll create a data frame from a list of dictionaries. Create a data frame from a list of dictionaries. Okay, I'll do the same thing over here. Now let me do one thing. Let me go ahead and create my data, and here I will just go ahead and create a list. And with respect to the list, what I will do, I'll just copy this entire thing. There's three fields. Let's say I'm just copying it. Okay. Now instead of writing like this, right, where name is got all the names, age is got all the names, what I will specifically do, I will say, hey, let's create a key, or let's create a dictionary over here, and this single dictionary will be this one. First of all, I'll just going to use name is equal to Krish, right? So name colon Krish. The second field that I will probably go ahead with is nothing but age. So age is colon with 32. Okay. And the third column that I'm specifically going to use is nothing but city. Okay. And city I am just using it as colon Bangalore. Okay. Bangalore, and here I will be using this. Okay. So this becomes my one row data. Okay. And I will remove all these things. Now similarly, I can go ahead and create with respect to any number of key value pairs. So let's say I go ahead and paste the same thing, go ahead and paste the same thing just to make sure that I have this entire thing in a similar way. Okay. So what this is the list of dictionary key value pairs. So this becomes my first row, like name 32 Bangalore, right? Like this. Let's say I'm going to change something over here 34. Let's say I'm going to write John over here, right? And here I'm going to write Bapi. Okay. Here I'm going to write Jack. Okay. All these elements are there. Let's go ahead and execute it, and I will go ahead and use the same thing pd.dataframe. Okay. And let me just go ahead and execute it. So here you can see Krish 32 Bangalore, John 34 Bangalore, Bapi 32 Bangalore, Jack 32 Bangalore. So all these values are specifically there with respect to this particular data frame, right? So this is also how you can actually go ahead and create it. It is up to you how you really want to go ahead, whether you want to go ahead with this. But most of the time, what we specifically do is that whenever we are creating something, right? Whenever we are creating, we mostly work with bigger data set, right? Like CSV file, Excel file, and all. So let me now just go ahead and show you how to probably read any kind of data set with respect to this. And let's say if I'm having a CSV file, how can I probably read it? You know, I'll be showing you multiple examples that when I go ahead, with Excel and all. But right now I'm just going to use this online sales data.csv, which is available over here. So for this, what I will do, we'll go ahead and write pd. Read underscore CSV. There are a lot of functions like read underscore Excel and all, but I'm actually going to use this. Okay, so read underscore CSV, and here I'm going to just call this CSV file. Let's rename it. Okay, I'll just go ahead and write this as sales data. Let's see whether this will get converted. Sales underscore data.csv. Okay, so I'll just go ahead and rename it, and let's go ahead and write sales underscore data.csv. Okay, and this basically becomes my data frame. Now, if I want to go ahead and see the top 5 elements of data frame, I'll just go ahead and write df.head. Right, so df.head is basically giving me this entire information. If I remove this print, also you'll also be able to see it much more clearly. So this is how it looks like. This is my first column, second column, third column, and all. And df.head of 5 is basically giving me top 5 records 0, 1, 2, 3, 4. Similarly, if I want to see the last 5 records, I can actually use df.tail, and it basically gives me the last 5 records, right? And these are the default indexes that we are specifically getting, right? So guys, now let's go ahead and see how we can access the data from this particular data frame, which is important. So here I'm going to basically write accessing data from data frame. Okay, so right now this is my data. Okay, like all this information is specifically data over here that is available. Or let me just go ahead and create this one. This also looks good. Okay, so I'll just go ahead and use this particular data. Let's see. So this is my data right now. Okay, Krish age and all. So if I go ahead also use df, right? So df is basically this one. Okay, now if I go ahead and create df, now let's say that I want to pick up all the elements with respect to name, right? So here what I can go ahead and do, I can just go ahead and write df of name, right? So whenever we are specifically using anything related to columns, we can directly go ahead and call the column name. So if I go ahead and write df of name, I'm actually able to get this, right? Now, very important thing that you'll see. If I'm picking up one column, right, it actually becomes what? It becomes a series, right? So if I go ahead and see type of df of name, you'll be able to see that I'm actually able to get series over here, right? So since I'm just picking up one entire column itself, okay. Now this is one way. Now there is also another way which I will be showing you. I will be using df of loc of 0. Loc of 0 basically means I'm just going to pick up my 0th row, right? If I really want to go with row index, that time I will be specifically using this loc operation, okay? Loc, loc, okay? Loc operation. That basically means row index, okay? Let's say I want to go ahead with column index also, so I can also go ahead and write index location, iloc, right? And here if I go ahead and give 0, that basically means I'm picking it up Krish 25 Bangalore. So here you can see name a city, Krish 25 Bangalore, right? Let's say I will just want Krish, I can go ahead and write 0, right? So I'm getting an error over here. Oh, no, it is not an error, it is a warning. It says 0, 0. 0, 0 is nothing but the specific element 0, 0, right? So first is something related to, you can just consider location of 0, 0 is basically giving you this thing, row and index. Okay, so let's say I go ahead and execute this. Let's try with iloc of 0. So here you can see I'm getting this. If I go ahead and 0 of 1, I'll be able to see this 25. If I go ahead and do 0, 2, I'll be able to see this, right? So all the information is basically there. If I go ahead and write 0 colon, right? So here you can see there's a key error because it is not able to find out that error. So 0 colon 2 is basically giving me this particular value, Bangalore. Okay, so you can also use index location to probably get some kind of information over here. Okay, now Let's say there is one more function which has been never discussed anywhere, probably. I guess I've hardly seen any tutorials that discuss text. It is nothing but accessing a specified element. Okay, I hope you got a difference between location and index location. Index location over here, let's say if I go ahead and write 0 of 2, is specifically working with index location. This is only with respect to row index. And whenever I really want to work with column, I can just go ahead and write this like that directly to column name. These are the three ways how we probably access. Okay, so let's say I'm accessing a specified element if I'm specifically using. What does this basically mean, right? So if I go ahead and write df of, okay, df of name, okay. So here you'll be able to see that I'm able to get all the names in this specific data frame, right? I call them Krish, John, Jack. So how many records are there with respect to that particular information I'm getting? And if I go ahead and just write df dot head or df, right? So if I go ahead and write here, I'll be able to see, okay, in the 0th row it is Krish, first this is John, and this is there, right? Now let me do one thing, something like this. Okay, I will write df dot at, okay, this is very much important. See, at, let's say I give 1 comma, and here I'm just going to give age. I'm able to get this particular value. Why I'm getting this value? Let's see. Okay, so if I go ahead and write df, okay, I'm saying, hey, from a specific element you have to specify, you have to take it, right? So from the age, which is my first index is this one, right? So I'm actually able to get 30, right? If I similarly go ahead and write 2 of age, I will be able to get it, right? 45. If I go ahead and write df of at, and let's say instead of 2, I will just go ahead and write name. So I want the second index name, so it will be nothing but Jack, right? So this is also very amazing at search. There is also something called as IAT, okay? So I will go ahead and write accessing a specified element, okay, using IAT, okay? Now what is this IAT? So here you can actually give your row index and column index. Let's say if I go ahead and write df of 2, 2, okay, that basically means, let's see what is the error. So here, okay, I did not write IAT. IAT operation of 2, 2, so here you'll be able to see second element. Second element is nothing but 0, 0, 1, 2, okay, and 0, 1, 2. Column wise, this is my second index. So I want to pick up Florida, so I'm able to get Florida over here, right? So IAT, here you're basically giving your both row index and your column index. So I hope you're able to understand all these things in an amazing way. Now, let me do one thing, okay? So right now, this is my df, okay? Now let's perform some data manipulation with data frames. This will basically give you an idea, okay? What are data manipulation with data frames? Data manipulation with data frames, okay? Now what I'm actually going to do, okay? So you know, this is my df, okay? Now what I'm actually going to do, I will be adding a new column, okay? And let's say how to add a new column. I want to add a new column which is called as salary, okay? So let's say how do I do it? So I will go ahead and write df of my salary name column, okay? So here you can see salary column, okay? Which will be equal to the salary that I'm probably planning to add over here, right? df of salary, okay? And then what I will do is that I'll just go ahead and use a specific list. Let's say I'll go ahead and write 50,000, 60,000, and 70,000, okay? So this basically becomes an array. So if I go ahead and print the df, now here you can see a new salary is basically added. So with the help of this, I am adding a column, right? Over here. Perfect. So this is great. Let's say I want to remove a column. Remove a column. Okay. So what I can do, I can write df.drop, and here I'm going to basically say salary. Okay. Now when I'm doing df.drop, I'll get, see, if I execute this, I will get an error. Salary not found in the access. Okay. But you can see over here salary is basically present. Now what does this access mean? Access has two values. Okay. One is the row value. It will probably go ahead and check with respect to row index. First of all, it is checking row index. It is not even going to the column index because by default your access value will be 0. Okay. So if I'm executing, it is basically checking by default in the row index, and row index does not have a name like salary. So if you want to make this entire code check the column index like name, age, salary, city, salary, you have to convert this into access equal to 1. Okay. So if I go ahead and execute this, here you'll be able to see that I am not having this salary column. But still, if I go ahead and again check df, again the salary column came. What has happened? Even though I dropped it, but still in my df, after some time, like if I go ahead and execute it again, salary is coming. So this is very much important when this drop is basically happening, right? With access equal to 1. It is not a permanent operation, right? It is just a temporary operation. It does not even save the state of the data frame. So in order to make it save it, you have another parameter which is called as in place is equal to true. Okay? Or in place is equal to true. So once you do in place is equal to true, then what it is going to do, whatever drop operation you're doing, it is going to do it permanently. So if I go ahead and execute it, and if I go ahead and see df, here you can see now I do not have that specific column. Okay? And this is how you remove a column. Okay? Remove a column. Now let's say that I want to do some kind of operation where I will add age to the column. Let's say after 1 year, what happens? Everybody's age increases by 1. So here I'm going to write df of age, okay, plus 1, right? And this is basically going to get applied to all the values inside the age, and this should be replaced in df of age itself, okay? So now what will happen is that initially I had 25, 30, 45. Now the age is going to be 26, 31, and 45. So if I go ahead and display it now, so here you can see 26, 31, and 46, right? 26, 31, and 46. So 1, it is got incremented by 1, okay? Now, you can add any number of rows as you like, or any number of changes or any manipulation that you specifically want to do, okay? And this is how you'll be able to do it. Let's say I want to go ahead and drop based on row. So what I will do, I'll just go ahead and write df of drop, and I can also give my index. So if I go ahead and write like this again, this is again not a permanent operation because if I go ahead and see df, I'll again back it. So in order to make it permanent, I will just go ahead and write in place is equal to true. Okay. Now if I go ahead and execute it, I just have two records, that is John and Jack. Okay. This was mostly about how you can probably read, how you can probably do things, you know, and some of the information regarding data frame and series. But as we go ahead, we'll be discussing more about manipulation. Now let me do one thing. Let me show you again with respect to some of the things that you really need to know about data frames. I can also say it as attributes, which will be important, right? So if I go ahead and write df.head of 5, I'm going to get the first 5 elements. Along with this, I'm just going to copy and paste some more additional things that you can do. You can see the data types. You can, if you go ahead and write df.describe, you'll basically get the statistical summary. Okay. So let's do one thing. Let's remove this and let's see the statistical summary. df.describe. Now if you don't want to see like that, I'll go ahead and write df.describe. If I go ahead and write it here, you can see these are some statistical analysis, like count how many number of records are there, mean, what is the mean of transaction ID, which is not important, but mean of unit sold is important, mean of unit price is important, total revenue, standard deviation also you can probably see over here, minimum, maximum values, 25 percentile, 50 percentile, 75 percentile, 7, max, all those values you'll be able to see with the help of df.describe. Okay. Now what I'm actually going to specifically do over here is that let's use one code. Okay. So what I'll do, I will just say, hey, do one thing, okay? Based on this unit price, okay? Based on this unit price. Or let me just show you that in the next session because I'm going to probably do some more operations over here and perform some data manipulation. In this video, I wanted to cover about data frames and series, data basic hands-on, and now in the next video, we'll talk more about the manipulation. So I hope you like this particular video. This was it from my side. I will see you in the next video. Thank you. Hello guys, so we are going to continue the discussion with respect to Python, and in this video we are going to see data manipulation and analysis with Pandas library. Now Pandas is a very important library where you can actually perform exploratory data analysis. You can also perform a lot of feature engineering. So in this video we will be talking about all these particular topics, and what we are going to do is that I've also taken some kind of CSV file, sample data set, which we will try to perform some kind of EDA. We'll do some analysis. Let's say if there is a missing values, I'll show you how you can basically handle it. So let's quickly go ahead, and first of all, as usual, we have to go ahead and import Pandas. So I will just go ahead and write import Pandas as PD. This is what is the library that we're going to specifically use. Then I'll just go ahead and write pd.read_csv. So let me just go ahead and use this read_csv, and here I'm going to basically use data.csv. Right. So data.csv is a file name, and if you see over here, I've already uploaded data.csv, and these are my entire data. You know, it also has a lot of missing values and all, so that will be amazing to check this. Anyhow, I will be giving you this in the entire material section. Okay. Now let's go ahead and fetch the first 5 rows. Okay, and for basically getting this particular rows, what I'm going to write, I'll just go ahead and write df.head of 5, and let's see this. So I have data like data, category, value, product, sales, and region. So these are some of the information that we have regarding that specific data. If you want to also go ahead and check out the last 5 rows, I can go ahead and write df.tail, and here I can just give the last 5 or last 10, whatever things. Whatever number you give over here, that many number of records you'll be able to see from the end, right? So from the end, these are my last 5 records that you are able to see over here. Perfect. One more thing is that let's say you want to go ahead and see the the entire. If I just go ahead and write df.describe all the statistical things that you want, right? Like count, mean, standard deviation, minimum, 25%, 50%, 75%, and over here you'll be able to see only values and sales has been taken. Remaining all it will just be considering as a category column. Okay. But if I probably consider value and sales, these are numerical columns, so it will just try to find out all the statistical analysis that we basically require for both of this particular column. Now this is there. Now let's say I want to go ahead and see the data type. So I'll just go ahead and write df.d data types. That is nothing but d types. So here you can see date is nothing but object is nothing but string, category is object, float is 64, product is object, sales is float 64, region is object. Let's say if I want to probably go ahead and convert this into date time, we can actually do it with the help of data analysis. Again, with the help of Pandas also we'll be doing. And we'll see those kind of projects when I will create a separate section for EDA. Okay, and how you can probably do some of the amazing EDA. All those things I will be discussing about. Okay. Now let's go ahead and discuss about handling missing values. Okay, handling missing values. So first of all, what I'm actually going to do is that once we read any data, there will be chances that whether there is any missing values or not. So if I go ahead and write df.isNull, right? And I'll just go ahead and execute it. So here you'll be able to see with respect to my entire CSV file, wherever there will be false, that basically means there is no missing values. And let's say if there is some values like true, that basically means in this particular column, in this record, this value is missing and it does not have any values over there, right? So obviously this is a missing value. Similarly, you can see one more row is over here, one more row is over here. But just seeing like this, it becomes very much difficult. So what I will do is that to find out the records, I'll just go ahead and write something like this, and whichever are true, I will be able to get the answer. Just a second, I'm able to get an error, no worries. So I'll just go ahead and see this. Now you can see over here, nan values are specifically coming. So I think I've done some kind of mistake over here. So I'm writing hey df.isNull, or let me do one thing, very simple. df.isNull if I'm going to write, and I'll use .any operation, and let's say I'll go ahead and write axis is equal to 1. So here you will be able to see that with respect to every record, right? See, axis is equal to 1 basically means what, right? With respect to every record, you'll be able to see where there is a missing value and where there is not a missing value. Okay, so these are some of the ways that you can probably check it out. Okay, and if I remove this axis is equal to 1 by default, it will take axis is equal to 0. So here you can see for date it is false. That is, date is basically having all the values. Category is false. Value is basically having a missing value, so it is showing true. Sales is basically there, true, right? So all these things are there. If you also go ahead and use one more inbuilt function called as .sum. Okay, so if I go ahead and use .sum, here you'll be able to see like in value there are 3 missing values, in sales there are 4 missing values, right? So all the missing values are specifically visible just by doing this. Like I'm just showing here what I'm calculating. df.isNull, wherever it is true, all the summation is basically going to happen, and this is by default going to happen with the help of column wise. Okay, so here you can basically see that. Okay, I feel like it is there. Okay, now the thing is that value is basically having a missing value and sales is basically having a missing value. So can I go ahead and fill those missing values? So it is very simple. Let's say if I don't know what all missing values are there, I can basically go ahead and write fill NA, right? Fill NA. And if I just go ahead and write fill NA with 0, right? By default some 0 value, then you'll be able to see that all these values, wherever there is a missing value, it will be replaced with 0. It will be replaced with 0. It will be replaced with 0. 0, 0, 0. Everywhere it will be replaced with 0. And if you are doing this kind of replacement, you have to also make sure that you go ahead and fill this in another, or you create a copy of that particular data frame. And usually most of the scenario we don't fill with 0, because if I have a numerical value based on a distribution, I may want to probably, if it is a numerical value itself, I may want to replace the missing value with the mean of that specific column. Okay, so that also I'll try to show it to you. Okay, now how to fill, and that may be the scenario over there, filling missing values, okay, with the mean of the column. Okay, let's try to do this. Okay, so here what I will do, I'll just say hey df of, let's say I know what all missing values are specifically there. I'll say okay, sales has a missing value, there are 4 values over there. I'll write hey df of sales, right, will be nothing but, or let me just go ahead and write sales underscore fill NA. Okay, so this will be my new column, and here what I'm actually going to do, I'll say hey df of sales, okay, dot fill NA. Now if I want to really do the fill NA over here, how do I do it? If I'm using this particular function fill NA, so here I will just go ahead and write df of sales, right, and I know sales has that particular missing value, so I'll just go ahead and take dot mean, right? So what I'm actually doing, wherever the nan value is basically present in that sales column, I'm going to replace with df of sales dot mean, the mean value. And now if I go ahead and see it, and if I just go ahead and print a df, so this is my new column that you'll be able to see, sales underscore fill NA. So it was 754 over here, then you can see wherever there is a nan, here I'm able to get the mean value of this particular column. Okay, so here also you'll be able to see somewhere, you'll be able to see nan, again I'm having this particular value, again there's a nan basically means not a number. Okay, and here we are specifically having the values. Wherever there's a missing value, that is basically considered as nan by the data frame. And how easily I have actually created this particular column, and just by writing one line of code, you'll be able to see just by using this dot fill NA, I've replaced all the missing values with mean. Okay, so these are some of the amazing methods that are already present in data frames. But in EDA, we will be looking into more examples where we'll be also working with time data and all. So first of all, let's do this entire analysis with the pandas, and later on you'll be seeing how I'll be combining NumPy, pandas, and some of the visualization libraries to do some amazing EDA. Okay, now let's do one thing again. Let's say that you want to change the data type. See, when I went and wrote df.dtypes, right? Details. So here you can see data is an object category, right? And here you can see category is an object, right? And product is an object. Object basically means string. And let's say I want to probably go ahead and convert this into numerical values, or see if I probably consider date, I want to convert this into date time. I will be showing you this example later on when we do the EDA. But let's say that I have some kind of categories, product and all. I want to change, or here I have float 64. I want to probably convert this into an integer value. How do I probably do that? Okay. And let's say if I have a specific column, I want to rename that column. How do I do that? Okay. So some of the analysis that we specifically do, let's start with renaming columns. Okay. And here what I'll do, I'll just use this date column and I'll try to rename it, right? So here we have in df a rename function, right? Rename function itself, and here you'll be seeing that I'll be providing my column name, the column name which I really need to rename. So here I will just go ahead and say, okay, it is date, and I need to rename this to sales date. Okay, so let's say I want to probably go ahead and rename in this specific way, and all this entire thing will be replaced back in the df. So if I go ahead and now see df.head, you'll be able to see, hey, I will be able to get all the answer. Okay, I'm getting a renal. Set object is not callable. We have to probably see, okay, I have to use colon. Okay, so this should be a key value pair, right, with respect to the column. Now, if I go ahead and see df.head, you can see sale data or sales data. I'll just go ahead and write, but this time again, I can replace the sale date with sales data. And here you can see that I've actually replaced the entire column. And similarly, you can also do it. And remember, this you really need to give in the form of key value pairs because this is completely dictionary type. Okay, now let's go ahead and change the data type. So let's say I will go ahead and change data types. Now, in data types, let's say I want to probably change the sales, which is in float 64, back to int32 or int16, whatever things I want. So I'll just go ahead and write df of, let's say, value underscore new. So let's go ahead and create this new column. And what I'm actually going to do is that I'm going to probably take this entire value and I'm just going to change the data type. So I will go ahead and write as type with nothing but with float. Okay. Now, if I go ahead and write df.head, and here you'll be able to see that I will be able to get a new column that is value underscore no, and I've just converted this into float. But what I will do, I'll just go ahead and convert this into int, right? Cannot convert. Okay, it is having a missing value also. Okay, the main thing is that it is having a missing value here. So what I will do, I'll just go ahead and write fill na. Okay, and with fill na, I'll just go ahead and write df of value. I'll replace with mean. Okay, mean dot mean. df of value dot mean. Okay, and then I'll convert that into type int. Okay, now let's go ahead and see this. So here you can see that now I'm able to get all the integer values, and here what I did, I just filled all the non values with this mean, and I try to replace with that integer value. Okay, so here you can probably see this is my new thing with a new column. Okay, let's say I want to apply a function to one of the columns, right? So for that, obviously I've seen lambda, right? Let's say I will go ahead and say this will be my new value, and let's say my new value rate has got increased by 10%. Okay, 10% or double of this particular value, something, right? So here I'll take this df of new value or value. Okay, whatever is the numerical column, I'm creating a new column. Now here I'm going to apply any function. So in order to apply, I'll just use this dot apply function. I'll call the function name inside this. So you can go ahead and create any function that you want. But I'll show you one application with the help of lambda. So here I'll go ahead and use lambda function. I'll go ahead and apply x, and I'll just give my expression x multiplied by 2. Okay, so if I go ahead and see this, and now if I go ahead and apply df.head, so here you can see initially my value was 28, now it is 56.0, 78.0, 64.0. So that basically means I'm able to apply all this kind of operations specifically in this just by using one kind of function, and this can be an inbuilt function, it can also be a custom function. With respect to custom function, you just need to call it by providing the parameters. I think that will be more than sufficient. Okay, so this was with respect to the some of the manipulation operations, but when we see the full-fledged EDA, we'll get to know more about it. Okay, now coming to the next thing, a very important topic altogether, and most common things that we specifically do is here I'm going to basically go to write data aggregating and grouping. Data aggregating and grouping. Okay. Now, data aggregating and grouping basically means that with respect to any column, let's say I want to probably go ahead and aggregate it. I want to probably go and do the things, right? I want to probably group based on different categories. I can actually do it. Okay. So let's say this is my df.head. Okay. df.head. Okay. Let's say based on products. Okay. I want to do an aggregation and I want to do the mean of the specific value. Can I do it? So let's see this. So here I'll just go ahead and write grouped underscore mean is equal to df of product. Okay. I'm just going to group by this specific product. Let me just go ahead and write df dot. There'll be a method which is called as group by, and inside this group by, I'm going to give my categorical column. Let's say my categorical column is product. Okay. And with respect to this categorical column, now when I'm grouping based on product, I have to also make sure that I need to calculate the mean. Like product 1, what is the average mean? Product 2, what is the average mean? Something like that, right? So here I'm going to take my value, okay, dot mean, right? So once I probably do this, you'll be able to see. I'll just go ahead and print my group underscore mean. So here, based on product 1, it is 46.21. Based on product 2, it is 52.8, and based on product 3, it is 55.16. So that is what is the mean. I'm able to get it. Let's say I want to probably do the group by based on two categorical variables, like let's say product or sale, product or region. I can also do that. So here, what I'm actually going to write, I'll just go ahead and write df.group by, okay, and here I'm basically going to use my first column, that is let's say one first categorical column, that is product, and here I will give it in the form of list, right? So here the next parameter that I'm actually going to specifically give, okay, let's see what is the next column, region. Okay, so let's say I am trying to group by two different categorical variables, and then I go ahead and take my value, and after giving the value, I'll just do the dot sum. This time I'll not do an aggregation function dot mean. Instead, I'll do dot sum, like total sale based on products and region. Based on regions, I'm trying to find out what is the sale with respect to that. Okay, and now this will basically be my grouped sum, group underscore sum, and here I'm just going to print my group underscore sum. So here you can see, so based on product 1, you can see in east there is 292, in north there is 9, south 100, west 246. So based on two categories, I'm actually grouping it and I'm doing the sum of all the values. I can also go ahead and do the mean similarly. Okay, so let's go ahead and do this. And this time I'll just take the mean. Okay. So based on every region and every product, I can also go ahead and calculate the mean. Okay. So here you can see in east there is 41.71, in north there is 4.450, in south there is 50.0. So all these kind of things are basically there. Okay. Now let's say I want to apply multiple aggregate functions. Okay. So aggregate multiple functions. So that also you can actually do it over here. So I'll just go ahead and write group underscore agg aggregate, and here I'm going to write group by operation df.group by. Let's say one of the categorical column. This time I will just take based on region. Okay. So this will basically be my region. And based on region, what I will do, I will take the value. Okay. I will take the value, and after taking this value, I'm just going to apply all my aggregated function, and this will be in the form of list, like mean, sum. And let's say one more aggregated function that I want to use is count. Okay, so all this operation I'm going to basically apply. Okay, and now if I go ahead and just go and open it, so here you can see based on east the mean is 42, north this much, south this much, west this much, and again based on the east sum is this much, north is this much, south is this much, west is this much. And count, you have all this particular data. So this was some of the amazing mechanisms of probably creating or doing some kind of aggregation function. Again, it's more about practice. The more you perform different EDA, you'll be able to do all these things. But just understand whatever things we are able to do in SQL, right? All the things we are also able to do it over here. Now let's go ahead and discuss about merging and joining data frames. Okay, so again, a set of operations that we can actually do with the help of merging and joining data frames. So let's go ahead and see some examples with respect to this. So guys, in order to understand merging and joining data frames, what we will do is that we'll go ahead and create some sample data frames. Okay, so here you can see with respect to df1 and df2, I have keys like abc, and keys are nothing but columns abd, and values are 1 2 3 4 5 6. Let's say I'm going to print this. Let's say this is my df1. Along with this is my df2. Okay, now you know over here is that these are my columns, right? Keys and value. Now can I merge a two data frame and on a specific key, and like I want to merge this two data frame, and here you can see one of the column is key, right? And it is, let's say there are some of the keys that are matching, and we need to merge based on this. Okay, so first of all, we will try to merge this data frame on the key columns. Okay, on the key columns. So here, what I'm actually going to do, I'm basically going to write pd dot merge df1 comma df2. Okay. Now, if you probably go ahead and see each and every parameters, right? So if I'm just going to merge df1 and df2, right? Here there are a lot of parameters. Let's say something like left on. There may be another parameter like on. So let's try one by one with respect to different parameters. So here I will just go ahead and write on. Okay. So I'm going to probably merge df1 and df2 in such a way that I'll use a specific key. Let's say that particular key is my key column. Okay. And the kind of join that I really want to do between this particular data frame is inner. So I will just go ahead and use a parameter called as how. Okay. So once I execute this, see the magic. So this is my key. This is my value 1, this is my value 2. So in my data frame 1, I had key value 1. In my data frame, I had key value 2. Now, based on a single column, I'm trying to merge both this particular data frame. So here, first parameter that I've given is obviously df1 and df2, the two data frames which is basically getting merged. And coming to the next one, that is on which column name, right? Column name is key, right? Because this is the column which is matching between both this particular data frames. Then how the join should happen. So obviously I'm going to use the inner join. Inner join basically means from the left hand side, from the right hand side, both will be basically considered. So here you can see AB. So if I go ahead and see based on the inner join, AB is matching in both this particular column, right? Both this particular data frame, AB, AB. Value 1, values are 1, 2. So value 1, 1, 2 is basically getting displayed. Value 2 will be 4, 5. So value 2 will be 4, 5. So this is how the merger is basically happen. Now what we are going to do, we're going to do this same merger on different join parameters. How? Let's say if I go ahead and do outer join. Okay. So here you'll be able to see both the data frame will be considered. So key value 1 and value 2. So matching key is nothing but AB. So that is the reason you'll be able to see both this particular data. But with respect to C, I don't have anything as in my data frame 2. I don't have anything like C key, right? So that is the reason it is basically showing you NaN value. And similarly in the case of data frame 1, when our key value was D in data frame 2, nothing was there in data frame 1. So here you don't have anything like D is equal to something. So that is the reason here you'll be able to see that the value is NaN. Okay. Now in outer join, both the data frame is considered and each and every rows and keys will be probably considered. It will be joined. If there is no value matching with respect to that, it is just going to give you a NaN. Okay. So this is also one type of join that we specifically do. The other join that I'm actually going to use is like left outer join. Right. Now in the left outer join, left data frame will be considered or given more priority with respect to all the keys that are available. Right. In df1 over here I've given left df1, and the right it is df2. So when I'm doing left join, df1 will be given more priority based on all the keys that is probably present. So here you can see AB, this value is getting matched, but with respect to C key, I don't have anything in my data frame 2. So that is the reason NaN value is basically given. Okay. So this is also one more example. One more join is there, which is called as right outer join. So here on the same key, if I'm doing right outer join, now right side data frame will be given more priority. So that is the reason you'll be able to see D's over here. Value 1 will be NaN because in df1 you don't have anything something related to key D. Right, in value 2 it is basically displaying 6. So here right side data frame is considered more important, and all the keys are basically taken over there. And based on that, whatever is matching from the left data frame, that is just written. If it is not matching, NaN will be given. Right. So these are some of the examples with respect to merging the data frame, and this will be very much important because whenever you work with any kind of data, right, you'll be able to see that hey, some or the other way we can really do a lot of data analysis. Okay. Now finally, there is also one more sales data that I've actually created for you. Just go ahead and try to do the same thing that we probably did it over here, right? Group by operations and all. You can practice it. I will be putting some kind of data sets over there in this particular material itself. So just go ahead and do some data aggregation operation like how I did product buy and all, right? You also need to calculate the average sales based on the product and all, right? So I hope you like this particular video. I think we have discussed a lot with respect to this, and more things we'll be discussing when we go ahead with doing EDA, right? So yes, this was it. I'll see you on the next video. Thank you. Hello guys, so we are going to continue the discussion with respect to pandas, and in this video we are going to see how we can read data from different sources by using some amazing inbuilt functions that are available in pandas. Now to start with, what I'm actually going to do, I've just copied and pasted this specific code over here. So here you can see I have imported pandas. I have imported from IO string IO, and here I've given some kind of JSON, right? So employee name, James email, job profile, and here is some list of details that I'm able to see, right? Like title 1 team lead, title 2 senior developer, something like this, right? I'm taking this particular data, and first of all, this data is in the form of JSON, right? Key value pairs. So what I'm doing is that I will take this entire data, convert into a string by using string IO, string input output, and I'm just writing pd.read_JSON. Once I do this, I will be able to get a data frame in this particular way, right? So here you can see employee underscore name, email, job profile. So here you're able to see this, right? And this is basically my data frame altogether since I'm using pd.read_JSON. Let me just go ahead and save this in df variable. So this is nothing but this is my df. Okay. Now the reason why I'm showing you this is that I'm just trying to show you that yes, if you have a key value pairs, then also you'll be able to read that and convert into a data frame, right? Now let's say I want to convert this data frame back into a JSON. So for this I will be using df.to_JSON again. So to_JSON, and I'll go ahead and execute it. Now, as soon as I go ahead and execute it, see the difference how this JSON is basically got converted, right? And here you'll be able to see initially we had something like this. Now you converted this into this kind of format, right? What is this all about? So here if you go ahead and see, here I'm not given any parameters. So there is one very important parameter which is called as orient. Okay, and by default orient will be based on index value, right? So orient basically means see here what it has done, it's taken this employee name as one key, then now it is taking 0:James. Okay, then it went to this email key, and now it is basically using the combination of index and but this particular value. So 0:James @gmail.com. Then finally you had job profile with 0:. So in short, when we converted this into a JSON, it is taking this as a column name and it is taking key value pairs based on the index number. Okay, if I try to convert this into JSON based on records, like if I use a parameter which is called as orient, and here if I just go ahead and if you probably go ahead and see this right parameter, let's see this parameter here, you'll be able to see this. Okay, I will just go ahead and write something like this, and here I will just go ahead and say orient. Now with respect to orient, let's say I'm going to basically use a parameter which is like index. Okay, so index is the default one, right? Same thing, right? So by default the index is that is getting applied over here is specifically with respect to this particular index value. Orient will be index. Okay, now you can also change the orient value to some other thing, and we will see what all values again we can probably match with it, right? And again you can also see the documentation with respect to to_JSON function in data frame. So now let me go ahead and copy the same thing and paste it over here. Instead of writing orient is equal to index, I'll go ahead and write orient is equal to records. Now you can see how we had actually given in over here based on records. Similarly, it is basically getting displayed, right? So here you can see employee underscore name, James, email this. So record by record, you'll be able to see in this particular manner. Okay. So this was some of the examples. Now what I'm actually going to do, I'll show you one more way of reading a specific data. So let me do one thing. Let me quickly open my browser. So here I'm showing you one URL. Okay. This URL you can actually see it is something like wine.data, right? And this URL you'll be able to see it is in comma separated value, like CSV format. So I'll take this particular entire URL, right? And I'll go to my code, and here I will just go ahead and write pd.read_csv, right? And here I will just go ahead and give my URL, and let's say that I'm going to say that, hey, don't consider anything as my header, so header will be none, right? So if I go ahead and just see this, right, df is equal to, I will be able to see this. It will take some time to read it, okay? Once it reads it, I will just go ahead and add df.head, and this is how my entire data set looks like, okay? So by default, since I wrote header is equal to none, it is just going to make the default column indexes by 0, 1, 2, 3, and similarly row indexes 0, 1, 2, 3, 4, okay? This was how to read a specific data from a specific URL if it is in the comma separated values. I can also convert this back into my CSV file. So if I go ahead and write .to_CSV, and let me just go ahead and write wine.csv. Okay, if I execute it, here you'll be able to see in my same folder location wine.csv has been created, right? So you can also convert back a data frame into a CSV file. Okay, now let's go ahead and see some more examples. I've already spoken about to_JSON with respect to orient and index. You can also do this. Okay, now let's say I have a specific HTML file. Now this HTML file, I'll just show it to you. I can also read data from HTML file. That is the most amazing thing. So let's say this is my HTML file over here. It is FDIC government field bank list. Now in this particular HTML file, I definitely have tables, right? And with the help of data frame, we can also go ahead and read this entire table also, or we can also read the content inside this HTML. So first of all, what I will do, I will go to my code. I will just say, hey, this is my URL. So let me just go ahead and define my URL. And now with this specific URL, what I'm actually going to do, I'll just go ahead and use pd.read_HTML, okay? And I'll give this particular URL, okay? Now, if I go ahead and create my data frame, okay, this will basically give me, so here you can see missing optional dependency LXML. So it is saying, hey, you need to install LXML. So let's go ahead and install this. There are some dependencies with respect to some of the libraries. So I'll go ahead and write pip install LXML. Okay, so I'll just go ahead and install this. So let's do the installation. Probably once I install this, it will start working. Okay, so here we have installed it. Now I think it should be working fine. Now I'll go ahead and read my HTML. Okay, again, it is giving me an error. Okay, I have to also go ahead and install HTML5. Okay, so these are some of the dependencies. Whenever you work with websites, you have to do this installation. Okay, so I'll go ahead and write pip install HTML5. I think now this is the live library. If there is any dependencies, again, it will be telling us. Okay, now I'll go ahead and execute it. Now I think it should not give us an error. It's still giving us an error because it is saying, hey, we need to also have beautiful soup 4. Okay, so let's go ahead and install this also. Okay, so I'll go ahead and install pip install beautiful soup 4. Once I do this installation, web encodings and all, so here you can see beautiful soup 4 is also encoded. Now I think it should work. So whenever you get this kind of errors, please go ahead and see the error, okay? And then you'll be able to see this. No tables found, okay? No table found in this bank list HTML. Let me do one thing. I think the URL has been changed or what? So this is my failed bank list. Okay, it is not HTML, it is this URL. Okay, so now let me go ahead and execute this. Now you can see if I go ahead and execute df, I'll be getting a list of tables. See, this is in this particular format. If I go ahead and write df of 0, so here I'm actually going to get my entire table. And this is how it looks like in the form of data frame. Okay, so here I've just shown you that how simply, if you have any HTML page which has tables over there, you can definitely go ahead and explore this, and it will be able to capture the entire table and it will be able to give it to you. Okay, now not only this, let's say I also may have a Wikipedia page. I may have some other things. I may have again, there may be different pages. Let me just show you one more HTML thing, okay, content, and here you'll be able to understand. So here, if I go ahead and execute this in this Wikipedia, you basically have mobile country code, right? So these are my tables that are present over here with respect to this, right? And let's say with the help of pandas, I really want to quickly go ahead and use all this particular data. Okay, so what I'm actually going to do over here is that I'll say, hey, this is my URL now, and based on this URL, I'll take up this entire country code, and now I'll just go ahead and write pd_read_HTML, and here I'm just going to give my URL. And one more thing that read_HTML has, one amazing thing, right? That is nothing but it basically also has some kind of match keywords. Okay, so this will basically be my URL, and it also has some match keywords. What does this basically mean? That let's say I want to match it with some main keys like this country. Okay, I want to probably match only this particular table. I don't want this table, right? So what I will do, I will just go ahead and write, hey, based on the country, let's go ahead and do the match. So here I'll just go ahead and write my match keyword like country, and I'll say, hey, I don't even want my header, so I'll make it as header 0. So if I go ahead and execute it, you'll be able to see that yeah, I'm able to get it in the form of list. So if I go ahead and take the first element of the list, so here is my data frame, and this is the same country we are able to get it, and it is able to do the match. Let's say I want the above table, I can do that specific match based on the keyword that I can actually use over here, and here you can see I'm able to get all the inputs, and with respect to this, I'm able to easily scrap the entire data itself, right? And one more type of data that you want to probably create, let's say you can also go ahead and use one Excel data. So here I will just go ahead and write Excel. Oh, this will be my sample underscore data dot xlx. Okay, so this data I will just go ahead and open it. If you reveal in this Explorer, and if I open this particular data, Excel file also I can probably open it. Okay, it is not opening it. Let's see. I'll just open this over here. I will open a file. Let's say here I go ahead and write name and age. I'm just creating it manually. So here I can go ahead and write name and age. Let's say here I go ahead and write Krish 32, Jack 34, John 31. Okay, and let me just save this. Save as, browse. Okay, I'll save it in my folder, data analysis with Python, and let me just go ahead and write over here as data.xls. Okay, and I'll close this. Okay, so here what I can actually do over here is that I will just go ahead and read this Excel file. Okay, in order to read this Excel file, I have to just use pd_read Excel underscore, and here I am just going to use that particular Excel file name, right? And it is nothing but data.xls6, right? The second parameter that I can give is something called a sheet name. By default, I have the first sheet over there, so it will be the first sheet name itself. So let me just go ahead and execute it. It says okay, no module open PyExcel. Okay, so when you are basically using read_excel, you also have to install this. So I'll go ahead and do the pip install this one. So the reason why I'm showing you all this error because this is for the first time that you really need to do, right? And when you're doing this, you may be facing some kind of error. Again, some error may come. So here you can see that I'm also able to read all these things, right? Now, one very important thing that I really want to show it to you after reading Excel, that is converting a pickle file. Now, what exactly is a pickle file? Okay, so if I go ahead and see what exactly is a pickle file, okay, pickle file. What is pickle file? Okay, if I just Google it, you can see that it is a process of converting a Python object into a byte stream, store it in a file or database, maintain state across sessions or transport data over the network. So let's say that I want to probably quickly go ahead and create some kind of pickle file where I do some kind of serialization. So this will basically be my Excel. I can also convert this into a pickle file, and I can also load it. So to_pickle is the function name that I'm going to use, and I will just go ahead and use my pickle file name over here, something like this. So if you go over here, you'll be also able to see this pickle file. It will be completely serialized. You will not be able to open this, right? And let's say if I want to quickly go ahead and read this pickle file, so what I can actually do, I can just write pd.read_pickle file, and they are all different files which you can definitely explore. It is up to you. And here I'll just go ahead and df.excel. Once I do that, again I'll be able able to convert that particular data into this. But at the end of the day, this pickle file will also be very handy when we are developing machine learning projects. There, let's say we have to probably develop the pickle file. There we basically train the models. We need to save it somewhere, so we'll also be using a pickle file over there. Again, along with this, as I said, guys, there are a lot of options. If I just go ahead and write pd.read, right? There's so many different options. Read pass, read SQL query, read table, read XML. So just go ahead and explore it. Anyhow, I have tried to explain as much as I could in this, along with the installation, the errors that we face, the HTML pages that we have actually read. So I hope you will like this particular video. I'll see you on the next video. Thank you. Hello guys, so we are going to continue discussion with respect to Python, and in this video we are going to discuss about SQL and SQLite. Now first of all, we'll also understand the difference between SQL and SQLite. So first of all, we'll just go ahead and understand the definition, what exactly it is, and I hope everybody knows about SQL, structured query language, and you may have also written a lot of code maybe in your company, even though you're a fresher, that you have that specific subject in most of your syllabus, right? So in this video, I'll be showing you how we can work with SQLite database, how you can connect it with the help of code, how you can insert records, how you can probably perform all the crude operations with respect to this. So SQL, that is structured query language, is a standard language for managing and manipulating relational databases, and SQLite is a self-contained, serverless, and zero configuration database engine that is widely used for embedded data systems, right? Now the basic difference over there is that SQL is completely a huge thing, right? It is a complete application over there which will actually help you to manage the relational databases. There you really have a lot of configuration that you really need to perform. It is not serverless, you need to probably set up that entire server and do everything. But the SQLite, which is a lightweight version of SQL, without any configuration, you can actually create this particular database and even store it in your local system, right? That is the reason it is widely used for embedded database system itself, right? So simple, it's just like a file. You'll be able to see that. I'll be able to store it in my local machine also. So first of all, by default in Python 3, right, SQLite comes installed. So in order to first of all import it, I will just go ahead and write import SQLite 3, okay? And for this, I will go ahead and select my kernel. Please make sure that you do that, and I'll just go ahead and execute it, okay? So this SQLite 3, we will try to probably create by using this particular library. We will try to create a database. We'll try to insert the record and do multiple things. So first of all, let's connect to an SQLite database. So we will first of all go ahead creating a database, right? And we definitely require that SQLite database. How to probably go ahead and create a database over here? We'll use the SQLite 3 dot connect. I'm just going to use this connect function, and then let's say I want to go ahead and create an example.db database itself, right? So this will basically be my connection over here, right? So if I go ahead and execute it, we will be able to see this will be my connection, and connection is not defined. Okay, I made some spelling mistake. Now it is fine. So this is nothing but it is a SQLite connection at this particular location. Let's see whether in my folder location this particular DB file is created. Yes, the answer is very much clear. Here you can see my DB file is basically created, and that is the reason, as I said, we'll be able to store this without any configuration. We'll be able to create it in our local system, right? So it will be very, very handy when we work with embedded system altogether, right? Now we will go ahead and create a cursor object, which will make sure that it will iterate to all the tables, rows. So that is the reason of we really need to create a cursor, right? So first of all, we'll go ahead and create a cursor, and with respect to this cursor, I will just go ahead and write connection.cursor. Okay, so this is how we basically go ahead and create it. Okay, so this is my cursor over here. So let me make the spelling right. Okay, now the first step is that we will go ahead and create a table. Obviously, we have created our database. Now inside a database, we really need to create a table. Now we need to create this particular table by using the same cursor object. Okay, so here in order to create it, we'll just go ahead and say, hey, cursor.execute, and now whatever is my command to probably create my entire table, that is what I'm actually going to use it over here, right? So you know the query, right? What I'll do, I'll go ahead and write create table. If not, let's say if not, I'll use if not exist, right? Let's say I'm going to go ahead and create my employees table, and this will basically be my brackets, right? Now with respect to this employees table, what I'm actually going to do is that first of all, I'm going to use ID, and this ID will be nothing but, let's say this is an integer. Let's say this is an integer. After creating an integer, I'll say, hey, this is my primary key. Okay. Along with the primary key, I have to make sure, see, at any point of time, whatever tables you specifically create, you really need to create a primary key. Okay. Then the next parameter will be name, and I will give a varchar. You can also write it as text, and this will also be not null because we really need to give this particular value at any point of time. Okay. The third parameter that we are going to give over here is nothing but age, which will be integer, right? We can also go ahead and write int, but right now I'm using integer, and then we'll also go ahead and write department, which will again be a text. Right. So this is my entire table information that I have with all the information over here. Now, if I want to really execute this, right? So I'll just go ahead and press shift tab so that let's keep the formatting very much simple. Okay. Here you can see this is closed and this bracket is also closed. Now in order to execute how to probably create a table, right? I will just go ahead and write, hey, commit, sorry. See, I'm already executing this entire thing, right? Cursor.execute, right? And then after this thing is basically executed, when this line of code is executed, I'll be able to see a table which is called as employees. And then finally, we also need to commit the changes, right? So committing the changes is very simple. I just have to write connection.commit. Okay. Without this, the committing will not happen. So if I go ahead and execute it, here you can see, hey, perfectly it has got executed. Everything is fine over here, and it has got successfully executed in short. Okay. And right now, if you go ahead and just execute again, right? So I'll copy this over here. I'll paste it over here. And let's say if I just go ahead and write my command, select star from this employees. Okay, if I go ahead and execute it, you'll be able to see that, okay, I'm getting an syntax error. Okay, now it should get executed. Here you can see that I'm getting an object. So some data is basically getting returned. That basically means I'm able to execute this particular command, right? After I create it, right? Don't worry, I'll be showing you how you can read this entire data that is available inside this particular table. But before that, what we really need to do is that we need to insert some data. So let's go ahead and insert some data. So for this, I will go ahead and write insert the data in SQLite 3. Okay, SQLite database or table, or I'll say table, right? And we're using that particular database, as you all know, that is nothing but example.db. Okay, now how to insert it? Again, I will be using cursor.execute. Okay, cursor.execute, and here I'm going to probably go ahead and write my insert statement. Right. So how do I insert records? So it will be nothing but insert into employees, and there are three parameters for the name, age, department. Okay, name, age, department, and here specifically we are going to use values. And with respect to values, I'll just go ahead and add my information. Let's say Krish, 32, and let's say I am a data scientist. So I'm just going to add this entire record over here. Okay. Now similarly, I need to insert some more records. So let me do one thing. Let me just copy some more records similarly, and we just need to execute this insert command inside cursor.execute. So here I'm adding Bob, engineering, Charlie, 35 in finance and all. Okay. And finally, I have to say connection.commit. So this will basically go ahead and go ahead and execute my, it will just do the commit of this particular code. Okay, so connection.commit. Okay, so here we are just going to commit the changes, that is basically the insertion. So if I go ahead and execute this, you'll be able to see that it has got successfully executed. Now let me do one thing. Let me just go ahead and execute this, and or if I really want to query any data, how do I query it? Let's see. So querying the data from SQLite 3. From the table or from the table itself, right? How do I query it? So again, what I'll do, I'll go ahead and write cursor.execute, and here I'm just going to use my command. Okay, what will be the command over here? Select star from employees. Okay, Now after executing it, once I execute it, I have to probably get the rows, right? So rows we can get it. I just need to use cursor dot fetch all. Okay, so fetch all is one function that we specifically use to get all the records from the select star command. Okay, once I get the rows, we can go ahead and print the queried rows, the queried data. Okay, so we can go ahead and print the queried data. So let's go ahead and print this. So I'll say for rows in row, sorry, for row in rows. Okay, we're just going to print the row. Okay, so once I execute it, here you can see in tuple format, I'm able to get Krish 32 data scientist, Bob 25 engineering, and Charlie 35 finance. So what all things we basically did, I showed you how to create a database, how to connect to a database, then how to create a table. If that table does not exist, also how you can create. And always make sure whenever you execute this kind of command, any crude operation that you're doing, you have to probably write connection or commit, right? Then here you can see inserting the data into SQLite. I've actually done this also. Okay, let's say that I want to update the data in the table. How do I do that? Okay, update the data in the table. Okay, so in order to do that, again, I'll go ahead and write cursor.execute. Okay, and with respect to this particular execute function, I will go ahead and write my update SQL command, right? I hope you're familiar with SQL, so I'll just go ahead and write it update employees. Okay, so this will be my function, that is employees, and here I'll say set update employees. Okay, now say set age is equal to 34. Let's say I'm going to set the age 34 where the name equal to Krish. So I'm going to basically execute this particular command. So wherever the name is Krish in the record, I'm just going to update the age from initially I gave 32. Now I'm actually going to give 34. Okay, so once I execute it, and again after doing this, I have to commit. If you don't commit it, guys, you'll get an error where you'll not be able to see the updated records. So here you can see unrecognized token. Okay, fine. Krish. Okay, where name is equal to Krish. So this is basically executed. Now I can again go ahead and print all these things, and here you can probably see I will be getting my row as 34. So this has also got updated. Okay, so we are just focusing on the entire crude statement, right? Where crude execution statements. I've shown you how to do the select, insert data, query the data, update the data. Now after this, I will also show you how to delete the data from the table. So let's go ahead and delete the data from the table. Okay, so with respect to deleting the data from the table, I'll again go ahead and write cursor.execute, and here I'll just go ahead and use multi-line characters so that I'll be able to execute it. So I'll go ahead and write delete from employees. Okay, delete from employees where name is equal to, let's say I go ahead and delete this record called as Bob. And here again I will go ahead and write connection dot commit. Okay, execute it. Bob where name, delete from employees where name, okay, capital where, okay, it should be fine, it should be smaller. Capital, delete from employees where name is equal to Bob. Let's see, it says near form, cursor.execute, delete from, okay, from, it should be from. Simple mistakes will definitely be there, so don't worry about it. Now, if I'll go ahead and print all my rows by just writing select star from queries or whatever data I have, you'll be able to see that I only have 2 records. Okay, so I'm not going to edit whatever errors I'm specifically getting, so that you should be able to see this entirely, right? Now, let me show you one entire project. So here I'll be working with sales data. Okay. Now, first thing first, what I'm actually going to do, I'll first of all connect to a SQLite database. Okay, so this is how you can connect it. SQLite.connect sales_data.db. This is my cursor. We'll create a table for sales data. Create table if not exists. Sales ID is there, integer, data text not null, product text not null, sales integer, region, right? And then after probably doing that, we will go ahead and insert some of the data, like sales data. So in order to insert, this time I've actually given this kind of list, and I've given all the values in tuples based on the 4 values, right? Whatever 4 values are, ID, integer. ID is a kind of a primary key, right? So here you can see date, product, sales, and region is basically given. So here are all my values. Now I will just go ahead and write connection dot commit. Okay, so we have inserted this entire records, right? 4 records. Now in order to probably get all the records, I can say one more thing, guys. Right now I should not be had executed this because I need to insert this entire sales data. Right now there are so many different records in the sales data. How do I insert so many different cells at once? Because previously I've seen about cursor.execute and we executed all the insert statement. Now I'll be showing how you can do the bulk insertion also. So for this I will be using cursor.execute many. Okay, so if I go ahead and basically write this cursor.execute many, and inside this I will use my triple quotes just to make sure that I write my query over here. So here I'm going to write insert into sales, and here the value are like date, product, sales, region, okay, region, values, and here I'll just give 4 question mark, 3 and 4, okay, and along with this 4 question mark, I know I have to replace this particular question mark with something else, right? And how do I do that? So here what I will do, I will just give it over here like sales underscore data, right? And this will basically be my entire sales data, which will get replaced it over here, right? So if I go ahead and execute it, and finally now I can go ahead and do my connection dot commit. Now I should execute it, okay? So connection dot commit, okay? If I go ahead and execute it, so here you can see all the insertion as may have happened. Now in order to check, I will just go ahead and write the same thing with respect to the. So here you can see all the records are basically there. I've just used select start from sales and all. Now if you really want to permanently close the connection, right, close the connection, that basically will not have access to any DB as such. So you can just go ahead and write connection dot close. This is the last statement that you can basically use. Okay. Now if you probably go ahead and see cursor.execute, if I try to execute this again, it'll give us an error. Okay, because we have closed the connection. Cannot operate on a closed database. See? So I hope you were able to understand all these things. Multiple examples. Quickly, I've actually shown you importance of SQLite database and how easy it was probably to create. If you are familiar somewhere with SQL or writing commands and all, I think you should be very much easily able to understand. Okay. So like how we have used execute many, right? Over here execute cursor.execute we have used. Here you can see execute many. You can also go ahead and write cursor.insert many, right? So there's also a method which you can go ahead and write out. So I hope you like this particular video. I will see you all in the next video. Thank you. Hello guys, so we are going to continue the discussion with respect to Python. Already in our previous video we have seen about SQLite 3. Now in this video we're going to talk about like how you can work with logging specifically in Python. Now logging is a very important concept whenever you're creating an end-to-end project. It is very much necessary. You have to probably log each and everything that is happening with respect to the execution, whether you're getting warnings, whether you're getting errors, everything needs to be logged some or the other way so that whenever we debug the entire application, we'll be able to see what kind of errors. If any error is occurring in the application, we'll be able to understand it. So in this video, I will be talking about logging itself. I'll be showing you like many different types of example with respect to code. And I hope by just seeing this video and afterwards when you follow the end-to-end projects, you will be able to understand it. Okay. So quickly, let's go ahead and now initially over here you can see logging is crucial aspects of any application, providing ways to track event, errors, and operational information. Python built-in logging module offers a flexible framework for emitting log messages for Python program. In this lesson, we'll cover the basics of logging, including how to configure logging, logging levels, and the best practices for using logging in Python application. So first of all, we'll go ahead and import logging over here. Now, whenever we basically import logging, first of all, we need to configure the basic logging settings. Okay, we need to configure this. Now, in order to configure it, I'll go ahead and write logging dot basic config. Okay, so basic config is a function, and here we go ahead and set a level. Right now, with respect to level, there are different levels. Like it is having debug, it has error, right? It has over here you can see error is also there. So let's say that since I'm developing the application over here, I'll just keep it to debug so that I'm trying to put this particular basic settings to logging.debug. Right? It's just giving an indication. Hey, I'm right now yet developing my entire application. So this is the initial basic logging settings that you really need to do. Right now, whenever I want to probably do a log messages, right? So I can go ahead and use different ways. So first of all, I will go ahead and use logging.debug. Let's say over here I go ahead and put a message. This is a debug message. Okay, debug message over here. Okay. Then similarly, I've used logging.debug. Here also you have logging.info, and here with respect to this, I will also go ahead and write this is an info message. Okay. Then you have logging.warning, warning. Okay. And here I will go ahead and write this is a warning message. Okay. And finally, here you can see I'll also go ahead and write logging.error. Right. We'll discuss about all these things, but these are some you can basically say logging message with different severity levels. Okay. So if I really want to use different levels, I can go ahead and use this. So I'll go ahead and like logging.error, and I'll go ahead and say this is an error message. Okay. Some logs I'm actually going to put. Along with this, I'll go ahead and write logging.critical. So critical is one more level which we can specifically use, and here I can go ahead and write this is a critical message. Okay, so once I execute this, here you can see that how it is putting all this information. So I have actually kept this logging.debug as my root level. So here you'll be able to see this is by default the date time that you'll be able to see over here. Then you have this debug first message. This is a debug message. Then you have info. This is an info message. So with respect to time, you're able to get all this information. So this is the default structure with respect to any logging message that is probably getting displayed, where you can use your date, your timestamp, and what is the root and what kind of level we are specifically using. Okay, so just one basic example. But if I go ahead and show you what are the different levels, so here I've actually written it down. Python logging modules has several levels indicating the severity of events. The default are debug, detailed information typically of interest only when diagnosis problem. So let's say we are trying to diagnose some problem, you want to put some kind of message after execution of some functions, or let's say within the function itself. Then you have this info confirmation that things are working as expected. So we basically use this kind of level in case of warning and indication that something unexpected happened or indicative of some problem in the near future. Okay, some of the example are like display slow, the stop, but you'll be able to see with respect to warning, the software will still be running, right? Your application will still be running. Then you have error due to a more serious problem. The software has not been able to perform some function, and critical, a very serious error indicating the program itself may not be maybe unable to continue running. Okay, now this is fine. Here we have done this. Now let's focus more on configuring the logging, right? So right now you'll be able to see by default I'm able to see some kind of date time over here and all these messages, but I can go ahead and configure this entire like how the logging message needs to be displayed. So for this I will go ahead and configure logging. Okay, again here I'm just going to write logging dot basic config. Okay, and now inside this basic config I can put different information. One is level. So let's say I'll go ahead and write logging dot debug. Okay, so this will be my first thing over here, logging dot debug. Okay, after putting this I also need to make sure that what format my date time stamp should be looking like. So I will go ahead and write the format over here, and with respect to format I will be using different characters over here. So let me just go ahead and show you. I'll use percentile. Okay, ASC time. Right, so I'll go ahead and write like this. This is my time itself. So the first thing you'll be able to see, right? Let me just go ahead and write this, and here you'll be able to find out all the information. Then I'll go ahead and write name, you'll be able to understand. Okay, then based on this you can actually go ahead and give your own format. Then this will basically be my level name, what kind of level name is there. Okay, with this S string, and then you have this message. Okay, I mean SSAG. Okay, fine. So this is what is the format I'm going to follow. Right now you'll not be able to understand what exactly this is, but let's see. Once we display the logs, you'll be able to understand it. Okay, so just for another 5 minutes. Then we're going to use my date format. In the date format, I will specifically want different dates. Let's say I want in year format, so I'll go ahead and write percentile y. Then I want month. Then I want day. Once I'm able to put this along with this, you'll be able to see that I'll also go ahead and use percentile h hour. This will be percentile m, and then you'll be able to see percentile s. Right. So this s is nothing but it is seconds. Okay, we are going to specifically use this. So I hope you're able to see this entire format, and this is how it looks like. Okay, let me just go ahead and execute it. It says logging has no attribute debug. The simple reason is that I have to use this as a capital letter. So this will be basically logging.debug. Now let's go ahead and execute it. So this is my logging .basic config. Now what I'm actually going to do, I'll just go ahead and take this entire message, different severity levels, and let's go ahead and print this. Okay, so here you can basically see that I have set up the level format and date format. Right now, if I go ahead and execute this, right? So I'm basically getting all this information, and I'm also getting the debug, and this is the debug message with respect to the display. Now let me do one thing, right? Because at the end of the day, if you're logging, we really need to save it in a file, or we probably want to log the entire logging details in a separate file altogether, right? So what I will do over here quickly is that I will just go ahead and create a file name. Okay, so for that I will go ahead and use a parameter which is my file name, and inside this let's go ahead and write app.log. Okay, now see the magic over here. What will happen? Okay, so I will just go ahead and write comma. Okay, so once I probably go ahead and write my file name, I will also go ahead and update one more thing that is called as file mode, and here I will say write mode. Okay, that basically means I'll go ahead and probably write in this app.log. Now understand one thing, guys. Once you probably do the basic config setting, you can see that I have actually done the basic config setting over here to logging.debug, right? And again, if I try to do the basic config setting, it won't work because previously we have done this kind of setting. So what I'll do, I'll just go ahead and restart my kernel. Okay, and now directly I'll go ahead and execute this message. Now, once I execute it, what is basically going to happen is that it is going to create an app.log file, okay? And inside this particular file, you'll be able to see that I will be trying to put some information over here, okay? This entire debug message that you're able to see, info, warning, error message, this all will be getting appended inside this particular file. So let me just go ahead and delete this app.log. Now you can see that I don't have any file over here. Now let's go ahead and execute it over here. So once I execute it, this has got executed successfully. If I go ahead and see, this is an app.log file, right? So here you can see this again. Let me just go ahead and execute once again. And now any number of log messages that I go ahead and write, right? It should be able to write in that specific file, right? So here you can see any number. Now based on the execution, whatever things you're specifically executing it, if you're just using this login.debug info warning and whatever message you really want to put in the logging file, you'll be able to put it, right? So this is how simple with the help of this logging functionality in Python, you're able to do all these things, right? And again, guys, you'll be facing an error or you'll not be seeing any logs if you execute this and you do not restart it. Because once we set up the basic config, unless and until the kernel is not restarted, we cannot change the basic config. And right now, I've actually showed you where I've written file name, file mode, and all everything as such. Now, any packages that you specifically use, you'll be able to do it. So let me just show you one example with respect to that type of flow. So let's say inside my logging folder, I will just go ahead and create my folders like this, logs, okay? And inside this logs, let me create my logs.py or logger.py. And this is how we are going to probably create it, you know? Now, with respect to logger.py, I'll go to logger this one. I'll go ahead and configure this entire thing with respect to my logging, okay? So once we go ahead and configure it, here you'll be able to see that I am just going to use apps.log. And again, inside this logs folder, only that folder file will also get created, okay? Now, let's say I go ahead and create my another file, which is like test.py, okay? And let's say inside this test.py, I go ahead and import, okay? Before importing, I will also do like this. So I'll go ahead and import, or I'll go ahead and write from logger, okay? Import logging, okay? So I'm going to basically use this functionality called as logging from this logger.py file, okay? And then now let me just go ahead and call this particular function. Let's say definition add, and I'm just going to create two numbers or a comma b, okay? And this will basically return, okay, a plus b, okay? So here I can just go ahead and write like this, and here I'll go ahead and write logging dot debug, okay? So debug will be my message. The addition operation is taking place. Okay? So this is just to log it in my app.log file, okay? So now I will just go ahead and call this, and now let's go ahead and call this function where I'm going to give my some values. Let's say 10, 15, okay? And here also I will just go ahead and put one more logger message just to show it to you whether we are able to track it or not. So logging.debug, here I'm just going to write the addition function is called. Okay, just to give you an example, okay? Is called. Okay, perfect. Now let's run this quickly. In order to run it, I will open my terminal. Make sure to go inside this path itself, right? This test.py file is available in 12th logging in Python. Inside that there is a logs folder, okay? So I will just go ahead and write cd 10th data analysis. Okay, this is data analysis. Let's see 11th working with data phase. Let's see 12th. Let's see which is the folder path. So 12th it is, okay? So here I'll say cd 12 logging in Python. And now let me clear my screen. And just let me go ahead and run this Python test.py. That is how we run, right? No such file or directory. Okay, I have to go inside my logs, cd logs, okay, cd logs. Now I'll go ahead and run it. So I'll go ahead and write Python test.py. So here you can see it has got executed successfully. I'm not displayed anything. But if I go ahead and see my logs, see inside this logs folder, app.log is created, and here you can see addition function is called, and addition operation is taking place. So this entire information along with this root, here you can see debug, right? Your date time, everything is basically getting created. Isn't it amazing? And this is the main funda behind the entire logging mechanism. But always make sure that in logging you have to make sure you have to put your basic config. And now after you put it in one file, you'll be able to use it anywhere just by importing it, which I've actually shown you. And just use the levels. You can use severity levels like debug, error, warnings, whatever thing you really want, and you can continue execution. So I hope you were able to understand this particular video. This was it from my side. And this was about logging. Go ahead and practice it. I'll see you in the next video. Thank you. Hello guys, so we are going to continue discussion with respect to Python, and in this video I'm going to show you how you can log with multiple loggers. Now what does this basically mean? You can create multiple loggers from different part of your application. So let me just show you one very simple example. So first of all I will go ahead and do the import logging. Okay. Now with respect to this particular logging, I will just go ahead and create a logger. Let's say I want to use only this particular logger for my module 1. Okay. Let's say any specific module that I'm actually creating. So this particular logger will be only for module 1. Okay. Now once I probably go ahead and create this right now, let's go ahead and write this particular code. Okay. So here you'll be able to see that I'll just go ahead and write logger 1 is equal to, and in order to create a logger, I will just go ahead and in order to create a logger for a specific module, I have an inbuilt function which is called as get logger. Okay, so logging.getLogger. Okay, so let me just go ahead and write logging.getLogger, and here I'm going to define my module. Let's say module 1. Okay, and then I will just go ahead and set my level also. So here I'll just go ahead and write logger1.set level. Okay, and let's say for my module 1, I just want to set it to logging.debug. Right, so this will basically be my logger for module 1. Let me just go ahead and create a logger for module 2. Similarly, I'll go ahead and create it for module 2, and this time I'll just go ahead and write logger2 is equal to logging.get logger, and this time I'm just going to use my module 2 over here. Okay. And again here, let me just go ahead and say that okay, here I'm going to probably set my level, okay, to my logging.warnings. Okay, logging.warnings. So here I'll just go ahead and write logging.warnings. Okay, so this you can see over here for module 1 I'm creating logging.debug, and for this I have logging.warning. So whenever I specifically want to use this particular debug logger, I can specifically call this, otherwise I'll be able to call this. Okay, then along with this I will just go ahead and do my basic config setting. So this basically becomes my entire basic config setting. So module logging has no attribute debug. The reason is very simple. I have to make this as a capital letter. Okay, and here we have already discussed about this. This is the basic configuration for the logging settings with respect to the type of message that we really want to display and the date format. Okay, now I will go ahead and log messages with different loggers. Okay, so whatever loggers you are specifically using, you can use it over here. Let's say I'll go ahead and write logger1.debug. Okay, then here I will, since it is already in debug, so I'll say this is a debug message for logger1. Okay, for module 1. Let's consider it this way. So I can use this direct message. In case of module 2, I only have to use logger2.warnings. Okay, so here I can specifically use warning. This is a warning message for module 2. Okay, so considering based on your loggers, right? Logger1.debug, logger2.warning, or let's say I can also go ahead and use logger2. In my module 2, I can just go ahead and write module 2 logger2.error. Okay, I can also go ahead and use this particular error, right? So this is an error message. So here you can see that I'm able to use this all modules and based on this particular module. Before it used to come as roots, right? So if you see my previous example, when we were creating the logs, by default it was coming as root because over here we're considering everything as one module. But here we are defining this particular modules. We can specify module 1, module 2, right? Based on the implementation that we are specifically doing. And this is how you actually work with can log with multiple loggers and based on your module of functionality that you're specifically defining, you can also do this. So this way I will be able to see my messages very much clearly and very much easily. Now in my next video, I'm going to discuss about one amazing use case where I'll be implementing logging. We'll try to create some application and then we'll also be implementing logging part. So yes, this was it from my side. I will see you in the next video. Thank you. Hello guys, so we are going to continue the discussion with respect to logging. Now, whatever things we have learned with respect to logging, including multi-logger, we're just going to implement a simple application and then we'll try to log some information out there in some specific file. So let's go ahead and let's do that. So first of all, this is my app.py file. So I will go ahead and import logging, and this time I'm actually going to do it in a py file itself, right? Now inside this, I will first of all go ahead and do my basic logging settings. So let's go ahead and do the logging settings over here. And you know how to probably do the logging settings. I have already shown you. So let me just take one of the example over here because again, I don't want to waste that entire time in writing the same code. And it's okay to do copy paste. So here I'm actually writing my level. So level will be logging.debug, the format, and specifically the date format itself, right? So all this three information is specifically there. Now one more parameter which we can specifically work with because I can also go ahead and write my file name where I really need to put all the login information. Along with that, this parameter I've not discussed it earlier, which is called as handlers. Okay, so here I'm going to define my handlers, and this handler will be in the form of list. First of all, inside the handler, I can go ahead and write logging.filehandler, and this will basically be my file name, right? So let's say app1.log will be my logging file name, and this is how I can also go ahead and put it. We can also go ahead and write directly file name over here, file mode over there, right? But here, with the help of handlers also, we can use this. So you just need to write logging.findhandler. Along with this, I have to make sure that whenever I get a logs, right, I need to probably keep on streaming and writing in this app1.log file. So for this, I need to also initialize logging.stream handler. Okay, so stream handler is one method which will be responsible in putting all the logs information inside this particular file. Okay, so this is my basic configuration setting that we really need to do. Now, what I'm actually going to do, I'll go ahead and create my logger. So inside this particular logger, I'll just go ahead and write logging.getHandler by name. Okay, so this, sorry, not get handler. Let me just go ahead and call get logger, right? So that if you remember, get logger will specifically be used to create a call my module, right? So for this entire project, I'm going to give my logger name right over here as arithmetic app. Okay, arithmetic app. So this will basically be my arithmetic app, and this is my module name, the entire module name. And with respect to this particular module, I'm basically using this particular logger. Okay, now let me just go ahead and create some add function. Let's say this will be a comma b, and here I'm going to basically write result is equal to a plus b. Okay, and now after probably creating that particular result, I can return that result. But before that, I will just go ahead and write logger.debug, and inside this particular debug, I can use my f string. Okay, and this will basically be me adding a and b, or a plus b, okay, and probably displaying this particular result. That is nothing but result. Okay, so this is what we are basically going to put in our app1.log file. Similarly, I'm going to do it for multiple things like this. So I will go ahead and I've written my code over here. So I will go ahead and do the same thing for subtracting a minus b result. Similarly, for multiplication, I'm just going to use this particular code. So here you can see return result a star b, and here I'm actually using a logger.debug. Along with this, I will go ahead and use divide function also. Now with respect to this particular divide function, I'm using a by b. Whenever I give my b input, I should also make sure that I use this division 0 error because I can put this value as 0. So whenever it probably comes, I'm going to write logger.debug with respect to dividing a by b. Otherwise, if this particular exception is caught, right, inside this try catch block, I'll go ahead and write logger.error. Logger is specifically the logger for this particular module. That is nothing but arithmetic app. Okay, and that is what we discussed in our multi-level logging, right? Specifically that particular logger, you can actually go ahead and use it. Okay. Now, quickly we will go ahead and perform this. So let's go ahead and write. I will first of all call my add function. So let's go ahead and call my add 10, 15. Let's say subtract 15, 10. Okay. Then we will go ahead and call our multiply operation 10, 20, and then we'll also go ahead and call our divide operation. This is nothing but 20, 10. Now quickly we will go ahead and execute it. So in order to execute it, I'll go inside this particular folder. So I'll do cd dot dot. Okay, and it is inside this particular folder. Please make sure you go in that particular folder before executing this. And now I'll go ahead and write python app.py. I hope so. It gets executed. So here you can see I'm getting some error. Logger debug a plus b result adding 5 minus 10. Okay, remaining all the arguments has been displayed, but here we are getting an error. Okay, not all arguments converted during string formatting. Okay, I can understand this particular error. Let's see. Return a plus b. Okay, now I think it should work. Let's see. Okay, so now again I'm getting an error message adding plus 10. First of all, let's go ahead and see whether the log is basically getting created or not. So here log is basically getting created, but the addition log is not happening. Why? Let's see the error. What exactly is the error with respect to add? Definition add, then I have adding a plus b. Okay, this was a simple error that I can basically use, and result should be in my another brackets. Okay, now let's go ahead and execute it. Again, f string is basically used over here. The reason is very simple, logger.debug, and here we will just go ahead and close this in my brackets. So this kind of issues will be coming up, so don't worry or hesitate about solving debug errors, right? Debugging is very much important. Now if I go ahead and execute it, now you can see all this message is basically getting displayed. If I go ahead and see my app.log, now you can see adding 10 plus 15, all this arithmetic app. This is with respect to my modules, right? And with respect to the modules also, you'll be able to see the message. Perfect. This looks really, really good. Now you can go ahead and create your own custom module like arithmetic app. Let's say in another file I want to create another module. You can create all the different loggers over here itself, right? Based on different modules. It is up to you. Okay. And then whether you want to use a debug or whether you want to go ahead and find out or probably display an error message, then you can actually do it. Let's say that I give over here as 20, 0. Okay, so here obviously I'm going to face an error, right? So if I go ahead and execute it, you'll be able to see division by 0 error is there, and here you'll be able to see that this particular error message is getting displayed, right, in my app1.log. So yes, I hope you were able to understand about this logging functionality. This is really important, really important for everyone out there. So please make sure that you keep on practicing it, and we'll be seeing more about it in the upcoming videos. So yes, this was it from my side. I'll see you in the next video. Thank you. Take care.
Hello all. So I'm super happy that you have completed this module on Python. Now Python is very important for starting a journey into any field, be it even data science, machine learning, AI or big data. And specifically for big data, the same is going to get used as we have used PySpark in our Spark modules. Now please make sure that you focus specifically on the map, lambda functions and the advanced concepts as they will be used more in big data. Along with that, please ensure that everything you are doing practically at your end as well. If you have any issues in setting up Python, make sure that you go to Google Colab and you're able to practice the same thing. But don't leave out any practical or don't leave out anything in between. As once you have this whole structure strong, it's going to be very much helpful in each and every field going forward. Now with that, I'm very happy that now you have your base set, and moving forward, we will cover about other things in this particular course. Hello all and welcome to the SQL module of this particular course. Now SQL is going to be a very important topic which we want that you cover as a part of prerequisite. The reason is that when you learn SQL here, the same will be used for interacting with your big data via the Spark SQL. And of course in Hive as well, though we use HQL, the same is very similar to your SQL. And if your concepts in SQL are a lot clear, the same is very much helpful. Now SQL normally as well is very important for an array of data related fields. So if you're trying to become a data scientist, a data analyst, or even a data engineer, you surely will require SQL. So please make sure that you cover this in a lot of depth. Do all the practicals. So when we will be teaching you, we will be writing the SQL queries. I want that you practice all those queries and get your hands properly inside the SQL understanding, as that will be a lot of help in many courses going forward. So with that, everyone, have a good learning journey, and let's meet in the next video. Hello all and welcome to the introduction to big data module of this course. Now I'm really sure that you have done the prerequisites which were Python and SQL before you're starting this module. If not, a very humble request to please first go and complete that. Now coming to this module, I have made sure that to start your big data journey, and for especially the learners who are completely new to the field, in this particular module, I am explaining you the basics and also the many confusion which you have regarding many terms and technologies in big data. So you will see that we will learn what is big data, then understand what are the 5 V's, how on-premise is different with cloud, then talking about the ELT versus ETL process, data warehouse, data lake, and database. Along with that, if let's say what is the difference between or what is the work of the data engineer, right? And that is like where exactly the big data will fit in. So all these things everyone we have covered properly in this module, which will give you a very good holistic idea that what exactly is the work of a big data engineer. And with that knowledge, you will be properly equipped to start with understanding about big data technologies. So I really hope that you have a good learning journey, and please make sure to cover each and every module. You will be able to get the handwritten notes as well, so make full use of them. And I will meet you in the next video. Hello all and welcome back. So in this video, let us now start and understand what exactly is big data. Now, to understand big data, you can actually search on the internet and see there are lots of definitions, lots of places where it has been explained to you. But the approach which I'm going to follow will actually be based on my personal experience. So when I just started my career and did my first internship in 2018, right, at Oyo Rooms, I was given with a problem. So the problem was pretty easy to understand if we see with respect to data. Whenever you used to make a booking on your phone, you used to get a message. So on your WhatsApp, basically, you used to get a text message, and in that text message, each and everything with respect to your booking, with respect to what is the time, what is the date, so all these details were written. Booking, time, basically the check-in time, dates, day, and everything was written. And you have to reply whether you want to confirm or cancel the booking, right? So you have to either write yes, no, the same in any other language, or you can reply with actually anything. Now, back in 2018, there was no click or basically options in WhatsApp, right? So we have to rely on what the user is saying. Many times, of course, there used to be a spelling mistake or the intention mistake in the reply. Though my aim was to make sure that whatever reply the user is giving, I am able to tell whether he wants to accept, that is confirm, or cancel the booking. So majorly transformed into a machine learning problem where based on previous data and what exactly user did, I have to tell if he wants to confirm or cancel the booking. Now, if you just forget about the problem for the time being and just focus on the overall data part, the data in this particular example or the problem is actually pretty straightforward. I was handed over a RDBMS system. So an RDBMS system, that is something which we have learned now, a SQL based system, in which, of course, by giving any query, I was able to get that, hey, what is the reply or what a particular user sent for, let's say, this particular date, whether he actually confirmed the booking or canceled the booking, was he was he there on the hotel if he confirmed the booking? So all that was pretty good. It was all in line with what I have learned, and the data was, of course, pretty small to handle, right? So from a single table, using the SQL queries, I was able to get the data, and all was good. I was able to do the project. Now, when I started with my second project, and of course, many projects which I also got in my Goldman at my time at Goldman Sachs, there I faced a difficult problem. In the second project, which was provided to me, which is easy to understand in Oyo Rooms, I was actually asked that, so I will write the second project as Delhi 2x. Here we were actually provided with a very varied task. That is, I have to understand each and everything about the user behavior and then basically try to increase the conversion at Delhi level. So right now, let's say there are 100 bookings happening in Delhi. Okay, I have to make sure that by let's say showing relevant hotels, by improving the app overall quality of recommendation in application, I have to make sure that user books more and more. Right. So for that again, I have to this time analyze lots of things that what exactly or how exactly are they happening. And this time, I have to actually get the data from something known as Google BigQuery. Right. So this time I was asked to get data from Google BigQuery. Now, when I asked my mentor and tried to understand that why exactly is that we are not able to store this kind of a data in a traditional RDBMS system, I was actually exposed to the world of big data. Now, for this particular problem, I of course have to understand lots of things, right? So, what exactly, how much time user is spending on the app, how much hotel is he viewing? So, for example, let's say if we have hotel 1, hotel 2, and hotel 3, and let's say he spends some 2 seconds here, then let's say some 3 seconds, and here he is spending let's say 0 seconds. Then in a way, I'm able to get or able to capture, right? That the first two hotels are the one where he's more interested. Then again, all these things with respect to hotels that okay, what are the images which are shown for a particular hotel, and all these total information. Also, I have to make sure that I'm able to incorporate into my model or while doing my analysis. Now, if we think about the scale of this data, and when I'm talking back in 18, OYO of course was on the verge of becoming a unicorn. So it was handling thousands of hotels. Now that I think it's hundreds of thousands of hotels. And each hotel you can think that okay, how many bookings are happening, how many users are there, how many images will be there for each hotel, its breakfast, and all these things, right? So for this particular use case, the data which was stored, it was not actually stored in traditional RDBMS system. And to understand that, okay, why was that not the case? And why was data stored across multiple places and in something which is not RDBMS? We have to understand a major property about RDBMS. So RDBMS systems are fine unless your data starts increasing in size. Whenever we are dealing with small size, right? For example, in the WhatsApp data part, I don't have any issue. All was good. I was just having some text which I have to store, and easily I can store that. Now, with respect to storing, even let's say if you're storing GBs or even TBs of data, you are fine by using RDBMS. But the problem happens when the size starts increasing and when you have to also work on that data, or when you have to process or, in a way, do some operation on that data. So that is what the case was with this project and with the amount of data which we were handling. Now, just to give you a little bit more idea, because many of you might be thinking that why is this a problem, right? We can always do vertical scaling. We can always add more storage to our databases and make sure that you are able to store more and more information. So think of, let's say, a DB. And we can maybe take Oracle DB here. Here, the database properties and the storage is separate. So in a way, you can keep on increasing the storage. So let's say anytime you feel that okay, your DB has full or your DB is full with all the data or information you have stored, you can basically add more storage. Just like you can get your overall, I would say, hard drive expanded in your lab. Now, the thing to understand is that again, there are many challenges here as well. The very first challenge, right, is that of course there's a limit on how much can you increase. Just like in your laptop, there's a limit to the RAM, to the hard drive, your motherboard, or normally your system will support. There is of course a limit on which up to which you can expand your storage, right? The second thing, what the second problem is, as the data increases, we have to make sure that we are partitioning or dividing our data, right? So as the data increases, we have to partition data into tables, right? So just to explain you, with respect to OYO rooms only, you can think that how many tables were we dealing with. So there was users table, then there were booking table, then there were table for hotel, then there were table for views. So let's say which user is viewing which hotel for how much time. And as you can imagine, all these tables were increasing with time, right? So it was not that the users or any of these tables was stagnant. They were increasing heavily with time. And thus, whenever this kind of a thing happens, now let's say if you have to do some operation, as long as the table or the data is small, it's all good. You can get maybe, let's say, for example, if I want to get that, hey, for this particular user, how many hotels has he viewed or what are the different bookings he has done? All is good when the size is small. But as the size increases and it becomes large, it tends to fail. So just as an example, let's say if you're trying to make a join with the lakhs of users, okay, with respect to their views or with the hotel to get, let's say, the information, this query or this operation is going to take a lot of time. And of course, as this time will increase, you are more susceptible to failures, bad user experience, and everything. It will never happen that you will go to Amazon and let's say in your my order section, it's showing you all the orders in 10 seconds, right? So all is good, but as the data starts increasing, then again we have to make sure that we are able to partition a table, and operations when we do on these large tables, they are very time taking. So that is the very big problem as well, and I will write down as well. With large data, operations are slow or susceptible to failure. Now moving forward, many of you, like, there are a few things which we still try that we can do for, let's say, the logical partitioning of the data across DBs, or let's say if you're trying to store everything, okay, we can store each and everything into a single table. But there are many problems. One of the problem which we can think of and we faced was that for images, right? So for hotels, we used to have the images which you see on any platform for that matter. Those can be stored on a RDBMS system, on a SQL system, but you cannot process from them. And along with that, when you're storing these kind of, let's say, data, which can be, let's say, some images or some videos, again, they are very much high in size. So your traditional RDBMS system fails very badly in such use cases. And that is why something known as NoSQL databases are basically used, which we are going to learn later in the course. But I'm pretty sure the problem is clear, right? And the third and the last one is that, again, they are very costly. So using these storage, which is the RDBMS system, for such high level of data, it's for such high volume of data, it's going to be very costly. And in current scenario or current age, each and every company, the data is increasing exponentially with time. For the last 3 years, last 5 years since COVID, we have actually generated almost half the data of the world, right? Because it is actually increasing exponentially. And storing on these systems, it is very much costly. So we have to make sure that we are able to come up with a much, I would say, cheap or at least efficient, cost-efficient system. Because along with storage, we have to make sure that we are doing some analysis and using other things as well for on our DB. So these were the major problems which I faced, or which I understood when I was given with this particular project. And that is where I was now, in a way, exposed to big data. I understood that, okay, why big data might be needed. Because of all these limitations or shortcomings, in a way, we were shown that, okay, we have to use something known as big data. Okay, so let us see now what exactly now do we mean by big data. So if we see the definition of big data actually refers to the data sets or the huge volume of data that are too large, fast, or complex for traditional databases to process efficiently. Now, with this particular example, the way I have shown you from my professional journey, I'm pretty sure that you must be able to understand or get that what exactly is big data. So instead of definition, I want to make sure that you understand this thing. In the today's world, the way data is getting generated, the speed and the different types, and all these other things which we are going to discuss in the next video as well, that is a lot difficult for traditional databases to handle. So big data is the name of problem and the solution or the technological solution which we will be learning again throughout this course, which is given. So big data is both the problem and the solution, right? So let us now understand why did big data emerge, like why did big data actually came into picture, what problem or what was the overall, I would say, running for that we want big data. That is the growth of internet for sure. As the internet started growing, lots and lots of data started getting generated. Okay, and because of that, we need storage. We need to make sure that we are processing that data. We are able to get insights from that data. So all these things are majorly the I would say, catalyst for the requirement of big data and why this field is increasing in today's world as well. The second again is the use of social media or the penetration of social media. So Facebook, Instagram, TikTok, all these social media, if you think about it, and even YouTube for that matter, they are generating data at a very vast scale. Images, photos, posts, each and everything they are supporting. And you can just imagine that at what scale we are dealing when they are generating data every day. And the last one is of course proliferation or the entering of data capturing and IoT devices. So if you would have seen around you, lots of devices have also gotten smart. They're also taking in lots of data, be it your smart switch, your smart bulb. It regularly takes in the temperature and then see if it has to get on. Basis of that, then your car is actually also now becoming a lot smarter. It is taking different, it is remembering all the routes. It is able to basically now in the way where it is generating and capturing the data as well. Okay, so that means that shift to big data was actually driven by the practical need of our. So because we were generating so much data, we have to make sure that we are able to cater to problems which we face due to that. One example, you can think of companies like Amazon and Uber as well. So in Uber, if you think about this, each and every time you are also moving, your driver is also moving. Okay, but every second the data is getting generated about your updated location, about millions of users, about millions of drivers. This data is getting generated, and in near real time it is getting processed. Right. So all these things are very very important to understand, and this is where, or this is what exactly big data is. It is the solution, like the technological solution. Those technology also came under big data, and the problem is again big data as well. So these systems deal with massive amount of data. Okay, every second something which our traditional DBs or technology were able to handle. And in this course again, we are going to make sure that each and every of those technologies we are able to understand, which will make sure that in a real life or a practical use case in any company, how can we come up with technological advancement or process to handle those data. Okay, so great everyone. Pretty sure that now you must have a very good idea about big data, not just the definition, but from a practical viewpoint as well. So in this video, first I told you about how in the first project I was just dealing with the text data and the normal RDBMS system was able to cater to that. But in the second project and subsequent projects which I did in my experience and overall the way world was evolving, the volume, the type, the speed at which data was getting generated, it was a lot fast. And we have to make sure that we have the technological advancement or something to cater to its use cases. Based on that understanding and seeing the problem which traditional RDBMS system have, we understood that okay, now what exactly big data is, okay, what exactly are the technologies in big data, and how or where the need about your big data emerged. Right. So in the next video now, we will continue our discussion and try to understand what are the different characteristics of the big data or the problems in big data. Hello all and welcome back. So in this video, let us continue our discussion on big data. And now let's try to understand what are the 5 V's which help us to define or understand our big data. Now you will listen this at many places and we will try to understand these 5 V's with example, try to bust some myths and also see that how given a problem, you can actually understand if it follows or if big data will be helpful or not in that particular problem. Now first to understand the 5 V's of big data provides a framework for understanding the challenges and characteristics of big data. Okay. So the very first one is actually volume. They're not ordered in any case, but normally we see that the first one is volume. And in a very simple way or in a very simple manner, volume is the size of data getting generated. Now, if you just think about this, of course, the overall volume or the size which you are generating in some way will handle or will determine if you should move towards a big data problem. To understand the same, you can even also think of, let's say, some grocery chain or something, right? For that grocery chain or let's say for a normal shop, if it is small, if it is just handling very basic, I would say, day-to-day activities, a traditional system like notebook or even a small database can work, right? But the second it expands, the volume increases, something akin to, I would say, Amazon store or something, then the system fails and we have to make sure that all these can be handled in a very efficient manner. And for that matter, only big data technologies are used, which can store and process the data across many servers or warehouses, something which we will see and understand better. Okay, so that is the major, I would say, use case or major understanding about volume. Now, just to clear some myths there, many people think that volume is the only thing which kind of determine if your problem is a big data problem or not. And many times in an interview, you will be asked that, hey, what should be the volume which, let's say, make problem a big data problem? Now, the question in a way is not right. The reason for that is it depends from company to company. So some data, let's say 30 GB, which might be bigger for a startup, might not be that big for, let's say, a particular company, say Amazon or Google. Okay, they might have systems who can very efficiently manage that level of data, which a startup or some small company is facing issues in handling. Hence, they have to move to big data. We will also understand the format and everything in the variety part. But based on that, just to give you an idea, it may happen that the kind of data, let's say, for example, Netflix is handling, that might be the movie data, though it is bigger in volume, it is not that big of an issue to handle that. Whereas, let's say, a similar kind of a table structure data, maybe that is less in volume, but due to the complexity, we might have to resort to big data solution to work on them. So this all is to make sure that myth which is there outside that some volume or after some volume we have to shift to big data technologies, that thing is wrong. So don't ever fall for that in any interview. You should make sure that you're able to explain the same properly. Okay, great. So now let's move to the next one, which is known as velocity. Now velocity is basically speed at which the data is getting generated and need to be processed. So speed at which data is getting generated and needs to be processed. Now, here as well, I think this is a little bit self-explanatory, but I would like to just give you lots of examples here. Majorly, in many problems, speed at which we have to process the data or the way it is generated defines what stack we will be using, like what technology we will be going forward with, right? So, just a very good example, and let us now divide it as well. So, maybe just let me say it in 1 minute. Yeah. So, myth, 1 minute. Volume is not the only factor and no specified limit. Okay, so this is the myth which we have to remember. Now, coming back to velocity, everyone, the first one is real time. Okay, now let's say if your use case is one where real time you have to process the data. A very good example for this can be whenever you're making some transaction via your credit card or from your bank. In the real time, it has to send you the message. If it feels that, let's say, it is a fraudulent transaction, it has to stop that and alert you in, I would say, matter of seconds. Let's say if your credit card is used for some online transaction, then it cannot wait that hey, after 5 minutes or 10 days, I will just let the person know that some transaction was basically made. The second one can be, so let me write down these as well, so you can remember them. credit card or bank transaction. The second example for that can be your live feed in all of these apps such as YouTube, Instagram, your Facebook. Just to show you an example as well, everyone. Let's say this is incognito tab. So we are going to go to YouTube here. Once I go to YouTube, right now it's just saying that try searching to get started, right? So nothing is there. If let's say I search for NBA, normally I'm searching for basketball. Let's say I open this video. And now if I just go back, okay, you will see that many of these things, right, in my feed, it has updated instantly. Okay, and it is showing me the videos along with the generic one which might be working in my area. And basketball videos are also buried into that, right? So you can see the same everyone. This is a basketball video. And if I just scroll down, this is a basketball video, and some other videos which might again be common in my area and all that. But majorly it tried to learn that yes, I opened some basketball video, and it is showing every like third or fourth video based on that understanding. See, this is a basketball video, and you can see that how real time it is, right? So it is not that it got updated after some minutes, some 5 minutes or 10 minutes. YouTube to provide a best, I would say, user experience. Okay, it has to make sure that it is so fast that it is almost real time. Okay, the next one is something which is known as batch, everyone. So batch. Here you can think of, let's say, your credit card bill. So for a transaction, though it's a real-time entry, your credit card bill you receive once a month. Now, what happens when you receive your credit card bill? The companies, they are actually running some jobs, they have the pipelines. And this is actually where the major work of, I would say, a data engineer come into picture. He have to make sure that he's defining those programs, those pipelines, where the data will flow. And at a specified time, right? It can be every day, every month, even every 5 hours or so. The code or the everything is going to run and then produce you with the output. In case of credit card bill, the same is happening monthly. Okay. But it can also be the case that let's say someone is generating daily reports, bi-weekly reports, maybe let's say 12-hourly reports, all that come into the picture of batch. Data engineer, the way they define the pipeline, the way they work on this, all this comes into this batch processing. And the middle one of all this is near real time. Now in near real time, what exactly happens? It's in between. So data is let's say coming out continuously, but we are taking some time to maybe let's say update. So what happens here? Data is coming continuously, but we are processing in say 2 minutes or let's say 5 minutes. So many apps they actually work on this way where they are collecting your data at a real time. Like data is getting processed or sorry, data is getting generated real time. Every like it is getting continuously generated, but they will take the time and let's say in 2 minutes or 5 minutes they will update the same. Many of your let's say when you do a bank transaction in your app, maybe it is not shown just that you will get the message, okay. But basically what happens there is that it will take a 2 minutes delay and it will show the balance updated then. Then again in many apps like Flipkart, Amazon, maybe once you do the payment status maybe kept on hold and it gets I would say updated after a minute or okay. So that's another example and that is what velocity is basically in your data problems. Now you can of course imagine that based on this, right, what kind of velocity you are dealing with in terms of generation of data as well as the processing. It will have different technologies or different, I would say, things which you will be working on using for your data. For example, for real time, there is Spark Streaming, Kafka. Then for batch, you can use the normal big data and Hadoop as well as other technologies. But yes, it will have an effect on what exactly you choose in the end. Now, the next one is something known as variety. Variety simply means that data can actually be in different forms. Data can be in different forms. And we have to deal with all of them, right, everyone? So with the advent of internet in the past 10 to 12 years, I would say majorly, you will see that data now is getting generated in lots of forms. So just to take an example of an app like let's say LinkedIn or let's say Instagram, it supports your videos, it supports your images, it is also showing all of your data for your profile, like your number, your name, all these things are also getting basically stored. So now a single application or a single website is actually dealing with lots of data. Now again, many use cases are there where such kind of things are not there. Like for example, let's say a normal banking application, maybe they're just dealing with your information. So it is a table level data. So the understanding is that based on what we are dealing with here, this is also one of the characteristics which will help us to choose whether we should be going towards big data technologies or not. As explained in the last video, your RDBMS system, they are very good for, they are like I would say good for storing the tabular form of data. Okay, they can still store the unstructured kind of a data as well, but when it comes to your processing, that is where they can struggle a lot. So we might have to go towards different technologies. Now to understand about variety a little bit more, it is also further divided into structured. So structured is pretty straightforward. It is having rows and column, tabular kind of data. So rows and column, just like the data is stored in your SQL DBs, where the overall I would say the schema is defined, right? We are able to say that okay, this is what the defined schema will be. We will discuss and see more and everything of this format, but let me also give you an basically show you by an example. So let me just make this image small. Okay, maybe we can delete this one, and this I can just 1 minute. So this again is a very straightforward example of your structured level data. Then the next one, which we normally see, is semi-structured. Right, so all your JSON data, XML files, this all come into your semi-structured JSON, XML, then your CSV. These are all what form the semi-structured data. Let me show you an example of this as well, as many of you might be not familiar. So this actually is an example of your XML structured data. Let me just make it a little bit more small. Yeah, so you will see that it is following some structure here. Okay, my bad, seems like there's a bug in the app, but should be fine. Yeah, so this is your XML kind of data, everyone. Now similarly, JSON, I think many of you will be aware. This exactly is your JSON level data. Great. So some issues there with the moving of the images, but that should be fine. So as I was saying, this is your JSON level data. This is your XML. Now the thing to note here is that it is having some overall structure here, but it is not as structured as your tabular data. So it is starting with university, student ID 1, student ID 2. This is some kind of information the way it is. It is structured in some semi way. Similarly for your JSON, you have this customer, then gender, all these information are present. Items, then all the information about items, more subnesting, all these information is there. The overall thing is that it is still readable. You can still make sense of it, but it is not as structured as your table will be. And the last one is actually something which is known as unstructured data. So let me just write it down. Unstructured data. Unstructured is basically the kind of data which we as human cannot read. So lots of examples are here in front of you. So yeah, these are all the unstructured data: text files and documents, video files, emails. So basically, the way they are stored is completely different, right? You cannot like if you will see the video file, it is normally again the data is in form of zeros one, and the way it is stored, it might not be that straightforward, right? So unstructured data is something which has been increasing, and that is also which we have to handle. In this course, again, as we move forward, we will discuss and see more and more of the example. In the projects, we will also see that how we can deal with each and every of these kind of data. Right now, we just have to make sure that we get what exactly it is. Okay, cool. So with that, I hope the three V's, the major three V's are clear. That is your volume, variety, and velocity. Now let's move to the next one. So the next one is something which is your veracity. So veracity in a very simple terms mean the trustworthiness or quality of your data. So what can actually happen is that our data can have issues. Let's say if we are collecting some information about students or employees in a company, then we can have some quality issues, right? So we can have a case where the problem is that, so the problem is that age is negative, right? In a similar manner, our data can be very messy. There can be very much quality related issues here, which we need to handle. Okay, and this also forms one of the characteristics of our data. Our data should be right. Okay, we cannot have wrong data and then see that, okay, what exactly are we handling? We should trust the overall source of the data. And that also forms one of the major characteristics which will help you to define what kind of technologies which you will be going forward with. So in a very simple manner, the reliability and accuracy of your data is known as veracity. Now, bad data of course will leads to bad decision. So the solution for this is that data cleaning and validation processes should be there to make sure that the information is correct. If your age is negative and you are using some let's say technology, you're not handling that beforehand, then it's again not going to be helpful and going to give you bad decisions or bad results, right? The last one is the value. So value basically means that ultimate goal of any data is to make sure that it can help you with the business decision, right? So data should have or provide some value. It should help in some business decision. It should give some insightful information, right? So let me write that down. Data should be or should have or provide value or insights helpful in making business decision. So the major aim of any data basically is to help you finally provide some value. So that is where this fifth V, the value V, comes into the picture, right? So we have to make sure that the data which you're collecting that is not meaningless. Okay. So big data technologies, for example, they help you to turn raw data into actionable insights. But the data should be or should have rather some value which we can extract. You cannot say or you cannot feel that hey, I'm just having lots of data, the volume and everything is there, so I should go with the big data technologies. Well, you should also see that yes, that those data it should be helpful. It should be providing you some value before you make that decision. Okay. A very good example is that let's say by analyzing the sales data, we can realize that okay, what exactly is working. Okay, it may happen that people are buying iPhones just around the salary day or when the Black Friday sale is there. Now all these are valuable insights which we can get from our overall data, and thus the data should be providing some value. It should not be a meaningless or basically the data which is just filling up the space or does not have any insights or actionable insights which we can extract. Okay. So yeah, these were the major 5 V's, everyone. I have made sure that I'm giving you examples and explain you properly. This is more than what you will have to understand to even explain to anyone. Just to quickly revise, we understood that okay, what exactly are these 5 V's? They help you to understand the challenges and characteristics of big data. First one is volume. Please make sure that with this myth, right, that volume is not the only issue. Okay, different company can have different size based on the problem which they are dealing with. The next is velocity. The next is variety. We have the subtypes here, or I would say different kind of velocity, the real time, near real time, batch. In this course, again, we will be seeing how we will be handling each and every of these types via projects and technologies. The next is variety, how to handle different kind of data. You have the examples right in front of you, and you will be getting these notes as well. And then finally, we have veracity, that is the trustworthiness or quality of our data, and finally the value. So these are the 5 V's, everyone, which help us to define or understand our data better, and then see which technologies we can use. Okay, so cool, everyone. I hope this is clear. Now let's meet in the next video. Hello all and welcome back. So in this video, let us now continue our discussion and now let's see that how are we going to handle the big data problem with respect to the system configuration. Now in the last few videos, we have tried to understand what big data is, how traditional technologies or systems are not able to handle the big data problem, and along with that, we saw that how the 5 V's can better able to help us understand or define the challenges and characteristics of our big data. Now moving forward, now I want us to focus that once we know that we have a big data problem at hand, how are we going to handle or work on the same? Now we already know that traditional technologies are not able to handle big data problems, and in some way or other, the complexity in the data is increasing. The same can now be with respect to say the volume or the velocity or say the variety, right? To better able to grasp the same, I would like you to think of in terms of let's say some app or some game, right? So maybe what we can do is we can think of a very common game or successful game which is GTA, let's say version 3. And then there was one which was introduced sometime back which was GTA 5. Now both of them are games, but GTA 5 have some overall complexity due to which it requires a stronger PC or a laptop, right? Similarly, many apps are there which demand that your overall configuration of your phone, right? Or let's say overall your some operating system or resources should be met so that they can run. As an example, WhatsApp, which is another very common application, it might now not run on some very old, let's say BlackBerry phone or some phone which is running iOS 8 or 9 version. Now, it is just not the problem with respect to the volume, right? Again, to make you understand that just volume is not at play here. But due to the increasing complexity, somehow we need resources one way or the other, right? So, as the data is increasing in terms of complexity, size, variety, we know that somehow in our system, we need to have more resources. Now, in this course, and let me write this down as well, when the complexity or size of our data increases, we will be needing more resources. Now, I would like to discuss a little on this resources because it's going to be a lot important and something which we will see and mention a lot in this course. So when I talk about resources specifically, I meant three major things. So the very first one is going to be your storage. Now, storage, all of us know that it can be in forms of hard drive, your SSD, CD, any other or any way you can store the data. The second is going to be your memory. When we talk about memory, it is majorly your RAM in play here. So with memory, we have the RAM. So if you're trying to basically process anything, then we keep that in the memory, right? So in your laptop as well, you might have 4 GB or 8 GB RAM. And the things basically which are getting worked on, they are stored in the memory. And the last one is going to be performance, where we talk about in terms of cores, like how many, or whenever let's say you're doing some compute or operation, right? So these are the things that can help you in that performance. So CPU cores we normally have, right? So even when we go to a market to buy a new laptop or a machine, we majorly for the performance part see on these three things, right? For the resources, that how many space it has, okay, that is the hard drive. Second is that how much memory it has, okay, how much RAM it is having, and the cores. So we see that we have the configuration such as 4 GB RAM, let's say quad core processor or octa core processor, and let's say 1 TB hard drive, right? So these are the resources which we will be talking and using a lot once we understand and work on big data problems. Now, let us move forward and see what are the choices we have when we say that we are now working on a particular problem, right? So the very first thing or the very first choice we have is something that we will have a single system. So a single system will be there on which we might try to increase the resources. A very common use case. Let's say if you have a laptop, if you have your laptop and it is showing that the storage is full, you can go to the market and get the storage upgraded. In a similar way, if let's say your laptop is having the RAM, you can go and say that hey, the 8 GB RAM is little less. I want 16 GB RAM, so that the performance or overall resource gets upgraded, and you can handle the same, right? So this kind of a system is actually known as monolithic system, where we have a single system. So let me just try to show you via this particular diagram as well. 1 minute, let me try to add up. So here we just have a single system in which we can try to increase the resources, right? So let me just draw a line as well. Yeah. So here what I'm trying to do is I will try to increase the resources. From a laptop or the PC, let's say where we are seeing this video or normally which you use, that is actually an example of monolithic system. Mono means one, right? So mono implies once. Now, when you try to get the resources increase, up to a limit, you might get that you might basically be able to see the proportional increase in the performance. So what I mean by that is, let's say if you have X resources and you get it increased to 2X, maybe a performance P is also getting increased. But if you try to, let's say, increase or getting those resources increased, at some point your performance will limit, and normally also there are limit to how much resource you can get upgraded. For example, your single laptop might not support 32 GB of RAM, right? In a similar way, there are limits on how much storage overall your laptop can support. Maybe after 4 TB, it won't support that. So if you increase, let's say, the overall resources by 10x, you might not see a similar increase in the performance. And thus, what happens is that the cost which you are spending, okay, to get your resources upgraded, it is not coming out in terms of your overall performance. Thus, we say that we have some hardware limitation in the case of a monolithic system. But if we think about this, our data, which we are generating in our big data problem, that is not limited by anything, right? If today you are getting some, say, a GB of data a day, it can very well increase to maybe 2 GBs or 5 GBs per day. So the biggest problem of your monolithic system is that they are not scalable. You can get the resources increased, but up to some time, what you will see is that we will not have the proportional increase in the performance. Okay. So Due to this, majorly we don't, or normally we will never be using a monolithic architecture or a system for a big data problem. Now let's move on to the next one. So next one is that, let's say when you have lots of images or lots of video files to store, then what you do is you can maybe use multiple systems, right? So multiple systems, and they are known as distributed. In this, what happens is that all of them are actually connected to one another. They are just connected to one another, and we will just try to make sure that somehow we are able to use combined power, right? So whatever power is there in them, we are able to use them combined. So they are connected to each other. And what happened now is that as we have multiple systems connected, okay, we can increase and add more and more system as and when we need. So for example, let's say if each of these systems is having 1 GB, then tomorrow if you have to store say 7 GB, you can just easily increase these systems. Each of them is having their individual resources, okay, on which you can maybe, for example, let's say if you have 5 files, okay, which you have to work on, you can just send a single file to each and every one of them, which they can do. Something which you're going to see moving forward, that from the basics of a big data. But I hope you're able to understand the basic gist that how a distributed system, right, will be able to help us better, because in this you can keep on adding more and more machines, okay. So this overall is known as a cluster. So we have a group of machines here. So we have a group of machines which are known as a cluster. So it is known as a cluster. These machines are also known as nodes. Okay. As we discussed, we can keep on adding. We can. So we can add more machines here as and when required. So each of these machines are having their individual resources, individual configuration. And again, because in our big data, we know that the problem or overall the data will grow with time in terms of complexity. We surely need a system which we are able to scale. And distributed systems are easily able to scale. And thus, we also call that here we are able to achieve true scaling. True scaling. That is, if we are trying to spend the cost to increase the resources, then we are able to get a similar increase in the performance as well, as they are all connected to each other in a distributed manner. To think of this with a very good example, what you can see or what you can think of is that, let's say you are running a restaurant. Now in that restaurant, let's say if you have 20 chefs, right? If you try to keep each and every of those chefs in the same kitchen, okay, and you keep on adding more and more chefs, somewhere the overall performance of your chef will limit and will not increase. The reason might be very simple. They might be coming in, I would say, work of each other. Your overall kitchen might have a limit that it cannot hold more than these chefs. Okay, they are not able to basically, after some time, they are just coming in between of each other workflow. But on the other hand, if you divide, let's say, the kitchen in terms of cuisine. So, for example, for your continental cuisine, you have a different kitchen. For Indian cuisine, you have a different kitchen. For Chinese cuisine, you have a different kitchen. Each have their designed number of chefs. Then tomorrow, when you have some cuisine or particular dish which you have to add, you can easily scale up your system, right? So this is a very good example to understand and imagine that how a monolithic system, if you keep on increasing the resources, the performance will limit somewhere, and you will not get the overall returns in terms of cost and performance. On the other hand, for a distributed system, as you scale, as you double or increase the resources, similar performance you will see in terms of your overall. As you increase the resources, similar effect you will see in terms of your performance, right? So this is approximately equal, of course, but yes, as you increase the resources, the performance also increases in a similar manner. Now, as in big data, we will be having these things increased. We will have to, or rather, we will majorly be using distributed system. So all good big data systems are based on distributed architecture of systems, right? So let me write this down as well. The major takeaway which we have is that all good big data systems are based on distributed systems. So with this, I'm pretty sure that you must have gotten the exact idea that why moving forward we will be seeing the distributed systems to learn and basically solve our big data problem. Now, the overall concept of monolithic and distributed is not something related to big data. It is something which was already there. But we saw that how for the increasing scalability, to achieve that scalability which our problem can have, we have to make sure the system which we are using that is also scalable. And hence, distributed system are the system of choice. Okay. So cool everyone. I hope with this overall, what all we discussed that is properly clear. So we started with understanding that why there is a problem. And if the problem is increasing, we will be needing more and more resources. For the same, we saw two types of system which we normally can choose, the monolithic and the distributed one. We saw how they majorly are and how getting the overall resources increase can cause a similar effect on the performance as well. And thus, we saw that for big data, as the problem is scalable in the sense, then why we will be moving towards with a distributed system. Hello all and welcome back. So in this video, I would like to discuss that what are all the things which we need to take care when we will be designing a good big data system. Now, before we deep dive into any of the big data technologies, I would like to make sure that we are spending enough time in clearing out many things which will help you to have a strong foundation in your big data journey. So when I say that we have to define an overall good system, what I mean is that a system which is designed to handle large scale data, effectively ensuring scalability, reliability, and fault tolerance. Now, in the last video, we saw that how we will be choosing distributed system to handle our big data problems, right? Now, in that, the very first thing which we need to take care of is the scalability. The problem which we face in our big data systems, they should be in such a way that they can grow to handle the increasing amount of data or users without any significant performance loss. So, if let's say we have the case where a company like Amazon, it is having its sale, right? Now, during sale, of course, million of new users or basically companies will be visiting our website simultaneously. A good scalable system will ensure that website doesn't crash and we are able to continue to process the orders effectively, even under heavy load, right? So anytime there's a sale on Amazon, be it Black Friday or any other major sale, a good big data system which has been defined, which in a way in Amazon, of course, will be able to handle the increased rush, right? Now, majorly, it is going to be of two types. The first one will be storage scalability. Now, whenever there would be an increase, there will surely be an increase in the size of data getting generated, right? So we should have an overall handling such that increased data can be stored. And the second thing is going to be processing or computation stability. Now, this again is a call a lot self-explanatory. We saw that how on our data we will majorly be doing these two operations. So the ability to process these larger data set, process the larger data sets faster by adding more compute machines. So we are going to see each and every of these things going forward. You don't have to worry. You just have to understand that how this is one of the requirements that a system which I'm designing, it should be able to process these large data sets, right? Now let's move on to the next thing, and to just explain that why this scalability matter. A big data system deals with ever-growing data volume, right? So scalability ensures that they can handle these all things without having any significant hit on the performance. The second thing which we all need to make sure or take care is the reliability and fault tolerance. In the last video, we saw that how we will be choosing distributed system as a system of choice to make sure that we can handle the big data, right? But in that, as there were multiple machines involved, it should be continue to operate the way it is operating, even if some component fail, right? So the basic thing here is that it should continue to work or operate even if some component fails. Now, one thing to note here, of course, a distributed system by the design is a lot more fault tolerant than a monolithic system. Just to understand, if you have a single laptop, of course, if that dies, then your whole system is down. You cannot do anything, right? In a distributed system, though, we have to still make sure that if any of the system in the cluster dies, then it should not have any effect in our overall working, right? So, for example, let's say, and we are going to see this more as we move forward. Let's say if there is a system which is handling the overall, I would say, use case for a big data, and we can think of, let's say, a grocery chain or something. If, let's say, one branch database fails, right? Let's say there's a grocery chain which have multiple branches. If one branch database fails, then it should not affect all the other branches in the country or overall. And that is what we will say that it's a reliable and a fault tolerant system, right? How it is achieved is something which we are going to see as we move forward. And the overall technologies which we will use to handle those, namely the Hadoop, Spark, all these are defined, or I would say designed with all these requirements in mind. Okay. So that is the second thing, which is again very, very important. The next thing is the cost effectiveness. Again, as we are dealing with lots of data and lots of systems, we should be make sure that there is a balance of performance and scalability with cost, right? So system should balance performance and scalability with cost. The real reason, or I would say justification for that, is that if you are, let's say, having a very small startup, or if you have some problem where the data is very high, the cost of solving that particular problem should not, in a way, exceed the benefit, right? So let's say if storing the big data or any of the working, it is very costly, then of course you will not be a lot interested in solving that particular problem, right? So the way we normally do that is by using commodity or cheap hardware, right? So we have to make sure that our overall big data technologies, right, are such that they can work with the cheap available hardware as well, so that whenever we are storing or processing the data, we are good to do the same, right? The last one in this is the security and data privacy. With so many machines involved and everything, we have to make sure that the data is safe from unauthorized access and all the compliance and regulations are actually maintained. Okay, so this becomes a lot important in companies like I have worked at Goldman Sachs, which is a bank. Now there, let's say if we are using some cloud provider, and again we are going to discuss about these in the next video. Let's say if someone is providing us with a solution for our big data, then we have to make sure and ensure that the data security and privacy should be maintained, right? So here we have to make sure that data is saved from unauthorized access. With so many machines and everything in the play, our system should be robust enough that all these things are taken care of. Now, again, these are the few things which we have to take care of. Now, these are very important to build a good, strong foundation. So tomorrow, when I will explain or introduce Hadoop to you, you will understand that how it is taking care of all these things and why they're important as well going forward, right? So these are the few considerations which we will put into picture when we are designing our big data solutions, right? So as I told in the very first class, big data is the problem and the solution as well. So the very first one is scalability, again, very important. Second is reliable and fault tolerant. So if we are coming up with a solution, it should not fail to operate if some of the component fails. The next is cost effectiveness, and the last one is security and data privacy. So these are the major ones. Yes, there can be other considerations as well, but if you are making sure that these are fulfilled, then we can go ahead and keep the technology to work on a big data problem. Okay, so cool everyone. I hope that is clear. So in the next class, we will now move forward and learn about the on-premise versus cloud. Okay. Hello all and welcome back. So in this video, let us now continue our discussion and see that how can we set up our big data system. Now in the last few videos, we have understood that what exactly a big data system is and how a distributed kind of an architecture is better suited due to its overall benefit of scalability and other factors. Now, before we jump onto using any system, I want to make sure that you understand all the choices which we have, and everything with respect to the on-premise and cloud is a lot clear to you. So, whenever a company or an organization has to deploy a big data system, they face a decision between on-premise infrastructure and cloud solutions. So, we are going to discuss each one by one and then also see the difference as well, right? So, let us first start with the on-premise. When it comes to on-premise system, what we can think of or infrastructure, it's equivalent for a company to buy an office, right? So, it's equivalent to buying an office and for an individual to buying a house. Now, if you are buying an office, right, there will surely be going to be a very big capital expenditure, initial investment, which you will have to overtake, right? So there surely is going to be a high initial investment. Post that, we will have to make sure that in our office, we are putting up all the equipments in place. We are having a dedicated space. We are buying all the machines because it is going to be distributed. A cluster is going to be formed. And let's say you feel that you will be requiring a 20 node cluster, that is a cluster with a 20 machine. Then you will have to buy and procure those 20 machines yourself. So we will have to procure these 20 machines ourselves. And further, a minute. Make sure that each and everything for these 20 machines, that is the installation of softwares, any update, any security patches, all the space, cooling equipment, the connection, each and everything, we will have to handle at our end, right? So setting up is our responsibility. And along with this, whenever you will say that, hey, I feel now I need 30 more, I would say PCs or 30 more nodes, whenever there is a, let's say, sale or some overall use case where you require more of these nodes, you will have to surely make sure that you are somehow able to expand the same. And when the usage will not be there, you will surely have to shut down some machines, not use them. But yes, you will still have to keep and maintain the same. Along with that, let's say after 10 years, if you feel that your hardware is getting old now, then surely you will not be able to update them that frequently, right? So if tomorrow, let's say after 5 years, you feel that some GPU is there, right? Just like with an office, you cannot upgrade the same thing in a very without putting up a lot of money because you have a very good investment in that. So these are the few things we are going to discuss about other factors as well. Now let us try to understand about cloud solutions. Now what happens in cloud solution? It is very much equivalent, I would say, to renting a house. So it is equal to renting a house or a co-working space. Now, in this, you are not owning anything. You will just be paying. So it's pay as you go model. All the hardware, everything, basically a cloud provider is going to help you with, will be providing you for that. You can connect to those machines via internet. And there are many cloud providers. So the common and the famous ones are, of course, AWS is there. We have Azure from Microsoft. And we have GCP, Google Cloud Platform. Along with that, we have IBM Cloud and other as well. But these are the market leaders. So we can say that Amazon is here, provided by Amazon. Azure provided by Microsoft. And GCP, again by Google. So in this, what exactly is happening is that, and majorly, because let's say if you're a startup or if you're someone who have just starting a company, it will not be a lot feasible for you to set up everything at your end and have that overhead, right? So in cloud, you will just be asking that, hey, I want these machines. I want to have a cluster like this. And in clicks, you will be able to get those hardware for yourself. So that is the major things. Now let us try to compare and discuss on them, like with different factors that which is better when. One more thing to always, like at this point, maybe you are always thinking that maybe cloud solution is always better. I actually have the exposure to both of them. So when I was working at Goldman Sachs, it being a overall tech giant, and due to the compliances and the data security thing, they had their own overall cloud and the overall infrastructure. Whereas in companies like Hoyo Rooms and Ninetical, they were using the solutions provided by cloud. So these are few factors which are going to be of, I would say, which will come into picture when you're deciding between these solutions. Now let us see the factors properly. So this is the table which I have created. Here we can better understand each and everything. So when it comes to on-premise, the deployment, hardware and software are hosted within the organization facilities. So you are taking overall responsibility of hardware and software and everything. Whereas in cloud, resources and services are hosted on the provider servers and accessed via the internet. So you will not have any machine at your end. You can just use any of your laptop or anything and connect to that particular machine and make sure that you can get your work done. Now, if we talk about cost, high upfront cost is there for hardware, maintenance, and IT staff. So we can say that there's a capex which is high. Once you have invested, just like your house, after that there are low cost. You're not giving anything pay as you go or anything. Whereas in cloud, there is a very good OPEX, which is your operating cost. Because you are just paying as you go, so there is no setup cost which you have spent, but as and when you will be using it, you will have to pay. The next is the scalability. So it is of course limited by organization hardware capacity. Once you have bought your systems, as I was saying, let's say if you have 20 systems and you want to have a workload of 50, then surely you will have to buy more, right? Whereas in cloud, it is very highly scalable. You can add resources on demand instantly with few clicks. You don't have to set up anything. Then maintenance, if you talk about, again, it's responsible for managing and maintaining hardware, software, and updates. All the security patches, everything a company has to handle. Whereas on cloud, it is managed by the cloud provider, AWS, Azure, GCP, or any other in general. When it comes to flexibility, again, very less flexibility because you have bought all these things. It's very much like you have bought the house or bought the company, bought the company space. You have to make sure that you are handling everything there. Whereas on cloud, it is very highly flexible, allowing resources to scale up and scale down. Whenever you want, you can easily scale up the resources and you can easily scale down the resources as well. If you feel that during some sale event, you will be requiring more and more, let's say machines, you can easily just scale them up. Okay. Now coming to security, data remains within organization premises, offering a greater control, right? Because you own the machines, everything is kept at your end. No one will be able to ever access the data. You can just control how or who basically will be having access to your data. On the other hand, in cloud, security is managed by the provider, often meets global compliance. So it is not the case that they are not good. They come with an awesome, or I would say very good security. But again, for sensitive data, they might face concern. And we have had instances where we have heard that there was a breach in iCloud or there was overall some data breach. So though overall there's a very high security with respect to your data, but still it can very easily happen that some data breach can happen. And for use cases where you feel that your data is very, very sensitive, majorly which happens in financial institutes, it's always the choice where they try to go with on-premise due to this particular reason. The next is disaster recovery. So require internal backup and disaster recovery system. So just to explain that, let's say if you have a overall your on-premise infrastructure at some place, okay, let's say it is in New York or somewhere. If there's some natural calamity or some disaster, right? All your data, everything is basically at risk. You will have to make sure that you maintain some, I would say, backups. You have some overall system in place to handle that disaster. Whereas coming to cloud providers offer built-in disaster recovery and redundancy. So in here, what happens is that these providers, as they have their data centers and they have their clusters at different locations, they are able to make sure that they can save your data at different locations. So if let's say tomorrow in New York there is some problem, maybe they have another data center in San Francisco from where they can get your data. They have the backup there, and each and everything is handled by them only. Okay, so these are majorly all the factors which you will have to understand, and I am pretty sure that this now must have given you a good idea. Majorly in companies, we go with cloud. And that's the reason AWS, Azure, GCP, all these are now one of the fastest growing sector in cloud, I would say, computation. So in this course as well, we will touch upon these things. And the major thing to understand is that why we will be going forward with the cloud. Just to show you, and again, this screen will not make a lot of sense, but yeah, just to show you how easy is it. This is one of the Google Cloud page where I can just easily get, okay, how many machines I want. So you can see different machines here with different hardware configuration. So I can just click and get those machines. I can have the software installed whichever I want. So we have the series here. I can just go back a step. And here I can select the software as well. So this is the cluster name. And yeah, this is the software. So I can change this overall as well, like which software I want, the version I want. I can even give the cluster image. Whereas on-premise, you have to go and yourself buy those machines, set them up, give them power, connect each and every one of them, then install those softwares. Here, just by click of these machines, I can change. Similarly, I can specify that how many overall, let's say, machines I want. If I want to scale up or scale them down based on some usage or anything. If I want a GPU, so let's say there is some use case which might require some heavy computation, easily I can demand for GPU. Just that I will have to make sure to pay for that as and when required. Okay. So pretty sure that this overall would have also given you a good idea. So many companies and startups, of course, it makes a lot of sense to go with cloud rather than directly investing anything in the on-premise infrastructure. So now let's discuss a little bit more about cloud, everyone. Let us see what are the different types of cloud. The very first one is your public cloud. Public cloud, as we saw in the example, there are AWS, Azure, GCP, IBM and others, but these are the famous ones. So third-party providers are there over the internet. Multiple organizations can, of course, access and demand resources from them. A startup will be very highly to use this because there is no overall cost associated with them initially. As you see, I as an individual can easily demand for the resources and get my cluster started. The next is private cloud. So in this private cloud, what happens is that a single organization, okay, all the infra set up by single organization for its use case. Now, many of you might be thinking that how is it different from on-premise? Well, there is a difference, and this was actually something which many big companies do. So just like AWS, Azure, and GCP, they have their own cloud, right? Something which I also use in Goldman Sachs. So all the UI and everything is provided. There also, it's not that I was in charge of physically going and getting the machines or saying that, hey, I want these type of machines. No, in a very similar way, the UI was given to us. VMware and OpenStack are also example. A bank also uses this private cloud to ensure that all the customer transaction data is secure and is in compliance with the regulation, right? So they can have different data centers and places. They can take care of your scalability, of your overall, I would say, security and that disaster management as well. So this is the private cloud. Third is the hybrid cloud. So as the name suggests, hybrid mixes up private and your public. So it's public plus private. In here, we have basically the overall use cases of public and private mixed. So let's say private cloud with certain capacity. So some of things are private, while other are or rest are on public. Okay, so what majorly this is used? Let's say we have some sensitive data which we are storing on our systems, so that is private. But maybe the computation and other part we are just using some solution provided by AWS or Azure, right? So that is the hybrid cloud. And the last one is the community cloud. So here what happens is that infrastructure is basically shared by multiple organizations with common concern, right? So let me write that down. Shared by organization with common concern. A very good example of this is the hospitals or the NGOs. So they may have access to each other's data. They will be trying to solve a similar kind of problem. So here it is for the whole community or some common concern which is binding, and they make sure that they are developing solution for that and using the same. So universities and your, let me write this example as well. So very good example for this can be your universities and hospitals, where they have the access to data, not anyone else. A particular community is majorly having that. So that is all I think. Till now, you must have a very good idea on what exactly is on-premise and what is cloud. Please make sure that you don't remember any of these things. I've tried to explain it in such a way that you get the gist. And from my experience as well, I told you that when a company will go towards an on-premise or a private cloud, versus where it will be using the public cloud or other things, right? Now, one very common question which I get at this point is that out of these public cloud offerings, which is the most common one on which one should go for? So I normally have two-step answer to that. The very first thing is to understand that all of these are in some way providing similar solution. They will be providing you with the machines, just like I showed you that GCP is providing you with those machines. Similar way, AWS and Azure will also be providing you with those machines, right? So first and foremost, we have to understand that they're trying to solve the same problem. So the basic thing should be clear a lot, right? You should be aware that what exactly is it which you want to do, and then every cloud more or less will help you in doing that. So that's the very first thing. Second thing is that if we talk about professionally, Azure and AWS are used a lot, while GCP is catching up. So from the job market requirement or overall, Azure and AWS can be the first choice if someone is very new and trying to learn them. But as I said, it is majorly your focus should be to get your basic clear first, something which we will focus on this course, and then we can just learn any one of the platform of cloud offering. And based on that understanding, you can use any other as well, as there will not be a lot of changes. Okay, so that's the major thing. But yes, if you're completely novice, new to cloud platform for big data offerings, it's good to start with either AWS or Azure. Okay, so cool then everyone. I hope this thing is clear. We have made sure that everything with respect to the big data system we have understood, and on-premise and cloud is very important to get clear in your mind. Now let's meet in the next video where we will discuss about more big data concepts. Hello all and welcome back. So in this video, let us now continue our discussion, and now let's try to understand the difference between a database, a data warehouse, and a data lake. Now, understanding the distinction between them is a lot important because of multiple reasons. The very first thing is that you're going to hear this a lot in your data, big data, or your data engineering journey, and students always remain confused between them. The second thing is that till now you must have learned a lot of technologies, and in future as well, you're going to learn many of the cloud technologies. If your distinction between this is clear, you will be able to better divide that if a particular technology is a database, a data warehouse, or a data lake, thus also strengthening your system design skill, or when you will be writing or making an end-to-end project, you will know which piece should fix in where. And the third thing is that having the overall idea about this will be a lot helpful when we cover multiple technologies going forward, so that you yourself will be able to make a call that what might be the use case of that particular technology in your overall project structure. So let us now start with them, and let's see first about the database. Now, database is something which you have already covered in this course as well, where you have defined a MySQL database or a PostgreSQL database, must have added some data in that, or must have written some queries by making the, I would say, generic employee table and then working on that. So a database, in a very simple terms, we can just say that it's a system which holds data, or it's an organized collection of data. This data normally is structured in table with defined schema, and of course the table is in the form of a row and a column. Now the major purpose of this particular type of, I would say, data storage is to handle your transaction data. That is your data of day-to-day activities, day-to-day operational data. Examples can be your customer orders, inventory, balance updates. So transactional data, that is day-to-day operational data. Examples can be your orders, balance update, inventory, all these things which happen for any of your app, basically all the transaction, any user action, that majorly will be getting stored in your databases. And with that in mind, of course, you can think that they should be very good with your write, right? They should be write heavy. Okay. Along with that, they are also said that they are very best for OLTP purposes. So best for OLTP purpose. So OLTP is online transaction processing. That is dealing with day-to-day transactions, the recent transaction. And few things to note or to make sure here is that these are majorly structured in nature, right? So they are majorly structured data is handled here. Let me use the different pen only. Majorly structured data, which implies that during the overall ingestion or entry of your data, schema will be well defined, which you have to follow. Example, let's say if you're talking about an employee, we will be creating a table of employee with, let's say, its ID, its name, maybe let's say email. So this structure has to be followed whenever you are trying to add any data to this databases. Now, one more thing to note here, which is again very important, is that we don't hold years of data here, but rather the recent one for better performance. So your databases are actually used a lot so as to make sure that you are able to store all the recent things here. They should be a lot good with your write. So we normally say that they should be write heavy. Okay. And data is in structured form. So whenever you are trying to add any data, schema is validated. And if any mismatch is there, if we feel that, let's say we have just defined the ID, name, and email, if you're now trying to provide, let's say, the fourth column, which might be the mobile number, then we are going to show an error here because there is a schema mismatch. So I can write it here very nicely that we do face an error on schema mismatch. Right? So these things are a lot important to understand. Along with that, the cost, overall cost of storing data is high in the system, and hence thus they are used for recent data. So MySQL, PostgreSQL, these are few solutions which are databases. They have to be write heavy. They have a very high cost, and we majorly use them for transaction databases, which is the day-to-day activities. We are not using the same for doing any analytics on top of that. So for example, or rather, let us now move to the next one. Many of you might have this doubt for recent data. So this is all about your databases. Now I have mentioned that storing or keeping lots of data, like let's say years of data is a problem here. But now what if, let's say tomorrow, you as a data analyst or as some person working in a company has the requirement where you need data, let's say for years for some analysis. Well, for that we have data warehouse with us. Now what happens in a data warehouse is that in this we store a lot more data than a database. And along with this, your data warehouse works on the concept of something known as ETL. So many of you must have heard the same ETL, in which we have multiple data sources. So say this is one data source, this is another data source, and like this, we will be dealing with multiple of these data sources. All of these data sources, right? It can be from different, let's say, year, all these things, they are extracted. So ETL, E stands for extract. Then we transform them. So this is the extract layer. This is the transform layer, and we are going to talk more about this in the next video. And then we finally load each and everything into a warehouse so that analysis can be done on top of that, right? Now, many of you might be thinking that what is the issue if we try to do this on the database? So let me write up that question. Why can't we use database for analysis? Well, there are multiple things or multiple reasons for this. The very first one, which you must have understood by seeing the above diagram, there can be multiple data sources. So it may happen that in my analysis, I want all the information about an employee, the company, or let's say the clients, each and everything. But in a database, majorly, what would happen is that we might not be having all those kinds of data and everything. So multiple data sources. So that is where we have to have a central repository. Second is that lots of data is there, right? Which would imply cost. In your database, as I said earlier, we will be not storing so much data, right? We will not be storing years of data. And analysis typically maybe something in which we are analyzing, let's say 5 years of data, or maybe I would say some months of data, right? So that is another reason. And the third one is that we write complex queries on our DB, right? So whenever you're doing any analysis, you'll be writing complex query on your DB. And what will happen here is that your database is now trying to do two operations. The first one is your transaction, or I would say write, transaction or write. And the second is running all those complex analysis query, right? Complex queries. So that means that the performance of your DB will suffer a lot and it will go a lot down, right? So when you're running complex query on a database to do some analysis, the transaction or day-to-day operation will be hampered, and hence your database has the overall problem, or it can become a lot slow, something which we cannot afford or which we don't want. Now, these are the major reasons, and then along with this, your database is actually having a storage cost not as high as a data warehouse. I might have said database earlier, not as high as a database. And it is a lot ideal for your OLAP purposes. So OLAP, online analytical processing. Analytical processing. So the basic idea remains the same, everyone, that in your database, you're handling day-to-day queries in which we are able to make sure that performance is top-notch. It is a lot write heavy. On the other hand, this needs to be a lot read heavy, should be able to store a lots of data. And one more thing to mention here, it follows an ETL process. All that thing is fine, but this is also having the data in the structured form. So let me write it here. Data is stored in a structured form. This thing is very, very important. Okay. So in between your database and data warehouse, the main difference, which I would expect you to remember, is that though both are storing the structured data, one is very optimized for writing and day-to-day operation, while the other one, okay, is optimized for your reading and analytical process. That is why you will many times see the difference being asked for OLTP and OLAP, right? So now you know the difference between them. So online transaction processing and online analytical processing, right? That is the difference, and now you know that why exactly is that the case. Okay. So this is about the database and data warehouse. Now let's move to data lake. And before I move to data lake, let me just explain you a problem here. Now in this process, which we have in front of you, the ETL process, you will see one thing, that you are extracting your data from multiple sources and you are transforming that in middle before you store that to your, or before you load that to your data warehouse. So it is known as DW as well, right? Now, in this all operation, what exactly is happening, or what is a bottleneck or a problem, is that many times we are not sure. Like let's say if you have just introduced a new table, we are not sure that how exactly we have to transform this data, right? This transformation, because it is getting done earlier before loading the data into warehouse, it is a very complex and time-consuming process. So in the transformation, we will be seeing that how exactly we have to store the data, what all we have to work on the data, and many times in a project or in some use case, this thing is not clear as well. Many times we might be getting some data generated, which we are not sure as of now if we will be using in analysis or not, and we might just have to store it, or data might also be some other form coming up from multiple sources, which we just need to load or just basically make sure to get into our systems as of now, and we might work on them afterwards. The very good examples can be log files and everything. And since this is structured as well, that is another thing. Many data we might not be able to provide in a proper structured manner, right, everyone? So that is some problem which we face in the data warehouse, and that is where now your data lake comes into the picture. So your third is data lake. Now coming to your data lake, what happened here? The problem which we faced, right, with respect to your data warehouse, we try to solve the same here. We want to get the insights. We want to get insights from large amount of data. And this data now can actually be in any format. So it can be on structured format, it can be semi-structured, or it can be a totally unstructured data as well. So the basic idea behind data lake is like that any data which we have, we can dump that and create a centralized repository. So it is said that a data lake is a centralized repository. Centralized repository that store all kind of raw data. And it can be in any form, structured, unstructured, anything, at a scale without any pre-structuring. Now, in this case, the process which we are following here, everyone, is something known as ELT, that is extract, load, and then we can transform. So we can transform as and when required. As of now, what we are doing is we have this data, let's say it's in table format. So we have some data in table format. We might have some data which is in the form of some image. So we might have some data which is an image kind of a data, and we might have some data which is your log files. Let's say some log files or text files. We try to get each and every of this data first into our system. So each and everything we will get into our system and have it in a centralized data lake. And then, as and when required, we can do transformation on them. So as and when required, transformation can be done on top of this data. Now, I hope all of you can see the benefit here. So let me just add the tags as well. We just extract, then we load, and we can transform as and when required. So a very good example of these kind of, and I think I forgot to give you the example of data warehouse. So Terraform is a very good example of a data warehouse. So let me write it in green pen. Let's say examples we can write here. Example can be Terraform. Right? Let us move forward. And for data lake, the examples are actually HDFS, something which we will learn a lot in this course. That is the Hadoop file system, a technology which is used for big data. Similarly, S3, right? And all the companies, they have or they maintain a data lake, right? So everywhere I have worked, there was some data lake from where we know that we could have gotten this data. Of course, it is very cost effective. So the very good positive here is that it is cost effective, right? As cheap hardware storage is used here, so it is very low on cost. And what exactly happens here is that, so let's say if you have a overall some table or something, right? We have a lots of flexibility here. Doesn't matter what schema your table is following, we can just have anything added. At the time of reading, we can specify or we can see that, okay, what exactly are we trying to read? So we are not following any schema or anything while we are sending in the data, but while we are reading, right? We can make sure that we basically are able to say that, hey, it is this type of a data, the schema is this, and we can make sense of it. Hundreds of team, or rather I would say many team can use the same. And that is what typically happens. So in my experience at Goldman Sachs, there was a centralized data lake, and it was known as data lake only, where we had lots of data for different use cases, different departments. And what we used to do was we used to extract the data from there. So we used to get the data, right? And then we used to see that, okay, what all is the type of data and get them into our system and then work on the same. The good part was that everything was available there. So we have a centralized repository, and different teams were also aware of the same. And that is the process which is generally followed in many companies. So with that, I'm pretty sure that it is a lot clear. So as I said, we can save, and let me write these down as well. So we can have a table, and let's say we have an image, or let's say we have some log file. So some text file, log file, you can just think of logs, right? So these are some overall, I would say, examples of all the or other any kind of a data, like your S3 or big data technologies. They are also very good in saving any kind of data which you want as a like HDFS or any other, depending on what technology you are using. So that is majorly about your, I would say, this data lake versus data warehouse versus database. Now to give you another example, you can just think of a grocery store chain. So a single store, okay, it can just use a database like tracking the daily sales, inventory, employee hours. It can maintain a simple database for that. Coming to data warehouse, maybe a head office, okay, or let's say the overall main branch of the grocery chain. It can connect all the sales data, okay, from all of its branches, and with over time it can analyze the trends, right? So the very first one is a single grocery chain. It is happening all its transactions and everything. The head office or the main branch is having or collecting all this data, transforming it, making sure that, let's say if someone is making the sales in dollar, some in rupees, some in euros, we are transforming and saving each and everything, and we can identify the trends over time, like what was the last best selling, let's say item, how much sales we have done. And the data lake can be, let's say, if the grocery chain, right, it is collecting a lots of things and storing them in those systems, like structured data, for example, the sales record. We can have semi-structured data, which can be your reviews, maybe from the social media, and let's say some unstructured data as well, images of the products, CCTV footage, all these things. They are just stored in the data lake. They're not immediately needed, right? But over time, we can maybe use them to make better decisions, and we know that yes, everything is stored in your data lake. As I said, for the software end, for the example, then we have MySQL, a very good example for your database. Then we can have for data warehouse, we have Terraform, and similarly for data lake, we have S3 and HDFS, right? So let me just give you a quick table which I have made, which will help you to remember and basically compare the differences better. Cool. So this is the table, everyone. Let me just have it. 21 minute. Yeah. So as you can see in this, your database, the purpose is real-time transaction, it is historical data analysis, and raw data storage for diverse use cases. Data structure here is structured. Here also it's structured. Here we can have raw data in form of structured, semi-structured, or unstructured as well. Then speed, high speed for small queries, right? As we discussed, it is optimized for your analytical queries. It is read heavy, a system which is going to read, and it variable depends on the data processing. Now here the use case is operational system, so transaction use case. Here we will be doing analysis, that is business intelligence, and data lake is majorly used for advanced analytics, machine learning, and everything, right? Scalability, of course, the database is limited. Data warehouse is scalable up to a limit, and your data lake is a highly scalable storage system. You can keep and adding data. It is very cost effective, a lot flexible. Data warehouse, it is moderately flexible. You can keep on adding and save the data. It is forming the structured approach, and your database overall is limited in your scalability. Okay, so that is all everyone with respect to these three terms. Pretty sure that you must have understood them in proper depth. Please remember the same as going forward. We will be using many of these technologies, right? So in your Azure, we have Azure Data Lake. Then basically Google also has those offerings. But the major thing which will help you to understand them is when your basics or the understanding will be clear. And that's the reason I've spent so much time in making sure that each and everything is covered for this particular topic. Okay, so cool everyone. Please make sure that you revise the note, and also everything is clear in this particular distinction of the three terms. Hello all and welcome back. So in this video, let us now move forward and continue our discussion. And in this video, I want to explain you the difference between ELT and ETL process. Now, we have already seen the difference between data warehouse, database, and data lake, where I kind of gave you an idea about them. The reason I'm covering all these terms and their differences is that in this module, my aim is to make sure that the common doubts and any confusion which you have in between these terms, they are very nicely cleared, so that when we start with the big data technologies, you don't have to worry about understanding that which might fall into which bracket, and you have a very clear understanding on what exactly is happening and why we are doing or learning a particular technology. So let's now get started. And ELT and ETL, we saw in the last video that how ETL is extract. So ETL we saw is extract, transform, and load. Now let us first try to talk a little on ETL framework. So what happens in ETL? And I can give you an example from my professional journey as well. When I was in Oyo rooms, that is Oracle States, we had data coming in from different places, right? So there was some customer data which was residing in say your MySQL DB. Then all the bookings related data was in some PostgreSQL. Apart from that, let's say some information regarding the overall what exactly a user is doing, right? The steps of the user, that was coming in from some overall Google BigQuery. Though Google BigQuery we can just remove for the timing, just a second. Yeah. So some information was coming in. So what used to happen was that when you scroll Facebook, right, let's say, or any other social networking website, you must have seen that you see advertisement or links there as well, right? So some information used to come from there as well. It was in the form of JSON. Like this, we had data, like some data was let's say coming in XML form. Okay. So like this, we had the data which was coming in from different places and following the overall booking workflow, right? And the team which I was part of, the name was Conversion. So our aim was to understand that what exactly is driving the conversion. That is when the person actually books the hotel, right? So the final aim after this was what we used to do, because this all is in different format and it's coming from different data sources. If I have to do any analytics on top of that, right? So if I have to create a pipeline, and that was a very common pipeline which we used to create, that how many people actually came to the platform from different places and ended up booking the overall hotel or ended up getting converted, right? So with that in mind, what we used to do was we used to get all this data. So we used to extract the data from different sources. Then we have to make sure that we are transforming this data. So again, this data is not in the clearest form. Each and every of this data might have different columns name. It can be a lot messy. It can be having different structure altogether. So we have to make sure that we transform this data. Second. And once it is transformed, then we used to load it into a data lake, into a data warehouse. On top of which, we can finally do or run our analytics. So data warehouse. Now, if anyone wants to learn that how many people actually came to the platform on different, let's say on web, on app, how many ended up going, let's say, to the booking page, how many ended up paying, how many were just scrolling and let's say dropped on the first page, I have a one single place from where I can get all this information, right? So ETL is when data is extracted from the source, transformed, that is cleaned and prepared, and then loaded into the target system, right? Majorly when it's used, when the target system, example, it can be a database or data warehouse, has limited processing capabilities. So in this, our data warehouse, right, it is optimized for all your, I would say, processing and everything, but it is not having far-reaching capabilities. It can still hold the data, it can work on that, provide you with the analytics, right? So all this data is given into this warehouse, okay? But on top of that, we will be running analytics. Let's say we can connect it to some business intelligence tool as well. So BI tool, right? It becomes a survey layer overall, and that's why it is also known as OLAP, which is your online analytical processing. Now this final data warehouse, right? It is not, I would say, open for the public or not facing the customer, okay? But on top of this, once you have this data in a proper format, we can then run our analytics and get the results. And there are many tools in the market for this. So few of them, if I just write the one which are very common, Informatica is one, which is very common, which used to be the market leader. Then we have the Talent, right? We have your fifth plan is one tool, okay? Which all basically what they do is that once you have your data loaded into this tool, then you can do analytics on top of that. Okay, so all the data is in the warehouse. Now let's say tomorrow your company CEO or any other person, he wants to see that what exactly is happening. You can just actually go to data warehouse. You don't need to go to these individual sources and basically get your data. One thing to note and always take care here is that all these processes should be a lot, I would say, right? Anytime you make any mistake, let's say if you made a mistake in bookings coming from web, right? All that error is going to get propagated and finally show up in your analytics. So if you made a mistake where you are not calculating the booking amount, let's say, properly, then it's going to show in the final system. Okay. Now this is very much suitable for structured data and traditional data workflows. So for traditional data workflows, this overall ETL used to work pretty well. I will just quickly write the steps here so that it is a lot clear to each and every one of you. So the very first step, collect data from multiple sources. One more example to help you clear understanding can be of Swiggy. So Swiggy is a food ordering app. It can collect data from restaurant menu, customer orders, right, tracking all these things. Second is we can transform this data. So in this transform, what we do is we have to clean, right? Then let's say filter and format the data for analytics, right? For analytics. And along with that, the third can be load. So here, what Swiggy can do is it can remove duplicate orders or let's say some invalid addresses which are there in the data. And the last one is load. So store clean data into data warehouse, right? So not sure I'm not able to write here. Yeah. Into data warehouse. So this is the whole process of your ETL process, ETL extract transform load. Okay, great. So pretty sure that this must be clear. Now before I move to ETL, okay, sorry, ELT, not ETL. ETL we have discussed just now. I want to explain you the few problems in this workflow. So you will see that what happens and why this was majorly traditionally used and used still for I would say structured data analytics is that you have some data which you are able to transform, right? You know that okay, this data, these are the kind of similar fields which I can work on. Okay, let's say if the book data is coming from web or app, majorly you will be able to get the common fields and make sure that you are able to make sense of your data via common structure, right? But as we basically evolved and as the data generation also evolved, we see that now many data is coming into play where the data might be of different forms. So just as an example, you can think of I would say your customer reviews, right? So that is majorly in text and an image, right? Something which you cannot that easily make sense of, something which you cannot have under a single or I would say simple structure or schema which you can transform and easily load, right? Along with that, of course, we have the data which is coming in streaming data, right? So not coming into batches. So this was still good for analytics. So these were a few challenges I would say which was there in the ETL processes, right? And because of our increasing data needs and us not able to transform data into a common schema, and many times what used to happen was that we were also not aware that how exactly do we want to transform this data or what exactly do we need to do it, right? We were aware that okay, this data is going to be helpful, but how exactly we were still not sure of that, right? So for that, what exactly happened was we have the ELT use case now. So let me just call up. Yeah. Good. So the next which we are going to learn, that's the ELT process. Now again, as the name suggests, extract, load, and transform, right? So this time what happens? We have this data from multiple sources again. That thing remains the same. And this time data is also of different format, right? So your data may be an image, it may be let's say some text. So maybe let's say some text, it's some SQL DB normal, maybe some streaming data, right? Some data may be coming up as some JSON hits. Now we know that okay, all this data will be useful, right? We know all this data will be useful. How exactly to transform them as of now, that we are not sure. So what we do, we store this or load this data into a system, into a data lake, which can handle and is made for this, I would say, big data processing and scalability. And then we try to transform or work on the data. So we have bring together all the data majorly into our data lake, okay, into our central repository. We have different ingestion frameworks for this. We will be learning about Azure Data Factory, and there are many more. But the basic idea is that if you have to get this data, right, if you have to get this data into different, I would say, from different source into this data lake, we need to have some ingestion framework here, right? And this is what exactly like in data engineering, these are some tools which you have to understand and master. So a very common one in Azure space is Azure Data Factory. And again, we have many of these things. I hope you get the basic idea. You can do it by writing via code as well. So that is not a problem. Just that these tools make your work a lot more easy. Okay. And once you have this data into your data lake, on top of that, now you can actually transform it. You can connect your business intelligence tool. Okay. All these things, the processing, computation, right? That can be done. So that is not a problem. Okay. You can just process and then create a serving layer overall on which you can just have your business intelligence tool. So this is the whole process of ELT. Now, I hope you're able to understand that how exactly this will happen. Let me give you clear this with an example. So let's take example of Swiggy again, right? This time what exactly is happening? We are pulling raw data from multiple sources. Maybe the customer review is one. So somebody saying that the business is great. Then there can be food photos, right? Photos of the food. Then there can be some GPS data, right? So you can understand here that the data is not in the same format, right? It is in different format. And it's very difficult to, or maybe we don't even need to combine or very difficult to get the data under a common umbrella. We know that yes, this data is going to be very useful, but can be multitude of use cases, right? So with that in mind, what we do is we load all this data into a central data lake. And majorly all companies have that with the name lake only. So in Goldman, the data lake was called the data lake. They have that made internally. Where we was aware that yeah, many data which we are looking for, maybe not a very sensitive one, will be present in this particular data lake. Okay, so we used to connect to that, write the queries, and get the data back. Okay, so this ELT is best for semi-structured or unstructured data with high scalability needs because as we are getting streaming data as well, and this data will be increasing or can increase a lot in size, right? So let's say we can have video data as well. So it makes a lot of sense that for this we should have high scalability needs, right? So a very good example, another example can be your social media analysis, right? So example can be social media analysis. So this exactly, right, is what is happening. We can, and one more thing to understand here is that we can store this data, right, into let's say a distributed system. We can just use distributed processing on top of that. These all things again we will understand once I introduce the big data technologies to you. But I hope the basic idea is clear, right? So with that, let us now see the differences between them totally. So one more thing to mention, I'm not as of now naming lots of these technologies like Azure Databricks, AWS Glue, AWS S3, because I think it will not make a lot of sense once we cover and move forward in the in the course, and we see that what exactly, and we focus on each and every of these things independently. That is when we will talk more about it. Just you have to understand one thing again, that when you are working on this ELT process, you have the sources, storing it into this layer, you are transforming it, and then you can save that transform data, let's say into some database or data warehouse. On top of that, it will then serve as a serving layer. What I mean by serving layer majorly is that you can connect any business intelligence tool or let's say any analytical platform to just get the insights and basically use that data which you have now worked on and transform. Okay, so let us quickly see the differences as well, everyone. This is the ETL and this is the ELT. In the processing location, data is transformed before loading, data is transformed after loading. Traditional data warehouse with limited compute power, modern data lakes or cloud platform with high compute power. Okay, so these modern, or I would say when you store that in the data lake, right, which we were saying, a very good example is Azure Data Lake as well, or let's say AWS S3, they have very high power or high compute power. They are distributed, you can work on them. So it is not that you are storing into the same kind of, I would say, finally you're storing it in the same way or same structure. No, that is where it gets the difference. When we know that our data is like which will have a high scalability requirement, we go for data lake, and again with different formats. So that is the reason data type, as we saw, data structure, and in this structure, semi-structured and unstructured data. Speed slower as transformation occur beforehand. So you can think of that, right? We are doing the transformation; it's going to take a lot of time. Let's say if you're loading the data, and normally that's the reason it is done in batching. So steaming is not a lot successful in this particular case because the data will be coming after getting transformed. So maybe let's say if you just use your credit card, first that has to be transformed and then sent for storage. On top of which you can do some analysis then, right? While on the other hand, in ELT it is faster as transformation happen after loading. We are right now just getting the data and dumping it into as we want, right? And use case you can now think bank transaction clean before storage. So for bank transaction, order history, okay, the whole conversion cycle which I was telling you, that all is in this ETL workflow. Whereas social media analysis, raw data stored for future use, this is something which we do via ELT framework. Okay, so just one more analogy to easily understand. Let's say if you have Almira, right, just like you have an Almira, and if that Almira basically is having these partitions, right? 1 minute. These different partitions. If Almira is having like this, then this is your ETL. Your data is the clothes, so you will get them. Make sure that you fold them, and then basically at each and every position you are storing them in a very nice manner. Coming to ELT, okay. Coming to ELT, it's just an open, I would say, box where, or let's open Almira, where you just for the timing throw everything. Okay, so all your clothes you are just throwing as of now. You don't have to worry about anything, and you can actually throw anything here. Then you basically make sure that when you have to get ready, you will be maybe folding it, getting it ironed. All these transformation happens after that, right? So yeah, I hope that this example is a lot more helpful to clear your mind, and you can then think of this as well now, right? Like where can we use the first one and the second one, and how the storage and everything also differs with respect to this. Okay, so yeah, that was all. I am pretty sure this must have cleared your doubts. If anything is still unclear, ask in Q&A. Again, very important, I would say, topics. This is going to be helpful in your overall journey a lot because as a data engineer or a big data engineer, you will be doing this only, and you will see that once we go into each and every process, how complex that becomes, right? So that's the big picture overall. But once we deep dive into each of these processes separately, we will see that okay, how complex can they be? Okay, so cool everyone. I hope that was fine. Now let's meet in the next video where we will understand a little bit more about data engineer and big data, like what's the difference, and basically make sure that you have that thing clear before we jump onto our big data technologies. So this module as a whole, I'm pretty sure that once you complete this, you will have your basic around the terms and any confusion which you might have be clear. Okay, so yeah, thank you. Hello all and welcome back. So in this video, let us now continue our discussion and see what is the difference between a data engineer and a big data engineer. Now, this is the most common question which students normally have, especially the freshers who don't have the exposure or any experience of working in the data till now. And when we were even making this course, many students were asking for a separate data engineer course. So I hope this gives you an idea that how deep this confusion runs. So via this video, I will make sure that I'm able to explain this in a very simple terms so that in future you will never face any confusion with it. Now, to understand this, let us break this down step by step and let's make it clear. Now, the very first thing which we are going to understand is what is the role of data engineer. So let us start by understanding what exactly is it which a data engineer do, right? For the timing, let us just move away from data and all these things and talk about how we get water into our homes, right? So let's forget all these things and let's try to understand or debunk that how is it we are getting water into our homes. Now, water, the very first thing which you have to understand, like when you open your tap and you're able to see the water, it's coming after a lots of work being done on it, right? So it is not that directly water is getting sent to you. We have different sources of water. So we have water sources. Now they can be ocean, lake, river, any well, where the water is normally stored. Now, what happens in between is that some company or some individual, what is being done is a pipeline is getting made, right? So that before you are able to see this water in your overall tap, right? So when you open your tap, let me do a tap like this. So let's say this is your tap where you see the water finally, which is clean and everything. We have a process in between. So let us now try to understand this process a little bit more. We have to make sure, or whoever is doing this thing, let us call that person a water pipeline builder. Okay, so let us call this person a water pipeline builder. He will be making sure that he designs and builds the pipeline to collect this water. Right? So the very first aim is to design and build pipeline to collect water from all these sources. Next, we will have to make sure that we are cleaning it, we are working on it. Some water might be, let's say, clean, which is coming from well. The one coming from ocean and river, maybe, let's say, will require a lot more processing or cleaning. So we have to make sure the next step is to clean it. And once we have cleaned it, then we have to store it, right? So that once it is stored, then from there, we are good to send this water for usage. So once we are storing it, and let me just remove this part for the time being, and say that we are storing this water finally in some very big tank, right? So the water is finally getting stored after being clean and everything in a big tank. So if you now just think of this whole process, this particular person is actually your data engineer. This water pipeline builder, which I asked you, is actually a data engineer. You can think of raw data as water coming from different sources, right? So just like we have water coming from different sources, your data in any organization, and you can think of it in terms of, let's say, any e-commerce website like Amazon, it's generating different data, right? Transaction data, login data, user activity data, data for products, like the information about the products, when someone is buying something, when he pays. So we have different like data coming from different sources, but all of that is raw data. So just like this person worked on this data, a data engineer designs and builds this pipeline to collect the data, then make sure that it is cleaning or processing it, and then finally store it into some database or data warehouse so that others can use it, right? And who are the others in this case? So here in this particular example, let's say we have data analysts, then we have data scientists, and many times it happens that let's say some management, some CEO wants to understand that how many CAs we did in some day and all these things. So it can be management and others as well. Just like our water was finally fit to drink or be used after all those processing and everything, data engineer actually works and do the same thing with your data. So now to give you the proper definition, a data engineer is responsible for designing, building, and maintaining the system that store, process, and make data accessible for analysis. So this is a formal definition, but what I will suggest you is to understand the process, as that will be a lot easy. Another very good analogy which you can think of is like, let's say, of a chef. So just like here we have the water sources, we will have different food sources, like let's say some vegetables coming from a place, then we have spices, we have let's say meat or overall some other grains. All these things are coming into as raw data, like as a raw material. What a chef does now in middle, he makes sure that he's collecting all of these things, right? Then he makes sure that he's processing them, right? He's working on them, and finally he provides the eater, or let's say someone provides the one who orders the food with a finalized dish which can be eaten, right? So this is another analogy which you will understand. Now let's talk about few responsibilities, right? So responsibilities will be clear, but let us write them down still. So the responsibilities will be data pipeline creation, data transformation, ensuring data quality. So we have to also make sure that just like with food and water, there are some qualities, right? Ensuring data quality, and something we have understood of this in your ETL pipelines as well, quality, and again the automation, right? So automation is very important. Automation. So these are all the things which we have to do. Now we have already discussed the ETL pipeline, that is extract, transform, and load, right? So something which your data engineer is actually working. So those pipelines, right? They fit in here. So we have seen that how ETL pipelines fit in here, where we are extracting the data, transforming it, and then storing it so that others can use the same, right? We have seen that earlier, that how it is overall used and how we are storing it. So traditionally that was the overall process which was followed. So we have ETL plus data warehouse, right? Data warehouse, which was traditionally being followed. Now there are a few issues in this thing, and one of the many major issues is that data warehousing is very costly and it is just supporting the structural data, right? So it is not good because of that. And to understand that or expand our analogy, what we can think of is that now is where big data will kick in. So let us understand where does big data fit. Now, in an analogy, just think about that. What will happen? Like, if let's say instead of just these rivers and sources, now we are dealing with a huge amount of data, like a lot huge. So, for example, let's say big data engineer or someone who is handling big data, in an analogous way, he will be handling massive floods of water, right? So, this time lots and lots of water. Let's say massive flood of water. And you can think that he is someone who is like a dam engineer. So, who is just like dam, right? We will specialize dam to handle this thing. In a similar way, big data is where we fit in these large sources of data which are in different formats. So the data can be unstructured, semi-structured, right? And we have to now use the technologies, these special tools and technologies through which we will be able to work on this data. So now, let's say this data is coming from a very large volume, and it can be of different sources as well. A big data engineer, right, is someone who will have knowledge about these tools and technologies. So like just like we have specialized dams to work on this data, and then finally control and process this. In a similar way, in big data, we have technologies like Hadoop and Spark, which help us to do distributed computing, distributed storage, something which we saw that why distributed systems are better. Because now, in big data, our data set has become a lot large. So big data refers to data which is large, complex, that traditional systems cannot handle effectively. So just like we build dam to now handle all these things in big data, a data engineer will actually be now using these technologies if he's handling or working on data of that volume, of that complexity. Now we have all seen the 5 V's as well. So in a proper analogy of restaurant case, you can think of a fast food chain, which is let's say like McDonald's or KFC, which is worldwide. So they have to make sure that because the incoming orders are so high, they have to generalize their process. They have to buy machines, they buy very large machines for let's say processing of fries, to make buns, to make patties for their burgers. In a very similar way, these are the tools, right, which they are using for distributed work, distributed processing. So in a very similar way, we have a big data engineer who now specializes. Okay, so he specializes in these tools and technologies. So a big data engineer specializes in tool and technologies. So they are majorly Hadoop and Spark, something which we're going to start in the next module, that can process and manage massive data in distributed system. Right? So this is where the role of big data engineer comes into picture. Now here also we have already seen that here how we are using majorly ELT workflow, right? So we have already seen the ELT workflow, where now in modern systems we are using something known as ELT and plus these big data technologies, right? So plus these big data technologies, which are Hadoop, Spark, Data Lake, all these things. So now I'm sure that this difference is clear. One more thing to understand, that though now because each and every industry, every domain, the data getting generated is a lot high in volume. If in some use case it is able to get handled traditionally, then it is all good. As a example, if your restaurant is pretty small, then of course you don't need that big machines which these food chains will have to process anything inside your restaurant or kitchen, right? But if it is very big, then for sure you will not be able to handle it without using those specialized machines, specialized tools, right? So that is all majorly around the big data engineer and the data engineer. So you can say that big data engineer is an enhancement or the next level of a data engineer who knows those tools as well, which will be able to handle this big data in a distributed system. Let's now try to just quickly summarize all the differences which we have seen. So a data engineer and a big data engineer, the focus of a data engineer is to handling structured data and manageable data, right? Whereas a big data engineer, he's handling massive data sets, right? And again, they can be in different format as well, which is your unstructured, something which our traditional technologies or system cannot easily handle. Then come tools, so SQL, Python, Airflow, and other ETL tools which were available to us, which we were using. But for a big data engineer, Hadoop, Spark, Hive, Kafka, NoSQL databases. Again, completely fine if you don't know what that is. We are going to learn them as we move ahead in the course. But yes, the tools are also now becoming different. Scalability, again, we are working with traditional systems here. But a big data engineer, he will be working with distributed system for scalability. Storage, we have data warehouse and databases, right? But here data lakes and distributed storage come into the picture. So in the next module, we are going to start with distributed storage, and we are going to learn about the Hadoop and HDFS file system. Coming to processing, majorly we have ETL pipelines for structured data, right? Here we have parallel processing for large scale data. So just like every machine in McDonald's or KFC, like it's processing something parallelly, in a similar way, we have this parallel processing which comes into the picture. Coming to the use case, preparing data for a monthly sales report. So if you have to do this kind of a use case where data is manageable, it's all structured, something which your traditional technologies can handle, surely you can go ahead and use the normal data engineer tools. So like for example, a monthly sales report in a bank or somewhere. But analyzing social media trends where the data is coming in real time, it is of different format, you surely will have to implement or learn those tools, and thus you will be a big data engineer now handling this totally, right? So let's now move forward and see them once quickly. So I think this will make a lot of sense. This is your overall, I would say, flow, right, of as a big data engineer. So you have different data sources with you. Now we have the ETL and ELT pipelines working in parallel. It's storing in data warehouse, it's let's say data lake. Then we create some data marts. Again, we are going to talk about this as we move forward. We are doing some transformation. And finally, business user and data scientist can use the same thing. As a data engineer, it is your responsibility to make sure that you can serve this data in a proper manner to your downstream. So this is now we call your downstream, and this is your upstream. And a data engineer is someone who is sitting in between. So as a data engineer, you surely will have to have the skills of as a big data engineer, you surely will have to have skills of data engineer as well, right? So it's a level above a data engineer because you have to still see, you have to still maybe handle or know that okay, traditional technologies can handle this part, but for the other, now I'm going to use the big data technologies. Okay. So cool everyone. With that, I hope this is clear. Just to quickly recap, you can just remember this example of water sources, water pipeline builder, or and a dam engineer, or let's say a chef and a fast food restaurant. Okay. So with that, I'm pretty sure that you have understood that what does a data engineer do and how does the big data fit into this whole process. Again, the ETL and ELT pipeline understanding is a lot required here. That's why I covered the same earlier. So cool everyone. I hope with that it is clear. Now in the next module, we are going to learn about what are the different tools which a big data engineer has in its overall, I would say, learning, so he can work on that data. Hello all and welcome back. So welcome to the Hadoop architecture module of this course. Now pretty sure that till now you have done the prerequisites and the introduction to big data, and thus you will have an idea that what exactly is the work of a big data engineer and some common terms which you will hear throughout your big data journey. Now coming to this module and the modules which will follow, we are going to start with Hadoop, which is a very important and one of the first mature technology which enable us to handle big data. Now instead of just going by the theory route, we have made sure that we have shown you practicals for each and everything, and for the same we have used Google Cloud, so for which you will have to create an account. Now you don't have to pay anything. It's a completely free account which Google provides you. It's a free trial. So you might be requested to add a credit card or via the UPI or a debit card. You can just go to Google and understand what are the requirements, and they will provide you with a $300 credit and 3 months trial, which is way more than enough than required. So within 3 months, you will be able to complete each and everything in the course, and that is the idea with which we have designed the full syllabus as well. Now coming to this module and the next few modules, you will learn about how exactly storage happens in a distributed manner, because when it comes to TBs or petabytes of data, the same cannot be handled by a local system or a single machine. Along with that, you will see some very common UIs. You will understand the concept about blocks, how exactly the whole pillar or the whole, I should say, base rather is set for your distributed processing for any framework. Now understanding this is going to be very much helpful, as the same concepts or the same understanding will move forward when we learn about AWS S3, ADLS Gen 2, or any other object-based storage as well. And that is the reason we have covered these things from complete scratch. We have shown you each and everything, so your basics are a lot clear. And of course, the same will be very much helpful in your interview as well. So with that, everyone, I'm pretty sure that you will have a great learning experience. You will be loving the way we have covered each and everything here in depth. If you're liking the course till now, please make sure that you give us a 5-star review, and that will be a lot motivating for us. Now let's meet in the next video, and I'm really hoping that in this particular module, you will be starting a big data journey, and you will be astonished to see how exactly and how smartly we have created technologies to handle big data. Thank you. Hey everyone, welcome to this new module. So in this module, now we're going to start with understanding about Hadoop. So in the last module, we understood about many things related to data engineering in general, as well as how the big data problems come into picture and what are the different ways in which we try to tackle it. So till now we have seen that how, right now we have first, which is lots of data with us. So the data again can be in terms of complexity, in terms of volume or variety, or let's say velocity. And we saw that how we will be using a cluster or a multi-node setup to solve our problem. So these are the two things which we have till now. With this comes into picture Hadoop. So Hadoop is the open source framework designed to handle massive amount of data in a distributed and scalable way. So in the last module, we saw that how the problem in big data will be solved in a distributed way because vertical scaling was not possible, and the same should be able to scale because the problem which we are facing in day-to-day industries, that also is getting scaled or getting complex with a lot of overall increase, right? So one thing which I would like to clear here is that Hadoop is one of the technology of solution for big data, and its understanding is very important for understanding other technologies as well. So many times you might listen the term that Hadoop is dead or don't learn Hadoop, just Spark is the only thing. Well, though like the statement in itself is wrong, understanding Hadoop, even though it is used a lot less right now, is very important because the same will help us to understand the other technologies which came up as a replacement for Hadoop in today's industry or today's world. So now let us deep dive into Hadoop. So to understand Hadoop, let us see that what was the problem before Hadoop. So we have already seen that how overall the data was growing a lot. So data started increasing exponentially. Right? So businesses were having this issue where the data was starting increasing a lot, and all the methods which we had earlier became impractical, such as because of the reason that storage had limits, processing of course was not able to keep up, and adding more capacity, that is vertical scaling, was becoming a lot expensive. So in early 2000s, Google was also facing the similar issue. So around 2000s, Google was facing a similar issue in its web search data, and you can understand that how the overall adoption of internet and the websites coming was also increasing at that time. So they developed two systems. Like the first one is known as GFS, which is your Google File Storage. And the next one was GMR, that is Google MapReduce, normally known as MapReduce only. So GFS was majorly for your storing, right, as the name says, storing. And MapReduce was for processing. So again, very important to know, these we have proper research paper also available for this thing, which you can go and read. Now, inspired by this, two people, Doc Cutting and Matt Keflella, created Hadoop as an open source implementation of these concepts. So they got an inspiration from GFS and MapReduce, and they created Hadoop as an open source implementation. So unlike traditional system, Hadoop shares and processes data across many cheap commodity hardware and machines working together. So we saw that how we have connected all the machines all together in a cluster. Now, of course, we would need some framework through which we are able to use those connected machines, right? So there are two major tasks of Hadoop, two tasks. The first one being massive data storage, and the second one is faster parallel processing. And these are the major things which we have discussed that we have to do whenever we are presented with the data. So with this, pretty sure that you would have got what exactly Hadoop is. So we have already, as I've repeated, that we have multiple machines with us. So let's say these machines are there. We know that we have lots of data as well. So Google made a system which is GFS and GMR. Inspired by that, Doc Cutting and Mike Keflella, they came up with Hadoop, which is an open source implementation. So it's a framework, right? Once we are able to add this framework, configure it into all these machines, we are able to handle the big data problem. And there are major two things which we have to, or two major tasks which Hadoop has to perform. That is the massive data storage. That is going to be a massive data storage, and the second one is faster parallel processing, right? So with this, pretty sure you would got an idea that yes, we are slowly moving towards our solution of handling the big data. And in the next video, we will see and learn about some properties of Hadoop, which makes it a very good solution to handle our big data problem. Hello all and welcome back. So in this video, I would just like to touch upon few of the properties of Hadoop. The same are going to be a lot in line with what we discussed about the properties of any big data, which any big data system should have. So let's get started. Now, the very first property of Hadoop is that it's again a lot scalable. So scalability. Just like we saw in the last module that how a big data system should be scalable, our Hadoop as a solution, it can scale horizontally. So Hadoop can scale horizontally. That is, we can add as many machines as we like, right? So it can scale in and scale out. So for example, instead of upgrading a single computer, right, we can have in a cluster more and more PCs or nodes which we can add here, right? So that is the very first property. The second one is your fault tolerance. And one more reason that I'm discussing about these technologies, these properties again, is that anytime if you are learning about any other completely new big data solution as well, right? So let's say tomorrow you are learning about S3 or some other solution overall which might be provided by any company, be it Google, Microsoft, Amazon. Make sure that you are understanding that how that technology is helping you in achieving these properties, because these are some things which should always be present. And that is again where I feel that if you understand that how Hadoop is able to provide you with these things, you will be able to better evaluate other solutions when they are provided to you. So the next one is fault tolerance. Right? Again, a very important property which any system should have. So we are going to see each and everything in depth as well, like how Hadoop does that. But the idea here is that Hadoop maintains or replicates our data across multiple machines. So even if one fails, the system continues to work. So Hadoop maintains copy or replicas to avoid failure if any single machine fails. So the idea is pretty straightforward. Let's say if I've given you a data and I want to make sure that data is always safe, right? It is not susceptible to failures. You can get multiple copies. Maybe you can keep one in your pen drive, one in your phone, and one in your laptop. So in worst case, if tomorrow your laptop is not working or it gets stolen or anything, we understand that yes, the data is there. Okay, so we will discuss more about this as we will learn and unravel Hadoop in further classes. But the idea here is that yes, this property is a very important thing which should be available in any big data solution. The next is distributed processing. Distributed processing. Here as well, whenever the data is stored, right? So data is processed where exactly it is stored, which reduces the need to move the amount of data across the network, right? So let's say if the data is stored across a machine, Hadoop as a framework, it makes sure that it is not moving data a lot over the machines because that is costly, and it is doing the processing on that machine only. Again, something which we will see in a lot depth, but the basic idea is that Hadoop can process the data where it is stored. And the fourth one is your cost effectiveness. So when we started or when Hadoop was introduced, and it was in 2006, we have to understand that the reason it was adapted a lot in the industry was that it was very cost effective. So Hadoop can use your inexpensive hardware, okay? So inexpensive hardware, or it is normally the word which is used is commodity hardware or commodity machines. Commodity machines, which can help to achieve what we want in our distributed framework or in our distributed processing and storing. So it's not that Hadoop needs some specialized high-end servers. And if you think about it, that is a very good overall, I would say, relaxed solution which makes everyone very likely to adopt Hadoop, and that is something which happened. If it had some, let's say, requirement as a supercomputer or a very high-end processor, then it would not have been that easy for everyone to adapt to that. Or let's say if high-end servers were required. So in a simple way, inexpensive hardware or commodity machines can be used. Along with that, one very important point is that Hadoop is an open source. So it comes under Apache Foundation, freely available to use and modify, right? So it is free to use and modify. Very important point, which made its adaptability a lot overall easy. Along with that, of course, there are normal points like it's suppose data locality, it is very simple, but they comprises in majorly these 5 points. And always remember that these are some properties which any solution which is helping you to, like any big data solution should have, because we have seen this already, that whenever we are facing problem related to big data, these are the things which if a system is able to handle, we can be pretty sure that overall we will be able to handle our big data problem. Now again, the last one, open source and cost effectiveness, is something which is not a necessity, but for the adaptability of any particular solution, it's a very important thing, right? And that's why you will see that many overall solutions like Spark, Hadoop, and all these Hive, they are open source, which can readily be learned and then applied to our big data problems. So these are the major properties about Hadoop. Now, also let us see that how Hadoop can help, or how Hadoop solves the real world problems, right? So let's say take an example. Hadoop solving a real world problem. So you can take an example of, let's say, Amazon, right? E-commerce company, right? So here we have millions of users, each generating data about searches, purchases, reviews, everything. So we have millions of users, and each of these users, they are generating every time data about searches. Then they can search all the purchases which they make, orders basically. They also leave the reviews and many more things. So Amazon as a company is dealing with all these things. Traditional system, of course, cannot handle this data in terms of storage and processing. So Hadoop comes into picture, where Hadoop is allowing that yes, you can store this data distributed across many low-cost machines. So we can use low-cost machine to store this data. And for processing this data, we can, let's say, to provide personal recommendation, to analyze trends, or let's say to optimize any delivery routes or anything. Majorly to work on our data, we can make sure that we can process the data as well very fast in a distributed manner. So Hadoop is a very good solution in this particular use case, where let's say an e-commerce company like Amazon has to store and work on the data of its customer. In a similar way, we have, I would say today, almost all the domain, right? They are using systems which are based on Hadoop, understanding of Hadoop, or similar distributed systems or framework to solve their big data problem. So I hope that is clear, everyone. So in this, we have just discussed about the properties of Hadoop and how it is helping to solve a real world problem by taking an example of Amazon. Now, moving forward in the next video, we are going to learn about the Hadoop ecosystem or framework in depth, so that we can understand that what are different components of which Hadoop is made up of, and then we are going to deep dive into its major component in proper depth to understand that how they exactly work. So hopefully this all is clear. Now let's meet in the next video where we will learn about the Hadoop framework. Hello all and welcome back. So in this video, we are going to now learn about the different component and tools which form our Hadoop ecosystem. So let's get started. Now, Hadoop ecosystem is a collection of open source tools and projects. So collection of open source projects and tools that work together to store, process, and analyze large amounts of data. So in the last few videos, we learned that what exactly Hadoop is and how once we have the cluster with us, Hadoop as a framework can help us to handle our big data problem. Now, Hadoop has different components, some of which were present when it was invented, while other were added by a group of different people, different companies, so as to make sure that each and every use case of your big data problem in Hadoop can be handled. So understanding this is very crucial, as this will help you to, in a way, make sense that what are the different problems we can have in a big data architecture, and what are the solutions, or what companies did, and they help us in providing that particular solution. So let's get started and see them one by one. I'm going to draw this particular diagram here, so that we can, after it's completed, we can just copy and paste it here. So let me just scroll a little bit down, and we can make the notes for each component in a separate page. So the very first component which we have is something which is known as HDFS. So let me write it down. 1 minute. Yeah, so first component is HDFS. Now HDFS, the full form is Hadoop Distributed File System. So let me write it here. HDFS. Hadoop Distributed File System. So this is inspired by the GFS, that is your Google File Storage. The main aim of your HDFS is to assist you in storing of your data. So it provides distributed storage for large data files. So as we have already seen that we will be, in a way, dealing with large data sets here, right? So for that, HDFS is the tool which is responsible for making sure that we can store it in a distributed manner. In a simple word, what does that mean is, let's say if you have a 20 node cluster, then it will have 20 machines. So using HDFS, we will be able to store our data across these 20 machines depending on the size. So storing is a very important part of our overall big data problem, right? So we majorly do two operations, that is storing and your processing. So HDFS is a component which helps you to do the storing part. Now we are going to discuss that in further videos in lot depth, that how exactly you do that, because it is going to be helpful. But yes, you should understand that HDFS is something which is provided by Hadoop to handle your storage of your big data. Now the next one is something which is known as MapReduce. So let me write MR here. This is your MapReduce. MapReduce, in a similar way, it has also been inspired by your GMR, that is your Google MapReduce. So I can write it here. It helps you. So the role of your MapReduce is that it helps in processing large scale data by splitting your jobs into smaller tasks. So it helps in processing of data by dividing it into smaller tasks, which again can run parallelly, right? So the basic idea is again the same. We will have somewhat this cluster with us. So let's say this is our master worker architecture, something which we have already seen. And in this cluster, we will have, for storage, we will be using HDFS, while for processing, MapReduce is the framework which we will be using. Now, the understanding of MapReduce is still important, even though it is used a lot less in the industry today, because the understanding will help you to, in a way, make sense that how this distributed processing happens. So, in a way, your data, let's say if you have a very big data, your data will be spread across these nodes via HDFS, and processing of these particular nodes, for the chunk of your data will be happening via MapReduce. So, these are what your basic components are. So, if you will install Hadoop, you are going to get HDFS and MapReduce. Now, let's move forward. So, since Hadoop 2.0, so version 2, we are also getting another layer in between, right, in between of your MapReduce and HDFS, which is known as Yarn. So Yarn, the full form is yet another resource negotiator. So third one is your Yarn, yet another resource negotiator. Yarn, what it does is that it decouples your resource management from your application execution. So before this, your MapReduce was having the role of making sure that it can handle all these resources. So let's say if you have submit some processing job, right? We have to say count the number of words in a sentence. Then along with doing this processing, Yarn used to handle the resource management as well. Moving forward, what we have done or what Hadoop has done is that it has decoupled this resource management. So let me write it down. Decouples the resource management from application execution. So in your cluster, the one which we have on right, what can happen is that many users can submit their job or they can ask or negotiate basically for their job to run. This Yarn is something which is going to handle all these resource management, that how these different nodes in the machine, how are they going to get divided, how they're going to execute a particular task. So these three are the major component, the one which you will get when you install Hadoop. And you can see them how they are in a component or in particular in the ecosystem like this. All the other components which we are going to learn, right? So there are many components which we are going to now see. They are the one which we can install, and they were added after our Hadoop, or basically they were submitted by some companies or something. We also can do the same thing. So in Hadoop, let's say we also can submit any particular component, and the other ones we are going to see once we move forward. So till now we have these three components which form the core component of your Hadoop ecosystem. So in the next video, now we will see that what are the other components and what role they play. But till now, pretty sure that we have handled the storing, the processing, and the resource management, which is the bare minimum or the major part of any distributed system or major work which any distributed system has to do. So cool everyone, now let's meet in the next video and we will see what are the other components. Hello all and welcome back. So in this video, let us now continue our discussion on different components which form a part of your Hadoop ecosystem. So in the last video, we saw the major components, that is your HDFS, that is Hadoop Distributed File System, MapReduce, that is your basically tool for doing the processing parallelly, and Yarn, which is your resource negotiator. So now let's see what are the other components which were added as a Hadoop started getting more mature. So the very first one is something which is used a lot till now, and that is known as Hive. So minute, yeah. Let me write it here so it's easy and you're able to refer to these notes afterwards as well. So the fourth one is your Hive. Now Hive was developed at Facebook in 2009. And it was then submitted to make a part of your Hadoop ecosystem. As I said, we can also create and submit anything if we are, let's say, if we are able to have a good use case and we feel that it will be helpful to the community. So the basic idea behind Hadoop is that it is a query engine. About Hive is that it's a query engine and not a database. So let us understand the problem here. What used to happen was that engineers at Facebook, they were having lots of use case. They like the Hadoop and everything. And the problem used to happen that we have to write MapReduce code for doing anything, right? So for, let's say, if you want to make a join, if you want to filter your data, right? So all the data is in a way kept at your machines, and MapReduce will be required to basically work anything or process that data. Now MapReduce mainly is written in Java. So what they want to do is they want to avoid the Java interaction and wanted some query language, right? So let's say it is very close to SQL as well, and wanted SQL or some query language, but at the same time they wanted the performance of MapReduce. So the basic idea was that, hey, we still want that performance of MapReduce I'm able to get, but instead of writing those long codes, I don't want to do that, and instead would be better if I can write a query language like SQL to work on my data. So engineer at Facebook created this and submitted this as part of Apache Software Foundation. What it does, it abstracts MapReduce in the backend, right? So by translating SQL queries into MapReduce jobs. So you will be writing SQL only, but in the backend, these jobs will be converted into MapReduce jobs. And the same thus can be very efficiently used in your data warehousing solutions. So the major use case of your Hive is as a data warehouse. Again, it is a query engine, not a DB. But on the data which is kept on your HDFS, on your Hadoop file system, Hive can help you to work on that data by just writing simple queries. And as I said, it was developed by Facebook. It is not an integral or a core component of your Hadoop, but majorly it is used a lot in the industry, and it is an abstraction of your MapReduce framework, right? So now let's move forward and see the next one. So the next one again is something which is known as Pig. Now coming to Pig, again the same issue. It was created by Yahoo, right? So they also wanted the same thing. So it was created by Yahoo, and their understanding was that see, we are all fine with the MapReduce, we like the performance, but we don't want to write the Java code or SQL for that. There is a language or a scripting language which is known as PigLatin, right? So using that PigLatin, we want to work on our data, right? But we want to transform our data, but we want the performance of MapReduce. So again the same thing here as well. It's also an abstraction of your MapReduce. Okay, here as well, MapReduce performance, but no Java or SQL. Instead, what we are doing here, we have a high-level scripting language to work on our data, scripting language for your MapReduce. So you will be writing your language, your code in this PigLatin, but it's going to get transformed in the backend to MapReduce and do your work just like let's say MapReduce would have done. But Yahoo, engineers at Yahoo, they were like, okay, we want the performance, we don't want to write the Java or SQL. Okay, so let's move on to the next one, everyone. So till now we have seen this 5 components. Now let me make the next one, which is known as your scoop. Let me make it here. So this is your scoop, right? Let me just keep it here. I think it's Q. Yeah. So let us go here and write it here as well. Scoop. So the basic idea behind Scoop is again very similar. It's actually a standalone Apache project. It was given by a group of community members. Now, just if you think about this, we have the data traditionally saved into RDBMS system, right? So in our DBMS systems, the data was there. To get that data, right, we have to again write a MapReduce code which can read from, let's say, a particular system and get that into our Hadoop. But again, for this particular use case, we want to get rid of our MapReduce programs. And one thing many of you might be thinking that why is that all of these components, they want to use the performance of MapReduce, but don't want to write the MapReduce code. And the reason for that is MapReduce, the code is not very easy to write. It has to be in Java majorly. Java is like other languages are supported, but majorly it's written in Java. And writing the code is a little bit difficult in that. And that's the reason MapReduce has largely been also replaced by Spark, that and other performance improvement as well. So here also, what Scoop helps you to do is it helps you in doing it helps facilitates import and export between Hadoop and relational databases. So here again, we want the performance of MapReduce. We have actually some Scoop commands through which, in a way, we can migrate our data between Hadoop and these enterprise systems like Oracle and MySQL. We are not writing MapReduce code here, right? And it can work in both the ways. So you can get the data out as well as get the data in. So that is where Scoop is majorly used, right? So it helps you in doing this easily, ease of use, and majorly you can create your data pipelines using this. In the backend again, it is going to make sure that it is using your MapReduce performance, but you will not have to write that code, right? So let's move forward to the next one, everyone. That's your Uzi. Uzi. So in Uzi as well, again, MapReduce is the major thing. So what we are trying to do here is that, let me write it as well. And that's the reason I'm drawing it all in top of MapReduce. So Uzi again is an abstraction of your MapReduce, right? The basic idea behind Uzi is that it helps you in scheduling your workflows, right? So let's say you have written multiple codes where you are first getting the data into your system. Let's say you have written a MapReduce code for that. Then you have written a code to work on that particular data, to transform the data. Then once that is completed, you are doing some other part. So all this managing of your workflow and dependency between job and Hadoop, that is where your Uzi is used. So I can write that it is also a abstraction of MapReduce, right? Here we are using XML files, right? So we are using XML files for scheduling and automating our work, right? So it is just specifying that how exactly a job should run, when exactly it should run. It manages your workflow and dependencies, right? That is the major work. This was created by Cloudera and it was contributed to Apache. It majorly the use case is that it is essential for scheduling complex workflow in your ETL process. So let me write it here: essential for scheduling complex workflows in our ETL process. So one thing which you all will be able to understand by watching or by understanding about these components one by one is how each and every one of them is helping you to solve some problem, which might be very straightforward. Like for example, we are still working on data, but just like the way we are working, that has changed, right? So for example, Hive, we are still transforming our data, but this time we have chosen SQL-based querying instead of writing the code from scratch. Same for Piglatin. Then Scoop again, we are importing and exporting. Just that we want to do that without writing your overall MapReduce code. And Uzi as well, we are just making sure that we can schedule all these things, right? So using our XML files, we are able to schedule all these things. Now these four are your abstraction of your MapReduce. So you can understand that companies actually wanted to make sure that they can use something which gives them the performance of MapReduce, but avoid writing the code. Okay. So the next one is something which is known as your HBase. So I can write columnar store here as well in HBase. Columnar store. Yeah. So HBase is actually now your NoSQL DB, right? So 1 minute. Yeah. 8th can be your HBase. Now it's a NoSQL database, right? It is also modeled after Google's Bigtable and it's open source. It's an Apache basically project. Now HBase is a columnar DB. So if you have learned about that how the data is getting stored in different databases, in many databases, majorly the NoSQL one or the one which are very read heavy, we try to store the data in a columnar format rather than row format. Okay, so we save those different columns all together in a. So we store them not by row but by column by column. So the idea is that it gives results quickly. Okay, so let's say we have lots of data with us, right? Something which we will be having in our big data problem, and we want to have access to a particular record, right? So we want to have a random access. So majorly your SQL DBs, this thing is not easily possible. Whereas in your NoSQL database, that allows that you can have access to your random access, or let's say to a particular row. Along with that, they allow real-time reads and write on HDFS. So the role of this is that it's NoSQL. HBase is your NoSQL database, which allows real-time read and writes on HDFS. So by default, because HDFS is handling so much data, this thing is not very easy that we can have real-time reads or writes, or we are able to randomly access some particular row. So this thing is very suitable for your fast random access, such as your time series data or your messaging system. And this is basically a NoSQL DB, which forms a part of your Hadoop system. So let us move forward now, everyone. The next one is something which is known as Mahout. Let me write here. Mahout. So the use case of Mahout is that it is helpful, right? So since we are having so much data now, we surely will be applying some data science or machine learning algorithms on top of that, right? So Mahout, what it's helped us to do, let me write that. Mahout. It provides you those machine learning libraries, right? So it implements the algorithms for your clustering, your classification, or let's say collaborating filtering. So I can write that it's a data science component. Data science component, right? Then it provides you with ML libraries. And along with that, it is basically helping you to implement algorithms for clustering, classification, etc. Right? So this is what your Mahout is, everyone. Now let's move on to the next one. So the next one is something which is known as Flume. Let me write here. So next one is 1 minute. Yeah. This is where we have Flume with us. Okay. I cannot just get this one. Yeah, cool. So just to make sure that the diagram is pretty much uniform. So the use case of Flume again, everyone, is for the real-time data streaming, right? So let's say you have some data which is getting generated in real time. Normally, let's say your logs are there, right? So whenever any website is there, so it is Apache project again. Let me write it down as well. So the next one is your Flume. The major use case, okay, it is a messaging queue. So many of you might be aware of Kafka. Similarly, your Flume is also a messaging queue, and it has largely been replaced by other things for short Kafka and other things. So it helps you in retrieving your data in real time. Okay, and through this you can just get the data to your Hadoop. You cannot. It's only one way. So it's collect logs or event data, right? So what it can do it can collect your logs or event data from various sources, and deliver them to Hadoop or HBase. So we saw that how HBase is also a database, right? It is used in your real-time analytics. So I can write it down as well. It is used in real-time analytics for monitoring. Similar technology is your Kafka as well, right? And it is for your ingesting streaming data. Okay, so that is what your Flume is used, everyone. Now let us see the last component majorly. And as I said, there can be other component as well, just like we are discussing the one which are most commonly used, which are most famous and which are used. But the basic idea remains the same. If you're able to understand what is the use case which they're helping you solve, surely it will be easy to understand. So the next one is your Zookeeper, everyone. Zookeeper. So Zookeeper is actually also used in other different places as well. Okay, so we are going to see this when we deep dive into HDFS and Hadoop architecture. So the role of your Zookeeper is to make sure that it can maintain the consistency. So since we are having this distributed system, right? So it is helpful. It was developed by Yahoo. It coordinates distributed system to maintain consistency. So since we will have many machines which are connected all together, we always have to ensure that they are in a line with each other, they are having the consistent data, and that is where your Zookeeper is used. This is used a lot in your Kafka framework as well. Okay, so it is very critical for ensuring reliability in Hadoop clusters, right? So I will write this as in critical for ensuring reliability. So it should not be that one node is saying that hey, I have 1 GB of data, and other is saying that hey, I have 2 GB of data. So this all thing is something which your Zookeeper is going to help you, right? So Hadoop cluster, yeah. So this is where your Zookeeper is used, and this I think majorly covers all the components which you might be using across your Hadoop architecture. So let me just add this to the notes as well. Minute, yeah. And hopefully using this, you should be able to quickly revise. So of course. So please refer to this diagram and just the understanding which I have given you, that should be more than enough as of now to understand that okay, what exactly they are doing. The major components, those are your HDFS, Yarn, and MapReduce. We are going to learn in complete depth. The reason for that is the idea and the implementation of these components that is very much useful in understanding their successors as well. So many times you must have like listened that hey, Spark is used, MapReduce is not used. Well, yes, but the basic idea behind the processing in MapReduce, that is what forms the core of your Spark as well, along with some I would say your implementations and your optimizations, right? So I can get another diagram just to make sure that this is in line, so you can see that as well, everyone. Yeah, so this diagram also again just a little bit more. So you will see almost all the things which we have discussed here. So we have Yarn here, we have HDFS, then we have Apache Spark. Okay, so you have seen Spark instead of MapReduce. Then you have the Storm and Kafka and Storm, right? They are also for streaming. Then you are seeing Flume here, okay, and structured or semi-structured data. We have the Scoop, where you will see the two things, right? So here we just have one arrow. Similarly, we see Uzi here, we see HBase, we see Zookeeper. There is Ambari also written. So these are again, as I said, there can be many more tools. Okay, it is not that the one which we have discussed, they just form all the tools. No, you can have other tools which can form this part of this overall system. So yeah, that is I think what all we have to understand here. Just one thing more which I would like to write here. 1 minute, yeah. So that is, let's say for your each and every use case of each and every component. So for your storage, we have seen that how HDFS and HBase are majorly used. Then next one is your processing. Here for processing, we can use MapReduce. Then we can use your Pig via Piglatin and Hive. And I can write Spark here as well, right? Then the next role is your data ingestion. And again, this I am writing for all the components which we have discussed. So here we can use your Flume and Scoop, right? Then the next one is your coordination. In here we are using our Zookeeper for all the coordination and maintaining the consistency. And the last one is your workflow management. Here we are going to use your Uzi. Okay. Then again for ML, Mahout can be used in the other libraries. So that's the basic idea given. And one last point which I would like to make sure that you understand for all this ecosystem feature is that there are two major properties. Okay, so which we have to understand here. So those are your first one is that like it's a loosely coupled framework. Like the first one is that it's a loosely coupled framework. So what I mean by loosely coupled framework is that even if we remove few elements, right, it is going to still work, right? So for example, like let's say for the definition, we can remove elements or components and it's still gonna work. And that is the reason, like for processing, we see that MapReduce now is not getting used. It is majorly been taken over by Spark due to its optimization and ease of writing code. And the full architecture will work as it is. So it is not your tightly coupled framework. So in a tightly coupled framework, if you even remove any single component, the whole thing basically will not work, right? So the second property is on the integration. So Hadoop as a framework can easily be integrated, right? It can be connected or integrated with, say, Spark or any other big data technology. So as I said in the starting, Hadoop is just one of the way through which we are solving our big data problem, and it is the most common one, right? But let's say if you have some other framework as well, it can be easily integrated with your big data frameworks, and even it can be easily integrated with your non-big data framework. Like let's say same for non-big data one, like MySQL, relational databases, right? So very easily we are able to connect to big data or non-big data technologies, and that is the reason. Like let's say we can get easily the data from your RDBMS to your HDFS, and these are very important things or property behind your framework, right? So two properties about Hadoop framework. Right, everyone? So I'm pretty sure that now everything will be clear with respect to these this framework. So these are very important property. This makes it a lot more easy, or I would say overall adaptable and something which can be used. We have discussed each and every one in a detail. Going forward in this videos and the videos which we are going to follow, we are going to discuss the major component, that is your HDFS, Yarn, MapReduce, and also Hive in a lot more detail. We will go down and see their architecture, that how exactly things are happening in them in the backend, so that you have an overall very good idea. But again, please make sure that in any case you are understanding this, because many technologies which are getting used nowadays, right, they will be something where the main idea is the same. So just as an example, MapReduce, we are using Yarn instead, right? For your MapReduce, we are using Spark instead. For your Yarn, we can use Kubernetes as well. Then as a data warehouse, instead of Hive, you can maybe use your Snowflake. Then for your coordination and all the scheduling, Airflow is as a tool can be used. But you will see one thing, that all of them, if you understand this main framework, the understanding of further tool is going to be a lot easy, because they will be doing one of the job, right? So yeah, that I think is more than what is required for understanding this full Hadoop ecosystem. And in the next videos which we will follow, we are going to start with HDFS, because first we should make sure that we are able to store the data, right? So cool, everyone. Thanks a lot. If you have any doubts, please ask the same Q&A. Just make sure that you revise them and also make your notes yourself, so that you understand each and everything about every component in this framework, as that will be very helpful from interview perspective as well. Cool, everyone. So let's meet in the next video. Hello all and welcome back. So in this video, let us now continue our discussion, and now let us try to understand about HDFS, which is a very important component of our Hadoop ecosystem. So HDFS, the full form we have already seen, it's Hadoop Distributed File System. From outside, it is just an